industries, including healthcare, finance, and technology, are looking for ways to automate repetitive tasks and improve efficiency. In order to do so, they are looking for professionals who can apply machine learning to solve real world problems and make data driven decisions. Due to this, there is currently a high demand for machine learning skills in the job market. Hello, everyone, and welcome to this session. You are currently watching an Edureka machine learning full course video. By the end of this video, you will have a thorough understanding about machine learning all the way from theory to practical applications. Now, if you love watching videos like these, then subscribe to Edureka's YouTube channel and click the bell button to never miss out any updates from us. Also, if you want to learn more about machine learning after watching this session and wish to obtain Edureka's machine learning certification course, then please see the link in the description below. Now let's begin with our agenda, where we'll have a brief overview of what we will cover in this machine learning full course video. We'll start with the introduction to machine learning, where we will learn what machine learning is and why we should learn it. After which, we will see how to become a machine learning engineer. Now once this is done, we will see some machine learning algorithms. Next, we have linear regression algorithm and logistic regression algorithm. We will then compare linear regression to logistic regression. We can then see some important concepts like decision tree algorithm, random forest, and KNN algorithm. Now it's time to deep dive into the technical aspects of machine learning. We will start with naive-Bayes classifier, after which we will then see what is support vector machine and k-means clustering algorithm. We will then understand why mathematics is required for machine learning. Now after all this, we will head over to model deployment in machine learning and machine learning on cloud. We truly hope that this session assists you in getting jobs in the industry. In order to accomplish so, we will look at how a career in machine learning works, which includes skills, jobs, resumes, salaries, and tools and frameworks that are required for machine learning professionals. Lastly, we will end the session with some important machine learning interview questions with answers that will help you in your interview. So stick till the end. Now let's get started with our first topic, that is Introduction to Machine Learning.
As you know, we are living in a world of humans and machines. The humans have been evolving and learning from the past experience since millions of years. On the other hand, the era of machines and robots have just begun. In today's world, these machines or the robots are like they need to be programmed before they actually follow your instructions. But what if the machines started to learn on their own? And this is where machine learning comes into picture. Machine learning is the core of many futuristic technological advancement in our world. Today you can see various examples or implementation of machine learning around us, such as Tesla's self-driving car, Apple Siri, Sophia AI robot, and many more are there. So what exactly is machine learning? Well, machine learning is a subfield of artificial intelligence that focuses on the design of systems that can learn from and make decisions and predictions based on the experience, which is data in the case of machines. Machine learning enables computer to act and make data-driven decisions rather than being explicitly programmed to carry out a certain task. These programs are designed to learn and improve over time when exposed to new data. Let's move on and discuss one of the biggest confusion of the people in the world. They think that all the three of them, the AI, the machine learning, and the deep learning, all are same. You know what? They are wrong. Let me clarify things for you. Artificial intelligence is a broader concept of machines being able to carry out tasks in a smarter way. It covers anything which enables the computer to behave like humans. Think of a famous Turing test to determine whether a computer is capable of thinking like a human being or not. If you're talking to Siri on your phone and you get an answer, you're already very close to it. So this was about the artificial intelligence. Now coming to the machine learning part. So as I already said, machine learning is a subset or a current application of AI. It is based on the idea that we should be able to give machine the access to data and let them learn from themselves. It's a subset of artificial intelligence that deals with the extraction of pattern from dataset. This means that the machine can not only find the rules for optimal behavior, but also can adapt to the changes in the world. Many of the algorithms involved have been known for decades, centuries even. Thanks to the advances in the computer science and parallel computing, they can now scale up to massive data volumes. So this was about the machine learning part. Now coming over to deep learning. Deep learning is a subset of machine learning where similar machine learning algorithms are used to train deep neural networks so as to achieve better accuracy in those cases where former was not performing up to the mark. Right. I hope now you understood that machine learning, AI, and deep learning, all three are different. Okay, moving on ahead. Let's see, in general, how a machine learning works. One of the approaches is where the machine learning algorithm is trained using a labeled or unlabeled training dataset to produce a model. New input data is introduced to the machine learning algorithm and it makes prediction based on the model. The prediction is evaluated for accuracy, and if the accuracy is acceptable, the machine learning algorithm is deployed. Now, if the accuracy is not acceptable, the machine learning algorithm is trained again and again with an augmented training dataset. This was just a high level example, as there are many more factors and other steps involved in it. Now let's move on and subcategorize the machine learning into three different types: the supervised learning, unsupervised learning, and reinforcement learning. And let's see what each of them are, how they work, and how each of them is used in the field of banking, healthcare, retail, and other domains. Don't worry, I'll make sure that I use enough examples and implementation of all three of them to give you a proper understanding of it. So starting with supervised learning. What is it? So let's see a mathematical definition of supervised learning. Supervised learning is where you have input variables x and an output variable y, and you use an algorithm to learn the mapping function from the input to the output, that is y equal fx. The goal is to approximate the mapping function so well that whenever you have a new input data x, you could predict the output variable, that is y, for that data. Right. I think this was confusing for you. Let me simplify the definition of supervised learning. So we can rephrase the understanding of the mathematical definition as a machine learning method where each instances of a training dataset is composed of different input attribute and an expected output. The input attributes of a training dataset can be of any kind of data. It can be a pixel of image, it can be a value of a database row, or it can even be an audio frequency histogram, right? For each input instance, an expected output value is associated. The value can be discrete, representing a category, or can be a real or continuous value. In either case, the algorithm learns the input pattern that generates the expected output. Now, once the algorithm is trained, it can be used to predict the correct output of a never seen input. You can see an image on your screen, right? In this image, you can see that we are feeding raw inputs as image of apple to the algorithm. As a part of the algorithm, we have a supervisor who keeps on correcting the machine or who keeps on training the machine. It keeps on telling him that yes, it is an apple, and no, it is not an apple. Things like that. So this process keeps on repeating until we get a final trained model. Once the model is ready, it can easily predict the correct output of a never seen input. In this slide, you can see that we are giving an image of a green apple to the machine, and the machine can easily identify it as yes, it is an apple and it is giving the correct result, right? Let me make things more clearer to you. Let's discuss another example of it. So in this slide, the image shows an example of a supervised learning process used to produce a model which is capable of recognizing the ducks in the image. The training dataset is composed of labeled picture of ducks and non-ducks. The result of supervised learning process is a predictive model which is capable of associating a label duck or not duck to the new image presented to the model. Now once trained, the resulting predictive model can be deployed to the production environment. You can say a mobile app, for example. Once deployed, it is ready to recognize the new pictures. Right. Now you might be wondering why this category of machine learning is named as supervised learning. Well, it is called as supervised learning because the process of an algorithm learning from the training dataset can be thought of as a teacher supervising the learning process. We know the correct answers. The algorithm iteratively makes while predicting on the training data and is corrected by the teacher. The learning stops when the algorithm achieves an acceptable level of performance. Now let's move on and see some of the popular supervised learning algorithms. So we have linear regression, random forest, and support vector machines. These are just for your information. We'll discuss about these algorithms in our next video. Now let's see some of the popular use cases of supervised learning. So we have Cortana. Cortana or any other speech automation in your mobile phone trains using your voice. And once trained, it starts working based on that training. This is an application of supervised learning. Suppose you are telling, okay Google, call Sam, or you say, hey Siri, call Sam. You get an answer to it and the action is performed and automatically a call goes to Sam. So these are just an example of supervised learning. Next comes the weather app. Based on some of the prior knowledge, like when it is sunny, the temperature is higher. When it is cloudy, humidity is higher. Any kind of that, they predict the parameters for a given time. So this is also an example of supervised learning, as we are feeding the data to the machine and telling that whenever it is sunny, the temperature should be higher. Whenever it is cloudy, the humidity should be higher. So it's an example of supervised learning. Another example is biometric attendance, where you train the machine and after a couple of inputs of your biometric identity, be it your thumb, your iris, or your earlobe, or anything, once trained, the machine can validate your future input and can identify you. Next comes in the field of banking sector. In banking sector, supervised learning is used to predict the credit worthiness of a credit card holder by building a machine learning model to look for faulty attributes by providing it with a data on delinquent and non-delinquent customers. Next comes the healthcare sector. In the healthcare sector, it is used to predict the patient's readmission rates by building a regression model by providing data on the patient's treatment administration and readmissions to show variables that best correlate with readmission. Next comes the retail sector. In retail sector, it is used to analyze the product that a customer buy together. It does this by building a supervised model to identify frequent item sets and association rule from the transactional data. Now let's learn about the next category of machine learning, the unsupervised part. Mathematically, unsupervised learning is where you only have input data X and no corresponding output variable. The goal for unsupervised learning is to model the underlying structure or distribution in the data in order to learn more about the data. So let me rephrase you this in simple terms. In unsupervised learning approach, the data instances of a training dataset do not have an expected output associated to them. Instead, unsupervised learning algorithm detects pattern based on init characteristics of the input data. An example of machine learning task that applies unsupervised learning is clustering. In this task, similar data instances are grouped together in order to identify clusters of data. In this slide, you can see that initially we have different varieties of fruits as input. Now these set of fruits as input X are given to the model. Now once the model is trained using unsupervised learning algorithm, the model will create clusters on the basis of its training. It will group the similar fruits and make their cluster. Let me make things more clearer to you. Let's take another example of it. So in this slide, the image below shows an example of unsupervised learning process. This algorithm processes an unlabeled training dataset, and based on the characteristics, it groups the picture into 3 different clusters of data. Despite the ability of grouping similar data into clusters, the algorithm is not capable to add labels to the group. The algorithm only knows which data instances are similar, but it cannot identify the meaning of this group. So now you might be wondering why this category of machine learning is named as unsupervised learning. So these are called as unsupervised learning because unlike supervised learning, above there are no correct answers and there is no teacher. Algorithms are left on their own to discover and present the interesting structure in the data. Let's move on and see some of the popular unsupervised learning algorithm. So we have here K-means, Apriori algorithm, and hierarchical clustering. Again, these are just for your information's sake. We'll discuss about these algorithms in our next video. Now let's move on and see some of the examples of unsupervised learning. Suppose a friend invites you to his party and where you meet totally strangers. Now you'll classify them using unsupervised learning as you don't have any prior knowledge about them. And this classification can be done on the basis of gender, age group, dressing, educational qualification, or whatever way you might like. Now, why this learning is different from supervised learning? Since you didn't use any past or prior knowledge about the people, you kept on classifying them on the go. As they kept on coming, you kept on classifying them. Yeah, this category of people belong to this group, this category of people belong to that group, and so on. Okay, let's see one more example. Let's suppose you have never seen a football match before, and by chance you watch a video on the internet. Now you can easily classify the players on the basis of different criterion. Like player wearing the same kind of jersey are in one class. Player wearing different kind of jersey are in different class. Or you can classify them on the basis of their playing style. Like the guy is an attacker, so he's in one class. He's a defender, he's in another class. Or you can classify them whatever way you observe the things. So this was also an example of unsupervised learning. Let's move on and see how unsupervised learning is used in the sectors of banking, healthcare, and retail. So starting with banking sector. So in banking sector, it is used to segment customers by behavioral characteristic by surveying prospects and customers to develop multiple segments using clustering. In healthcare sector, it is used to categorize the MRI data by normal or abnormal images. It uses deep learning techniques to build a model that learns from different features of images to recognize a different pattern. Next is the retail sector. In retail sector, it is used to recommend the products to customer based on their past purchases. It does this by building a collaborative filtering model based on the past purchases by them. I assume you guys now have a proper idea of what unsupervised learning means. If you have any slightest doubt, don't hesitate and add your doubt to the comment section. So let's discuss the third and the last type of machine learning, that is reinforcement learning. So what is reinforcement learning? Well, reinforcement learning is a type of machine learning algorithm which allows software agents and machine to automatically determine the ideal behavior within a specific context to maximize its performance. The reinforcement learning is about interaction between two elements, the environment and the learning agent. The learning agent leverages two mechanisms, namely exploration and exploitation. When learning agent acts on trial and error basis, it is termed as exploration. And when it acts based on the knowledge gained from the environment, it is referred to as exploitation. Now, this environment rewards the agent for correct actions, which is reinforcement signal. Leveraging the rewards obtained, the agent improves its environment knowledge to select the next action. In this image, you can see that the machine is confused whether it is an apple or it's not an apple. Then the machine is trained using reinforcement learning. If it makes correct decision, it gets rewards point for it. And in case of wrong, it gets a penalty for that. Once the training is done, now the machine can easily identify which one of them is an apple. Let's see an example. Here we can see that we have an agent who has to judge from the environment to find out which of the two is a duck. The first task he did is to observe the environment. Next, he selects some action using some policy. It seems that the machine has made a wrong decision by choosing a bunny as a duck. So the machine will get penalty for it. For example, minus 50 point for a wrong answer. Right. Now the machine will update its policy and this will continue till the machine gets an optimal policy. From the next time, machine will know that bunny is not a duck. Let's see some of the use cases of reinforcement learning. But before that, let's see how Pavlov trained his dog using reinforcement learning, or how he applied the reinforcement method to train his dog. Pavlov integrated learning in 4 stages. Initially, Pavlov gave meat to his dog, and in response to the meat, the dog started salivating. Next, what he did, he created a sound with the bell. For this, the dog did not respond anything. In the third part, he tried to condition the dog by using the bell and then giving him the food. Seeing the food, the dog started salivating. Eventually, a situation came when the dog started salivating just after hearing the bell, even if the food was not given to him, as the dog was reinforced that whenever the master will ring the bell, he will get the food. Now let's move on and see how reinforcement learning is applied in the field of banking, healthcare, and retail sector. So starting with the banking sector. In banking sector, reinforcement learning is used to create a next best offer model for a call center by building a predictive model that learns over time as user accept or reject offer made by the sales staff. Fine. Now in healthcare sector, it is used to allocate the scarce medical resources to handle different type of ER cases by building a Markov decision process that learns treatment strategies for each type of ER case. Next and the last comes the retail sector. So let's see how reinforcement learning is applied to retail sector. In retail sector, it can be used to reduce excess stock with dynamic pricing by building a dynamic pricing model that adjusts the price based on customer response to the offers.
Let's understand how data science came into existence. Do you guys remember when most of the data was stored in Excel sheets? There were simpler times because we generated lesser data and the data was quite structured. Back then, we used simple BI or business intelligence tools to analyze and process the data. But times have changed. Over 2.5 quintillion bytes of data is created every single day, and this number is only going to grow from here. It is estimated that by 2020, 1.7 MB of data will be created every second for every person on Earth. Can you imagine how much data that is? How are we going to process this much data? Not only that, the data generated these days is mostly unstructured or semi-structured. So in order to process such data, we need more complex and effective algorithms. We need a more advanced field. This is exactly where data science comes in. Data science is all about uncovering findings from data by exploring data at a granular level to mine and understand complex behaviors, trends, and inferences in the data. It's about surfacing hidden insights that can help enable companies to make smarter business decisions. For example, I'm sure all of you have binge watched on Netflix. Now, Netflix data mines movie viewing patterns of its users to understand what drives user interest. And then it uses this data to make decisions on which Netflix series to produce. Similarly, there is Target. Now, Target identifies each customer's shopping behaviors by drawing out patterns from their database. All right, this helps them make better marketing decisions. So guys, before we start comparing between machine learning and data science, let's try to understand the different fields which are covered under data science. Now, data science covers a wide spectrum of domains, including artificial intelligence, machine learning, and deep learning. Data science uses various AI, machine learning, and deep learning methodologies in order to analyze data and then extract useful insights from it. To make things more clear, let me define these terms for you. So artificial intelligence is basically a subset of data science which lets machines to stimulate human-like behavior. Okay, so they try to mimic human-like behavior. Machine learning, on the other hand, is a subfield of artificial intelligence which provides machines the ability to learn automatically and then improve from experiences without being explicitly programmed or without any human intervention. Now, deep learning is a part of machine learning that uses various computational measures and algorithms inspired by the structure and function of the brain called the artificial neural networks. So guys, to conclude, data science involves the extraction of knowledge from data, and in order to do so, it uses a bunch of different methods from various disciplines like machine learning, artificial intelligence, and deep learning. A point to note here is that data science is a wider field and does not exclusively rely on these techniques. Okay, there's a lot more to data science, and in fact, there's a lot more to machine learning, AI, and deep learning than just the data science part. All right. Now that you have a clear distinction between AI, machine learning, and deep learning, let's discuss the use case. Okay, here we'll be seeing how data science and machine learning is used in the working of recommendation engines. So before we start off by comparing data science and machine learning, let's look at what exactly a recommendation engine is. So I'm sure all of you have used Amazon for online shopping. Okay, so guys, have you noticed that when you look for a particular item on Amazon, you get recommendations of similar products, right? So how does Amazon know this? How does it show you items which are relevant to your interests? The reason why companies like Amazon, Walmart, and Netflix are doing so well is because of how they handle the user-generated data. All of these companies are data-driven companies. So the key to their business has always been data, and that's the reason why they're growing so much. Now, a recommendation system basically filters down a list of choices for each user based on their browsing history, based on their ratings, based on their profile details, transactional details, cart details, and so on. Now, such a system is used to get useful insights about customers' shopping patterns. It provides every user a particular view of the e-commerce website based on their profile, okay, and it allows them to select relevant products. For example, if you're looking for a new laptop on Amazon, there is a possibility that you might want to buy a laptop bag too. Now, Amazon will decide this possibility by studying the details of similar transactions. All right, it maps similar transactions together and then it suggests relevant items to you. All right, now let's see how data science and machine learning are used to build a recommendation engine. So guys, this is the entire data science lifecycle. Now, it starts off with the business requirements. Now, before you even start on a data science project, it is very important that you understand the problem that you're trying to solve. All right, so in this stage, you're just going to identify the central objective of your project. In our case, the objective is to build a recommendation engine that will suggest relevant items to each customer based on the data generated by them. Now, the second stage is data acquisition or data gathering. So after you define the objectives of your project, it's time to start gathering the data. This process is also known as data mining. Data mining is basically the process of gathering your data from different sources. Now, one more thing to note here is that data sources can be of two types. There is explicit data and implicit data. Now, when it comes to a recommendation engine, the explicit data includes all the data which is entered by the users, such as the users' ratings and comments on the products. Implicit data is the purchase history, like your cart details, your search history, and all of that comes under implicit data. Now, collecting such data is easy because the users don't have to do any extra work since they're already using this application. All right. Now, the next phase after data acquisition is data processing or data cleaning. So guys, usually you'll never have data stored directly in a database. Okay, if you're very lucky, only then that's going to happen. Otherwise, you'll need to scrape the data. All right, this is where you transform your data into the desired format so that you can read it. Now, data cleaning is considered one of the most time-consuming tasks in data science. According to a recent survey, it was found out that about 50 to 80% of the time goes in data cleaning. All right, this can be a very tedious task because you don't know what are the relevant items and what are the missing values. Okay, so you have to remove all the irrelevant items or all of the inconsistent data. Okay, these inconsistencies have to be identified and fixed in this stage itself. For example, if you're filtering the needful logs from the less needful ones, or if you're trying to identify fake reviews, or if you're trying to remove unnecessary comments or missing values, all of that is dealt with in this stage. All right. So after you're done with your data cleaning and your data processing, your next stage is the data exploration. This is a very critical stage because here you try to understand the patterns in your data and you try to retrieve any useful insights. Now, in our case, since each user might have a different taste or they might have a different opinion about an item, their respective data sets will be different. Okay, so each user will have a different data set depending on his likes and his dislikes. This is how you perform data exploration over here. You need to find patterns or behaviors of a particular customer, and such information is used to grow the business. So only after you know what a customer likes or dislikes, you'll be able to suggest or recommend something to them. All right, this is exactly how data exploration works when it comes to a recommendation engine. You're just going to study the shopping behavior of each customer and then try and suggest relevant items to each customer. All right, now let's move on to the next stage, which is the data modeling stage. So guys, there's this one important thing I want to tell you all. There is no actual distinction between data science and machine learning. In fact, machine learning is a method which is used by data science in order to retrieve useful information. All right, so there's no actual distinction between them, but they do have different processes or they do have different steps in the processes. So the next stage that I'm going to talk about in the data science lifecycle is known as modeling. And at this data modeling stage is where you incorporate machine learning. All right, so basically the entire data modeling stage is the machine learning process. Okay, so let's look at the machine learning process. So guys, the 5 stages that I've defined over here are basically the steps in the data modeling phase. Okay, now in the data modeling phase is where machine learning is implemented. So let's look at how machine learning works, okay, step by step. So there are 5 distinctive stages in machine learning. It begins with importing your data. So guys, the data that we already gathered in the previous stages, you're going to import that data for the machine learning process. Now this data has to be in a readable format. Okay, it can be in the table format, or you can also use formats like the comma separated versions. All right, after you've imported the data, the next step is data cleaning. Now I know that we already performed data processing and data cleaning, but guys, data cleaning is a very iterative process. You cannot just clean everything at once. You'll have to do this repetitively and iteratively. So after you import the data, you might notice a lot of duplicate values or a lot of missing or null values. So such inconsistencies in the data can cause wrongful predictions, okay, and they have to be dealt with or they have to be removed at this stage itself. Now the next stage in machine learning is creating a model. Over here you perform the data splicing. Now data splicing is basically splitting the data set into 2 sets. One is for training your model and the other is for testing your model. Okay, after this you build the model by using the training data set. Now how do you create these models? These models are nothing but your machine learning algorithms like K-nearest neighbor algorithm, support vector machines, linear regression, and so on. So for a problem statement like recommendation engine, you can make use of clustering and classification algorithms. All right, you can make use of the k-nearest neighbor or the k-means algorithm. So after you've built the algorithm and you've built your model, your next stage is going to be model training. So over here, the machine learning model is trained on the training data set. Earlier, I told you that we perform data splicing, wherein we split the data set into the training set and the testing set. So in model training, obviously, you're going to use the training data set. Also, let me tell you that a large portion of the data set is used for training so that the model can learn to map the input to the output on a set of varied values. Next step in machine learning is the model testing. Now, after you've trained the model, it is then evaluated by using the testing data set. At this stage, the model is fed new data points and it must predict the outcome by running the new data points on the machine learning model that was built in the earlier stage. Now, the last stage is improving the efficiency of the model. Right, so after you create the model and you evaluate it using the testing data, its accuracy is calculated. So guys, a lot of methods can be used for improving the accuracy. You can make use of cross-validation techniques and all of that. So after you improve the accuracy and the efficiency of your model, you can finally come back to the last phase of the data lifecycle, which is deployment and optimization. Okay, so the aim of this stage is basically to deploy the model into the production environment. So basically, this is your endpoint wherein you deploy the recommendation engine on your e-commerce website or on any sort of data-driven website. All right. So apart from deploying it to production, you must also check the performance of your model. Okay, so the users must validate the performance of the model. And if there are any issues with the model, then the issues have to be fixed in this stage itself. All right. So guys, that was it for our use case. We basically studied the entire data science lifecycle and the machine learning process. So guys, I want to conclude that data science and machine learning are interconnected. Okay, since machine learning is a part of data science, there isn't much comparison between them. Okay, they are separate cycles, but they are used together. Okay, so machine learning aids data science by providing a suite of algorithms for data modeling, for decision making, or even data preparation. Okay, on the other hand, data science, what it does is it stitches together a bunch of ideas or a bunch of algorithms drawn from machine learning to create a basic solution.
Who is a machine learning engineer? Machine learning engineers are sophisticated programmers who develop machines and systems that can learn and apply knowledge without any specific direction. So they're basically just enthusiastic computer programmers, but their focus goes beyond specifically programming machines to perform tasks. So what they really do is they create programs that will enable machines to take actions without being specifically directed to perform those tasks. Now that we know who a machine learning engineer is, let us talk about what does an ML engineer do. Machine learning engineers are creators of the algorithms that allow a machine to find patterns in its own programming data, teaching it to understand commands and even think for itself. The artificial intelligence seen in automatic vacuums and self-driving cars is the thought children of these engineers. Researching new technologies and implementing them in machine learning programs is one of the many tasks that a machine learning engineer does. Finding the best design and hardware to use when building the robot or computer, developing tangible prototypes to show stakeholders, and also putting the machines through various number of rigorous tests to ensure they function as planned. So by now you must have an idea about what they do and who they are. So now let us understand what are the skills needed to become an ML engineer. The first most important skill is the programming skill. Computer science fundamentals are extremely important for machine learning engineers. They include data structures, algorithms, computability and complexity, and even computer architecture. You must be able to apply, implement, adapt, or address them when programming. Practice problems, coding competitions, and hackathons are a great way to hone your skills. So some of the programming languages that you must be familiar with is R language, Python, Java programming. So R language here is basically used for developing statistical software and data analysis, whereas Python lets you create, analyze, and organize large chunks of data with ease. Also, Java helps in data description. Moving on, the next important skill is probability and statistics. A formal characterization of probability and techniques derived from it are at the heart of many machine learning algorithms. These are a means to deal with uncertainty in the real world. Closely related to this field is of statistics, which provides various measures like mean, median, variance, etc. Also distributions like uniform, normal, binomial, etc. and analysis methods like hypothesis testing that are necessary for building and validating models from observed data is extremely important. Many machine learning algorithms are essentially extensions of statistical modeling procedures. Moving on, the next skill that is really important is understanding data modeling and evaluation. Now, what is data modeling? Data modeling is simply the process of estimating the underlying structure of a given data set with the goal of finding useful patterns like correlations, clusters, etc., and predicting properties of previously unseen instances. A key part of this estimation process is continually evaluating how good a given model is. Depending on the task at hand, you will need to choose an appropriate accuracy or error measure, example log loss for classification, sum of squared errors for regression, etc., and also an evaluation strategy like testing, training, split, sequential versus randomized cross-validation, etc. Iterative learning algorithms often directly utilize resulting errors to tweak the model. Examples are backpropagation for neural networks, so understanding these measures is very important even for just applying standard algorithms. So also applying machine learning algorithms and different libraries are very important. Standard implementations of machine learning algorithms are widely available through libraries or packages or APIs. Some of the examples are TensorFlow, scikit-learn, but applying them effectively involves choosing a suitable model like the decision tree, nearest neighbor, neural net, etc. Also, a learning procedure to fit the data, as well as understanding how hyperparameters affect learning, is really important. You also need to be aware of the relative advantages and disadvantages of different approaches, and also understand how biases and variance works, overfitting and underfitting work, all of the basics of machine learning and how do you apply them. Data science and machine learning challenges such as those on Kaggle are a great way to get exposed to different kinds of problems. Also, to become an ML engineer, you need to understand how software engineering and system design works. So at the end of the day, a machine learning engineer's typical output or deliverable is software. And often it is a very small component that fits into a larger ecosystem of products and services. You need to understand how these different pieces work together, communicate with them, and build appropriate interfaces for your component that others will eventually depend on. Careful system design may be necessary to avoid bottlenecks and let your algorithms scale well with increasing volumes of data. Software engineering best practices, including requirements analysis, system design, modularity, version control, testing, documentation, etc., are invaluable for productivity, collaboration, quality, and maintainability. Now that we have discussed the skills needed to become an ML engineer, let us look at some of the major roles and responsibilities. Now, the first and most important role is to create artificial intelligence products for the team. Well, this is achieved when we're able to create machine learning models of our own, right? What's more important is that we need to build efficient applications. The efficiency plays a really big role here. There are some responsibilities of a machine learning engineer, such as we need to be able to study some prototypes and then transform them into applications. We also have to be able to design and build our own machine learning systems. We have to be in a position where we put in some research to find the appropriate algorithms and tools necessary. And yes, we will be developing machine learning application based on what's required. Also, what's important is to select the right data set and to find the correct data representation methods. We also need to run machine learning tests and experiments to keep improving on our implementation for the use case. And lastly, we need to train the systems for top-notch accuracy. But sometimes you will have to retrain them again based on the changes in the requirement. Well, this sure does seem like a lot for now, but it really isn't that complex. Once you start learning and begin cracking the basics, it's extremely simple. Moving on, let's see some of the salary and trends of a machine learning engineer. According to the 2019 Indeed report, the best jobs in the US and Indian market is the machine learning engineer. What's more interesting is that the role of an ML engineer recorded a whopping 344% increase since 2015. The average salary for a machine learning engineer in India is rupees 6,89,460 rupees, whereas the average salary for a machine learning engineer in the United States of America is $112,000. So that's really a huge amount, right? Moving on, let's talk about some of the companies hiring machine learning engineers. The number of opportunities is exponentially growing, and this is amazing because you'll be trending when you're a machine learning engineer, and obviously you'll be paid really well. Everyone from Apple to Uber, Facebook to Salesforce, all these big players are on a constant ML engineers hiring spear, and they obviously pay really high salaries for this. Now, this takes us to the last part of today's session, that is the future of machine learning. What is perhaps most compelling about machine learning is its seemingly limitless applicability. There are already so many fields being impacted by machine learning, including education, finance, computer science, and much more. There are also virtually no fields to which machine learning does not apply. In some cases, machine learning techniques are in fact desperately needed. Healthcare is an obvious example. Machine learning techniques are already being applied to critical arenas within the healthcare sphere, impacting everyone from care variation reduction efforts to medical scan analysis. The world is unquestionably changing in rapid and dramatic ways, and the demand for machine learning engineers is going to keep increasing exponentially. The world's challenges are complex, and they will obviously require complex systems to solve them. Machine learning engineers are building these systems. If this is your future, then there's no time like the present to start mastering the skills and developing the mindset you're going to need to succeed.
Let me connect you to the real life and tell you what all are the things which you can easily do using the concepts of machine learning. So you can easily get answer to the questions like which types of house lies in this segment, or what is the market value of this house, or is this a mail, a spam, or not a spam? Is there any fraud? Well, these were some of the questions you could ask to the machine. But for getting an answer to these, you need some algorithm. The machine need to train on the basis of some algorithm. Okay, but how will you decide which algorithm to choose and when? Okay, so the best option for us is to explore them one by one. So the first is classification algorithm, where the category is predicted using the data. If you have some question like, is this person a male or a female? Or is this a mail a spam or not a spam? Then these category of question would fall under the classification algorithm. Classification is a supervised learning approach in which the computer program learns from the input given to it and then uses this learning to classify new observation. Some examples of classification problems are speech recognition, handwriting recognition, biometric identification, document classification, etc. Shall we move ahead? Okay. So next is the anomaly detection algorithm, where you identify the unusual data point. So what is anomaly detection? Well, it's a technique that is used to identify unusual patterns that do not conform to expected behavior, or you can say the outliers. It has many applications in business, like intrusion detection, like identifying strange patterns in the network traffic that could signal a hack, or system health monitoring, that is spotting a deadly tumor in the MRI scan. Or you can even use it for fraud detection in credit card transaction, or to deal with fault detection in operating environment. So next comes the clustering algorithm. And you can use this clustering algorithm to group the data based on some similar condition. Now you can get answer to which type of houses lies in this segment, or what type of customer buys this product. The clustering is the task of dividing the population or data points into a number of groups such that the data point in the same groups are more similar to other data points in the same group than those in the other groups. In simple words, the aim is to segregate groups with similar trait and assign them into cluster. Now this clustering is a task of dividing the population or data points into a number of groups such that the data points in the X group is more similar to the other data points in the same group rather than those in the other group. In other words, the aim is to segregate the groups with similar traits and assign them into different clusters. Let's understand this with an example. Suppose you're the head of a rental store and you wish to understand the preference of your customer to scale up your business. So is it possible for you to look at the detail of each customer and design a unique business strategy for each of them? Definitely not, right? But what you can do is to cluster all your customer, say into 10 different groups based on their purchasing habit, and you can use a separate strategy for customers in each of these 10 different groups. And this is what we call clustering. Next, we have regression algorithm, where the data itself is predicted. Question you may ask to this type of model is like, what is the market value of this house? Or is it going to rain tomorrow or not? So regression is one of the most important and broadly used machine learning and statistics tool. It allows you to make prediction from data by learning the relationship between the features of your data and some observed continuous valued response. Regression is used in a massive number of applications. You know what? Stock prices prediction can be done using regression. Now you know about different machine learning algorithm. How will you decide which algorithm to choose and when? So let's cover this part using a demo. So in this demo part, what we'll do, we'll create 6 different machine learning models and pick the best model and build the confidence such that it has the most reliable accuracy. So for our demo part, we'll be using the Iris dataset. This dataset is quite very famous and is considered one of the best small projects to start with. You can consider this as a hello world dataset for machine learning. So this dataset consists of 150 observation of iris flower. There are 4 columns of measurement of flowers in centimeters, the 5th column being the species of the flower observed. All the observed flowers belong to one of the 3 species of Iris setosa, Iris virginica, and Iris versicolor. Well, this is a good project because it is so well to understand. The attributes are numeric, so you have to figure out how to load and handle the data. It is a classification problem, thereby allowing you to practice with perhaps an easier type of supervised learning algorithm. It has only 4 attributes and 150 rows, meaning it is very small and can easily fit into the memory. And even all of the numeric attributes are in the same unit and the same scale. It means you do not require any special scaling or transformation to get started with. So let's start coding, and as I told earlier, for the demo part, I'll be using Anaconda with Python 3.0 installed on it. So when you install Anaconda, how your navigator would look like. So this is my homepage of my Anaconda navigator. On this, I'll be using the Jupyter Notebook, which is a web-based interactive computing notebook environment, which will help me to write and execute my Python codes on it. So let's hit the launch button and execute our Jupyter Notebook. So as you can see that my Jupyter Notebook is starting on localhost 8890. Okay, so this is my Jupyter Notebook. What I'll do here, I'll select new notebook Python 3. This is my environment where I can write and execute all my Python codes on it. So let's start by checking the version of the libraries. In order to make this video short and more interactive and more informative, I've already written the set of code. So let me just copy and paste it down. I'll explain you then one by one. So let's start by checking the version of the Python libraries. Okay, so there's the code. Let's just copy it, and let's paste it. Okay, first let me summarize things for you. What we are doing here, we are just checking the version of the different libraries. Starting with Python, we'll first check what version of Python we are working on. Then we'll check what are the version of SciPy we are using. Then NumPy, Matplotlib, then Panda, then scikit-learn. Okay, so let's execute the run button and see what are the various versions of the libraries which we are using. Hit the run. So we are working on Python 3.6.4, SciPy 1.0, NumPy 1.14, Matplotlib 2.12, Pandas 0.22, and scikit-learn of version 0.19. Okay, so these are the version which I'm using. Ideally, your version should be more recent or it should match. But don't worry if you lag few versions behind, as the APIs do not change so quickly. Everything in this tutorial will very likely still work for you. Okay, but in case you are getting an error, stop and try to fix that error. In case you are unable to find the solution for the error, feel free to reach out Edureka even after this class. Let me tell you this, if you're not able to run the script properly, you will not be able to complete this tutorial. Okay, so whenever you get a doubt, reach out to Edureka and just resolve it. Now, if everything is working smoothly, then now it's the time to load the dataset. So as I said, I'll be using the Iris flower dataset for this tutorial. But before loading the dataset, let's import all the modules, function, and the object which we are going to use in this tutorial. Same, I've already written the set of code, so let's just copy and paste them. Let's load all the libraries. So these are the various libraries which we'll be using in our tutorial. So everything should work fine without an error. If you get an error, just stop. You need to work on your SciPy environment before you continue any further. So I guess everything should work fine. Let's hit the run button and see. Okay, it worked. So let's now move ahead and load the data. We can load the data direct from the UCI machine learning repository. First of all, let me tell you, we are using Panda to load the data. Okay, so let's say my URL is this. So this is my URL for the UCR machine learning repository from where I'll be downloading the data set. Okay. Now what I'll do, I'll specify the name of each column when loading the data. This will help me later to explore the data. Okay. So I'll just copy and paste it down. Okay. So I'm defining a variable names which consist of various parameters including sepal length, sepal width, petal width, and class. So these are just the name of column from the data set. Okay. Now let's define the data set. So dataset equals panda.read underscore CSV. Inside that, we are defining URL and the names that is equal to name. As I already said, we'll be using panda to load the data. All right. So we are using panda.read CSV. So we are reading the CSV file, and inside that, from where that CSV is coming from the URL. Which URL? So this is my URL. Okay. And names equal names. It's just specifying the names of that various columns in that particular CSV file. Okay. So let's move forward and execute it. So even our data set is loaded. In case you have some network issues, just go ahead and download the iris data file into your working directory and load it using the same method. But yeah, make sure that you change the URL to the local name or else you might get an error. Okay. Yeah, data set is loaded. So let's move ahead and check our data set. Let's see how many columns or rows we have in our data set. Okay. So let's print the number of rows and columns in our data set. So our data set is dataset.shape. What this will do, it will just give you the numbers of total number of rows and total number of column, or you can say the total number of instances or attributes in your data set. Fine. So print dataset.shape. What you're getting? 150 and 5. So 150 is the total number of rows in your data set and 5 is the total number of columns. Fine. So moving on ahead, what if I want to see the sample data set? Okay. So let me just print the first 30 instances of the data set. Okay. So print dataset.head. What I want is the first 30 instances. Fine. This will give me the first 30 result of my data set. Okay. So when I hit the run button, what I'm getting is the first 30 result. Okay. 0 to 29. So this is how my sample data set looks like. Sepal length, sepal width, petal width, and the class. Okay. So this is how our data set looks like. Now let's move on and look at the summary of each attribute. What if I want to find out the count, mean, the minimum and the maximum values and some other percentiles as well? So what should I do then? For that, print dataset.describe. What it will give, let's see. So you can see that all the numbers are the same scales of similar range between 0 to 8 centimeters, right? The mean value, the standard deviation, the minimum value, the 25 percentile, 50 percentile, 75 percentile, the maximum value, all these values lies in the range between 0 to 8 centimeter. Okay. So what we just did is we just took a summary of each attribute. Now let's look at the number of instances that belong to each class. So for that, what we'll do, print dataset first of all. So let's print dataset and I want to group it, group by using class, and I want the size of it, size of each class. Fine. And let's hit the run. Okay, so what I want to do, I want to print what? Data set. How I want to get it? I want it by class. So group by class. Okay, now I want the size of each class. Find the size of each class. So group by class dot size. Execute the run. So you can see that I have 50 instances of iris setosa, 50 instances of iris versicolor, and 50 instances of iris virginica. Okay, all are of data type integer of base 64. Fine. So now we have a basic idea of our data. Now let's move ahead and create some visualization for it. So for this, we are going to create two different types of plot. First would be the univariate plot and the next would be the multivariate plot. So we'll be creating univariate plots to better understand about each attribute. And the next we'll be creating the multivariate plot to better understand the relationship between different attributes. Okay, so we start with some univariate plot. That is plot of each individual variable. So given that the input variables are numeric, we can create box and whiskers plot for it. Okay, so let's move ahead and create a box and whiskers plot. So dataset.plot, what kind I want? It's a box. Okay, and do I need a subplot? Yeah, I need subplots for that. So subplots equal true. What type of layout do I want? So my layout structure is 2 cross 2. Next, do I want to share my coordinates, x and y coordinates? No, I don't want to share it. So share x equal false, and even share y, that too equals false. Okay, so we have here dataset.plot kind equal box. My subplot says true, layout 2 cross 2. And then what I want to do it, I want to see it. So plot dot show, whatever I created, show it. Okay, execute it. Now this gives us a much clearer idea about the distribution of the input attribute. Now what if I had given the layout to 2 cross 2? Instead of that, I would have given it 4 cross 4. So what it will result? Just see. Fine. Everything would be printed in just one single row. Hold on guys, Arya has a doubt. He's asking that why we are using the share x and share y values. What are these? Why we have assigned false values to it? Okay Arya, so in order to resolve this query, I need to show you what will happen if I give true values to them. Okay, so be with me. So share x equal true and share y that equals true. So let's see what result we'll get. You're getting it. The x and y coordinates are just shared among all the 4 visualization, right? So Arya, you can see that the sepal length and sepal width has y values ranging from 0.0 to 7.5, which are being shared among both the visualization. So is with the petal length, it has a shared value between 0.0 to 7.5. Okay, so that is why I don't want to share the value of x and y. So it's just giving us a cluttered visualization. So Arya, why I'm doing this? I'm just doing it because I don't want my x and y coordinates to be shared among any visualization. Okay, that is why my share x and share y value are false. Okay, let's execute it. So this is a pretty much clear visualization which gives a clear idea about the distribution of the input attributes. Now if you want, you can also create a histogram of each input variable to get a clear idea of the distribution. So let's create a histogram for it. So dataset.hist. Okay, I would need to see it. So plot.show. Let's see. So there's my histogram, and it seems that we have 2 input variables that have a Gaussian distribution. So this is useful to note as we can use the algorithms that can exploit this assumption. Okay, so next comes the multivariate plot. Now that we have created the univariate plot to understand about each attribute, let's move on and look at the multivariate plot and see the interaction between the different variables. So first, let's look at the scatter plot of all the attributes. This can be helpful to spot structured relationship between input variables. Okay, so let's create a scatter matrix. So for creating a scatter plot, we need scatter matrix, and we need to pass our data set into it. Okay, and then what I want to see it. So plot.show. So this is how my scatter matrix looks like. It's like that the diagonal grouping of some pair, right? So this suggests a high correlation and a predictable relationship. All right, this was our multivariate plot. Now let's move on and evaluate some algorithm. Now it's time to create some model of the data and estimate their accuracy on the basis of unseen data. Okay, so now we know all about our data set, right? We know how many instances and attributes are there in our data set. We know the summary of each attribute. Now I guess we have seen much about our data set. Now let's move on and create some algorithm and estimate their accuracy based on the unseen data. Okay, now what we'll do, we'll create some model of the data and estimate their accuracy based on some unseen data. Okay, so for that, first of all, let's create a validation data set. What is a validation data set? Validation data set is your training data set that will be using it to train our model. Fine. All right, so how we'll create a validation data set? For creating a validation data set, what we are going to do is we are going to split our data set into 2 parts. Okay, so the very first thing we'll do is to create a validation data set. So why do we even need a validation data set? So we need a validation data set to know that the model we created is any good. Later, what we'll do, we'll use the statistical method to estimate the accuracy of the model that we create on the unseen data. We also want a more concrete estimate of the accuracy of the best model on unseen data by evaluating it on the actual unseen data. Okay, confused? Let me simplify this for you. What we'll do, we'll split the loaded data into 2 parts. The first 80% of the data, we'll use it to train our model, and the rest 20% will hold back as the validation data set that will use it to verify our trained model. Okay, fine. So let's define an array. This is my array. What it will consist of? It will consist of all the values from the dataset. So dataset dot values. Okay. Next, I'll define a variable x, which will consist of all the column from the array from 0 to 4, starting from 0 to 4. And the next variable y, which would consist of the array starting from this. So first of all, we'll define a variable x that will consist of the values in the array starting from the beginning 0 till 4. Okay, so these are the column which will include in the x variable. And for a y variable, I'll define it as a class or the output. So what I just need the 4th column, that is my class column. So I'll start it from the beginning and I just want the 4th column. Okay, now I'll define my validation size. Validation underscore size. I'll define it as 0.20 and I'll use a seed. I'll define seed equals 6. So this method seed sets the integer starting value used in generating random number. Okay, I'll define the value of seed equals 6. I'll tell you what is the importance of it later on. Okay, so let me define first few variables such as x underscore train test, y underscore train, and y underscore test. Okay, so what we want to do is select some model. Okay, so model underscore selection. But before doing that, what we have to do is split our training data set into 2 halves. Okay, so dot train underscore test underscore split. What we want to split is the value of x and y. Okay, and my test size is equals to validation size, which is a 0.20, correct? And my random state is equal to seed. So what the seed is doing here, it's helping me to keep the same randomness in the training and testing data set. Fine. So let's execute it and see what is our result. It's executed. Next, we'll create a test harness. For this, we'll use 10-fold cross validation to estimate the accuracy. So what it will do, it will split our data set into 10 parts. Train on the 9 part and test on the 1 part. And this will repeat for all combination of train and test splits. Okay. So for that, let's define again my seed that was 6 already defined, and scoring equals accuracy. Fine. So we are using the metric of accuracy to evaluate the model. So what is this? This is a ratio of number of correctly predicted instances divided by the total number of instances in the data set multiplied by 100, giving a percentage. Example, it's 98% accurate or 99% accurate, things like that. Okay. So we'll be using this scoring variable when we run the build and evaluate each model in the next step. So our next part is building model. Till now, we don't know which algorithm would be good for this problem or what configuration to use. So let's begin with 6 different algorithms. I'll be using logistic regression, linear discriminant analysis, k-nearest neighbor, classification and regression trees, neighbors, and code vector machine. Well, these algorithms which I'm using is a good mixture of simple linear or non-linear algorithms. In simple linears, which included the logistic regression and the linear discriminant analysis, or the non-linear part, which included the KNN algorithm, the CART algorithm, the neighbors, and the support vector machines. Okay, so we reset the random number seed before each run to ensure that evaluation of each algorithm is performed using exactly the same data splits. It ensures the results are directly comparable. Okay, so let me just copy and paste it. Okay. So what we are doing here, we are building 5 different types of model. We are building logistic regression, linear discriminant analysis, k-nearest neighbor, decision tree, Gaussian neighbors, and the support vector machine. Okay. Next, what we'll do, we'll evaluate model in each turn. Okay. So what is this? So we have 6 different model and accuracy estimation for each one of them. Now we need to compare the model to each other and select the most accurate of them all. So running this script, we saw the following result. So we can see some of the result on the screen. What is this? It is just the accuracy score using different set of algorithms. Okay, when we are using logistic regression, what is the accuracy rate? When we are using linear discriminant algorithm, what is the accuracy, and so and so. Okay. So from the output, it seems that LDA algorithm was the most accurate model that we tested. Now we want to get an idea of the accuracy of the model on our validation set or the testing data set. So this will give us an independent final check on the accuracy of the best model. It is always valuable to keep a testing data set for just in case you made an overfitting to the testing data set or you made a data leak. Both will result in an overly optimistic result. Okay. You can run the LDA model directly on the validation set and summarize the result as a final score, a confusion matrix, and a classification report.
Let us understand what regression in machine learning is. So what exactly is regression? The main goal of regression is the construction of an efficient model to predict the dependent attributes from a bunch of attribute variables. A regression problem is where the output variable is either real or a continuous value like salary, weight, area, etc. We can also define regression as a statistical means that is used in applications like housing, investing, etc. to predict the relationship between a dependent variable and a bunch of independent variables. For example, let's say in the finance application or investing, we can actually predict the values of certain stock prices or those values depending on the independent variables like how many years it takes for a stock to actually mature or how many days will it take to grow or those variables that you have in investing, and depending upon that we can make a possible outcome or a possible prediction of how our stock is going to be invested in a profit state or a loss state or all those things. Or we can take another example like housing. We can take different parameters like number of years it's been there, how many people have used it, or what is the area of the house. Depending on all these factors or how many rooms does a house have, we can predict the price of a house. So this is basically what regression really is. So let us take a look at the various types of regression techniques that we have. We have simple linear regression, then we have polynomial regression, support vector regression, decision tree regression, we have random forest regression, and we have logistic regression as well. That is also a type of regression that we have. But for now, we'll be focusing on simple linear regression. So let's talk about how or what exactly is simple linear regression first. So one of the most interesting and common regression technique is simple linear regression. In this, we predict the outcome of a dependent variable y based on the independent variables x. So the relationship between the variables is linear, hence the word linear regression. Then comes the polynomial regression. So in this regression technique, we transform the original features into a polynomial feature of a given degree and then perform regression on it. So this is basically polynomial regression. After this, we have support vector machine regression, or we can also call it SVR. We identify a hyperplane with maximum margin such that the maximum number of data points are within those margins. It is also quite similar to the support vector machine classification algorithm. Then we have decision tree regression. A decision tree can be used for both regression and classification. But in this case of regression, we use the ID3 algorithm, which is iterative dichotomizer 3, to identify the splitting node by reducing the standard deviation. After this, we have a random forest regression, which is basically an ensemble of predictions of several decision tree regressions. So this is all about the types of regressions. For now, we are going to focus on simple linear regression. So let's take a look at what exactly is a simple linear regression. Simple linear regression is a regression technique in which the independent variable has a linear relationship with the dependent variable. The straight line in the diagram is the best fit line, and the main goal of the simple linear regression is to consider the given data points and plot the best fit line to fit the model in the best way possible. So if we talk about a real life analogy to explain linear regression, we can take an example of a car resale value. So we have different parameters, when we are talking about a resale value of a car, like how many years the car has been there in the market and how many kilometers it has been ridden, the kind of mileage the car gives, and then we have different parameters we can focus upon, and all these independent variables somehow are linearly connected or interconnected to the price of the car. So that is one example to understand linear regression. We'll be doing that in the use case. I'll be telling you about how you can predict the price of car. Now talking about linear regression terminologies, there are a few terminologies that you have to be thorough with to begin with linear regression. So first of all, we have to talk about cost function. So the best fit line can be based on the linear equation that is given here. So in this, the dependent variable that is to be predicted is denoted by y. A line that touches the y-axis is denoted by the intercept b0. The b1 is the slope of the line, and x represents the independent variables that determine the prediction of y. The error in the resultant prediction is denoted by e. Now talking about cost function, the cost function provides the best possible values for b0 and b1 to make the best fit line for the data points. We do this by converting this problem into a minimization problem to get the best values for b0 and b1. So with this, the error is minimized in this problem between the actual value and the predicted value, and we choose the function above to minimize. Now we square the error difference and sum the error over all the data points. The division between the total number of data points and the produced value provides the average square error for all the data points. It is also known as mean squared error, and we can change the values of b0 and b1 so that the MSE or the mean squared error value is settled at the minimum. So this is one terminology, that is cost function, that we use in linear regression. Then we have the gradient descent. So the next important terminology to understand linear regression is gradient descent, of course, and it is a method of updating b0 and b1 value to reduce the MSE, which is the mean squared error. The idea behind this is to keep iterating the b0 and b1 values until we reduce the MSE to the minimum. Now to update b0 and b1, we take the gradients from the cost function, and to find these gradients, we take partial derivatives with respect to b0 and b1. And these partial derivatives are the gradients and are used to update the values of b0 and b1. I'm sure guys this might be a little confusing for you guys if you are new to this, like gradient descent and cost function, but you don't have to worry about this, because in Python when we're using linear regression, we're going to be using the sklearn or the scikit-learn library, so you don't have to worry about this. You just have to integrate your model with the linear regression module that we have already over there, and you will be done with it. And when I'm implementing the linear regression model, you'll see how easy it is to actually implement linear regression in Python. So after this, let's talk about a few advantages and disadvantages of linear regression. So talking about the advantages first, linear regression performs exceptionally well for linearly separable data. And it is actually very easy to implement, interpret, and very efficient to train as well. And even though the linear regression is prone to overfitting, it handles it pretty well using dimensionally reduction techniques, regularization, and cross-validation. And one more advantage is that the extrapolation beyond a specific data set. So these are all the advantages that we have with linear regression. Let's talk about a few disadvantages as well. So one of the most common disadvantage with linear regression is that it takes the assumption of linearity between dependent and independent variables. The next disadvantage is it is often very prone to noise and overfitting as well, which is not a very good sign for any model if you are doing regression or classification in machine learning. The next disadvantage is it is very quite sensitive to outliers as well. And the last one is that it is very prone to multicollinearity. So these are all the advantages and disadvantages of linear regression. Now let's also take a look at a few use cases that we can use linear regression for. So we can use it for sales forecasting. Depending upon the features, like we can actually predict the price of a item, or in sales we can forecast the price or make assumptions over there, like predictions obviously. Then we can use it for risk analysis for disease predictions. Like we can take a disease data set, and depending upon several features that are linearly connected with one risk detection, we can use it for risk analysis as well. We can obviously use it for housing applications to predict the prices and other factors, like what are the different aspects that are going to be decisive in the price of a house. All those features using the linear regression. And then of course we can use it for finance applications to predict the stock prices, investment evaluation, etc. The basic idea behind linear regression is to find the relationship between the dependent and independent variables to get the best fitting line that would predict the outcome with the least error. So we can use linear regression in simple real life situations as well, like predicting the SAT scores with regard to the number of hours of study and other decisive factors that we can use it for. Now that we are done with the use cases as well, let's take a look at specific use case that I'm going to show you in sklearn or scikit-learn library. And we're going to implement the linear regression model over there. So let me take you through the steps that are going to take place over there. So first of all, we are going to load the data. After that, we'll explore the data. So we'll take a look at how our data is, what are the different features, and what are the data points that we have in the data set. After that, we'll slice the data according to our requirements. And then we'll train and split the data using the fit and predict method that we have in scikit-learn. And then we'll generate the model from the scikit-learn. And after we are done making the model, we'll evaluate the accuracy. So let's take it up to PyCharm, guys. I'll show you a very simple example first of all with the diabetes dataset that we have in scikit-learn. We can simply import it from the datasets module that we have in scikit-learn. And after this simple example, I'm going to show you a custom dataset that is a car resale value, and we're going to predict some prices for car resale values. So without wasting any more time, let's take it up to PyCharm. So now that we're in PyCharm, guys, we'll try to implement linear regression using simple dataset that we have in sklearn library. So first of all, we'll have to import basic libraries like matplotlib. I'll make it a little bigger for visibility. So first I'll import matplotlib.pyplot as, let's say, plt. And after that, I'll import numpy as np. So from sklearn, we'll have to import datasets because we are going to use the dataset from the datasets module. And we are going to import linear model as well for linear regression. Yeah, I made a mistake over here. And again, we have to import metrics for accuracy evaluation, and we'll be importing mean squared error. So these are all the libraries that I'm going to use to show you how you can implement linear regression. But before that, don't make a mistake of using these libraries just as it is, because I have already installed all these libraries. So for that, you can just go to the project interpreter that you'll find in the settings. And over here, you can just install all the packages that you need. So this is the add button. There you can add all the libraries that you need. So for sklearn, you can just type sklearn and install that library. I'm not doing that again because I've already done it. So after this, first thing that you have to do is import your dataset. So for that, I'm taking a variable disease and datasets dot load datasets, or I'm just going to load diabetes because that's the dataset that we are going to use in this. And let's just see what all we have in the dataset that we have over here. So I'm just going to print this to know what all we are dealing with right now. So it's going to take a while. So this is our dataset, guys. We already have our data over here. I'm sure we'll be having a target. We have a description over here. So this is our dataset, guys. We have a target also. So this is a very sliced up data, which is actually pretty good for our use right now because I'm showing you a simple implementation of linear regression. So this is going to be very easy. So what I'll do is I'll comment this line because we don't need this right now. And after this, I'll just take one more variable. Let's just say disease X. And inside this, I am going to take disease.data. Now after this, I'm going to split my data into train and test. So what I'll do is I'll just write disease X. After this, I'll write train. And let me take another variable, that is the X test. And we'll have to take this same variable for Y as well because we need two variables. So I'll take it as Y, train, and disease Y test. Now inside this, I'll have to split my data into training and testing data. So I'll use the disease over here, or we can just call it data also, disease X. And I'm going to split the data from the starting until -30. So I'll leave the last 30 data entries inside the data set, which I'm going to use in the training set. So I'll use for the training set the -20, that is from the last, the 20 entries that we have over here. And similarly, in the same thing, we are going to do for the Y train and Y test as well. So over here, I'll just write Y. So before doing this, I'm just going to make it as target because we're using the target variable over here, disease.target again. And in this, I am going to use the last 20 entries. So we have successfully split our data. Now what happens is, after splitting your data, you have to generate your model. For that, I'm just going to take one variable. So I'm just going to take it as reg, or regression. We can call it as regression as well. So I'm going to use linear model, and I'm going to call linear regression. So this is how you can generate your model. So after this, you have to fit your training data inside the model using the fit function. So I'll use fit over here, and to fit the data, I'm going to use disease X train that has the data variables, all those values that we have over here. That is this one. This array is going to be in the training one, and we're going to use the target one for the disease Y. So I'll just do that. Disease X train and disease Y train as well. So we're done. After this, I have to make a prediction variable as well. I'll make it as Y predict. And inside this, I am going to use the predict function. So for this, we are going to use the disease X test because this is what we are testing right now. So our model is actually done, guys. I'll just write some code for checking the accuracy as well. So I'll use the mean squared error over here. And inside this, I'll pass disease Y test and the Y predict that we are going to get after the prediction. So we're almost done. After this, I'll print the accuracy as well, whatever we will get. And let's just print the weights and the coefficients as well. So let's just say weights is equal to reg dot. So you have a function for this as well to calculate the coefficient, that is the weights, and intercept as well. So I'll name it as intercept and reg dot intercept. We'll print these as well, weights and intercept. So our model is done, guys. So we have successfully used all these libraries. We have loaded the data set, and after that we have generated the model by splitting the data and everything. So I'll just run this code and see what the output is. Okay, so we have the accuracy, that is a mean square error, that is 2004, and then we have the intercept and the weights as well. So this might sound a bit confusing for you guys. So I'll just add a few things over here to make you understand this better. So what I'll do is I'll make a few changes over here. So I'll just write it like np dot new axis. I'll write it as 2 over here, and we'll plot the graph also. So for that I'll just write plot scatter. Inside this I'll use disease dot x test, disease dot y test, plt dot plot for the line, and inside this I'm going to use disease x test and y predict. So now when I run my code, you will be able to see the graph which will have the data entries, and you'll be able to see the graph which has the data points, and there'll be an intercept as well with a line plotted, which is the best fit line over here. Okay, we have not written plt.show, that's why we're not getting the graph. Now it should be fine, and we'll be able to see the graph as well. So this is our best fit line, guys. So we have successfully implemented linear regression using Python for this disease dataset. But to do this, I had to segregate this data all separately. And if you implement it using all the columns that you have in over here in the data, it's not going to be fine. I mean, it's going to throw you an error and will not show you a best fit line. So now that we are done with this one, I'll show you one more use case. Inside we are going to use the custom data set which has the car resale values. So let's get it done. So I'll just remove all this. So first of all, I will import, as you can see over here in the directory, guys, you can already see this cars.csv. This is my custom data set that I'm going to use inside this one. So I'll just import numpy as np, import pandas. Because we are using a custom data set, I'm going to have to use pandas to import or to actually load the CSV file that I have over there. And after this, I'll use matplotlib.pyplot as plt, and from sklearn linear model, we are going to use linear regression. And after this, I'll just import sklearn.metrics and import the R2 score, or we're not going to use that, so I'll just remove this one for now, and we'll use import stats model. We'll leave this one for later as well. So first of all, I have to load the data, so I'm naming it as cars. So for this, I'll just write pd.read csv, and if you don't know how you can import the CSV files, the custom made CSV files inside your program, you can check out other tutorials on Edureka. So we have a tutorial in detail how you can read CSV files. So first of all, let me just get a quick exploration of the data what we have over here. So I'll just write the print statement. I'll get the head. So this is what my data set looks like, guys. It's loading still. So we have all these values, and to get the better picture over here, I'll try to print the columns as well. So I'll just write cars.columns. So it will give me the name of all the columns that I have in this data set. Okay, so we have all these values, sales in thousands, we have a 4-year resale value, then we have price in thousands, and we have engine size, horsepower, wheelbase, width, length, then we have curb weight, we have fuel capacity, fuel efficiency as well. Okay, so this is what our data looks like, guys. So let me just plot a graph first of all. So I'll just write plt, and we're going to use the figure size. For figure size is equal to, let's just say, 16 by 8, and after this I will use a scatter plot, and inside this I'm going to give a few values. So I'm going to use cars. So first of all, I want to check the relationship between a horsepower, and then I'll check what is the relation between a horsepower and the price of the car, which is in thousands, of course. And let's just get it as black. Yes, and let's just put a few labels as well. So X label is going to be, let's say, horsepower, and we will write the y label as, let's just say, price. And let's just plot this graph for now. Okay, I'll put it over here only. Now when I run this, let's see what I'm getting over here. Okay, so I'm getting a graph like this. So you can see all the data points, and as we go further, the values are actually increasing. We're not getting the y labels over here somehow. I think there's some problem. I'll just check it out. Okay, we leave it for now, and let's check the image of over here. So on the x-axis we have the horsepower, which is going until 450. So a car with the horsepower 450 is ranging around 70,000. That is the price, and that's going to be in dollars, guys. And all these values, like a 150 horsepower car, it's going to be around 20,000 bucks, and a simple 50 horsepower car is going to be around 10,000 bucks. So this is our data, guys. I think it's pretty evident that we have a relation between a horsepower and the price of the car that we are actually looking at right now. So we'll build a model around this for now. So I'll take one variable, let's just say x, and inside this I'm going to put cars horsepower, because we are going to take horsepower as our independent variable. And all these values, I'm going to reshape them into -1 and 1. I'm going to take one more independent variable y. That's going to be my price in thousands, guys. I'm going to do the reshaping again. It's just basically to avoid the errors, guys. The reshaping that I'm doing over here. And I'll just generate my model right now. So I'll use linear regression. And after this, I'll try to fit my x and y over here using the fit method. So just write x and y. Now I'm going to print the coefficient using the coefficient function that I've shown you before. I'm going to take the values as 0 and 0. Again, for the same thing, I want the intercept as well. So instead of coefficient, I'll write as intercept, and I'll remove this one. After this, let's make one variable, let's just say predictions. That's going to store the predicted value, and we're going to use the predict function over here. So I'm just going to put x over here in the predict function, and let's just plot a graph again. So I'll write figure size, again let's just take 16:8. We'll use the scatter plot again. We'll just write it again. So first of all, we have cars and horsepower. Then we have cars, price in thousands. After this, I'm just going to write c is equal to black. Now we have one more plot for the line, so I'm going to use plt.plot. Inside this we'll have cars horsepower. We'll use the predictions as well, and let's just make it blue. We'll put the label again. So the x label is going to be the horsepower, and the y label is going to be prices, or just price. I'll write plt.show. Now when I run this, I should be getting okay, we'll get the first plot before getting the second plot. So we have a plot like this. So actually the horsepower is over here, that is going up till 450 horsepower, and this is actually our price. Now when I close this, okay, I've made a mistake somewhere. Okay, this is actually, now when I run this again, it should be fine. I'll close this, and after this, Okay, so I've got the mistake that I was making. So before running this program, I'll add the line width as well. And let's just run this again. So first I'm getting this, which is horsepower right here, and we have the price right over here. After this, let's see. So we have a best fit line over here, as you can see, guys. So this is a simple linear regression implementation on a custom data set.
So let's understand the what and why of logistic regression. Now this algorithm is most widely used when the dependent variable, or you can say the output, is in the binary format. So here you need to predict the outcome of a categorical dependent variable. So the outcome should be always discrete or categorical in nature. Now by discrete, I mean the value should be binary, or you can say you just have two values. It can either be 0 or 1. It can either be yes or a no, either be true or false, or high or low. So only these can be the outcomes. So the value which you need to predict should be discrete, or you can say categorical in nature. Whereas in linear regression, we have the value of y, or you can say the value you need to predict is in a range. So that is how there is a difference between linear regression and logistic regression. Now you must be having a question, why not linear regression? Now guys, in linear regression, the value of y, or the value which you need to predict, is in a range. But in our case, as in the logistic regression, we just have two values. It can be either 0 or it can be 1. It should not entertain the values which is below 0 or above 1. But in linear regression, we have the value of y in the range. So here, in order to implement logistic regression, we need to clip this part. So we don't need the value that is below 0, or we don't need the value which is above 1. So since the value of y will be between only 0 and 1, that is the main rule of logistic regression, the linear line has to be clipped at 0 and 1. Now once we clip this graph, it would look somewhat like this. So here you are getting a curve which is nothing but three different straight lines. So here we need to make a new way to solve this problem. So this has to be formulated into an equation, and hence we come up with logistic regression. So here the outcome is either 0 or 1, which is the main rule of logistic regression. So with this, our resulting curve cannot be formulated. So hence our main aim to bring the values to 0 and 1 is fulfilled. So that is how we came up with logistic regression. Now here, once it gets formulated into an equation, it looks somewhat like this. So guys, this is nothing but a S curve, or you can say the sigmoid curve or sigmoid function curve. So this sigmoid function basically converts any value from minus infinity to infinity to your discrete values, which a logistic regression wants, or you can say the values which are in binary format, either 0 or 1. So if you see here, the values are either 0 or 1, and this is nothing but just a transition of it. But guys, there's a catch over here. So let's say I have a data point that is 0.8. Now, how can you decide whether your value is 0 or 1? Now, here you have the concept of threshold, which basically divides your line. So here threshold value basically indicates the probability of either winning or losing. So here by winning, I mean the value is equals to 1, and by losing, I mean the value is equals to 0. But how does it do that? Let's say I have a data point which is over here. Let's say my cursor is at 0.8. So here I'll check whether this value is less than my threshold value or not. Let's say if it is more than my threshold value, it should give me the result as 1. If it is less than that, then it should give me the result as 0. So here my threshold value is 0.5. Now I need to define that if my value, let's say 0.8, it is more than 0.5, then the value shall be rounded off to 1. And let's say if it is less than 0.5, let's say I have a value 0.2, then should reduce it to 0. So here you can use the concept of threshold value to find your output. So here it should be discrete, it should be either 0 or it should be 1. So I hope you caught this curve of logistic regression. So guys, this is the sigmoid S curve. So to make this curve, we need to make an equation. So let me address that part as well. So let's see how an equation is formed to imitate this functionality. So over here we have an equation of a straight line, which is y is equals to mx plus c. So in this case, I just have only one independent variable. But let's say if we have many independent variables, then the equation becomes m1x1 plus m2x2 plus m3x3 and so on till mnxn. Now let us put in b and x. So here the equation becomes y is equals to b1x1 plus b2x2 plus b3x3 and so on till bnxn plus c. So guys, your equation of the straight line has a range from minus infinity to infinity. But in our case, or you can say in logistic equation, the value which we need to predict, or you can say the y value, it can have the range only from 0 to 1. So in that case, we need to transform this equation. So to do that, what we had done, we have just divided the equation by 1 minus y. So now our y is equals to 0. So 0 over 1 minus 0 which is equals to 1. So 0 over 1 is again 0. And if we take y is equals to 1, then 1 over 1 minus 1 which is 0. So 1 over 0 is infinity. So here my range is now between 0 to infinity. But again we want the range from minus infinity to infinity. So for that what we'll do, we'll have the log of this equation. So let's go ahead and have the logarithmic of this equation. So here we have just transform it further to get the range between minus infinity to infinity. So over here we have log of y over 1 minus 1, and this is your final logistic regression equation. So guys, don't worry, you don't have to write this formula or memorize this formula. In Python, you just need to call this function which is logistic regression and everything will be automatically for you. So I don't want to scare you with the maths and the formulas behind it, but it's always good to know how this formula was generated. Moving ahead, let us see the various use cases wherein logistic regression is implemented in real life. So the very first is weather prediction. Now logistic regression helps you to predict your weather. For example, it is used to predict whether it is raining or not, whether it is sunny, is it cloudy or not. So all these things can be predicted using logistic regression. Whereas you need to keep in mind that both linear regression and logistic regression can be used in predicting the weather. So in that case, linear regression helps you to predict what will be the temperature tomorrow, whereas logistic regression will only tell you whether it's going to rain or not, or whether it's cloudy or not, whether it's going to snow or not. So these values are discrete. Whereas if you apply linear regression, you'll be predicting things like what is the temperature tomorrow, or what is the temperature day after tomorrow, and all those things. So these are the slight differences between linear regression and logistic regression. Now moving ahead, we have classification problem. So Python performs multi-class classification. So here it can help you tell whether it's a bird or it's not a bird. Then you can classify different kind of mammals. Let's say whether it's a dog or it's not a dog. Similarly, you can check it for reptile, whether it's a reptile or not a reptile. So in logistic regression, it can perform multi-class classification. So this point I have already discussed that it is used in classification problems. Next, it also helps you to determine the illness as well. So let me take an example. Let's say a patient goes for a routine checkup in a hospital. So what doctor will do, it will perform various tests on the patient and will check whether the patient is actually ill or not. So what will be the features? So doctor can check the sugar level, the blood pressure, then what is the age of the patient, is it very small or is it an old person, then what is the previous medical history of that patient, and all of these features will be recorded by the doctor. And finally, doctor checks the patient data and determines the outcome of an illness and the severity of illness. So using all the data, a doctor can identify whether a patient is ill or not. So these are the various use cases in which you can use logistic regression. Now I guess enough of theory part, so let's move ahead and see some of the practical implementation of logistic regression. So over here I'll be implementing two projects wherein I have the data set of a Titanic. So over here we'll predict what factors made people more likely to survive the sinking of the Titanic ship. And in my second project, we'll see the data analysis on the SUV cars. So over here we have the data of the SUV cars, who can purchase it, and what factors made people more interested in buying SUV. So these will be the major questions as to why you should implement logistic regression and what output will you get by it. So let's start by the very first project, that is Titanic data analysis. So some of you might know that there was a ship called as Titanic which basically hit an iceberg and it sunk to the bottom of the ocean. And it was a big disaster at that time because it was the first voyage of the ship and it was supposed to be really strongly built and one of the best ships of that time. So it was a big disaster of that time, and of course there is a movie about this as well. So many of you might have watched it. So what we have data of the passengers, those who survived and those who did not survive in this particular tragedy. So what you have to do, you have to look at this data and analyze which factors would have been contributed the most to the chances of a person's survival on the ship or not. So using the logistic regression, we can predict whether the person survived or the person died. Now, apart from this, we'll also have a look with the various features along with that. So first, let us explore the data set. So over here, we have the index value. Then the first column is passenger ID. Then my next column is survived. So over here, we have two values, a 0 and a 1. So 0 stands for did not survive and 1 stands for survive. So this column is categorical where the values are discrete. Next, we have passenger class. So over here, we have three values, 1, 2, and 3. So this basically tells you that whether a passenger is traveling in the first class, second class, or third class. Then we have the name of the passenger, we have the sex or you can say the gender of the passenger, whether passenger is a male or female. Then we have the age, we have the SIB SP. So this basically means the number of siblings or the spouses aboard the Titanic. So over here we have values such as 1, 0 and so on. Then we have patch. So patch is basically the number of parents or children aboard the Titanic. So over here we also have some values. Then we have the ticket number, we have the fare, we have the cabin number, and we have the embarked column. So in my embarked column, we have three values. We have S, C, and Q. So S basically stands for Southampton, C stands for Cherbourg, and Q stands for Queenstown. So these are the features that we'll be applying our model on. So here we'll perform various steps and then we'll be implementing logistic regression. So now these are the various steps which are required to implement any algorithm. So now in our case, we are implementing logistic regression. So our very first step is to collect your data or to import the libraries that are used for collecting your data and then taking it forward. Then my second step is to analyze your data. So over here, I can go through the various fields and then I can analyze the data. I can check did the females or children survive better than the males, or did the rich passenger survive more than the poor passenger, or did the money matter? As in, who paid more to get into the ship? Were they evacuated first? And what about the workers? Does the worker survived, or what is the survival rate if you were the worker in the ship and not just a traveling passenger? So all of these are very, very interesting questions, and you would be going through all of them one by one. So in this stage, you need to analyze your data and explore your data as much as you can. Then my third step is to wrangle your data. Now data wrangling basically means cleaning your data. So over here you can simply remove the unnecessary items, or if you have a null values in the data set, you can just clear that data and then you can take it forward. So in this step you can build your model using the trained data set and then you can test it using the test. So over here you will be performing a split which basically split your data set into training and testing data set. And finally you will check the accuracy so as to ensure how much accurate your values are. So I hope you guys got these 5 steps that we're going to implement in logistic regression. So now let's go into all these steps in detail. So number one, we have to collect your data, or you can say import the libraries. So let me just show you the implementation part as well. So I'll just open my Jupyter notebook and I'll just implement all of these steps side by side. So guys, this is my Jupyter notebook. So first let me just rename the Jupyter notebook to, let's say, Titanic Data Analysis. Now our first step was to import all the libraries and collect the data. So let me just import all the libraries first. So first of all, I'll import pandas. So pandas is used for data analysis. So I'll say import pandas as PD. Then I'll be importing NumPy. So I'll say import NumPy as NP. So NumPy is a library in Python which basically stands for numerical Python, and it is widely used to perform any scientific computation. Next, we'll be importing Seaborn. So Seaborn is a library for statistical plotting. So I'll say import Seaborn as SNS. I'll also import Matplotlib. So Matplotlib library is again for plotting. So I'll say import matplotlib.pyplot as PLT. Now to run this library in Jupyter Notebook, all I have to write in is percentage matplotlib inline. Next, I'll be importing one module as well so as to calculate the basic mathematical functions. So I'll say import maths. So these are the libraries that I'll be needing in this Titanic data analysis. So now let me just import my data set. So I'll take a variable, let's say Titanic data, and using the pandas, I will just read my CSV, or you can say the data set. I'll write the name of my data set, that is titanic.csv. Now I have already showed you the data set. So over here, let me just print the top 10 rows. So for that, I'll just say, I'll take the variable Titanic data dot head and I'll say the top 10 rows. So now I'll just run this. So to run this, so I just have to press Shift plus Enter, or else you can just directly click on this cell. So over here, I have the index, we have the passenger ID, which is nothing but again the index which is starting from 1. Then we have the survived column, which has the categorical values, or you can say the discrete values, which is in the form of 0 or 1. Then we have the passenger class, we have the name of the passenger, sex, age, and so on. So this is the dataset that I'll be going forward with. Next, let us print the number of passengers which are there in this original dataset. So for that, I'll just simply type in print. I'll say number of passengers. And using the length function, I can calculate the total length. So I'll say length, and inside this, I'll be passing this variable, which is Titanic data. So I'll just copy it from here. I'll just paste it dot index. And next, so let me just print this one. So here the number of passengers which are there in the original data set we have is 891. So around this number were traveling in the Titanic ship. So over here my first step is done, where you have just collected data, imported all the libraries and find out the total number of passengers which are traveling in Titanic. So now let me just go back to presentation and let's see what is my next step. So we're done with the collecting data. Next step is to analyze your data. So over here we'll be creating different plots to check the relationship between variables, as in how one variable is affecting the other. So you can simply explore your dataset by making use of various columns and then you can plot a graph between them. So you can either plot a correlation graph, you can plot a distribution graph. It's up to you guys. So let me just go back to my Jupyter notebook and let me analyze some of the data. Over here, my second part is to analyze data. So I just put this in header 2. Now to put this in header 2, I just have to go on code, click on markdown and I just run this. So first let us plot a count plot where you compare between the passengers who survived and who did not survive. So for that I'll be using the Seaborn library. So over here I have imported Seaborn as SNS. So I don't have to write the whole name. I'll simply say sns.countplot. I'll say X is who survived and the data that I'll be using is the Titanic data. Or you can say the name of variable in which you have stored your data set. So now let me just run this. So over here, as you can see, I have survived column on my x-axis and on the y-axis, I have the count. So 0 basically stands for did not survive and 1 stands for the passengers who did survive. So over here, you can see that around 550 of the passengers who did not survive and there were around 350 passengers who only survived. So here you can basically conclude that there are very less survivors than non-survivors. So this was the very first plot. Now let us plot another plot to compare the sex as to whether out of all the passengers who survived and who did not survive, how many were men and how many were female. So to do that, I'll simply say sns.countplot. I'll add the hue as sex. So I want to know how many females and how many males survived. Then I'll be specifying the data. So I'm using Titanic data set. And let me just run this. Okay, I've done a mistake over here. So over here you can see I have survived column on the x-axis and I have the count on the y. Now, so here your blue color stands for your male passengers and orange stands for your female. So as you can see here, the passengers who did not survive, that has a value 0. So we can see that majority of males did not survive. And if we see the people who survived, here we can see the majority of females survived. So this basically concludes the gender of the survival rate. So it appears on average women were more than 3 times more likely to survive than men. Next, let us plot another plot where we have the hue as the passenger class. So over here we can see which class that the passenger was traveling in, whether it was traveling in class 1, 2 or 3. So for that, I'll just write the same command. I'll say sns.countplot. I'll keep my x-axis as subject only. I'll change my hue to passenger class. So my variable is named as P class. And the data set that I'll be using is Titanic data. So this is my result. So over here you can see I have blue for first class, orange for second class and green for the third class. So here the passengers who did not survive were majorly of the third class, or you can say the lowest class or the cheapest class to get into the Titanic. And the people who did survive majorly belong to the higher classes. So here 1 and 2 has more rise than the passenger who were traveling in the third class. So here we have concluded that the passengers who did not survive were majorly of third class, or you can say the lowest class. And the passengers who were traveling in first and second class would tend to survive more. Next, let us plot a graph for the age distribution. Over here, I can simply use my data. So we'll be using pandas library for this. I'll declare an array and I'll pass in the column that is age. So I plot and I want a histogram. So I'll say plot.hist. So you can notice over here that we have more of young passengers, or you can say the children between the ages 0 to 10. And then we have the average age people. And if you go ahead, lesser would be the population. So this is the analysis on the age column. So we saw that we have more young passengers and more mediocre age passengers which are traveling in the Titanic. So next, let me plot a graph for fare as well. So I'll say Titanic data. I'll say fare. And again, I'll plot a histogram. So I'll say hist. So here you can see the fare size is between 0 to 100. Now let me add the bin size so as to make it more clear. So over here I'll say bin is equals to, let's say 20, and I'll increase the figure size as well. So I'll say fig size. Let's say I'll give the dimensions as 10 by 5. Okay, so it is bins. So this is more clear now. Next, let us analyze the other columns as well. So I'll just type in Titanic data and I want the information as to what all columns are left. So here we have passenger ID, which I guess it's of no use. Then we have see how many passengers survived and how many did not. We also see the analysis on the gender basis. We saw whether female tend to survive more or the men tend to survive more. Then we saw the passenger class, whether passenger is traveling in the first class, second class, or third class. Then we have the name. So in name we cannot do any analysis. We saw the sex, we saw the age as well. Then we have SIB-SP. So this stands for the number of siblings or the spouses which are aboard the Titanic. So let us do this as well. So I'll say sns.countplot. I'll mention x as SIB-SP and I'll be using the Titanic data. So you can see the plot over here. So over here you can conclude that it has the maximum value on 0. So you can conclude that neither a children nor a spouse was on board the Titanic. Now second most highest value is 1. And then we have very less values for 2, 3, 4 and so on. Next, if I go above, we saw this column as well. Similarly, you can do for Parj. So next we have Parj, or you can say the number of parents or children which were aboard the Titanic. So similarly, you can do this as well. Then we have the ticket number. So I don't think so any analysis is required for ticket. Then we have fare. So fare we have already discussed. As in the people who tend to travel in the first class usually pay the highest fare. Then we have the cabin number and we have embarked. So these are the columns that we'll be doing data wrangling on. So we have analyzed the data and we have seen quite a few graphs in which we can conclude which variable is better than the another or what is the relationship they hold. So third step is my data wrangling. So data wrangling basically means cleaning your data. So if you have a large data set, you might be having some null values or you can say NaN values. So it's very important that you remove all the unnecessary items that are present in your data set. So removing this directly affects your accuracy. So I'll just go ahead and clean my data by removing all the NaN values and unnecessary columns which has a null value in the data set. So next I'll be performing data wrangling. So first of all, I'll check whether my data set is null or not. So I'll say Titanic data, which is the name of my data set, and I'll say is null. So this will basically tell me what all values are null and it will return me a Boolean result. So this basically checks the missing data and your result will be in Boolean format, as in the result will be true or false. So false means if it is not null and true means if it is null. So let me just run this. So over here you can see the values as false or true. So false is where the value is not null and true is where the value is null. So over here you can see in the cabin column we have the very first value which is null. So we have to do something on this. So you can see that we have a large data set. So the counting does not stop. And we can actually see the sum of it. We can actually print the number of passengers who have the NaN value in each column. So I'll say Titanic underscore data is null and I want the sum of it. So I'll say dot sum. So this will basically print the number of passengers who have the NaN values in each column. So we can see that we have missing values in each column, that is 177. Then we have the maximum value in the cabin column. And we have very less in the embarked column, that is 2. So here if you don't want to see these numbers, you can also plot a heat map and then you can visually analyze it. So let me just do that as well. So I'll say sns.heatmap. I'll say y tick labels to false. So I'll just run this. So as we have already seen that there were 3 columns in which missing data value was present. So this might be age. So over here almost 20% of age column has a missing value. Then we have the cabin columns. So this is quite a large value. And then we have 2 values for embarked column as well. Add a CMap for color coding. So I'll say CMap. So if I do this, so the graph becomes more attractive. So over here your yellow stands for true or you can say the values are null. So here we have concluded that we have the missing value of age. We have a lot of missing values in the cabin column and we have very less value which is not even visible in the embarked column as well. So to remove these missing values, you can either replace the values and you can put in some dummy values to it or you can simply drop the column. So here let us first pick the age column. So first let me just plot a box plot and they will analyze with having a column as age. So I'll say sns.boxplot. I'll say X is equals to passenger class. So it's P class. I'll say Y is equals to age. And the data set that I'll be using is Titanic set. So I'll say data is equals to Titanic data. You can see the age in first class and second class tends to be more older rather than we have it in the third class. Well, that depends on the experience, how much you earn, or might be there n number of reasons. So here we concluded that passengers who were traveling in class 1 and class 2 tend to be older than what we have in the class 3. So we have found that we have some missing values in M. Now one way is to either just drop the column or you can just simply fill in some values to that. So this method is called as imputation. Now to perform data wrangling or cleaning, let us first print the head of the data set. So I'll say Titanic.head, sorry, it's Titanic underscore data. Let's say I just want the 5 rows. So here we have survive, which is again categorical. So in this particular column, I can apply logistic regression. So this can be my Y value or the value that I need to predict. Then we have the passenger class, we have the name, then we have ticket number, fare, cabin. So over here we have seen that in cabin we have a lot of null values, or you can say the NaN values, which is quite visible as well. So first of all, we'll just drop this column. So for dropping it, I'll just say Titanic underscore data, and I'll simply type in drop and the column which I need to drop. So I have to drop the cabin column. I'll mention the axis equals to 1, and I'll say in place also to true. So now again, I'll just print the head and let us see whether this column has been removed from the data set or not. So I'll say Titanic.head. So as you can see here, we don't have cabin column anymore. Now you can also drop the NA values. So I'll say Titanic data dot drop all the NA values, or you can say NaN, which is not a number. And I'll say in place is equals to true. It's Titanic. So over here, let me again plot the heat map and let's say what the values which were before showing a lot of null values, has it been removed or not. So I'll say sns.heatmap, I'll pass in the data set. I'll check it is null. I'll say y tick labels is equals to false. And I don't want color coding, so again I'll say false. So this will basically help me to check whether my values has been removed from the data set or not. So as you can see here, I don't have any null values. So it's entirely black. Now you can actually know the sum as well. So I'll just go above. So I'll just copy this part and I'll just use the sum function to calculate the sum. So here that tells me that data set is clean, as in the data set does not contain any null value or any NaN value. So now we have wrangled our data, or you can say clean our data. So here we have done just one step in data wrangling, that is just removing one column out of it. Now you can do a lot of things. You can actually fill in the values with some other values, or you can just calculate the mean and then you can just fit in the null values. But now if I see my data set, so I'll say Titanic data.head. But now if I see over here, I have a lot of string values. So this has to be converted to categorical variables in order to implement logistic regression. So what we will do, we will convert this to categorical variable into some dummy variables, and this can be done using pandas, because logistic regression just take two values. So whenever you apply machine learning, you need to make sure that there are no string values present, because it won't be taking these as your input variables. So using string, you don't have to predict anything. But in my case, I have the survived column, so I need to predict how many people tend to survive and how many did not. So 0 stands for did not survive and 1 stands for survive. So now let me just convert these variables into dummy variables. So I'll just use pandas and I'll say pd.getDummies. You can simply press tab to autocomplete. I'll say Titanic data and I'll pass the sex. So you can just simply click on shift plus tab to get more information on this. So here we have the type data frame and we have the passenger ID, survived, and the passenger class. So if you run this, you'll see that 0 basically stands for not a female and 1 stands for it is a female. Similarly for male, 0 stands for it's not male and 1 stands for male. Now we don't require both these columns, because one column itself is enough to tell us whether it's male or you can say female or not. So let's say if I want to keep only male, now I'll say if the value of male is 1, so it is definitely a male and it is not a female. So that is how you don't need both of these values. So for that, I'll just remove the first column, let's say female. So I'll say drop first and true. So over here it has given me just one column which is male and has the value 0 and 1. Now let me just set this as a variable, let's say sex. So over here I can say sex.head. I'll just want to see the first 5 rows. Sorry, it's dot. So this is how my data looks like. Now here we have done it for sex. Then we have the numerical values in age. We have the numerical values in spouses. Then we have the ticket number, we have the fare, and we have embarked as well. So in embarked, the values are in S, C, and Q. So here also we can apply this get dummy function. So let's say I'll take a variable, let's say embark. I'll use the pandas library. I'll enter the column name, that is embarked. So let me just print the head of it. So I'll say embark.head. So over here we have C, Q, and S. Now here also we can drop the first column because these two values are enough whether the passenger is either traveling for Q, that is Queenstown, S for Southampton, and if both the values are 0, then definitely the passenger is from Cherbourg, that is the third value. So you can again drop the first value. So I'll say drop and true. Let me just run this. So this is how my output looks like. Now similarly you can do it for passenger class as well. So here also we have three classes, 1, 2, and 3. So I'll just copy the whole statement. So let's say I want the variable name, let's say PCL. I'll pass in the column name, that is P class, and I'll just drop the first column. So here also the values would be 1, 2, or 3, and I'll just remove the first column. So here we just left with 2 and 3. So if both the values are 0, then definitely the passenger is traveling in the first class. Now we have made the values as categorical. Now my next step would be to concatenate all these new rows into a data set. Or you can say Titanic data. Using the pandas, we'll just concatenate all these columns. So I'll say p.concat, and I'll say we have to concatenate sex, we have to concatenate embark and PCL. And then I'll mention the access to one. And I'll just run this. Okay, I need to print the head. So over here you can see that these columns have been added over here. So we have the male column which basically tells whether a person is male or it's a female. Then we have the embark which is basically Q and S. So if it's traveling from Queenstown, the value would be 1, else it would be 0. And if both of these values are 0, it is definitely traveling from Cherbourg. Then we have the passenger class as 2 and 3. So if the value of both these is 0, then the passenger is traveling in class 1. So I hope you got this till now. Now these are the irrelevant columns that we have it over here. So we can just drop these columns. We'll dropping P class, the embarked column, and the sex column. So I'll just type in Titanic data dot drop, and I'll mention the columns that I want to drop. So I'll say I'll even delete the passenger ID because it's nothing but just the index value which is starting from 1. So I'll drop this as well. Then I don't want name as well, so I'll delete name as well. Then what else we can drop? We can drop the ticket as well. And then I'll just mention the access, and I'll say in place is equals to true. Okay, so my column name starts from uppercase. So these has been dropped. Now let me just print my data set again. So this is my final data set, guys. We have the survived column which has the value 0 and 1. Then we have the passenger class. Oh, we forgot to drop this as well. So no worries, I'll drop this again. So now let me just run this. So over here we have the survived, we have the age, we have the SIB SP, we have the parch, we have fair, male, and these we have just converted. So here we have just performed data wrangling, or you can say clean the data, and then we have just converted the values of gender to male, then embark to QNS, and the passenger class to 2 and 3. So this was all about my data wrangling or just cleaning the data. Then my next step is training and testing your data. So here we will split the dataset into train subset and test subset. And then what we'll do, we'll build a model on the trained data and then predict the output on your test dataset. So let me just go back to Jupyter and let us implement this as well. Over here, I need to train my dataset. So I'll just put this in heading 3. So over here, you need to define your dependent variable and independent variable. So here my y is the output, or you can say the value that I need to predict. So over here, I'll write Titanic data. I'll take the column which is survived. So basically, I have to predict this column whether the passenger survived or not. And as you can see, we have the discrete outcome, which is in the form of 0 and 1. And rest all the things, we can take it as a features, or you can say independent variable. So I'll say Titanic data dot drop. So we'll just simply drop this survived, and all the other columns will be my independent variable. So everything else are the features which leads to the survival rate. So once we have defined the independent variable and the dependent variable, Next step is to split your data into training and testing subset. So for that, we'll be using sklearn. I'll just type in from sklearn.cross-validation, import train test split. Now here, if you just click on Shift and Tab, you can go to the documentation and you can just see the examples over here. I'll click on plus to open it. And then I just go to examples and see how you can split your data. So over here you have xtrain, xtest, ytrain, ytest. And then using this train test split, you can just pass in your independent variable and dependent variable and just define a size and a random state to it. So let me just copy this and I'll just paste it over here. Over here we'll train test, then we have the dependent variable train and test, and using the split function we'll pass in the independent and dependent variable, and then we'll set a split size. So let's say I'll put it at 0.3. So this basically means that your data set is divided in 0.3, that is in 70-30 ratio, and then I can add any random state to it. So let's say I'm applying 1. This is not necessary. If you want the same result as that of mine, you can add the random state. So this will basically take exactly the same sample every time. Next, I have to train and predict by creating a model. So here logistic regression will grab from the linear regression. So next I'll just type in from sklearn.linear model, import logistic regression. Next I'll just create the instance of this logistic regression model. So I'll say log model is equals to logistic regression. Now I just need to fit my model, so I'll say log model dot fit, and I'll just pass in my xtrain and ytrain. Alright, so here it gives me all the details of logistic regression. So here it gives me the class weight, dual, fit, intercept, and all those things. Then what I need to do, I need to make prediction. So I'll take a variable, let's say predictions, and I'll pass on the model to it. So I'll say log model dot predict, and I'll pass in the value that is xtest. So here we have just created a model, fit that model, and then we had made predictions. So now to evaluate how my model has been performing, so you can simply calculate the accuracy, or you can also calculate a classification report. So don't worry guys, I'll be showing both of these methods. So I'll say from sklearn.metrics, import classification report. So over here I'll use classification report, and inside this I'll be passing in ytest and the predictions. So guys, this is my classification report. So over here I have the precision, I have the recall, we have the F1 score, and then we have support. So here we have the value of precision as 75, 72, and 73, which is not that bad. Now, in order to calculate the accuracy as well, you can also use the concept of confusion matrix. So if you want to print the confusion matrix, I'll simply say from sklearn.metrics, import confusion matrix first of all, and then we'll just print this. So here my function has been imported successfully. So I'll say confusion matrix, and I'll again pass in the same variables, which is ytest and predictions. So I hope you guys already know the concept of confusion matrix. So can you guys give me a quick confirmation as to whether you guys remember this confusion matrix concept or not? So if not, I can just quickly summarize this as well. Okay, Jagriti says a yes. Okay, Swati is not clear with this. So I'll just tell you in a brief what confusion matrix is all about. So confusion matrix is nothing but a 2 by 2 matrix which has 4 outcomes. This basically tells us that how accurate your values are. So here we have the column as predicted no, predicted y, and we have actual no and an actual yes. So this is the concept of confusion matrix. So here let me just feed in these values which we have just calculated. So here we have 105, 105, 21, 25, and 63. So as you can see here, we have got 4 outcomes. Now 105 is the value where a model has predicted no, and in reality it was also a no. So here we have predicted no and an actual no. Similarly, we have 63 as a predicted yes. So here the model predicted yes, and actually also it was a yes. So in order to calculate the accuracy, you just need to add the sum of these two values and just divide the whole by the sum. So here these two values tells me where the model has actually predicted the correct output. So this value is also called as true negative. This is called as false positive. This is called as true positive, and this is called as false negative. Now in order to calculate the accuracy, you don't have to do it manually. So in Python, you can just import accuracy score function and you can get the results from that. So I'll just do that as well. So I'll say from sklearn.metrics import accuracy score, and I'll simply print the accuracy. And I'll pass in the same variables, that is y-test and predictions. So over here it tells me the accuracy as 78, which is quite good. So over here, if you want to do it manually, you have to plus these two numbers, which is 105 plus 63. So this comes out to almost 168. And then you have to divide it by the sum of all the four numbers. So 105 plus 63 plus 21 plus 25. So this gives me a result of 214. So now if you divide these two numbers, you'll get the same accuracy, that is 78%, or you can say 0.78. So that is how you can calculate the accuracy. So now let me just go back to my presentation and let's see what all we have covered till now. So here we have first split our data into train and test subset. Then we have built our model on the train data and then predicted the output on the test data set. And then my fifth step is to check the accuracy. So here we have calculated accuracy to almost 78%, which is quite good. You cannot say that accuracy is bad. So here it tells me how accurate your results are. So here my accuracy score defines that, and hence we got a good accuracy. So now moving ahead, let us see the second project, that is SUV data analysis. So in this, a car company has released new SUV in the market. And using the previous data about the sales of their SUV, they want to predict the category of people who might be interested in buying this. So using the logistic regression, you need to find what factors made people more interested in buying this SUV. So for this, let us see a data set where I have user ID, I have gender as male and female. Then we have the age, we have the estimated salary, and then we have the purchased column. So this is my discrete column, or you can say the categorical column. So here we just have the value, that is 0 and 1. And this column we need to predict whether a person can actually purchase a SUV or not. So based on these factors, we will be deciding whether a person can actually purchase a SUV or not. So we know the salary of a person, we know the age. And using these, we can predict whether a person can actually purchase a SUV or not. So let me just go to my Jupyter notebook and let us implement logistic regression. So guys, I will not be going through all the details of data cleaning and analyzing the part. So that part, I'll just leave it on you. So just go ahead and practice as much as you can. Alright. So my second project is SUV predictions. Alright. So first of all, I have to import all the libraries. So I say import numpy as np. And similarly, I'll do the rest of it. Alright. So now let me just print the head of this data set. So this we've already seen that we have columns as user ID, we have gender, we have the age, we have the salary, and then we have to calculate whether the person can actually purchase a SUV or not. So now let us just simply go on to the algorithm part. So we'll directly start off with the logistic regression, or how you can train a model. So for doing all those things, we first need to define your independent variable and a dependent variable. So in this case, I want my x, that is an independent variable. I say dataset.ilog. So here I'll be specifying all the rows. So colon basically stands for that. And in the columns, I want only 2 and 3 dot values. So here it should fetch me all the rows and only the second and third column, which is age and estimated salary. So these are the factors which will be used to predict the dependent variable, that is purchase. So here my dependent variable is purchase. And the dependent variable is of age and salary. So I'll say dataset.ilog. I'll have all the rows and I just want fourth column, that is my purchased column dot values. Alright, so I've just forgot one square bracket over here. Alright. So over here I have defined my independent variable and dependent variable. So here my independent variable is age and salary and dependent variable is the column purchase. Now you must be wondering, what is this ilog function? So ilog function is basically an indexer for pandas data frame, and it is used for integer based indexing, or you can also say selection by index. Now let me just print these independent variables and dependent variable. So if I print the independent variable, I have the age as well as the salary. Next, let me print the dependent variable as well. So over here you can see I just have the values in 0 and 1. So 0 stands for did not purchase. Next, let me just divide my dataset into training and test subset. So I'll simply write in from sklearn.crosssplit.crossvalidation import train test. Next, I'll just press shift and tab, and over here I'll go to the examples and just copy the same line. So I'll just copy this. I'll remove the points. Now I want the text size to be, let's say, 25. So I have divided the train and test split in 75-25 ratio. Now let's say I'll take the random state as 0. So random state basically ensures the same result. Or you can say the same samples taken whenever you run the code. So let me just run this. Now you can also scale your input values for better performing. And this can be done using standard scaler. So let me do that as well. So I'll say from sklearn.preprocessing import standard scaler. Now, why do we scale it? Now, if you see our data set, we are dealing with large numbers. Well, although we are using a very small data set, so whenever you're working in a prod environment, you'll be working with large data set where you'll be using thousands and hundred thousands of tuples. So their scaling down will definitely affect the performance by a large extent. So here, let me just show you how you can scale down these input values. And then the pre-processing contains all your methods and functionality which is required to transform your data. So now let us scale down for test as well as a training data set. So I'll first make an instance of it. So I'll say standard scaler. Then I'll have xtrain. I'll say sc.fit, fit underscore transform. And I'll pass in my xtrain variable. And similarly, I can do it for test, wherein I'll pass the xtest. Alright. Now my next step is to import logistic regression. So I'll simply apply logistic regression by first importing it. So I'll say from sklearn.linear model import logistic regression. Now over here I'll be using classifier. So I'll say classifier dot is equals to logistic regression. So over here I'll just make an instance of it. So I'll say logistic regression. And over here I just pass in the random state which is 0. And now I'll simply fit the model. And I simply pass in xtrain and ytrain. So here it tells me all the details of logistic regression. Then I have to predict the value. So I'll say ypred is equals to classifier, then predict function, and then I just pass in xtest. So now we have created the model, we have scaled down our input values, then we have applied logistic regression, we have predicted the values, and now we want to know the accuracy. So to know the accuracy, first we need to import accuracy score. So I'll say from sklearn.metrics import accuracy score, and using this function we can calculate the accuracy, or you can manually do that by creating a confusion matrix. So I'll just pass in my y test and my y predicted. Alright, so over here I get the accuracy as 89%. So if we want to know the accuracy in percentage, so I just have to multiply it by 100, and if I run this, so it gives me 89%. So I hope you guys are clear with whatever I have taught you today. So here I have taken my independent variables as age and salary, and then we have calculated that how many people can purchase the SUV. And then we have calculated our model by checking the accuracy. So over here we get the accuracy as 89, which is great.
Let's compare the two models. So first of all, let's look at the definition of linear regression and logistic regression. So the main aim of linear regression is to predict a continuous dependent variable based on the values of the independent variables. But when it comes to logistic regression, the aim is to predict a categorical dependent variable based on the values of independent variables. These are the main aim of each of these models. Now let's look at the variable type. Now in linear regression, the dependent variable is always continuous. All right, this is very important to remember because this is the main objective of linear regression. Okay, it makes use of continuous dependent variables to predict continuous values. Similarly, when it comes to logistic regression, you're going to use categorical dependent variable to predict a categorical value. All right, now let's look at the estimation method. So guys, linear regression is based on the least square estimation, which basically says that the regression coefficient should be chosen in such a way that it minimizes the sum of the square distance of each observed response. Okay, now this is in depth about linear regression, so that's why I'm going to leave a link in the description. Now logistic regression on the other hand is based on maximum likelihood estimation. Okay, this basically says that the coefficients should be chosen in such a way that it maximizes the probability of y given some value of x. Next is the equation. Earlier we discussed this equation where for linear regression we have y is equal to b0 plus b1 into x plus e. Okay, similarly this is the equation for logistic regression. So the next difference is the best fit line. So guys, linear regression aims at finding the best fitting straight line, which is also called the regression line. All right. But when it comes to logistic regression, if you try and map the relationship between the dependent and independent variable, you're going to get a curve, which is also known as the sigmoid curve. All right. So in linear regression, the relationship between the dependent and independent variable is represented using a straight line. But when it comes to logistic regression, the relationship between the dependent and independent variable is represented using a sigmoid curve. Now let's look at the relationship between dependent and independent variable. Now, when it comes to linear regression, there has to be a linear relationship between the two. So when I say linear, I mean that the variables have to vary linearly. Okay, that's how the straight line is formed in the first place. All right. When it comes to logistic regression, it's not necessary to have a linear relationship. Now, the output of linear regression is always going to be a predicted integer value or basically a continuous value. So when it comes to logistic regression, the output has to be a binary value. Okay, so it should either be class A or class B, or it should be 0 or 1, something like that. Finally, we have applications. Now, linear regression is mainly used to predict outcomes like the expected number of sales, and it's always used to predict some continuous value. All right, but when it comes to logistic regression, it's mainly used in classification. So when you want to classify a data set into two different classes, then you use logistic regression. You can find a lot of applications of linear regression in the business domain. And logistic regression is mainly used in the cybersecurity, image processing, and classification domain.
What is classification? And if I have to tell you about classification, like for example, what happens is like we have two type of, when we talk about machine learning is nothing but like a series of instructions you give it to the computer so that it can learn the patterns from your data set, right? To give you an example, imagine that there is a trending topic. For example, you want to find it out whether Prime Minister Modi will be the second Prime Minister, once again the Prime Minister for the country or not. Okay, so now what you will do is you will collect the data set from multiple different sources, and you will actually build it like a algorithm where you will get a label as yes or no. Yes, he will continue as the next prime minister, or no, he will not continue as a next prime minister. So you will collect the data set and you will feed this data set to the computer, and this process is called as a machine learning, right? So now in this case, what happens is so this is about the classification, right? So now machine learning is basically of two types. One is called as a supervised machine learning, another is called as a unsupervised machine learning, and the third one is a reinforcement machine learning. So when we speak about supervised machine learning, as the name suggests, it provides some supervision, right? For example, the teacher teaching the kid, it's a supervised machine learning, right? So we will give the trained examples, we will give the trained data set with the pure label on top of that. This is called as a supervised machine learning. So if I draw in front of you, this type of machine learning look like this, supervised machine learning, where what happens is like you would have the data set, which is a structured data set, and you would have one column which is called as a label, what you want to predict. Okay, and you would have a various predictors by which you want to predict. To give you an example, imagine that you want to predict a pricing of a community. Okay, you want to predict what would be the pricing of apartment in a particular community, right? Now these can be the variable, like you can see that what would be the number of how many floors it has. You can have a variable like what is a pollution level, how many educational institutions are nearby, right? So based upon that, the pricing will change. But this type of supervised machine learning, why it is called supervised machine learning? Because we provide the independent variable, or we provide the predictors, also we provide the label data set. Okay, now this supervised machine learning is basically of two type. So this supervised machine learning, one first is called as the regression based supervised machine learning. Okay, and the second one is called as a classification based supervised machine learning. Now, what is the difference between regression based and a classification based supervised machine learning? Regression based supervised machine learning is that machine learning where what you want to predict is continuous in nature. Okay, imagine you want to predict the community prices, right, which is a continuous value. If it is a continuous value, then we will go ahead with regression based supervised machine learning. Okay, whereas if you want to predict something which is the discrete outcome, to give you an example, you want to predict that whether I will win the match or not. Okay, I want to predict whether the particular employee will churn out from the company or not. You want to predict, like whether the person will have a cancer or not. You're getting my point, right? So if you have the output which you want to predict is in the form of yes or no or true or false, right? This is called as the supervised machine learning, but a classification based supervised machine learning. Okay, so classifications based supervised machine learning is the process of dividing the data set into different categories or group by adding a label. Okay, so always remember that whenever you guys want to predict the classes in the data set, whenever you want to predict, like whether this will happen or not, whether a person will do a credit card fraud or not. You're getting my point, right? Whether the employee will churn out from the company or not, right? Whether the particular person will have a diabetes as a disease or not. All these questions, wherever you want to find it out, yes or no, or true or false, or you want to predict classes in the data set, this is called as a classification based supervised machine learning. Okay, so this is what is called as a classification based supervised machine learning. And today I will teach you, I will tell you about various form of classification based supervised machine learning, although we will do a deep dive into decision tree. Right now you will be able to understand that decision tree, how decision tree is connected to the network, what we are learning today with classification based supervised machine learning. Okay, so now we have various algorithms. Algorithm is nothing but a set of mathematical equations for classification based supervised machine learning. We first of all we have something called as decision tree, then we would have something called as random forest, then knife base, and then KNN, which is called as a k nearest neighbors. Okay, so let me give you few statements about this algorithm, and we have many others, but today we will focus on one of them, which is decision tree. So now first let's start with decision tree. Now what is a decision tree? What I was telling you is, believe me or not, decision tree is something you use every day in your daily life. For example, you take decisions, and today also you took a decision to attend this webinar, right? But how do you decide a decision? Based on various further decisions, right? For example, for today joining the webinar, you have seen that, okay, when this webinar is about, okay, so you said it is weekday or weekend, then you might have said check it out, right? What is the time of the webinar? Then you might have checked it out, what is the topic of the webinar, right? So, and who is conducting this webinar? So based upon this, you took a decision, shall I go ahead or not go ahead? You're getting my point, right? So this is what is called as a decision tree. We call it as decision tree because it is a graphical representation of all the possible solution to a decision. It's like a tree. Like decision tree is like a tree. Why? Because a tree also start with a root and then it emerge into various branches. Similarly, you have a decision tree, which I'm showing to you here as a simplest algorithm, which is being used for machine learning purposes. Now it is something like this. Imagine that you want to find it out that, like, do you want to go to a restaurant or do you want to buy an hamburger? Okay, so you have two choices. Either you can go for a restaurant or either you can buy a hamburger. Now how would you decide which one you would follow? So you will start with what is called as a root node. You will start with a root node that whether I am hungry or not, right? If I am hungry, right, then only I will go for all these activity. If I am not hungry at all, then simply go and sleep. You got my point, right? So this is how you will start with the first node, which is to find it out whether I'm feeling hungry or not. If I'm feeling hungry, then I will decide that, well, I have money which is around $25 worth. If I have money, then I will go for a restaurant. If I don't have a money, then I will buy an hamburger. You understood this? This is simplest representation of decision tree. Basically, you decide something on the basis of the previous outcomes. And you can imagine any sort of example here. Imagine that you want to find it out whether the person will do a credit card fraud or not. Again, it will depend upon the previous circumstances that, for example, it will depend upon how much is the salary of the person. It will depend upon what is the job profile of the person. It will depend upon the fact that, like, for example, how many fraud or how many cards this person have, right? So on basis of, you will decide that whether this will do a credit card fraud or not. So this is the simplest form of classification based algorithm. Then we have the next algorithm, which is called as a random forest. Now, what is a random forest? As the name suggests, you built one decision tree in the last example, right? But one decision tree can sometimes be overfitting as a case, right? So people said that, like, why should I only trust one decision tree? For example, whenever you take a bold decision in your life, you don't trust only a single voice, right? You want to hear it from multiple different people to make your decision more stronger, right? Go to a doctor. If the doctor says to you that you have this type of a disease, you don't believe in that. What you do is you also talk to second doctor, third doctor, fourth doctor to confirm that this is true or not. Okay, so this is what is called as a random forest. As the name suggests, why it is called random forest? It is called random forest because now you're building the various number of decision trees here. It's like a forest of all the trees, right? It is no longer a single tree, it is a forest of complete trees. So for example, you can imagine that if it is my training data set, I will split my training data set into multiple examples, multiple decision trees will be built, and then based upon the majority, I will decide whether should I do this or not. Okay, so it is also called as a bagging sort of methodology where we bring the outcome of various models or we bring the outcome of various trees all together to make our powerful decision. Okay, so this is another example. This is another algorithm which is called as a random forest. Then after random forest, we have something called as naive Bayes. Okay, now what is a naive Bayes algorithm? Naive Bayes is also a simplest algorithm, but naive Bayes is basically based on the Bayes theorem. Okay, so this algorithm is basically based on the Bayes theorem, and Bayes theorem is based on the conditional probability, right? So it is based on the conditional probability, which is your naive Bayes. Now in naive Bayes, what happens is, like, we decide that whether something will happen or not on the basis of probability. So let me illustrate you with this example. Imagine that you want to find it out whether I would have a disease or not. Okay, so first of all, the probability of having a disease is 0.10 and the probability of not having a disease is 0.90. Okay, so if there is a probability of having a disease is 0.10, you will further find it out that what is the probability that my test will be positive given I am diseased. What is the probability that my test to diagnose the disease is negative given I have a disease, right? Similarly, if you go into this direction, if there is a probability of not having a disease is 0.90, you will find it out that what is the probability of having a disease, test being positive with no disease, and what is the probability of no disease given I don't have the disease, which is 0.90. So basically here you check the outcomes. Here you check the outcome of all the possible combinations. This is what is called as the naive Bayes algorithm or Bayes theorem, or conditional probability based theorem. Okay, then we also have something which is called as a key nearest neighbor, which is the one of the finest algorithm, which also helps you in deciding the classification, right? Now, what is k nearest neighbor? K nearest neighbor, as the name suggests, what happens in this case is we try to build, basically it's like a neighbor. So it's something like this. Like if I give you the data set, say I give you the customer data set, okay, and it is a transaction data set. So customer number one has bought a product number one, right, from a particular vendor at a particular rate, and this is a profit this customer has given to us, and this is the revenues. Okay, this is my customer number one. Similarly, you would have customer number two, customer number three, customer number four, right? Now if I ask you that which customer profiling is same, is nearby same, right? So what you can do is you can group your customers, or you will get to know that which customer behave in the similar way. So you can say that customer 1, customer 3, and customer 4, they behave in the similar way because they are giving us the high profit and high revenue margins. You understood? So this is what happens in the case of k nearest neighbor. So k nearest neighbor, what you generally do is you find it out that what I would be able to, find it out who is my nearest neighbor, like what are the similarities in the patterns we have, right? This is what we use for k nearest neighbors. And this you can see that, for example, the algorithm based on the distance based mechanism find it out that how many people or what type of audience is similar to the outcomes, right? So then moving further here, with the second topic, let's go into detail about what is decision tree all about, right? So far I have touched base on classification based algorithm, right? And I was teaching you different type of classification based algorithm, but since the focus of today's class is decision tree, let's take a deep dive into the decision tree. Okay, so let's get started with decision tree. A decision tree is a graphical representation of all possible solutions to a decision based on a certain condition. What does it mean? It means that it is as simple as that. Imagine that this is a tree, right? So it is like a tree where you have a problem statement that should I accept a job offer or not. Imagine that you want to find it out that should I accept a job offer or not. This is a problem statement which is there in your mind. Now how would you solve this problem statement with the help of a decision tree? First of all, you will start with what we call as a root node. We will start with a root node, starting with to find it out what is a salary. Okay, what is a salary I'm getting? So if my salary is equal to or greater than equal to 50,000, I'll go here. If my salary is not greater than equal to 50,000, I will say I will not accept this offer. Okay, now imagine that you say that your salary is greater than 50,000, then you will check another variable here. You will check it out whether I have to commute more than 1 hour. If I have to commute more than 1 hour, I will decline the offer. You're getting my point, right? Then you will, if you don't have to commute more than 1 hour, then you will still consider this option, and then you will check it out. For example, in this case, we are checking it out whether you are getting the free offers also, like coffee or some snacks or other things like that. If yes, then you will accept finally the offer. Otherwise, you will decline the offer. You got my point? This is how our decision tree works. Basically, decision tree will keep on splitting unless and until you are able to find it out your decision. Okay, so here the decision was, shall I accept this or not? Right? So it will keep on splitting unless and until you get your decision whether you do this or not. Like this example which I have explained you. Okay. Now, with this, what happens is, like, let me, if I go further and explain you further on this decision tree, let's understand this more importantly, right? Let's understand this one by one. So imagine that this is my data set. Okay. Now, in my data set, you can see that I have various colors given to you. It's like a green color, yellow color, red color, and a yellow color. I am saying if there is a green color fruit with a diameter of 3, right? And I can say it is a mango. Whereas I'm saying if it is a yellow color and a diameter 3, still will be called as a mango. If it is a red color with 1 diameter, then it is a grape. And it can be a red color with a diameter of 1, still can be a grape, but even a yellow with a diameter of 3 can be lemon. Now, what is happening in this case is, if you have this type of a data set where you want to predict the label of the fruit, right? You want to predict whether a fruit will be mango, whether a fruit will be lemon, right? Or whether a fruit in this case is mango and lemon or grape. I have to build a classifier, which is a decision tree classifier on the basis of this data set. Imagine this is a problem statement given to you. Now, first of all, what you will do here is you will take this data set, right? You will take this data set and you will start with a root node. Root node, imagine here is like, is my diameter of the fruit greater than equal to 3 or not? Okay, is my diameter of the fruit greater than equal to 3 or not? If it is greater than equal to 3, right? Now, if it is greater than equal to 3, you can see that you have 3 fruits here, 3 rows of the data set here. One is green with 3 mango, yellow with 3 lemon, yellow with 3 mango. And wherever it fails in the condition, you are left with where the diameter is not greater than equal to 3, it is less than equal to 3. Then which are the data set we have? Red 1 grape and red 1 grape. Okay, so I hope you are understanding this, right? How we have starting with the decision tree with the based on one condition here, right? Which is diameter. Now, based upon this, what I will do is I have to split it further. Here in this case, I don't have to split it because I already got the result. So if my diameter is greater than equal to 3, in my data set, if the diameter is not equal to greater than equal to 3, I know it is a grape, right? Whereas if the diameter is greater than equal to 3, then it can be a mango or it can be a lemon. I'm not sure on my decision. So what I will do here is I will split it further. So I have to split this further. Here the splitting is not required, but if I split this further, I may check it out now. Is the color equal to yellow or not? Now, if the color is equal to yellow, then I have two fruit, which is your this row, which is your mango or lemon. And if the color is not equal to yellow, then you will have the another row of the data set, which is which you are left with, right? So this is how you have done this work in the case of your decision tree. Okay, and how you will find it out at which type of the criteria or which type of the algorithm I should, or which type of criteria or variable I should choose here to split the tree is on the basis of Gini index and the information gain, which I will illustrate and show you in the few slides from now. Okay, so I hope with this you understand the how your decision tree works, basically on the basis of the condition. And if you get a pure subset, then no need to split it further. If there is no pure subset, you will keep on splitting unless and until you get a pure subset. Okay, so in this case, what has happened is you got 100% mango. Here you got 50% mango and 50% lemon. Okay, so now this is what I have told you in the previous slide, like how does it work, right? Now this all depend upon the Gini index basis, right? Now in the next subsequent slide, let me tell you and explain you about Gini index and information gain. How does it work, right? How does that something works on the basis of your Gini index? So imagine that, imagine that I have a feature here, is the color green or not, right? Basis of whether the feature, whether you have a color green or not, what would happen here is if the color is green, you will get this row here. If it is not, you will get these two rows here, right? In the next, it may decide on the other basis, right? It can be, is the diameter which is greater than equal to 3 or not, and many other things. Okay. Now let's go ahead the example and the questions which is coming to your mind, which is related to decision tree terminologies. I'm pretty sure you would have these questions in your mind and you would be thinking that how should I decide that which feature I should use and which feature shouldn't I be using? This is the question which you had. And this is an excellent question for understanding the decision tree. But before I go on to that, I have to tell you about some of the terminologies which we commonly use while we build the decision tree. So first of all, decision tree looks like this type of a tree-based structure. Okay, so every decision tree will have its root node. So root node is where the decision tree will start. So it represents the entire population or sample, and it is further get divided or into two or more homogeneous sets. So as you know that this will be the first feature on the basis of your tree will start. Like tree start with a root, your in this case your decision tree will also start with a root node. Okay, now once you have the root, after that in a tree what happens is you will start getting the branches, right? I hope you understand what is branches. In this case we will keep on splitting unless and until we get a decision whether this will happen or not. So it's like a branches. Okay, then we would also have a parent or a child node. So child node is nothing but when you have a branches, then the branches can also have the outcomes. So in the previous example, like for example, we have whether the diameter is greater than equal to 3 or not. You remember whether the diameter is greater than equal to 3 or not. If it is true, what is happening? If it is a false, what is happening? So this is a child or child node. Basically, this is an intermediate node. This is not the final decision which is being made. So this is called as a parent or the child node. Then we also have other terminology here, which is splitting, which you know that we will keep on splitting unless and until you get a desired node. And finally, the tree end with the leaf node. So always remember one thing, you will start your tree with a root node. Root node is a node with which you will start the decision tree, and you will end your decision as decision tree at a leaf node where you will get a decision that you should do this or not. Okay, and now pruning is the activity where you will cut down the decision tree if it is pruned lot amount of times. I will even explain you this. It is a case of overfitting. You shouldn't build shouldn't build 1,000 branches of the tree when it is not even required. So I'll explain you this point. Now let's move further here and let's see this with the help of an example, which was your Gini index and your information gain, right? So this is where you were asking me that which question to ask and when, right? How would you decide that which feature has to be taken first, right? Let's take up an example here, and I would encourage every one of you to hear me really fine here, because this is on the basis how would you decide or how the algorithm decide to break this further. And I'm explaining you with the help of one simplest example, and we will do some maths over it. So imagine that there is a data set where I want to find it out whether I will play the match or not. Okay, there is a cricket match or there is a football match or whatever it is. I want to find it out whether I will play the match or not. Okay, now how do the decision tree look like? Decision tree look like this. If the outlook, if the outlook is humid, if the outlook is humid, and if the outlook is humid and humidity is very high, then I will not play the match. On the other hand, if the outlook is humid and humidity is normal, I may play the match. Okay. If the outlook is absolutely clear, then I will always play. On the other hand, if outlook is windy and the winds are very strong, I may not play the match. On the other hand, if the outlook is windy and the wind are weak, I may play the match. So now what is happening again is that you are not sure how you decided with outlook, how you decided with these nodes here, how you decided with these features here. Let me try to show you this entire data set. So this entire data set look like this. Okay, so this is basically your 14 days data set, and this exactly happens in the case of your classification based algorithm. You will get a data set like this. So you can imagine that you want to find it out. I would like whether I will play or not, right? This is what you want to essentially want to find it out whether I would play or not. On basis of what? On basis of 4 different variables you have. 4 different variables or features in the data set is outlook, temperature, humidity, and wind, right? So now it can be like if the outlook is sunny, temperature is hot, humidity is high, wind is not there, I will not play the match. This is how you will read this one data point, right? Similarly, I have multiple data point. Now I have to decide how can I build a decision tree, and out of these 4 features, which feature should I use first as my root node, right? So this is what I have to decide, and let's do it accordingly, right? So now what I'll do from here is I will illustrate you what is Gini index, what is information gain, and how does this happens, right? And this is basically used to build your decision tree. So before I make you understand about Gini index or information gain, one thing which you should always remember is to understand the concept of impurity. What is impurity? Impurity is nothing but, you can see there is a basket where you have apples, right? Now, if you have a basket which is of apple and another tray, it is written the label as apple. Now, in this case, you will never make a mistake. You will never make a mistake because here you have an apple, here you have only one label. So everything will be perfect. It will be 100%. Basically, there is no impurity, there is no problem in your data set, right? On the other hand, let me flip the story. In this case, imagine that I have different fruits in the basket, which is like apple, you have a banana, you have a grapes, you have a cherries and many other things, right? And you have many apples, many labels here. In this case, try imagining you have to match each fruit with its label, right? Now, in this case, the impurity cannot be equal to zero. The impurity will not be equal to zero in this case, because what would happen here is that you have a chances of misclassification, right? This is a very important concept, right? When you have perfect thing, the misclassification will not happen. But whereas if you have a multiple labels with multiple fruit, misclassification or impurities will not be equal to zero, right? So this is associated with a term called as entropy. Maybe in your childhood days you have learned about entropy in your chemistry class. In a simple sense, what is entropy? Entropy is a randomness of the space, sample space. Whenever you are not sure on your decision, then entropy will be more. Imagine that I'm giving you the data set where it is like 51% of doing this thing, 49% of not doing this thing. 51% chance that the employee may leave the organization, 49% chance that employee may not leave the organization. So basically you are not sure on your decision. If you are not sure on your decision, then the entropy will be very high. On the other hand, if you are very sure on your decision, then the entropy will be very low. So basically we need that feature which can provide us lowest entropy rather than the highest entropy, to select as that as a good feature. So we generally find it out entropy by the help of this formula. What we simply do is don't get scared with this formula because everything happens automatically in R or Python, right? Imagine, just look at this formula. What is this formula? This formula says that what is the probability that something will happen, multiply by log base 2 probability that something will happen, subtract this with probability that something will not happen, into log base 2 probability that something will not happen. Okay, let's take up an example. Don't worry about it. Let's take up an example that probability that I will win the match you will apply here, and probability that I will not play the match or win the match you will apply here, and then you will calculate the entropy. Let's take an example how you can do this in our case. So in our case, let me show you. Yeah, how we will build the decision tree in our case. In our case, you just see here what is happening is that we have 14 instances or 14 rows of the data set, where 9 times if you see it, I will play the match, and 5 times I will not play the match. Okay, so if you see carefully, there are 9 labels where I'm playing the match, and there are 5 labels where I'm not playing the match, right? So first of all, I have to find it out the total entropy. How I will find the total entropy? This is being determined by probability that I will play the match, multiply this with log base power 2 probability that I will play the match. What are the chances that I will play the match? 9 out of 14. All of you will be with me, right? This is 9 out of 14. Multiply with log base 2, 9 out of 14. Subtract this with what is the probability that I will not play the match? 5 out of 14. Multiply this with log base 2, 5 out of 14. So once you calculate this, you will find it out the entropy of this entire system. Entropy of this entire system is 0.94. Okay, so this is the entropy of your entire sample space. This is the first thing. Now, how this entropy will help you in selecting which features you will take or not? So let's go further. So now we will take each feature one by one, whether I should take outlook, whether I should take temperature, whether I should pick up humidity, or whether should I pick up windy, right? Let's go one by one. Now, first I'm plotting for outlook. Imagine for outlook, how many times, so what are the distinct value of outlook? Outlook can be sunny, outlook can be overcast, or outlook can be rainy. right? These are the three different combinations you can have for outlook. Now, if the outlook is sunny, 2 times I'm playing, 3 times I'm not playing the match. If the outlook is overcast, I'm always playing the match. If the outlook is rainy, 3 times I'm playing, 2 times I'm not playing the match, right? This is how I have bifurcated it. What I will do in the next iteration is, let me find it out the entropy of outlook. Okay, so if we start with outlook, remember this formula, which is, probability that I will play, multiply with the probability that I will play, right? And subtract with probability which I will not play, and log base 2 of not playing. So 2 by 5 is the chances that I will play, into log base 2, 2 by 5. This is a subtraction here, right? With I will play and log 3 by 5 I will play, right? So you will calculate this entropy when outlook is sunny. Yeah, so you got this entropy when the outlook is sunny is 0.971. Accordingly, you will proceed with calculating the entropy when the outlook is overcast. Outlook is overcast, always you are playing, right? If the outlook is overcast every time you are playing, so it means that you will get a probability of 0. If you apply in that formula, you will get 0. And third, what would happen if the outlook is sunny? In that case, you will again multiply and you will put the formula and you will get it out 0.971, right? So you will find it out entropy for each and every distinct combination of your feature. You got my point, right? Outlook being sunny, outlook being overcast, outlook being sunny, overcast, sunny, and rainy. This should be replaced here, right? And then what you will do is you will finally calculate the information gain. Information gain is nothing but what you will do is you will pick it up the chances, you will pick it up the entire chances when you are playing, right? Which is 5 out of 14. You remember 5 out of 14 were the total chances that I will play, into if it is sunny, plus 4 out of 14 if it is overcast, 5 out of 14 if it is rainy, right? And you will calculate the information from this outlook. And once you calculate the information, you will subtract this information from your total entropy, which I found it out in the last slide, which was 0.94. You will subtract this and you will get the information gain, or this is also called as a information gain from a particular feature. So basically, these type of a calculation, first of all, don't get scared away that you have to do this calculation. But what I'm trying to explain you is this is how your algorithm will work. For each and every feature, it will calculate the information gain from your feature, right? If you have the more information gain, it means that this variable is of very, very important in predicting that something will happen or not. Okay, so for outlook, I got the information gain as 0.247 with all the calculation. Remember, then we will proceed with wind, if the wind is there or not, right? And then I will proceed with wind and I will calculate the information gain and say information gain I found it out is 0.048, right? Similarly, we will calculate for all the 4 of them. Let me put it together for all of you. So this is what happens here. Now, if I put in front of all of you, these were the 4 different variable I have: outlook, temperature, humidity, and wind, right? I am calculating the information gain for each one of them, and the information gain I got for outlook is 0.247. So if the information gain is highest in a particular feature, that feature will become your root node. You got my point. So therefore, we will pick it up outlook as our root node. Similarly, for when the tree gets started later on as a branch node also, your information gain will be calculated, and whichever feature is giving you more information gain, that will be picked up later in the your tree also. So this is how you will build your decision tree, and you will finally get a decision tree like this. Okay. So now what I will do is, I will quickly show you how do we do the decision tree in your Python. Okay. So I'll show you how do you do this in Python, and then I will summarize for all of you that why decision trees or tree-based algorithms are better than your other algorithm. Okay. So how do you choose? basically that which algorithm you will select and when. Okay, so I'll describe you this, but before, let's jump on to Python and go there. So what I have done here is, like, I had built the decision tree in front, already. So quickly, I will walk you through the commands. Okay. So what happens here is that in Python, as you would be well versed with this, that we generally import packages in Python. So I'm importing NumPy, I'm importing matplotlib for plotting the chart. I'm importing various packages from your sklearn, which is for machine learning purposes, right? So I am importing your label encoder, your decision tree classifier, classification report, and I'm importing your tree, right? So we have all this which I am importing, right? After I import, what I will do is I'm reading my data set. So I'm showing you this with the help of our iris data set, which is one of the very popular data set for building the a decision tree, right? For any particular source. So imagine that this is my data set, and I'm just showing you 6 rows of the data set where, I want to find it out whether a particular flower species will be Setosa, versicolor, or virginica. I have 3 different flowers which I want to predict, and on the basis of sepal length, sepal width, and petal width. So basically, I have different dimensions of flowers length and width, and based on that, I want to find it out whether the particular species will be Setosa, versicolor, or virginica. You got my point, right? So this is a data set. So what I will do is, as you know, with every machine learning data set, we play with the data set. So I'm checking the information here, what type of the data type it is. So sepal length, it is a float, petal length, it is a float, and species is a object. Why object? Because this is a categorical column. So after this, I'm also checking whether there is any null value present in the data set or not, because if there is any null value, then we have to get rid of that null value, or we have to replace that null value with some imputed value, right? This is what I'm checking here. Once I do that, I'm also plotting this because we usually do visualization, right, to understand the data set better. So what I'm doing here with the help of SNS, which is your SNS.pair plot, I'm plotting all the possible plots. So basically, sepal length with sepal width, what type of the combination look like. So Setosa, versicolor, and virginica, there are 3 different species you can see in the data set. And this is what I'm getting a trend between your sepal length and sepal width. Similarly, this is basically from sepal width to petal length, right? So this is how I'm understanding the patterns, or I'm understanding the relationship between the variables in the data set. So this is what I'm understanding here. I am also checking whether there's a correlation or not. Higher the shade, it means there will be a strong correlation. So all of these things is being done as a part of exploratory data analysis before even you start your machine learning model, right? Once you do this, after that, what I have to do is, after that, what I'm trying to do is, I am taking your species column, what I want to predict, as my target variable, which is your dependent variable. And so this is the dependent variable, and with the help of what I want to predict will be my independent variable. So I'm calling X all my independent variable, and I'm calling target as my dependent variable. Once I do this, then you will also think about it that the variable which I want to predict is the flower species, right? But I want to convert this into 0 and 1 class, 0, 1, 2 class, because your computer cannot understand text, right? Computer can only understand the numbers. So what I'm doing here is I'm changing it to the class, right? So what I'm trying to do here is I'm saying wherever it is Setosa, it will become 0. Wherever it is Virginica, it will become 1. And it is versicolor as a third category, it will become 2. So now imagine my data set, my label to predict becomes 0, 1, or 2 instead of 3 flower, which was Setosa, versicolor, and Virginica. This is what I'm doing with the encoder here. Once I convert this and this become my target, what I will do is, as I told you, that I will split this data set into training and test data set. So basically 80% of the data is going into the training data set, and remaining 20% I'm taking as a test data set. Okay. Now I will call decision tree classifier. Like I want to make a decision tree and I want to fit this on my training data set and the test data set. And I will start building the decision tree, and with the help of from so here is when I have created the decision tree, and here is when I am checking the prediction, how accurate my decision tree is. So I got my precision, which is good. I got my recall, I got my F1 score, and I also get the support, right? So all these matrices are being used to calculate your how accurate your predictions are. So higher the precision, better the results would be, right? And finally, I am showing to you that how does the tree look like. So I had tried to plot this decision tree in front of you. So basically it starts with petal length, and you can see the Gini index coming up here, or the information gain, which is information gain and Gini index are reciprocal to each other. If you want to use information gain, you will get that score. If you don't want to use information gain, you will get Gini index. So they are both reciprocal of each other. It is one and the same thing. You use Gini index or you use information gain. They are the two different metrics to build your decision tree. So you can see that based on a petal length, the tree gets splitted like this. Then based on the petal length of different dimensions, your tree further split, then it further split, then it further split, and finally you get to know that whether the particular species will be versicolor or virginica. Okay, so this is how your entire decision tree is built in Python. Okay, so this is how it's so simple. I know it takes time to build this thing, but once you are a good data scientist and you understand all these things, it is very simple to build all these things very easily in Python or R, right? So now, finally, going back, how would you decide? How would you decide that which algorithm, which algorithm will be taken when? So what happens is, this is on the basis of scikit-learn. So it starts something like this. Okay, so it is on the basis of like this, that first of all you see here that um, whether how many samples you have, how many data points you have in the data set, right? If you have more than 50 samples, then you will go here. If you have less than 50 data point, then you will go here. So you will get more data set, right? So if you have more data, if you have greater than 50 data point, then you will go further, you split of your data set. If it is not, then you just the kind advice it, get more data set. Okay, so then you will decide that what you want to predict. If you have a labeled data set, then you will go here, right, and do clustering. If you don't have the labeled data set, then you will see whether you want to predict a quantity. If yes, you will go in regression. If you want to predict, if you just want to do exploratory analysis, you can do dimensional reduction. If you have a labeled data set, for classification, you can do all this classification. So basically, this is a cheat sheet which we generally use to decide that what we have to do with the data set and when.
Let's understand what is a random forest. So random forest is constructed by using multiple decision trees, and the final decision is obtained by majority votes of these decision trees. So let me make things very simple for you by taking an example. Now suppose we have got 3 independent decision trees. Here we are just taking 3 decision trees, and I have got an unknown fruit, and I want that these trees would give me a result of what exactly this fruit is. So I pass this fruit to the first decision tree, the second decision tree, and the third decision tree. Now a random forest is nothing but a combination of these decision trees. So the results are being fed into the random forest algorithm. So what it sees is that, okay, the first decision tree classifies it as peach. The second decision tree says that it is an apple. And the third one says that it is a peach. So random forest classifier says that, okay, I've got the result as 2 peach and 1 for an apple. So I would say that the unknown fruit is an peach. All right. So this is based on the majority voting of the decision trees. And that is how a random forest classifier comes to a decision of predicting the unknown value. Okay, so this was a classification problem, so it took the majority vote. Now suppose if it was a regression problem, it would have taken mean of it. Okay, so now let's move on further to understanding what is a decision tree. But before that, we should understand that random forest, the building blocks are decision trees. And that's why studying decision tree becomes important, because if we understand one decision tree, we can apply the same concept to random forest. Okay, so now let's move on forward and understand the important terms in random forest. And this will also help us consolidate whatever we have learned so far. So we've taken the same small decision tree of the previous example, and let's understand these are also the important terms which will be relevant to random forest also. So the first is the root node. Now here what happens is that the entire training data is being fed to the root node. And then we've got here that each node will ask either true or false question with respect to one of the feature. And then in response to that question, it will partition the dataset into different subsets. That's what it is doing here based on the condition that if the body mass is greater than or equal to 3500, it asks a question either yes or no. And based on that, again, further partition is done. And if not, then it just classifies the species. And then again, what happens is that the splitting. Now, this is very important here. The splitting takes place either with the help of a Gini or entropy methods. And these helps to decide the optimal split. And we will be discussing about splitting methods very soon, right? Okay. And then we've got the decision nodes, which provide the link to the leaf nodes. And these are really important because then only the leaf nodes would tell us what actually the real predictions or to which class does this species belong. So now coming to the leaf node, and these are the endpoints where no further division will take place and we will obtain our predictions. Okay. So now coming up to another important thing here is working of random forest. So now for working of random forest, we will have to understand a few important concepts like random sampling with replacement, feature selection, and also the ensemble technique, which is used in random forest, and that is bootstrap aggregation, which is also known as bagging. So we will understand this with the help of an example, which will be very simple. And then we will go on understanding how feature selection is done in both the classification and the regression problem. Actually, how random forest select features for the construction of decision trees. Well, in random forest, the best split is chosen based on Gini impurity or information gain methods. So this also we will understand. Now let us first understand random sampling with replacement. Now what happens here is that we have got a small subset of the same penguin dataset, wherein we have got some 6 rows and 4 features, that means 4 columns. And the arrows that you can see is that now we will be creating 3 subsets from this small subset, right? And these 3 subsets will become our decision trees. And then we'll be constructing decision trees from these subsets. So let us create our first subset. And you can see here that the subset is randomly being created. And for convenience sake, let me just also show you the different subsets here. Okay, so now for better understanding, let us understand this, that in the first subset, if we focus, we've got certain random rows here and we've got certain feature, but we do not know how this feature has been selected. We got island and we got body mass, but in the second subset, we got island and flipper length. And in the third subset, we got body mass and flipper length, right? Now let's look at the rows. Now, when I am talking about these features, I will say this is feature selection. And remember this term. Now coming to the second concept, that is random sampling. Now random sampling is nothing but selecting randomly from your subset. So I'm selecting randomly certain rows from my subset and creating further subset. Okay. So what is replacement here? Replacement can be seen here and can be understood with this second subset. We see here that the Gento species, this row is being repeated again. And this is replacement. That means that when we are working with repeated rows and this row can be repeated again in the second or the third subset, then this is random sampling with replacement. That means my random forest can use a row multiple times in multiple decision trees, right? So this is the basic concept of random sampling with replacement and feature selection in random forest. Another important term which I would like to bring into the notice is that when we are working with these type of small subsets, these are also known as a bootstrap datasets. And when we aggregate the results of all these datasets, it becomes bootstrap aggregation. So just filling in the gaps so that later on the concepts become more clear. So now let's move on to drawing decision trees of these subsets. Okay. So let's draw the decision tree of the first subset. Again, we are taking body mass as the first root node, and then based on a decision like If the mass is greater than or equal to 3500, then take a decision either yes or no. If it is no, then the species is chin strip. And if it is yes, then again you partition based on island. And if it is Togresen, then it is Adelie. And if it is Visco, then it is Gentoo species. Okay. So this is how we will construct 2 more decision trees of the remaining subsets. So on the second subset, let us just again create decision tree. And here now we are taking flipper length. And then based on a condition that if the flipper length is greater than or equal to 190, then make a split. If it is yes, then the species become Gentoo. And if it is no, that means again make a decision based on island. And if it is Togresen, it is Adelie. And if the island is Dream Island, then it is a chin strip species. So this is how the decision tree of the second subset has been created. And this is how it will take decisions, right? Based on the tree length, depth, and also the features it is selecting. Okay. So now let's create the third decision tree of the third subset. And we get a decision tree something like this, wherein body mass, if it is greater than 4000, and if it is yes, then clearly it is a Gentoo species. And if it is no, then again make a partition with respect to flipper length, another feature here. And then if it is again greater than or equal to 190, then the species would be Adelie, else it would be chin strip. So this is how decision tree 3 will make a decision. Now let's just keep these decision trees with us, okay? And we will make sense of these trees just in a while, okay? But before that, let us understand how feature selection is done in a random forest. How am I selecting the columns? So for classification, by default, the feature selection is taken as the square root of total number of all the features. Now suppose I've got here 4 features. So it is a classification problem. I will take the square root of these 4 features, which becomes 2. So decision tree would be constructed based on 2 features each. If suppose I had 16 features, then it would be square root of 16. That would be 4. So 4 features would be taken in each decision tree. All right. And suppose if this would have been a regression problem, then by default, what would happen? The features would be selected by taking the total number of features and dividing them by 3. Okay. So this is how by default the feature selection is being done by a random forest. Okay. Now let us move on forward to consolidating our learning. So now we are coming to ensemble techniques, that is also known as bootstrap aggregation. Random forest uses ensemble techniques. And what is ensembling? It just means that you are aggregating the result of the decision trees and taking the majority vote in case of classification and the mean in case of regression problems and giving the output. Okay. So now we have again plotted all our decision trees here. And below we can see that there's an unknown data and I want to predict the species of this data. So what will happen is that again, let us just feed this problem to each of the decision tree and let's see what each decision tree makes the prediction. So I just feed this unknown data to decision tree 1 and it says that, okay, the species seems to be chin strip. Okay. And then decision tree 2 says that based on the data, it has been found that the species is Adelie. And then decision tree 3 says that, no, I with my decision tree, this species is chin strip. Okay. Now, all these data is being fed to random forest classifier. And it says that, okay, for chin strip, I've got 2 votes. For Adelie, it's got 1 vote. So the new species would be chin strip, right? So this is how the bootstrap aggregation is done based on the majority voting and the decisions taken by different decision trees. They have been combined together, aggregated, and we get an ensembled result in the random forest. Okay. So this was a very simple concept of ensemble techniques, which has been used in random forest. Okay. So now let's move on forward to splitting methods. So what are the splitting methods that we use in random forest? So splitting methods are many, like Gini impurity, information gain, or chi-square. So let's discuss about Gini impurity. So Gini impurity is nothing but it is used to predict the likelihood that a randomly selected example would be incorrectly classified by a specific node. And it is called impurity metric because it shows how the model differs from a pure division, right? And another interesting fact about Gini impurity is that the impurity ranges from 0 to 1, with 0 indicating that all of the elements belong to a single class and 1 indicates that only one class exists. Now value, which is like 0.5, this indicates that the elements, they are uniformly distributed across some classes, right? Now moving on forward to information gain. Now this is another splitting method which random forest can use, and information gain utilizes entropy. So entropy is nothing but it is a measure of uncertainty. So information gain, let's talk about that first. So the features they are selected that provide most of the information about a class, right? And this utilizes the entropy concept. So let's see what is entropy. This is a measure of randomness or uncertainty in the data, right? So we will understand this entropy with the help of a small example. So don't worry about it. So let's understand this entropy. Now suppose there's a fruit tray with 4 different fruits, right? And what do you feel about the entropy here? That means the randomness of the data. Is it really easy to classify these fruits into the respective class? So this becomes really uncertain and the data looks messy here. But what if we just split here these into 2 trays, wherein the first tray would have peaches and oranges, and in the second tray will have apples and lemons. So now this becomes a little more certain. We get low randomness here, and this is called as low entropy. So when we move down from tree, that means from root node to the leaf nodes, the entropy reduces. And we can also calculate information gain from this entropy. That is the difference in entropy before and after the split. That is known as information gain. Okay. So once we move down the tree and start reducing the randomness from the data, the entropy becomes lower. And that is what we want in our data. If there's low entropy, that means we are likely that the predictions would be more accurate and we can make predictions very easily as compared to very messy data which has high entropy. Okay. So that was about entropy. So now let's move on to understanding the advantages of random forest. And we see here various advantages. So let's focus on firstly low variance. Now, since random forest overcomes the limitations of decision tree, and it also has the advantage of low variance because it combines the result of multiple decision trees. And each decision tree is being trained on limited data set that we have seen earlier also. So each tree was making its own subset of data and training the data on that limited length of the tree. So there's less depth, there's less overfitting and low variance of the data. So coming to the next point, that is reduced overfitting. Again, since we were working with multiple decision trees, hence reduced depth of the tree, so we get reduced overfitting. That means the model is fitted well and it does not tries to learn even the noises, right? So we use the bootstrap aggregation or bagging here in random forest, and that is why we also get reduced overfitting in random forest. And this is one of the reasons that why is it so popular, because you don't have to worry about overfitting of the data, right? All right, now moving on forward to the another advantage is that the normalization is not required in random forest because it works on rule-based approach, right? And another advantage is that it gives really good accuracy, which we will also see in our hands-on. It really gives very nice predictions, either precision or recall, and generalizes well on unseen data as compared to other classifiers or machine learning classifiers which are present like Naive-Bayes or SVM or KNN. Random forest really outperforms other classifiers, right? So let's move on to understanding few more advantages of random forest. Is that it is suitable for both classification and regression problems, and also it works well with both categorical and continuous data. So you can use it well with any of the data sets, right? And it performs well on large data sets, right? So it solves most of the problem. That's why random forest is largely been used in machine learning problems. Now moving on forward to certain disadvantages of random forest. So the first disadvantage is that it requires more training time because of the multiple decision trees. If you've got a huge data set, you would be constructing hundreds and hundreds of decision trees, and that requires a lot of training time. And here comes one more disadvantage is that the interpretation becomes really complex when you've got multiple decision trees. So decision tree interpretation is easy because it is an individual decision tree. But when you combine hundreds of decision tree to form a random forest, the interpretation is really very difficult to understand and it becomes quite complex to apprehend what exactly the model is trying to predict and where the splitting occurs and what features are being selected and so on. And another disadvantage is that it requires more memory. So memory utilization is really heavy in case of random forest because we are working with multiple decision trees. And another disadvantage is that it is computationally expensive and requires a lot of resources because of the training of multiple decision trees and also storing them. All right, so this was all about random forest, the theory part of it. And now let us just move on to the practical demonstration or a hands-on on random forest. Okay, so now it's time for a hands-on on random forest. So let us just import a few basic libraries of Python in our Jupyter notebook. And we will run this. We will import pandas, spd, numpy as np, and seaborn as sns. Now seaborn is needed here because we want to load a data set, that is a penguins data set, with the help of seaborn. And this is already been preloaded in seaborn. This is already loaded data set, and seaborn has got multiple data sets, for practice for beginners. So it is a good way to practice for data sets. Now we can see this asterisk sign, that means it is telling us to wait. So let us just let it get loaded. So we got our data in an object called df, and we can see the first 5 entries here. And this data frame is shown in the form of a table, rows and columns. And we see here some species, island, bill length, bill depth, flipper length, body mass, and the sex of the penguin. So our task is to specify or to classify these species of penguins into the respective correct species, right? So we see the shape of our data, and we see that it is like 344 rows and 7 columns. And we will see the info. So we see df.info, and this gives us, along with the non-null count, we also get the data type of the values. So we have got species island as the object data type, whereas the bill length, bill depth, triple length, and body mass are in floating point, or you can say floating data type, and the sex is in object data type. Right? So now moving on forward to calculating how many null values are there with the help of df.isNull.sum. So we get certain sum around 2 null values in all these columns. As you can say, the features like bill length, bill depth, flipper length, and body mass, whereas there are 11 null values in sex feature. Right? So what we do is, since they are very small null values, we can just drop it, or you can also ignore them. So here in this data frame, what I'm doing is I'm just dropping these null values, and let us just check whether they have been dropped or not with the help of, again, the same function .isNull.sum, and then we see that yes, they have been dropped from our data frame. Now let us do some feature engineering with our data. Now we have seen that we have got some object data type in our data frame. And before feeding it into algorithm, that is random forest, we have to transform the categorical data or the object data type into the numeric. So we are using here one-hot encoding to convert the categorical data into numeric. Now there are various ways in Python which we can do that, like one-hot encoding, or you can also use the mapping function in Python. But here we are using one-hot encoding. So let us just do that. And we find here, first of all, let us apply it on the sex column. And here we see that we have got 2 unique values in sex, that is male and female. And we use pandas here to get dummies. That is how we will apply this one-hot encoding, because this is how get dummies work. So what happens is that the new unique values are converted into the respective columns in the data frame. So we see here we have got 2 unique values, males and female, and they are being converted into the columns. Okay, so one thing to note here is that we also get a problem of dummy trap, because here we see only 2 unique values. Now suppose if I had 6 or 7 unique values and I do this one-hot encoding, I would have lots of features in my data frame, and that would lead to several complexities. So what I do is, to keep things simple, I can use one-hot encoding when my data frame or my unique counts are low, when my unique values are less. So since I had just 2 or 3, I can use it. So I'm using here. So what I do is, again, now one row, one column, as we can see here, that it is redundant, giving me extra information. So I will just drop it. So I drop this first column, and what I get in this data frame is only male. So let us just infer whether I can also infer females from this or not. So if the value is 1, that means the penguin is a male. And if the value is 0, that means the penguin is a female. Okay, so only one column is needed for this data frame. So I just kept one and dropped the another one. Okay, now apply again one-hot encoding to the island feature. So in island, if we check the unique values, we've got 3 unique values here: Togresen, Bisco, and Dream Island. And the object is the data type, right? So again, we will use pandas. pd.getDummies, and we will apply it on the feature island, and let's get the head of it. So we get here, again, the unique values were converted into columns, and we get here respective 3 columns. And then again, we will just drop the first column to get the remaining 2 columns. So here also we can infer that if the island is Togrison, if it is 1, then it is not Dream, neither Bisco, right? So this is how we can read it from the data frame and understand that. Now remember this thing that these 2, island and here sex, these are 2 independent data frames. These are not yet included in the main data frame. So what we will do now is we will concatenate the above 2 data frames into the original data frame. So what we do, we again create a new data frame, that is new data, and let us just concat with the help of pd.concat function, and we will concat what? df, island and sex. And access is 1, that means in the column. Okay. So when we will run this, let's see the head of it. So everything gets concatenated in a single data frame, which is good for the feeding this data into or splitting the data into test and train data. So now we have this new data frame, and we've got some repeated columns here which needs to be deleted. So what we do is we will delete sex and island here, which are just repeating because we've got here male, and we have also got here Dream and Togrison. So we do not require this island column, neither this sex. So we just drop it with the help of new data.drop and the column names x is 1 in place equals to true, right? And let's see the head of this data frame. Head of the data frame gives me 5 unique values, right? And now it is time to create a separate target variable. And what we'll do is we will store in a variable called y only species. So what we do is from this new data.species, we will just store the species in this y. And we see this y.head, that is the first 5 species. And we got the values here. That means another target variable is being created now. So, and you can also see the y.unique values as Edeli, Chinstrap, and Gentoo. So now we see here 3 unique values of the penguin, that is Chinstrap, Edeli, and Gentoo, and the data type is object here. So again, we need to convert this object into the numeric data type. So now what we are doing is we are using the map function in Python, and what we do is we map Edeli to 0, Chinstrap to 1, and Gentoo to 2. So this is how we see then all the values are being mapped to numeric. This is another way to convert a categorical value into a numeric value in Python. Now what we do is let us just drop the target value species from our main data frame. So we just drop it, and let's see our new data frame. So we see that we don't have any target species here, right? Okay. So in X, let's store this new data and perform the splitting of the data. So what we do is from sklearn.model selection, we will import our train test split, and we will split our training data into 70% and 30%. So test data becomes 30% and training data is some 70%. And this random state is 0, which means that I'm not fixing any random state. And this is also used for the code reproducibility. Now suppose if I again run this code, I will get the same result. It will not change. You can set this random state to any of the random number as per your choice, and the result would differ. Okay. So now let us print the shape of xtrain, ytrain, xtest, and ytest. So we see here that it has been split into 70 and 30%, and we get xtrain as 233 values here and 7 features, and xtest has 100 values and 7 features. Similarly, ytrain, you can see 233 values and ytest has 100 values. That means the species. Okay. So that has been perfectly splitted into 70 and 30%. Now what we do is we will train the random forest classifier on the training set. How do we do it? We will import the random forest classifier from sklearn.ensemble. So we've already dealt with what is ensemble. And then in classifier, we will store this random forest, and this n estimator is nothing but decision trees. So we are creating some 5 decision trees here, and the criteria is entropy. And again, random state is set to 0. So let's see. And then we will fit this X train and Y train. So this has been fitted, and the criteria is entropy here. All right. So now let's make some predictions, and let's create a variable called yPredict, and we will just predict it on xtest. And we have also printed this y prediction. And now let's print the confusion matrix to check the accuracy of random forest algorithm. And what we do is from matrices, sklearn matrices, we will import classification report and confusion matrix, and also the accuracy score. So we will just import them, and then in CM variable, we will print the confusion matrix of y test and y predictions. So we will print it, and we see here the accuracy score also, which is 98%. So our random forest classifier is giving us a very good accuracy of 98%. And you can see your confusion matrix that only 2 cases have been misclassified. Rest all the cases have been correctly classified by random forest classifier. Okay, so now let's move on to printing the classification report of Y test and Y prediction. Let's see. And we get the precision as 96%. That means the true predictions by the algorithm is 96%. The recall or the true prediction rate is 100%, which is very nice. And F1 score is also good, which is 98%. So this is giving us a good result. But what if we change the criteria from entropy to Gini? So let's just experiment with that too. So let's try this with the different number of trees and change the criteria to Gini coefficient. So now again from sklearn.ensemble, we will import random forest classifier and fit it. Okay. And here what we are doing is just we are using 7 trees. Previously we used 5. And now in the criteria, we will use Gini coefficient and random state is 0. So let's run this and see whether there is a change in accuracy or not. And let's predict this. And let's check the accuracy score. What is the accuracy score for this random forest classifier with 7 trees? So we get 99% accuracy with changing the criteria and changing the number of trees. So you can just experiment with different number of trees and different number of decision trees. Let's just experiment with 12 decision trees and see what happens. So you can see the accuracy reduced to 98%. Okay. With 7, we were getting 99. So let's just keep 7 because it is giving us really good accuracy. So this is about random forest classifier and how it works with several trees and different criteria to give us very good accuracy on our training and test data.
The case that we are discussing is basically the KNN algorithm, which is an algorithm which we used for mostly supervised machine learning, which is where you have labeled data. Okay, so what is KNN algorithm? So as we said, KNN algorithm is K nearest neighbors algorithm, and it is an example of supervised learning algorithm where basically you try to classify a new data point based on the neighbors of that data point, which is basically which data points are closer to it. For example, here, as you can see, you have on one side couple of cats, and on the other side you have on one side you have dogs, and on the other side you have cats, right? Now, if a new data point is given to us, there is a picture of a new animal, and if it is lying somewhere here, right, then we know that it is nearer to the cats, right, and therefore we will classify it as cat. Whereas if it is sort of nearer to the dogs, then we classify it as dog, right? So that's the neighborhood for the dog, and therefore we sort of classify it, that new animal or the new picture, as being that of a dog. And this is quite this is something which is we even see in our regular day-to-day life, right? We have had examples where our parents keep telling us, okay, don't play with those kinds of children or something, because they are not good in their studies, or probably they are not so good in their behavior, because you would become like them, right? So it's again an example from real life of classifying a particular person based on the company that they keep, right, or from the with the kind of people that they are. So that's sort of the example. And now let me actually go back. Okay, what are the features of K nearest neighbors algorithm? Okay, so let's talk about the features of KNN. So as I said, KNN is a supervised learning algorithm. Typically, it is used for supervised learning kind of problems. It's very simple, as we mentioned. Intuitively, you can it's about what kind of neighbors do you have. So your class is predicted based on your nearest neighbors, as the name suggests. And then it's a non-parametric technique. So I would like to spend a couple of minutes here to discuss about what we mean by non-parametric. So Typically, the supervised machine learning algorithms are of two kinds, right? One is the parametric types, and the second one is the non-parametric type. When we say parametric, what we mean is basically that the machine or the algorithm assumes that there is an underlying function or a distribution that is known of the particular data set. Like, for example, the linear regression would assume that the relationship between two things x and y is linear in nature, right? um, and similarly for a distribution, a Gaussian distribution, it would assume a normal distribution of the data points and so on. So a lot of the supervised machine learning algorithms, they assume some kind of function association between the predictor, which is basically the root causes which help you in predicting, and the variable that you are trying to predict. Whereas there are certain algorithms like the KNN or the Parson window or the linear discriminant analysis, which is of the kind which is called non-parametric, because it does not assume any particular kind of distribution or any particular kind of functional relationship of the data that you are trying to predict, or you're trying to learn the pattern of. So KNN is one of the kind. As I said, Parson window is another one, which is basically where you in Parson window, essentially, the volume of the data set or the area that the data set covers is known, whereas you're trying to find the k there, which is the number of data points within that area or the volume, right? Whereas in case of non-parametric technique like KNN, it's the opposite, where the k is known, which is basically you would like to associate the class of the data point that you're trying to predict based on the k number of neighbors around it. Now k can be 3, 4, 5, whatever, right? 10, 20, and so on. Essentially, the difference between Parson window and KNN is that in KNN, you already know the k, and then from the k you try to find out the volume, and therefore then you try to find the probability or the density underlying distribution. And then there is the discriminant analysis, which is of, again, two kinds: linear discriminant and multiple discriminant analysis, where basically what you do is you transform the underlying data, the features, into a higher dimension, and in such a way that in the new feature space, after you have transformed the data, you now try to apply a parametric approach. Like, for example, you will try to project the features onto a line, or if it is on a subspace which is higher dimension than a line, then essentially it becomes multiple discriminant analysis. So basically, those are the three kinds of non-parametric techniques. So even if you were not able to sort of get the full hang of what these three types are, what you need to keep in mind is that non-parametric technique does not assume any kind of distribution or any kind of functional relationship of the underlying data, and therefore it gives us a lot of flexibility. Whereas the parametric techniques, they basically assume some kind of functional relationship between the data points, or they assume some kind of distribution. So where would you use a non-parametric versus a parametric technique, right? So basically you would use non-parametric technique, where you do not know about the functional relationship. That is one. Second is that, there is maybe, let's say, large amount of data and so on. And thirdly, non-parametric technique like KNN does not work in a very high dimensional data. So you would also use parametric techniques in that case. Whereas if you have, smaller data sets, you would use, typically non-parametric techniques. And then also, if you understand that the relationship between the data points might be, for example, linear or something like that, you would use a parametric technique. So you are assuming that there is some kind of relationship, like a linear relationship or something like that between the data point. So that's where you will use the parametric technique. So again, just to summarize, basically non-parametric is an approach where you do not assume any kind of distribution or functional relationship, whereas parametric assumes a functional relationship or basically a distribution between the data points. The other feature of KNN is that it is a lazy algorithm. So what do we mean by lazy algorithm? Actually, in most of the supervised learning algorithms, you basically train your model on the training data set, then you have your model, and then you apply this particular model to the test data set to then classify or predict. For example, whether a new image is that of a cat or a dog, right? So this can be, some kind of algorithm like support vector machine or regression or logistic regression or whatever, right? So you run this logistic regression or you run this regression or support vector machine on the training data set, and it learns the features or it learns the parameters of the model from that data set, and then applies this learnt model on the test data set. Whereas in case of KNN, actually there is no training step at all. That's why it's called a lazy algorithm, because what it does is, at the time that you are actually now want to predict, at that point in time, actually it will go and it will do all the calculations of the distance of the new data point, like for example the new image of the cat or dog, from all the other data points that you have. So it will calculate all the distances, and then we'll check for those data points which are, or the k data points which are nearest to this. So that's why it's called lazy algorithm, because nothing happens till the point, or no calculations happen till the point you are actually trying to predict something. So there is no training step involved. Okay, and then it's used for both classification and regression, as we just mentioned. So it can be used to predict the values as well as be able to classify something like, okay, whether it is a cat or dog, or if you're trying to, let's say, predict some value, some forecast or something, that for that also you can use it. And then it is based on feature similarity, which is basically, what do we mean by feature similarity? So feature can be things like, if for example, you are looking at classifying cats versus dog, right? So is the eyes like a dog? That can be one of the features. How do the ears look? That can be one of the features. What about the tongue, the face, and so on? So there can be multiple such features, and how similar these features are between two data points, which is used basically by the KNN algorithm. And then, as I said, there is no training step involved. So these are the features of KNN algorithm. And therefore, now let's look at actually just some simple examples of how it works. So as you can see here in this slide, we have two classes of data. So one is all these blue data points, and there is another one which is the orange data points. Now, if you have a new data point, which is this pink one here, which class should it belong to? Should it belong to class A or should it belong to class B? So what you would do is, you would actually start calculating the distance of this pink data point from every square or blue triangle data point. And then you will decide, you will have to assume a particular k. Let's say k is 3, right? Which is, I'm looking at the nearest 3 data points. And in that case, basically, as you can see, if we draw this circle, right, then we see that 2 of the nearest data points within that circle is of the square orange kind. So basically, we will predict that this particular new data point belongs to class A. Whereas k value was 7, right, as in this particular example now, you would see that 4 out of the 7 is actually of the blue triangle kind, and therefore we will now classify it as belonging to class B. So essentially this prediction changes, as you can see here, depending on what is the k value. So therefore the question is, what should be the value of k, right? And typically what happens is, you run a trial and error, and basically you come up with, okay, what is the best k value? But essentially what one needs to understand is that as the value of k increases, basically the partition line starts moving towards becoming more and more linear. So it starts becoming less flexible, and it starts assuming some kind of a linear dividing line or something like that. So what happens is that as you increase the k, your bias basically increases, but your variation reduces. So we know that in classification problems or in machine learning problems, bias and variance are two things that we are trying to manage, right? Bias is basically how close you are to the actual class or to the actual value, whereas variation is how much variability is there in your prediction. So as the k increases, the bias sort of increases, but the variance reduces. And then it is vice versa. So if your k decreases, let's say at k is equal to 1, where you are only looking at just one nearest neighbor and then predicting based on that, actually the bias is the least, which means it is the most flexible. K is equal to 1 is the will give you the most flexible sort of demarcating line or function, whereas the variability will be the maximum. So that's the sort of the trade-off, and that's how we actually determine k. So we have to get a k value in such a way based on trial and error that sort of maximizes our sort of or reduces the bias as well as the variance, and that's the kind of optimization we are trying to do. Okay, so how do we calculate the distance itself, right? And distance typically can be of many kinds. So the example here is of the Euclidean distance, but you can have other kinds of distances like Manhattan distance or Mahalanobis distance, and you can look up references for other kinds of distances. Now Euclidean distance is calculated for the point P1 and P2 as given here. Essentially Euclidean distance is nothing but the square root of sum of the x coordinates of these 2 points P1 and P2, and then y coordinate square of these 2 points P1 and P2. And this is just an example of one kind of distance, and other kinds of distances like Manhattan or Mahalanobis are also there. And then calculating this distance becomes quite challenging, especially in cases where you are trying to, for example, calculate, let's say, how close two LinkedIn profiles are, right? Or trying to classify the category of electrocardiogram and so on and so forth. So there we have to bring in more creativity to just decide what kind of distance to use. Okay, now let's move ahead. We will now talk of some use cases where KNN can be used, and this is an example of how KNN can be used for book recommendation. So if you have purchased books on Amazon or wherever, right, some of these recommendations are based on KNN algorithm. And then as we said, KNN is like based on features, right? So maybe let's say what will be the nearest neighbors of a particular book. It can be based on who is the author, what is the topic, and so on and so forth. And then there are other use cases like I mentioned, so for classifying satellite images, for classifying handwritten digits on image analytics, or for classifying electrocardiograms, etc. Typically KNN can be used. Okay, so now actually we will get into some hands-on. Okay, so to start the hands-on session, I'll go to this Jupyter notebook that I already have installed on my system, and I have a certain code written which we will take 2 examples. Both the examples are based on data sets which are available in the open source, so you can easily get access to that data. So what we do is we start by importing the necessary libraries. So we import pandas, Seaborn, NumPy, and Matplotlib. Basically, pandas and NumPy are there for doing the data manipulation and also for storing data as matrices or as arrays, and be able to perform some mathematical procedures on them. And then Seaborn is basically used for plotting, and Matplotlib for plotting as well. And this line here, get IPython, just helps us to run the images that we'll be creating in line with Jupyter Notebook instead of opening up a new window. So let's run this, and what it will do is it will import all these packages for us which we are going to use. And then we will first import the breast cancer data that is available in your scikit-learn datasets. So we import that, and then let's just initialize that data into a variable here called cancer. So cancer here represents all the breast cancer data. And now let's actually look at what this data is. It's a bunch of attributes in this dictionary here. So you have data, the target, which is basically nothing but whether it is a cancer or not. So whether it is malignant or benign. Malignant means it's a bad cancer, and benign means, well, it's just a tumor, it's not cancerous. Target's name, description, feature names, which is basically the features that will tell us whether a particular case belongs to cancerous or non-cancer, or malignant or benign. And then actually let's just print the description of this particular data here. So as you can see, we can use this command to print the description here. And then we see that there are 569 data points with about 30 attributes. And these attributes are radius, texture, parameter, etc. And the max and min values of those are given here. And then now let's look at some of the feature names. So these are the feature names, radius, texture, and so on. And now let's actually set up a data frame of this particular data here using pandas, this function here. So there are 569 data points, and all these are basically your features as we talked about. And let's look at the target variable, which is nothing but whether it is telling us whether a particular data point belongs to malignant or benign. So 0 is cancerous and 1 is non-cancerous. And then we convert the target into a data frame as well. And then let's look at the couple of examples of how the data points look like. This is, one row of the data points with all the several feature values that we have. So basically we use this package called standard scalar from scikit-learn for pre-processing and for standardizing the variables. And we initialize this standard scalar into a variable called scalar. So standardizing is nothing but, basically bringing all the samples to essentially the same range, right? Because what might happen is some of the data point, like for example, temperature might be from 0 to 100, and some price might be from, let's say, 1,000 to 100,000 or whatever, right? So the absolute values can lead to some issues with respect to the prediction. Therefore, we have to standardize it or bring it between, let's say, -1 and 1. So, and then a mean of 0, right? So we have to bring everything to the same scale to be able to compare the samples. So we first of all, we fit this standardization or normalization on the data set we have. And that is, we calculate the variance and the means, and then we actually apply it on the data set to transform it to the actual values. And then if we look at the scaled values now, so let's look at the scaled values. And this will give an example of the top 5 rows here. So we can see now the values are between -1 and 1, or rather it is standardized essentially with a normal distribution. And then we divide this data into test and train. So basically we will train the model and then we will test it on a separate data set. If you use the same random state, you should be able to get the same result. Otherwise, you may get a different result here. And essentially, we are keeping the testing size to 30, which means that we are dividing the entire data set into 2 parts. The train part, which is having 70% of the data, and the test part, which is having 30% of the data. And again, we are using this package called train test split from the scikit-learn package. So we get the X and the Y's, which are basically nothing but your train, and the X's are your predictors and Y is your predicted variable, whether it is cancerous or not. And then now let's import the k nearest neighbors classifier. This is the actual algorithm, which we are importing from scikit-learn package. And now we initialize this particular algorithm, and then we fit it on the data. And some of the parameters, as you can see, is basically what is the leaf size and so on and so forth. The nearest n neighbors we are taking. So we are taking k is equal to 1 here, basically, as of now. We will see the results based on that, and then we will change it and see how the results vary. And we now run it on we now try to predict it. And then we will now try to evaluate what the results look like. So we have imported the classification report and confusion matrix, which is basically trying to see whether we were able to correctly classify the cancerous and non-cancerous as non-cancerous as or not. So we can see that this is the actual and this is the predicted. So basically some data points here, 5 and 4, are classified wrongly. Otherwise, all the others are classified well. So if we look at the accuracy, calculated accuracy actually, so we see that the precision, which is true alarm, right, which is basically from the cancerous samples, how many were you able to actually predict as cancerous? So if you see, the accuracy is quite high, almost 94-95%. And then the recall, which is from all of the cancerous samples, how many were you able to actually predict accurately, is about again 94-95%. And F1 score is nothing but a combination of both precision as well as recall, and that's quite good as well. So with k is equal to 1, we are able to get already some good results. Now let's try to see how to choose the k value, right? So this is basically nothing but a bunch of code that actually runs the k value from 1 to 40 and then tries to check the accuracy. And this is just like doing a trial and error to see where we get the best results so that we can then use the best k value. So if you can see this particular plot here, after we plot the result from the running the trial and error from 1 to 40, we see that the error actually starts decreasing, and somewhere around this k is equal to 21, we get the minimum value of error. So for us, the best k value is 21. So now if we compare the results between k is equal to 1 and k is equal to 21, we should be able to see the prediction result. So as you can say, this was the result with k is equal to 1, which is we get about 94-95% accuracy. And then with k is equal to 21, we will see whether the accuracy improves, right? So we see that yes, the accuracy has now gone up to almost 99%, which is, we earlier had 9 misclassified data points out of all of the points, and then here we have just 2 data points which are misclassified from the test data set. So now this was one example of applying KNN on the cancer data set, which is available freely. And now let's look at another example, which is the iris data set, and again available freely as well. So iris is a type of flower, and we will see what flower is it. So just give me a moment here. So we again start by importing the necessary libraries, and then we'll look at what this iris data set is. So the iris data set comprises of 50 samples of 3 species of iris flower, which is iris setosa, iris virginica, and iris versicolor. These are the 3 types of iris flowers. And if you run this, basically we will find that, okay, sorry, we did not copy the code here, so it was giving an issue. Let's just run it again. Okay, so we see that it is this particular flower, which is iris setosa. So the iris setosa you can see. And now let's look at the other 2 kinds of flowers here. So which is iris versicolor. So this is iris versicolor. And then you have the iris virginica. So we see that this one is iris virginica. So essentially we now will import the sort of data set. We have already done that, and we will now use the Seaborn package to actually plot some of this data and see how it looks like, which is basically do some kind of exploratory data analysis. So if we look at the data itself, so this is the top 5 rows from the data, right? So essentially the data consists of basically what is the sepal length, sepal width, petal length, and petal width. And this is nothing but basically your petal is your this colored part of the flower, and the sepal is basically your green part here, right? So it is talking about what is the sepal length, sepal width, and petal width of each of the species, whether it is setosa, virginica, or versicolor. And we will see whether we can use KNN to actually classify these flowers into the data points into these categories of flowers. So let's do some quick exploratory data analysis on this. So we are running a pair plot on the data set, and in the meantime, I'll just copy another part of the code here. Okay, so now the plot has come up. So as we can see that the green is basically your setosa flower, and we can see that this pair plot actually just plots the sepal length, sepal width, and the petal length, petal width of each of the samples of setosa, versicolor, and virginica. And we see that the green dots, which are the setosa flower, is actually quite separable from the others. It's when you plot, let's say for example, sepal length and petal length, right? We see that this is quite separate from the other data points. So let's see whether we can actually be able to classify it using KNN or not. And here we are running a kernel density estimation function on the setosa flower to check what kind of distribution it has. So this is the kernel density estimation plot using the SNS package. So only for the setosa flower. So if we plot the sepal length and sepal width, we get something distribution like this. So essentially we see that the maximum centered around here, and then there is a distribution, as you can see here. So there's some kind of a linear relationship here. Okay, so now we will again do the same standardization of the variables that we had done in the cancer dataset case. So we are importing the standard scalar function from the scikit-learn pre-processing. So we will initialize that. So we are again basically doing the standardization or normalization of the data. And we will do the standardization on everything except the species, which is a categorical value, right? So it's categorical whether it is which kind of flower it is. So we have removed that, and then we have done the standardization or normalization on rest of the data. So we now convert this into a data frame, a pandas data frame. And if we look at the top 5 rows, now it's all converted or transformed. So the values are now normally distributed basically. Okay, so now we divide the data again into train and test. And we again have a training of about 70% and test data set of about 30%. So we are dividing that entire data set into these 2 buckets. And we will now use KNN to see if we can use KNN to classify them. Again, the same k is equal to 1. And we will check the results, and then we will do a trial and error to check what is the best value of k. So here k is equal to 1. And now we are going to predict on the test data set and look at the results. So we are now importing the classification report and the confusion matrix. So if we look at the confusion matrix, we see that kind of already we are getting quite good prediction. So just 2 misclassified points. And if we look at the accuracy, we see that the accuracy is quite high, around 96% already. Now we have to see what is the best value of k. So essentially we will again run k is equal to 1 to 40 and check which is the best value. So let's plot the errors when we vary the k from 1 to 40. And we see that actually the error decreases and then increases. So basically the error is minimum with k is equal to, let's say, 3 or even 5 or maybe 11. So let's choose one of these values. So let's say k is equal to 3. And let's see how the results look like. Does it improve the accuracy or not? So we now see that even the 2 data points which were misclassified earlier is now classified properly. So the accuracy improves to 100%. So that's the example of how you can choose k.
What is naive Bayes? Let us understand naive Bayes with an example. Here, I just cannot seem to figure out which are the best days to play football with my friend. Can you please help us out? All possible conditions are given to us. There is summer, monsoon, and winter, which is nothing but the outlook. Am I correct in saying that? Summer, monsoon and winter is nothing but the outlook. Then we have sunny or not sunny. So that basically is the humidity, right? And then we have windy or no windy. That speaks about the winds. How are the winds, right? So if you look at these combinations, okay, we will look at this using navy bars on how do we decide whether we can play or not. So if I have noted down all the days it was good, bad to play football and the combination of weather matrices on that day, that will be perfect, right? That is perfect. And we will be able to do navy Bayes classifiers using that. Now, navy Bayes classifier comes from the navy Bayes theorem, and navy Bayes theorem is purely and purely based on the assumption of independence. So what does it mean? When I say independence, what it means is that this variable has no relationship, no association with this variable. Now, when I talk about this in a linear context, obviously in summer, you will see that we have more sunny days. Yes. So if you look at it from the correlation area, from the linear algebra concepts, linearly, these two are correlated to each other. Am I correct in saying that? Obviously, in monsoon, we have less sunny days. In winter, we further have less sunny days. Yeah. So, although there is a relation, Navy Bayes theorem says that all these variables are independent of each other. What does that mean? If this is causing any kind of an effect, if this is causing any kind of an impact, this should not matter. Okay, there is going to be no relationship. Summer, monsoon, winter, it has its own weightage. Okay, and it has nothing to do with the other conditions. Every condition is equally significant. All right. So what happens in Navy Bayes is we estimate the posterior probability of every event happening. Here we calculate the posterior probability of an event happening. Okay. So here if you see, if you look at the sunny conditions, what we have done, sunny conditions, we have this distribution that there is no play happening in summer, there is play happening in monsoon, there is play happening in winter, right? So based of the season, we are figuring that out. Similarly, for windy conditions, we are doing that, right? Again, then we do it for a combination, right? Whether when windy conditions are yes and no, what happens to play? Okay. So here, what at the end of the day, what gets selected is the one which has a posterior probability of greater than 5. Now, when I talk about posterior probability, what do I mean by posterior probability? Let me have a blank slide. Here you go. Actually, it's given, so I need not show you that. What is the simplistic probabilistic classifier here? What is the probability of an event A happening given B? So if you look at our problem context, what is it that we are trying to figure out? We are trying to figure out what is the probability of play happening given the outlook is sunny, comma, the winds are normal and there is no rain. On any given day, when there is no rain, there is no wind, and the outlook is sunny, whether play will happen or not. So what we end up doing is we calculate the posterior probability of play happening given these conditions. We also calculate the posterior probability of play not happening given these conditions, and then we normalize these probabilities. Mathematically, we do all of these calculations to figure out Navy Bayes. Okay. Now here, see, here we are talking about one event. Here we have three events. We have outlook, we have winds, and we have rains. So what this becomes is probability of 3 independent events. So what we will do, we figure out what is the probability of play happening given outlook is sunny. We also figure out what is the probability of play happening, multiply this with the probability of wind as no, given no, then probability of play happening given rain is no. We figure out all the three independent probabilities, multiply it. All right, this is what we do mathematically. This is what is done mathematically in Navy Bayes theorem. Ultimately, the posterior probability of an event A happening given B conditions is calculated by first calculating the class probability. What is the class probability here? Probability of it raining given play was happening in that day. This is multiplied by the total probability of play happening and divided by the total probability of sunny conditions. Here, as you see, this is the posterior probability. This is the class probability. Here is the predictor's probability. This is the outlook. X is the outlook. C is what we are trying to predict, right? And here is the likelihood. So how is this formulated into our table? Now, if you correlate this to our graph, what will be the likelihood? What will be the likelihood of sunny conditions given play happens? Sunny conditions, play happens. 2 divided by 3 out of, sorry, how many sunny conditions do we have? 6 conditions. In 6 conditions, how many days does play happen? 2 days. 2 by 6, 1 by 3. What is the class probability? So of all the events that are given to us, how many days does play happen? Okay, this is how this is calculated. So here you see what we have done is, let me go back to the previous slide. Here you go. Okay, here what we have done is we have calculated this table. Now it speaks about a data set. Where can you get this data set? You can look for golf play days data set online. You can look for golf play days data set. Okay, in this data set you will find all the data which is required for this particular example to be done. So what I will be doing is I will be doing this example, this Navy Bayes classification with you in Python. All right, so whatever calculations are being done here, okay, I will do the same activity in Python with pen and paper, and instead of doing this in a numeric way where I'm doing a lot of probabilistic calculations, I will achieve this simply in very limited lines of code, with Python. Once I have done that, I will come and explain this probability table to all of us. I'm going to use some basic libraries. All right, so here what I will be doing is using some very basic libraries for this activity. All right, done. Now let me quickly go and read the data set So for that, what I will do is quickly change my working directory. And now let me quickly go and read my data. So my data frame is pd dot. Here you go. This is my data set, right? So if you look at this data set, in this data set, you have 14 days. In these 14 days, you have the outlook, overcast, rainy and sunny. You have temperature. Temperature is hot, cool and mild. You have humidity, you have wind, and you have play, right? So I will not be using okay, let us use all four. In this example, they are using only 3 variables, but in our hands-on, okay, in this hands-on, what I will be doing is I will be using all 4 variables. Let us do that. Okay, so before I do that, let me convert everything into a category. If you look at your data frame right now, it's not, everything is not into a categorical variable. Here you go, see. Okay, so let me quickly go and convert everything into a category. And once I have done this, let me create a new data frame in which I have everything as a category code, so that I have numbers. I'll show you what do I mean by this. So let me execute this. Here you go. See, now I have 2 data frames. In the first data frame, I have all these values. These are now categorical variables. But in the second data frame, I have all ones and zeros. So wherever you see there is sunny conditions, now I have a code 2. Rainy conditions, code 1. Similarly, when play happens, I have a 1. When play does not happen, I have a 0. This is what I have done. This data frame is available online. Okay, you can get this data frame online. All right, now my data frame is ready. So now what I'm going to do is I'm going to divide my data frame into training and testing. I have 14 records. So let's take 10 records for training. I will give 10 records as an input, and I will give 4 records, last 4 records, as my test data frame. All right. So now I will need to create my X and my Y. So how I will do that is I'll say Y underscore train is equal to, from train, I don't want the play variable. That play variable should be my Y. As simple as that. And I will say X underscore train is equal to train. Okay, and I will do the same thing for my test data frame also. Now, those who are new to Python will find this a little bit strange. Please bear with me. But these are the only calculations, only steps which need to be performed every time you are trying to achieve Navy bias algorithm or any kind of an algorithm. Right? So here, now you see, this is my training data frame in which play variable is not there. Play variable is not there. This is my Y, in which only play variable is there. This is my training data set. So both of them have 10 records with the matching index. Similarly, test data frame, 4 records with the matching index, right? So that we know which data frame is where. Now, multinomial navy bars. Very simple, 3 lines of code and my model will be done. Okay, first I initialize my model. Here you go, I have initialized my model. In this model, I fit my data. In this model, I will fit my data. So to do that, what I say is fit x underscore train comma y underscore train. Done. Your model object is now ready. And now you can simply get the classification outcomes. So we have in our test data frame, if you look at our test data frame, this is our test data frame. We have 4 conditions. All 4 are sunny, high temperature, low humidity, and windy, right? And if you look at their outcomes, these are their outcomes. On the first 2 days, play is not happening. On the next 2 days, play is happening. Let us look at what is the prediction of our model for this. So to do that, what I simply do is x out is equal to model.predict. To this, I give my x underscore test. Here you go. Okay. Now you have your y out variable. So this is the prediction for all the 4 inputs that you give, and this is the prediction. First day, we say play does not happen. Let us match it. Let us try to match it with our here. See, out of 4 records, 3 records we are predicting correctly. 3 records we are predicting correctly. If you want to check the accuracy, what is the accuracy of your model? What you can simply do is print. Let us print the accuracy on both training and testing. Training accuracy. How do I get the training accuracy? Very simple. Model.score. And here I give my x underscore train comma y underscore train, and then we do the testing accuracy also. Here you go. So here you can see for our model training we have 80% accuracy, and for testing we have 75% accuracy. Okay, so this is the advantage of doing this activity in Python. But what is happening in the backend? Now let us go and also understand that in terms of naive Bayes classifier. We have successfully implemented the naive Bayes classifier in Python programming language. But here, let us try to understand Bayes theorem, what is happening. So from this data set, all the tabulated data frequency tables are calculated. Once the frequency tables are calculated, they are substituted in our formula to calculate the probabilistic scores. So what is the probability of summer given it is playing conditions? Total, how many playing conditions are there? Total, there are 9 playing conditions. 9 days play happened. That becomes our denominator. Out of those days, how many days was summer is our numerator. That is how for this we get a probability of 0.33. Then we calculate the class probability where we look at how many days was it summer. Out of total 14 days, 5 days was summer. So that's the probability, and the class probability is 0.64. Put everything into our equation. And this is what we get. Okay, so we do this for each and every condition. So here we calculated for winter. All right, once we have done it for all 3 days, winter, sunny and windy days, we substitute those here, and that gives us the probability which is more than 0.5. Thus now we can say that if it is winter, sunny, and conditions are sunny and there are winds. Conditions are not sunny and there are winds. Play can happen. Look at another example. If a single card is drawn from a standard deck of playing cards, the probability that card is a king is 4 by 52, since there are 4 kings in a standard deck. King is the event. This card is a king. This is the event. The prior probability of this is 1 by 13. If evidence is provided, for instance, someone looks at the card, that the single card is a face card, then the posterior probability can be calculated using bias theory. Okay, since every king is also a face card, the probability of face happening given you getting a face card given it's a king is 1. Since there are 3 face cards in each suit, all right, it's actually 4. Ace is also a face card, so it's jack, queen, queen, and ace. The probability of the face card is 4 by 13. Okay, so if you combine these 3 likelihoods, what you get is 13 by 4. So using bias theorem, this is the probability that you get.
What is support vector machine? Support vector machine comes under supervised machine learning, and we use it specifically for performing the task of classification. So support vector machine is a discriminative classifier that is formally designed by a separate hyperplane. Okay, it is a representation of examples as points in a space that are mapped so that the points of different categories are separated by a gap as wide as possible. So in this case of this support vector machine, let's say I have some data points. So there are some data points of X and there are data points of circle. Now this support vector machine is a type of machine learning algorithm where if I have the collection of points, so here in this data points, I have 2 classes. One is X and the another one is circle. Now, given this kind of data points, okay, given this kind of binary classification problem, so the expectation is, in case of support vector machine, I'm going to draw a hyperplane which separates as much as possible. Okay, so I'm going to draw a hyperplane which separates these 2 classes as much as possible. So it says that I'm going to draw a hyperplane and it will be separated by a gap as wide as possible. So that is the intuition behind support vector machine. Okay, now that you have an intuition behind what is support vector machine, let's understand as how does this SVM, that is support vector machine, would work. So in case of support vector machine, so here there is one more example. I have the set of points which is green color, and I have another set of points which are in red color. So these 2 points are belonging to the different classes. Now what I'm going to do is I'm going to draw a hyperplane which separates these 2 classes data points as much as possible. And when I'm drawing the hyperplane, I'll make sure that this hyperplane is equidistant from my support vectors. Now the support vectors is nothing but the point which is closer to my hyperplane. Now here in this example that you're seeing, this data point and this data point are called as support vectors because these are the data points which are nearest from my hyperplane that I've just drawn. If I am trying to make use of this SVM model, it is going to draw this kind of hyperplane to make sure that it is separating 2 classes. The 2 classes that we have over here in this example is red and green. It's going to separate these 2 classes as much as possible, and it will be equidistant from my support vectors, and the support vectors are nothing but the nearest point to my hyperplane. And that is how I'm going to separate between 2 classes when it comes to support vector machines. Now here in this example that you're currently seeing, the hyperplane that I've just drawn, so this is a simple linear hyperplane. This is like a straight line that I'm trying to draw if I want to separate 2 classes of data points.
Now, apart from drawing this straight line, we also have other kind of lines as well, which we can draw. So let's see how we can do that. So the types of line that we can draw, or the hyperplane that we can draw, is called as SVM kernels, that is support vector machine kernels. The example that we have seen, it's an example for linear SVM kernels. So let's see what are the other types of kernels that we have. So when it comes to SVM kernels, we have linear kernels, radial basis function kernel, and along with that, we also have polynomial kernel. Now, in case of linear kernel, I'm going to draw a hyperplane, which is like a straight line. In case of polynomial kernel, I can draw my hyperplane on the basis of polynomial function that I have created, on the basis of number of variables that I have, and the degree that I have over there in case of polynomial. And in case of radial basis function, so I'll make use of radial basis to separate my data points. Okay, so these three are the important kernels that we have in SVM, and this is one of the commonly asked interview question when it comes to the topic of support vector machines. Now, let's look at some of the use cases, or the way we can do, where we can use this SVM to work, or let's look at some of the use cases where we can use this SVM. Okay, so we can use this SVM on many of the use cases. So to name a few, we can use it in face detection. We can use it in text and hypertext categorization. We can use the SVM if I'm trying to classify any images. I can make use in bioinformatics. And if I'm trying to detect something, so I can, in an example here, remote homology detection, handwriting detection, or in general, we can make use of this generalized predictive control. So wherever we are dealing with the task of classification, we can use this SVM model. Okay, now that we have a theoretical understanding as what is SVM and how it is actually going to look like and how it will be, let's have a quick walkthrough as how we can implement this SVM. Now, to implement this SVM, these are the common steps that we are going to follow. We are going to load the data, we'll explore the data, and once we have explored the data, we are going to split the data into two parts. The reason is simple. When I have training, so I'll be making use of my training data, and once my training is complete, I'll check how my model has been trained with the help of my test data. So I'm going to split the data. Now once that is complete, we are going to train this SVM model, and finally we can evaluate the model and observe as how model is working. So this is the overview of the implementation of support vector machines. So let's do one thing. Let's work it out and let's create the notebook in Google Colab, and let's see it in action as how we can implement this SVM. I'll come back to my Google Colab. So this is the notebook that I have already prepared, and I'll give you a walkthrough as we proceed along. Now here in my first cell, I'm importing my NumPy library, pandas library, and along with that, for creation of plots, I'm importing my matplotlib library. Now if you are comfortable with Seaborn, you can use the Seaborn library as well. So in my example, I'm just making use of matplotlib because we are not interested in creation of visualization, but we want to understand as how a model is being working. Okay, and I'm going to execute this cell. So this is going to take care of necessary imports. I'm importing my necessary libraries. And once that is done, here I'm importing this SVM. So this SVM model is available inside my sklearn library. So I've mentioned as sklearn.svm, and from sklearn.svm, I'm importing my SVC. Okay, so I'm importing my SVC. So I'll show you what is this SVC. SVM SVC. So it's C means support vector classification. Okay, now here when I'm instantiating this SVC, I can mention what is the kernel that I want to use. And if I'm working with any polynomial kernel, then I can also mention what is the degree of polynomial that I want to use while performing the fit for my data set. So I'm importing my SVC, and along with that, I'm also importing the data sets. So in the sklearn library itself, we have a data set. So sklearn host already, like it actually, sklearn has many toy data set which will actually help us in our learning journey. So we are going to use one of the data set, the famous iris data set. We use that for multi-class classification. So I'm going to load that iris data set, and I'm just going to extract only two features. So the two features that I'm extracting is petal length and petal width, because I don't want to complicate it. I just want to visualize the data. So in order to help in visualization, I'm just getting only two features of my given data, and I'm separating my y as iris target. So whatever the target variable that I had, I'm assigning to my variable of y. Then I'm going to do this check whether it is setosa or versicolor. That means this default data set, which is in multi-class classification, I'm just going to convert it into a binary classification task. You'll get a better understanding once I execute this next cell. So this is going to prepare my data set, and once the data set is prepared, if I create a scatter plot, so I'm just creating the scatter plot to show us what and how my data set looks like. So this is how my data set looks like. On my x-axis, I think I'm having petal length. On my y-axis, I'm having petal width. And here, the blue points refers to the class 0, and the orange points refers to the class of 1. Okay, so this is how my data set looks like. You can clearly see that I have one set of points in one region and I have another set of points in another region. Now this is a classic example to understand about the SVM. How does it draw a hyperplane? So we have the data set ready, and as I mentioned already, in order to fit this model, so when I say support vector machine, I'm going to draw a line. This line that I have drawn, it will be equidistant from my support vectors. Now here in this example, the support vector is this, because this is the only point which is nearest to my line. And here I think this is the data point which is nearest to my SVM line, that is this fisted line, hyperplane line. So I'll be placing this hyperplane such that it is equidistant from the support vectors. That is how I'll be drawing this support vector line. So we now have an intuition. Let's see whether we get the same outcome as we are expecting. So here I'm initializing my model. So for initialization, I'm saying it as SVC. Use the kernel as linear because I'm able to draw a line effectively. We just seen, and I'm using the C as infinity. That means it should be a hard classifier. So hard classifier means I want the 100% result. I mean, I don't want any loose ends. I want to draw a line which clearly separates two classes. So I'm saying it as C as infinity to mention this as a hard classifier. And once I initialize any model, here in this scenario SVM model, I am performing the fit on my data set. Now this is the common flow that we follow whenever we are performing the fit. So we'll initialize the model and then we perform the fit on a data set. Now since this SVM being a supervised machine learning model, I have to specify both my input X as well as my output Y. Hence SVM classifier.fit X, Y. So this is going to perform the fit for my data set. I'll just execute this. So this has performed the fit, and here it is giving me the confirmation as this is the parameter that are being used to perform the fit. Okay, now once I have drawn and once I have found this fit, next if I want to display the weight terms, so I can say it as SVM classifier dot coefficients. So these are the weight terms. And if I want to display my bias term or the intercept, it is minus 3.78. Now this means the line that I have just drawn, so that line has the that line has the C term as, or the W0 term as minus 3.78, and W1, W2 are 1.29 and 0.82 respectively. So that's how the data is distributed for us. That's how the values has been found for our scenario. Next, in order to get the better visualization, here I have created a function that is called as plot SVC decision boundary, and this takes my SVM model, the Xmin and the Xmax. Now W and B I'm extracting from the coefficient and the intercept parameter that we have over here. So we are extracting from this attributes that we have from this model. And now if I want to draw a decision boundary, so I need the set of points. So in order to get the points, I'm saying it as x naught is equal to nb dot linspace xmax comma xmin comma xmax comma 200, and I'm specifying as how does my decision boundary should look like. My decision boundary is given by w0 into x0 plus w1 into x1 plus b is equal to 0. So this is what my decision boundary would look like. So I know what is x0, I know w0, I also have w1, and I also have b. So the only term that I do not have is my x1. Okay, so the only term that I do not have over here in this example is x1, and the x1 if I want it, so I just have to substitute it. So x1 is equal to minus w0 divided by w1 into x0 minus b divided by w1. Now I'm specifying the same equation over here for my x2. So my x0 and the decision boundary will give me the pair of input and output. Okay, now along with this, there is a property in SVM. Okay, so the property is given by whenever I have a margin, so that margin is given by 1 over w1. Okay, so the margin is nothing but the distance between my hyperplane and the support vector, so that is given by 1 by w1. Hence I have mentioned as gutter up and down. Gutter up means one line, or the one line where the support vector lies, so that is given by decision boundary plus margin, and one line below my below my hyperplane, that is where another support vector would lie. So I have mentioned as decision boundary minus margin. Okay, then I'm defining where exactly my support vectors are present. My support vectors, I can access the support vector coordinates by saying it as, by accessing the attribute of my train model support underscore vectors underscore. Now I'm specifying where exactly those support vectors are present with the help of a simple scatter plot by highlighting my support vectors, and I'm specifying where exactly my decision boundary is present, and I'm also mentioning where is my line that is gutter up and gutter down. So let's do one thing. I'll just execute this. This is going to create me a function. I'm going to call my function support vector machine classification, and I will specify my range of x and y as here, yeah, xmin and xmax as 0, 5.5. I'll just execute this. So what we have done just now is we have created this hyperplane. So the middle one, the solid line that you're seeing over here, so this solid line is called as your hyperplane. And these points that you're seeing over here, so these 2 points which are highlighted, these 2 points are actually called as support vectors. Okay, so this dotted line that you're seeing, so this dotted line refers to my gutter up and gutter down, which I've found right here. Let's do one thing. I'll add some labels so that you'll get some more visualization in the plot itself. I'll say label, and I'll mention it as hyperplane. Okay, and there is one more, yeah. These are support vectors, and I'll say pld.legend. So this clearly says which are all my hyperplane and which are all my support vectors. So this is the intuition behind support vector machines. So we'll be drawing a hyperplane which separates the points that we have. Okay, and whichever the point which is nearest to my hyperplane, we call that point as a support vector. Now to access that support vector, we make use of the attribute. So let's do one thing. Let's explore the attributes svm dot support underscore vectors underscore. So this is going to tell me where exactly my support vectors are present. So one point is given by 1.9.0.4. I think this is the point that I'm talking about. And the another support vector that we have is at the location 3 comma 1.1. So 3 and 1.1, this is where we have another support vector. So using all these attributes, we have been able to create this visualization. Okay, now whenever we are working with the support vector machines, it's very important that we scale the data first. If I do not scale the data, I'll not be able to get a better fit of my SVM model. So here I've given one more example where I have my X is given as 1,50, 5,20, 3,80. As you can clearly see, it's not scaled. Okay, so I'm going to execute this cell. So this is going to tell me and give me a visualization as how the fit will be in case of scaled and unscaled. See, if it is unscaled, if it is not scaled, okay, that means if it is unscaled, we can clearly see that the hyperplane that I'm drawing and the distance from my hyperplane, it's very close to each other. And whenever I'm working, it will be difficult for me to separate those two data points. But if I scale them correctly, now here for scaling, I have made use of a scalar and standard scalar. Now, if I scale it correctly, then in that scenario, it will be easier for me and it would actually work better when I have scaled data. Okay, so this is about using the linear SVM model to perform the fit on my given data set. Now, if I go below, we have some more examples about nonlinear classifiers as well. Now, in order to test out the same, here I'm creating an example dataset, and that dataset that I'm generating is called as make moons dataset, and this has been generated with the help of sklearn dataset generator. Now, as you can clearly see, I cannot make use of linear classifier. So linear classifier is nothing but a classifier, okay, which is an SVM model where I'm drawing or where I'm using a straight line to split my data points. I can clearly see that wherever I join or wherever I try to draw a line over here, I cannot split the data in an effective manner. Now this brings us the challenge. Now if I have a data set in this way where I cannot linearly separate it, how can we go about and perform the fit on our SVM model? So in order to save us, we have a model that is called as SVM model, and from that SVM model, we can actually create a polynomial kernel. So we can make use of polynomial kernel, and using that polynomial kernel, I can actually create it like this. I mean, using polynomial kernel, I can perform polynomial regression, or I can draw a line like this. Now to show you how it works, I'm getting some data like this. So this is some random data, and I'm making use of pipeline. So this pipeline is going to take care of my standard scalar as well as kernel. I'll do one thing, I'll just come below. So this is what we are currently interested in. So here I'm importing the polynomial features, and I'm generating the polynomial features for my data. I'm performing the fit and transform my polynomial data. That means I'm just modifying my existing data and I'm sending it for my X. Okay, so this is how my pair of input X and Y looks like. Now I'll use my X. I'm going to transform it with the help of my polynomial features, and then I'm going to scale it with the help of my standard scalar, and I'm going to send it inside my classifier, that is SVM classifier. Okay, so I'm going to combine it together like this. Now observe what would happen. And once that is complete, see, with the help of my uh, polynomial features that I have applied on my given linear data, so I have increased the degrees by which my model can learn. Now instead of straight line, my model is also having the ability to learn this complex representation as well, because I have increased the model complexity by adding my polynomial features. And while doing it, to make sure that we follow a clear path, so I have defined this sklearn's pipeline. So if you're new to data science machine learning, I highly recommend you to learn this concept of sklearn pipeline. Now this sklearn pipeline helps us to combine multiple operations in a single call. So here we have created a pipeline. This pipeline is going to add some polynomial features for my input data, and on top of it, this is going to perform scaling, and then I'm going to perform this binomial classification using this SVM. And finally, I'm performing the fit on my data set. See, when I perform the fit, it takes my input X and it's going to do all these activities. It is going to chain all these activities together, and then it is going to perform the fit for my data Y. Once the fit has been complete, so we can validate how my model is performing.
So what is a clustering technique? Clustering technique is something that we will use it for grouping purpose. So especially there is a very easy way to understand what is clustering technique. You would have seen such a while we are going through an COVID-19 situation, the governments has came up with creating some containment zones, as all of you must be knowing. So how, on what criteria government has taken that, okay, which area is supposed to be a containment zone, or which area is supposed to be applied with some restrictions, or which areas can be considered as normal, on what criteria that they have created. So that's what using clustering technique. Which means the governments, or when I say government, means that the people who will be taking the final decision in such criteria, either prime minister, either the chief ministers of that particular state will be taking decisions whether to go for a lockdown, whether to not to go for lockdown, or which areas has to be considered as containment zones or non-containment zones. So those high-level decisions are something which will be taken based on the clustering technique output which is generated by these algorithms, based on a number of inputs. Okay, what is the population in a particular area? How many number of people are affected? How many number of hospitals which are present? How many number of people who are been recovered? So likewise, based on these multiple criteria, people will do some clustering technique on top of the data, and according to that, people will be segregated, or the areas will be segregated. So that saying that, okay, these are the observations which belong to one cluster, these are the observations which belong to one cluster, like that, so that people can cluster them, which can make organizations to take decisions on a very high level. Okay, that's what is our clustering technique. Which clustering technique output will contain the different groups. It itself will group the different components based on whatever the number of clusters that you want to generate. That may not give the direct output. On top of the generated output, people will be taking business related decisions. That's what is all about clustering techniques. Okay, so now what we will do, let's take an example of within clustering techniques, what are the different types of clustering techniques we have. So what are the different types of clustering that we have? So there are multiple types of ways based on the type of output that we want to produce. There are multiple different types of clustering techniques we have, but out of which let's try to understand about what are the very famous and most widely used clustering technique algorithm, out of which we have something called k-means clustering algorithm is one of the very famous and most widely used. More than 90% of the people will end up with using k-means clustering algorithm, which is very famous in clustering techniques, right? Which is very famous in clustering techniques. So what are these clustering techniques? As I said, how this clustering technique will work. So k-means clustering is nothing but, always remember one thing, if any one of you are going to work in machine learning or anywhere, wherever you see a notation called k, by default K is nothing but you are supposed to, as a user, you are supposed to provide what is the input of K, which means wherever you see there are multiple techniques that we have in machine learning, like K means clustering technique, K nearest neighbor is one of the algorithm, K fold cross validation. Likewise, wherever you see a notation called K, what does a K means? It's an input that you are supposed to provide. Always remember this. It's an input that you are supposed to provide to your algorithm. Your algorithm cannot identify that K value. Of course, everything else will be taken care by your algorithm. But whenever you see K, which means in K means clustering, what is the meaning of K means clustering? How many number of clusters that you want to provide? That is something that you have to input it to your algorithm. That is something that you have to input to your algorithm, right? Here, the meaning of K is how many clusters that you want to generate. So how many clusters that you want to generate? Okay, when you have 1,000 observations which are present, when you have 1,000 input records which are present in your historical data, how many number of clusters that you want to produce? Do you want to go for one cluster? Obviously, one cluster means that the entire data set will be considered as is. Do you want to create 2 clusters out of the data? Do you want to create 3 clusters out of the data, 4 clusters, 5 clusters, or 10 clusters? So how this can be done? There are multiple steps that are involved in generating K-means clustering algorithm. So you can see, choose the number of clusters. This is what is nothing but your first step. It means you need to decide what is your K is nothing but number of clusters that you want to produce. And then there is an initialization of centroids will happen as a one-time activity, right? So there is an initialization of centroids which will be declared, that will be used as your initial step for your machine, and then assign the clusters, move the centroids, and optimization, and then converge all the clusters into one component. Yes, I know it will be very difficult to understand by looking at this thing. So let me show you a very simple example how exactly it will be done. Maybe let me take a simple diagram for you to show how exactly that's going to work. Okay, so let's say, for example, I'm going to take some historical data just to explain you on how exactly the K-means clustering algorithm will work. So what is that it is written in the first step? What is that it is written in the first step? So the choose number of clusters. Choose number of clusters. Now, which means, say for example, we need to take some historical data. I'm considering some historical data here. Let's assume this is the historical data. Let's assume this is the historical data that we have. So as you can see, there are multiple historical data points. So as you can see, the first step, choose number of clusters, which means, let's assume, to make this thing simple, I'm going to choose that we want to have 2 clusters generated. Okay, so this is, which means we want to have 2 clusters created. So because my number of clusters that I want to generate is 2, I'm going to consider that there are 2 centroids which are present. This is my first step. How this algorithm will do? How algorithm will come with the number of clusters? So this is how it will happen. So first step is to choose the number of centroid and then initialize your centroid. That's the second step. So now what is the third step? Let's assume this is observation number 1. This is our data point 1. So now what is the next step? We will take the distance from every observation to every centroid and every observation to every centroid, which means, now tell me, which observation, for this observation number 1, which centroid is more closer? Is the green color centroid is more closer, or the red color centroid is more closer for this? Centroid means that data points, the one which I have highlighted, that's what we call a centroid, data points. We have chosen 2 centroids only because that is as a user, you are supposed to input what's supposed to be your K. What's supposed to be your K value, that's what I said. You need to know what is your K is nothing but how many number of clusters that you want to provide. Usually your business users are going to provide that. In case if you're going to work in this kind of algorithms, they will provide that. Or else there are some methods available like elbow method or other things. We will talk about that. Now this observation is more closer to red color. So now what happens? What is the next step? The algorithm will assign this particular observation 1 as a red color for now, as considering that this belongs to red color. Likewise for the second observation, when the second observation appears, what is the distance from the second observation to both the centroids? Now which one is more closer? I see green color is more closer. So now I'll mark this as green color. If the distance is same equal, so then the algorithm will force any of the observation to get into any of the centroid. So number of clusters, number of centroids that you will choose based on the K value, as I said. Now you're going to likewise you will repeat the same process, and whatever the observation which is more closer to whatever the centroid it is, you will mark them as with their so-called mark like this. Now you are going to initially mark them as observations into either into green color, either into red color. So now these observations are now considered as green color observations, and these observations are now considered as red color observations. This is step number 1. What is the step number 2? Step number 2 is segregate all these red color observations and take the average value of x and y coordinates, and repeat the same process for calculating average coordinates of x and y coordinates for the green color observations. Take the average of all these observations, calculate average, and take all these observations, take the average. You'll end up with getting a new centroid positions called xy, which means now you ended up with getting a new centroids. In the initial step that we have taken random centroid, now you got the centroids that you can use based on the previous iteration. Now you ended up with getting a new centroids. You repeat the same process again you repeat the same process. Take the distance from every observation to every centroid and assign the observation based on the nearest distance, and continue to mark every observation either into red color or either green color or whatever it is, and you repeat the process until you will be able to see there will be no change applicable for your clusters. You repeat the process, which means in every step you might end up with changing your centroid. Every step will continue to change your centroid. Now the centroid might become like this, then later your centroid will become like this. Likewise, your centroids will be keep on moving. Initially you are taken it like this, but it might continue to move like this. Somewhere it will be fixed, and after that there will be no change that you will notice if you are repeating the same process. At this particular stage, whatever the observations which are marked into, which are grouped into green color, you will say like these are the green color observations. Whatever the observations which are marked into red color, you will mark them as okay, these are the observations which belong to red color. These are the observations which belong to red color. Likewise, you will segregate all these observations either into red color or green color, right? So that's how we can generate these clustering technique. That's how the K-means clustering algorithm will generate these algorithms, output of using this algorithm. Okay, so that's how K-means clustering algorithm will work. Okay. So now, likewise, there are multiple algorithms that we have. So like when we talk about machine learning, so there are multiple types of algorithms that we have. So like how we have the how does the k value will occur, as you can see on the PPTs which are also mentioned. So you're going to choose some randomly generated k value, and you will be choosing the number of k's over here, and you can see that it will assign them based on the number of this most nearest distances, and according to that you will change your centroids. Once you change your centroids, you will repeat the same process until you are able to change that your centroids don't move further, and then once it has been finalized, you will say like this is the final centroid and final cluster output that we can generate out of this, right? So likewise, we also have different types of clustering technique, and the second type of clustering technique that we have is fuzzy or C-means clustering. So what is fuzzy or C-means clustering? The output will remain same. So C-means clustering means that there are places that one or two observations can belong to one or two different clusters, right? One or two different clusters, which means usually the primary difference between your C-means and K-means clustering technique is, in case if there are any observations which are having equal amount of distance, usually in K-means clustering what we will do, we will force this observation to be part of any of the cluster. But in C-means clustering, based on the distance that we see, there are chances that an observation can go to or can belong to one or two clusters. So it purely depends on the business use case, who is going to decide to either to go for K-means clustering or C-means clustering based on the business use case, based on our business outcome. So if people are going to decide whether to go for C-means clustering or K-means clustering. So there are a number of observations which might, it's not mandatory, which might can belong to one or more clusters that can happen. So the third is agglomerative clustering. So which is the third type of clustering technique that we have. Okay, so which is also one of the clustering technique that we have. Okay, so now which can also be used here. Okay, so now what is this agglomerative clustering? So this is what we also call it as hierarchical clustering. So in times you'll also call them as hierarchical clustering. These clustering techniques are built using H clustering. In short, we call it as H clustering. And also people will also call it as hierarchical clustering technique. So what are this? So based on the type of algorithm, they will try to, there is a mathematical expressions which are involved in it, but considering that the limited time that we have, I'm not going to take you through all the in detailed depth of it. So considering the way how the data points have been segregated, it will build a kind of dendrogram. So on top of this dendrogram, your observations can be classified here like this, as you could see on the screen. Is K-means clustering sensitive to outlier? You need to understand one thing. when we are talking about unsupervised learning algorithms, as I said, you may or may not have clarity on the data, which means your assumption is that at the least level, you don't have clarity on the data. Then if you don't, when you don't have clarity on the data, how can you say this is an outlier or this is not an outlier? When you have clarity on the data, especially when you're working on supervised learning algorithms, you can. But you don't have output column also. How you will be able to evaluate how the so-called output column can be evaluated, because this is not been classified properly, this is not been clustered properly based on the historical data, because there is no output column. So those type of concepts are something which you don't need to worry about when you are working on unsupervised learning. They will be constrained when you are working on supervised learning algorithms. And of course, in case if you see that there are outliers which are present, obviously it will be considered as one of the clustering any of the cluster, it belongs to the data. But anyhow, that's the characteristic of the data. You don't need to you don't be taking care, because you might be killing the actual original values which are present in the data, but you cannot expect that outlier can be recognized out for all the cases that you have in unsupervised learning. So the next type of clustering technique that we have is division clustering. So what is this division clustering? As the division clustering is also creates the data in a form of dendrogram, but the difference is you can see that it starts with all data points in one cluster, splits the root into child recursively based on the dendrogram, and stops when there is a singleton clusters which are created, which means that for every cluster there will be one observation which belongs to. So likewise, the clustering technique will work. Now, there is one more technique that we have in terms of building a clustering technique. That's what we call it the mean shift clustering. So what we will do, we'll take an average of every cluster that we have. What we will do, we'll end up with reducing their means into a single density of items, and then we'll continue to repeat the process to see to that which observations mean will belong to the same cluster, and according to that, we'll continue to identify which observation will belong to a cluster, a particular cluster. So likewise, we can apply different types of clustering technique that can help us to cluster the data, which is part of unsupervised learning, right? So now let's jump into something called a small hands-on. Okay, let's take a small Python example, and we will see how do we build that particular clustering technique on top of the data using one of the simple data that we have. Jupyter Notebook. Let me open how we can use scikit-learn using one of the example. So meanwhile, let me show you some of the data set also. Let me show you a data set that I'm going to use as well. So what I'm going to do is I'm going to take this movie metadata information. Let me open this data set. I'm going to take this example of movie metadata information where this data set has got a number of observations which are present. Okay, let me open this. Okay, you can see that there are a number of movies related information. As you can see, the movie names. So Avatar, Pirates of the Caribbean, Spectre, The Dark Knight, Star Wars, etc., etc., John Carter, Spider-Man 3, Tangled, or etc., etc. We have a lot of movies, and about every movie we got a lot of information which is present, like who is the director, who is the actor, what are the director Facebook likes, what are the actor Facebook likes. Likewise, we got a lot of information which is present as part of these particular every observation. So now what we will do, we will try to cluster these data points. You can see a lot of observations which are given. What is the gross of the movie? What is the number of reviewers? What is the IMDb rating? What is the so-and-so called IMDb score? What is the movie span? What is the gross? What is the budget and everything? So now what I'll be doing, I'll be reading this data set using one of the pandas library that we have. Okay, so I'll be reading this data set. Let me open the Jupyter Notebook. I'll be using something called pandas. As you can see, read.pandas.csv. I'll be reading this data set where you can see that this is the data set that I am able to read. I got a number of observations that are present. I can see that director Facebook likes and actor 3 Facebook likes. So now what is that I want to do is, instead of building this clustering technique on top of every observation, so what I will do is I will take these columns called number of Facebook likes on director and number of actor Facebook likes versus director Facebook likes. So where I can see that if I want to select a director Facebook likes alone, I'll be able to choose this director Facebook likes alone. You can see for every movie you got the number of director Facebook likes which are present. So if there are more number of Facebook likes, what does it mean? The director is famous person, correct? Or either if there are more number of famous Facebook likes that the actor has got, which means that the person is or the actor is very famous person. So that's what you can understand. So now we can see that I'll try to extract these independent components that we're talking about. I will extract all the records in all the director Facebook likes versus actor Facebook likes, where I'm just going to form an object called new data by applying some iLocation as a filter. iLocations, ILOC stands for index location, where I can filter out what are the records that I wanted to, what are the columns that I wanted to, using this iLocation function. Now I got all the so and so called number of director Facebook likes versus actor Facebook likes, which are present as part of this. Okay, so this has been loaded into an object called new data. So now what is that I'll be doing? After that, I'm importing something called sklearn k-means cluster. So this algorithm is available as part of this scikit-learn algorithm. Whatever the number of steps that we have discussed, you're not supposed to execute all these steps manually. And of course, if you want, you can also write such a program as well. But what is that we'll be doing in scikit-learn library? There is a Python library called scikit-learn which has got most of the algorithms present, and we will be importing this k-means clustering algorithm. And for this k-means clustering, I'm providing the c is equal to number of clusters is equal to 5. So here, if you are aware of object-oriented programming using Python, you'll be able to correlate. I'm importing this k-means clustering, which is implemented as a class here, where I'm creating an object called k-means clustering by providing an input called n number scores clusters is equal to 5, which means that what is the meaning of 5? I want to build 5 clusters out of this. So where once you create an object using k-means, I'm calling this method called fit method by providing new data as my independent variables. I'm calling this fit method, which means fit is a method that's going to invoke what's supposed to be the process that needs to be executed. That's going to build my clustering technique algorithm by taking number of clusters is equal to 5. So now I'm able to generate my algorithm where by looking at my model, I'll be able to extract what are the centroids that I got, final centroids, because initially you'll be taking some random centroids, but at the end you'll end up with getting a final centroid position somewhere fixed to it. That is nothing but a center point for every cluster that we got. These are the final centroid that we got. Even if I want to print what is the labels which are generated, labels is nothing but it will extract the outcome. You can see that these are the label numbers which are added here. Out of 5,000 movies, we got the labels which are added as an array, but we won't be able to see it like that. What is it I'm trying to do? I'm trying to get all the unique values present in these labels with respect to counts. Now you can see that my data is now clustered into 5 different, all the movies are clustered into 5 different clusters. As you see, cluster number 0 has got 4,700. Most of the observations are moved into cluster number 0. 104 movies went into observation number 1, 11 movies are moved into cluster number 2, and 87 movies are moved into cluster number 3, and 67 into cluster number 4. So the data properties are being distributed, and that's how the clustering technique has divided the data into 5 clusters. Now you can see what is that I'm trying to do. I'm trying to put this into a new data of cluster, which means whatever the labels that are generated here. This is my output column. I'm going to create this into as a new column in my new data, where I'm using this lm plot that will print whatever the column that I have called director Facebook likes versus actor Facebook likes, and I'm choosing this data is equal to new data that will help me to identify what column can be considered as Q, so that I'll be printing it in a cool warm type chart. You can see that pellet type is equal to cool warm type, which will help me to identify based on the cluster that you have created. Now if I print this, you can see that pretty much every observation is now categorized into individual cluster. You can see these are the movies which are now graphical representation. This is the graphical representation that we are using to see how these movies are being segregated. I can see these movies are nothing but cluster number 0. You can see there are a few more movies which are extracted over here. This is nothing but based on the color indication. This is cluster number 3, and these movies are created as a cluster number 1, cluster number 2. These movies are something which are created as cluster number 1, and these movies are created as cluster number 4. 0, 1, this is nothing but 2, cluster number 3, cluster number 3, and cluster number 4, like this. Now you can clearly see that how the k-means clustering has came up. The movies which are made by new people with new directors, new actors are making films with new directors, or new directors are making film with new actors. These are all, you will see more number of movies will fall into this category, because you will end up with getting new people into the film industry most of the cases. A lot of movies are being made with new directors with new actors, and you can see that these movies are the clusters which are being segregated very clearly. The famous actors are making films with new directors. Very famous actors are making films with new directors, and these movies are something where very famous directors are less. I mean, average fame directors are making films with some new actors. You can see these movies are nothing but very famous actors are making, directors are making films with very new actors. You can see very famous directors are making films with very famous actors. Like Spielberg might be making a film with Tom Cruise or something like that. So likewise, you can clearly see that where instead of if you do this activity manually, it might take a little longer time for you to segregate each and every component. But within 5 minutes, we're able to cluster this activity, right? So that's what the beauty with algorithms. You don't need to manually do this activity, where it can provide you data automatically based on the properties of the data. Your algorithm itself will build this clustering output out of the data. All right. So that's how we will be able to build a clustering technique on top of the given data. So that's what we have as part of one of the hands-on example.
What is hierarchical clustering? So hierarchical clustering, it is also known as HCA or hierarchical cluster analysis. And this is a method of cluster analysis as we have seen. So what happens here is that this clustering allows us to build the tree structure from data similarities, like we have built X and Y, and we have created trees, and these trees are actually called known as dendrograms. So the way you represent a hierarchical cluster or hierarchical clustering is through dendrograms. So we actually drew a dendrogram. Okay. So this is how the clustering is being formed, and this is how the clusters are being made, and this is how the relationship among the clusters is being shown by a dendrogram. So based on these things, now we will go on further to understanding what is agglomerative clustering. So when this hierarchical clustering follows a bottom-up approach, this is called agglomerative clustering. And when this is following up a top-down approach, this is used in divisive clustering. So now let us understand what is agglomerative clustering. So the types of hierarchical clustering are two, that is agglomerative and divisive. So now moving on further, what is agglomerative clustering? So agglomerative hierarchical clustering, this is also known as AGNES, which means agglomerative nesting hierarchical clustering. And it follows a bottom-up approach, which means that clustering or clusters, they are formed from the bottom and are again clustered till a complete single cluster is formed. And what happens then is that the clustering continues until we obtain a single cluster, and we will see how we obtain a single cluster, and we also represent it. So individual data points are clustered based on similarity, and we go on clustering until there's only one single cluster left. So let us just plot this agglomerative clustering and make things really simple for us. Now, suppose I have got these data points scattered here, A to G, and these data points have to be clustered. So another important thing is that now we will form clusters. So how clusters are formed? So we can see that based on some similarity, like because of the distance, nearby distance, A and B can be grouped together in a single cluster. So I am just doing that. C and D, I form another cluster because they are near. So I just club them. And again, I would just club E and F based on their distance, and G is separate, so I will just form a separate cluster. Now what happens in agglomerative clustering is that I have to plot all these data points like A, B, C, right, D, E, F, and G. So these are separate clusters. The clustering starts from the bottom, and each data point is treated as a single cluster, which we will also understand with the help of an example further. But now for simplicity, let's take A, B, C, D. So then what happens is that since A and B are grouped as one cluster, so this is how I just group them, all right? And C and D is grouped as one cluster. This is how I group them. E and F are grouped in one single cluster. This is how I group them. Now remains G, which is not being grouped into any of the cluster. So now clustering, I said that it continues until a single cluster is left. So now I would have to have another level of clustering. That means that E, F, G, since G is very close to E, F, I will cluster it in one single cluster. Okay. And since I can see that both these AB and CD pairs, these clusters are again together, so I will just cross this line and I will make one single cluster of these 4 points, right? So what I do is, since these two are connected, I connect them with the help of this line figure, that is tree structure dendrogram, and this G, E, and F, they are connected somehow. I connect them. All right. Now what happens is that I have got two big clusters, and clustering continues until a single cluster is obtained. So in the end, I will have to cluster everything into a single cluster. And this is how I do that. And to join it, I will again join this entire graph. So this is when it follows a bottom to up approach. This is called as agglomerative hierarchical clustering. Okay. So now we will go and see an example of this hierarchical agglomerative clustering, right? Okay. So let us understand what is agglomerative clustering with this example. Now we see that here the clustering takes place from bottom to up. And we have taken an example of population wherein we go on clustering until we get population. So here from the bottom, the individual professions are being plotted. And we see that, let's take for a convenience the left-hand side. And on the left-hand side, the red dots, as you see, this is individual profession in public sector. And on the another side, which we see in the brown circles, is the private sector employment. So somehow there's similarity between private sector. So they are being clustered as one single cluster and the private sector as another cluster. These again are being clustered into one single cluster, and that is employment cluster. Whereas on the another side, we can see another cluster which is different, and that is unemployed section of cluster of people. Now, they again share one similarity, and that is that they all belong to a single gender, that is male. So everything is being clustered into one single cluster, that is male. And then again, male and female clusters are being clustered together to form one single cluster, that is population. Similarly, we also divide on the right hand side the individual professions of women clubbed into private and public sector. And then again, we have separate clusters of employed and unemployed women, and they had been grouped into one single cluster, and that is women. Again, we merge the two big clusters into one single cluster, that is population. So this is how the clustering is taking place. The levels are being increasing from bottom to up. So when we are using this bottom-up approach, this is agglomerative clustering. Okay, I think things are very clear now. So now let's move on to how does this agglomerative clustering work, and we will take this example as a reference. So now what happens here is that each observation is treated as a separate cluster, which means that each individual profession was being treated as a separate cluster. And then the two clusters that were closest, they were identified and merged. So the public sector, which was closest, it was being merged, and so on. Now moving on further, the clustering continues, and then again the clusters were being formed when we see that employed and unemployed cluster, they were different. And we go on clustering until we obtain a single cluster, and that was population, right? Okay, so now this was about agglomerative, and now moving on forward to what is divisive clustering. Now in divisive clustering, this is also known as Diana, and this is divisive analysis clustering algorithm. And this follows a top to bottom approach. This is just the opposite of agglomerative hierarchical clustering. And clustering continues until small groups of similar clusters are obtained here. This means that all the data points, they belong to first one cluster, and then the clusters, they are formed as we move down the hierarchy. Now, having said this, let us understand what exactly is divisive clustering, and we will take an example, and let's understand it by drawing first, and then we'll go on to understanding with the help of an example. So now let us understand how divisive clustering actually works. So now we've got, suppose, these data points scattered, and let us now cluster them. So for divisive clustering, what happens is that we start from one single cluster, and we just cluster them into one single whole, right? And then we will start clustering them. So then what we will do is we will form another cluster based on the similarity, or you can say the distance between EFG cluster. We see that these are near. So what I do is I form one single cluster of E, F, and G, and I see that these share some, distance. They are similar and they have share the same distance. They are nearby. So I cluster them into one single whole. Okay. Now I would go on dividing or clustering until I get single unit of cluster. So I would go again further, and let me take a different color. So what I do is I will cluster A and B into one single cluster, and C and D again into similar cluster based on certain distance, and which we will study further. And again, we would cluster these clusters based on that E and F are very near to each other, C and D are near to each other, and so on. Now, the clustering is not yet complete because I have not got individual clusters. So what I do is I will cluster A and B into single cluster again, and this would complete my divisive clustering, starting from one single cluster to boiling it down to simple small clusters, right? So if I want to just write it down into A, B, C, D, some kind of a diagram. So what I'll do is like similar figure I have. Suppose I start from A and B and C and D. This is just same like agglomerative, but this just the approach is different. A and B and C and D. But what happens here is that when I'm moving up from forward, from above, so I have all my data points here, A, B, C, D, E, F, G, and now I am moving on forward to dividing them into different clusters, which is suppose A, B, C, D here, and here we have E, F, G. And then I will go on further and make further cluster. For that, I will go on, this is G, I know this is separate, and here this is E and F, so this is E and F, right? And this figure is nothing but a dendrogram that I'm drawing. Don't mind the lines here, just follow the concept. And here I have here A, B, and C, D cluster, and this has been divided into A and B, and this is divided into C and D, right? So this is how the clustering takes place, dividing a single cluster, separating it down into separate clusters. And when I'm following a top to bottom approach, this is known as divisive hierarchical clustering. Now let us understand this with the help of an example and make things more clear. This was just a rough, a vague idea about how this clustering is and how our dendrograms form. So now coming to the same example of divisive clustering, and here the clustering takes place from top, and we have the population which we divided into male and female clusters, and moving on further, the male cluster is divided into employed males and unemployed clusters, male, and again the cluster is further divided into the private sector employed males and the public sector employees male. Similarly, we can replicate this with the female clusters also. So this is how divisive clustering approaches from top to bottom clusters, and this is divisive clustering. Now let's move on further to how does this divisive clustering work. So all the data points are treated as single clusters, and then the cluster is partitioned into two least similar cluster, and then again the clustering takes place based on certain similarity between the clusters, and then further until we get a single individual cluster within a cluster, and this is how divisive clustering will take place till the end. Now let us understand what is agglomerative and divisive clustering just in a nutshell. So when you're moving from bottom to up, it is agglomerative, and when you're moving from top to bottom, that is divisive. All right, and this representation is called dendrogram, which we have seen and we have plotted, and we have seen it in the example too. Okay, so now moving on forward, let us understand how to decide the group of clusters. So it is done based on some similarity between the data points that we have seen. And the similarity could be single linkage, complete linkage, median linkage, centroid linkage, and which we will discuss it also. And it is now similarity. Another thing is that the similarity, it is obtained by calculating the distance between the clusters. And generally, the distance matrices used are Euclidean distance, Manhattan correlation distance, even Minkowski distance is used. So now, generally, the Euclidean distance is used to figure out the distance between the data points, but the choice of a distance matrix again depends upon the data set under study, right? Like, for example, in gene expression, correlation distance is often used. So now moving on further, how to calculate the similarity between two clusters. Now here we have got two clusters like X and Y, and to find the similarity between two clusters, single linkage technique is used. Here what happens is that the distance between two most similar parts of the cluster is being taken, the distance is mapped, and this is how clustering takes place. Another way is complete linkage. In complete linkage, again, what we take here is that we take two least similar bits of cluster, that is the farthest point in the cluster, that distance will be taken, and then the clustering is done. Another way to cluster the data or to form clusters to find the similarity between cluster is centroid linkage. Now what happens is that the distance between centroids of the two clusters is being taken. There are other methods also like mean or average linkage, where the center of the cluster is taken. And now remember here, centroid of the cluster is taken, which is different from mean or average, right? And there's yet another way of linkage criteria, like Ward's method, where the sum of square of Euclidean distance is minimized. All right, so depending upon the data set, we will choose, or the hierarchical clustering will choose which method, which distance, which matrix to be applied, right? Okay, now moving on further to some of the applications of hierarchical clustering. Hierarchical clustering, now this is used in taxonomy, which is the biological classification of animals and plants kingdom. So let us understand this with the help of an example. Now, this is the example which we will be understanding and how the classification takes place. So now we start with the first order, that is the first level of cluster, that is carnivora, and it falls into order, right? Another, it has been divided into the family of Felidae, Mustelidae, and Canidae, right? Now, these are some scientific names, but when we reach the end, we will understand what does this really mean. So don't worry if you're not from like scientific or biological names friendly, never mind. Now, another level is genus. So this family is then further divided into the genes of a species, which is Panthera, Mephitis, Luthra, Canis. And again, this has been further divided into species. So until we get individual clusters of these species, we will keep on clustering them into various levels. So the species are leopard. Here we have got striped skunk, European otter, and in Canis we have got domestic dog and wolf, right? So domestic dog and wolf share some similarity. That's why they are being clubbed into the same species. And then they are being clustered into Canis because they're carnivores. And then, but their family is Canidae, which is different from Felidae and Mustelidae, but they're forming into the one single cluster, that is carnivora, right? But these individual species, they have certain dissimilarities between them, but they fall under the same family and the same order, right? The same order, not the family. Okay, so this is how the application of hierarchical clustering finds its usage in taxonomy and biological classification of animal and plants. Now, moving on forward to other applications of hierarchical clustering is tracking the outbreak. So hierarchical clustering is used to track the virus and their sources. And this is really very useful for scientists because this gives understanding of the virus source, the origin of the outbreak, like why and how the outbreak began, and potentially they can save life. And then another important application is clustering crimes in the city. So the lawmaking agencies and the police involved can really understand the trends and the patterns in the data and classify the crimes accordingly and take strict actions as per the crime. So need for more strict laws in clusters which are having high number of like murders or assaults or rape cases. And this clustering really helps in understanding the trend, the pattern in the data, and accordingly, then data-driven decisions and actions can be taken. Yet another important hierarchical clustering application is evolution through phylogenetic trees. Now, this means that to find how different a species relate to each other. Now, for this, what we take DNA sequencing and hierarchical clustering, they are being used together. And the DNA sequence of the species, they are generated, and similarity in the DNA is found by calculating the distance between the sequences. Based on this, phylogenetic tree is constructed. And this really helps in classifying or placing the new discovered species into the gene chart or into the family or the order of species, right? So hierarchical clustering is really useful for that. Now, moving on forward to the advantages of hierarchical clustering is that it is easy to understand and implement and gives better results in certain cases too. And here we do not need any prior information about the number of clusters, unlike in k-means where clusters have to be pre-assigned. The another advantage is that the outliers can be detected with the help of dendrograms, and it also gives insight into the data structure. So another advantage is that hierarchical clustering is more deterministic and more predictable, whereas k-means with random initialization can produce different results when we run the same data multiple times. So hierarchical clustering will give you the same results whenever you run it multiple times. So this is more predictable. Now, moving on forward to the disadvantages of hierarchical clustering is that it is not suitable for large data sets because of large space and time complexities. Time complexity of at least n squared log n is required, where n is the number of data points. So you can really imagine that how much space and time complexity is involved with hierarchical clustering. Now, another disadvantage is that it is difficult in handling different sized clusters and convex shape. Also, at times, it is really difficult to identify the correct number of clusters by the dendrograms. So, this is quite a complex thing. And it is also sensitive to outliers and noise in the data set. Okay, so having said this, hierarchical clustering finds its application in real life also. And we have seen that ranging from biology, scientific research, market research, gene segmentation, and understanding crimes in the city, hierarchical clustering is being used. Thus, to establish the relationship, to figure out the connection among the data points, or finding the similarity, we use hierarchical clustering, or even the dissimilarity, we use hierarchical clustering. And it helps to make data-driven decisions and also strategic decisions.
Now, many of us have visited retail shops such as Walmart or Target for our household needs. Or let's say that we are planning to buy the new iPhone from Target. What we would typically do is search for the model by visiting the mobile section of the store and then select the product and head towards the billing counter. But in today's world, the goal of the organization is to increase the revenue. Can this be done by just pitching one product at a time to the customer? Now, the answer to this is clearly no. Hence, organization began mining data relating to frequently bought items. So, market basket analysis is one of the key techniques used by large retailers to uncover associations between items. Now, examples could be the customers who purchase bread have a 60% likelihood to also purchase jam. Customers who purchase laptops are more likely to purchase laptop bags as well. They try to find out associations between different items and products that can be sold together, which gives assisting in the right product placement. Typically, it figures out what products are being bought together and organizations can place products in a similar manner. For example, people who buy bread also tend to buy butter, right? And the marketing team at retail stores should target customers who buy bread and butter and provide an offer to them so that they buy a third item, suppose eggs. So if a customer buys bread and butter and sees a discount offer on eggs, he will be encouraged to spend more and buy the eggs. And this is what market basket analysis is all about. This is what we are going to talk about in this session, which is association rule mining and the Apriori algorithm. Now, association rule can be thought of as an if-then relationship. Just to elaborate on that, we have come up with a rule. Suppose if an item A is being bought by the customer, then the chances of item B being picked by the customer too under the same transaction ID is found out. You need to understand here that it's not a causality, rather it's a co-occurrence pattern that comes to the force. Now there are two elements to this rule. First is the if and second is the then. Now if is also known as antecedent. This is an item or a group of items that are typically found in the item set. And the later one is called the consequent. This comes along as an item with an antecedent group or the group of antecedents are purchased. Now, if we look at the image here, A arrow B, it means that if a person buys an item A, then he will also buy an item B, or he will most probably buy an item B. Now, the simple example that I gave you about the bread and butter and the eggs is just a small example. But what if you have thousands and thousands of items? If you go to any professional data scientist with that data, you can just imagine how much of profit you can make if the data scientist provides you with the right examples and the right placement of the items which you can do. And you can get a lot of insights. That is why association rule mining is a very good algorithm which helps the business make profit. So let's see how this algorithm works. So association rule mining is all about building the rules. And we have just seen one rule that if you buy A, then there's a slight possibility or there's a chance that you might buy B also. This type of a relationship in which we can find the relationship between these two items is known as single cardinality. But what if the customer who bought A and B also wants to buy C? Or if a customer who bought A, B, and C also wants to buy D? Then in these cases, the cardinality usually increases and we can have a lot of combination around these data. And if you have around 10,000 or more than 10,000 data or items, just imagine how many rules you're going to create for each product. That is why association rule mining has such measures so that we do not end up creating tens of thousands of rules. Now, that is where the Apriori algorithm comes in. But before we get into the Apriori algorithm, let's understand what's the maths behind it. Now, there are three types of matrices which help to measure the association. We have support, confidence, and lift. So support is the frequency of item A or the combination of item A or B. It's basically the frequency of the items which we have bought and what are the combination of the frequency of the item we have bought. So with this, what we can do is filter out the items which have been bought less frequently. This is one of the measures, which is support. Now, what confidence tells us? So confidence gives us how often the items A and B occur together, given the number of times A occur. Now, this also helps us solve a lot of other problems because if somebody is buying A and B together and not buying C, we can just rule out C at that point of time. So this solves another problem is that we obviously do not need to analyze the products which people just buy barely. So what we can do is, according to the sales, we can define our minimum support and confidence. And when you have set these values, we can put these values in the algorithm and we can filter out the data and we can create different rules. And suppose even after filtering, you have like 5,000 rules. And for every item, we create these 5,000 rules. So that's practically impossible. So for that, we need the third calculation, which is the lift. So lift is basically the strength of any rule. Now let's have a look at the denominator of the formula given here. And if you see here, we have the independent support values of A and B. So this gives us the independent occurrence probability of A and B. And obviously, there's a lot of difference between the random occurrence and association. And if the denominator of the lift is more, what it means is that the occurrence of randomness is more rather than the occurrence because of any association. So lift is the final verdict where we know whether we have to spend time on this particular rule what we have got here or not. Now let's have a look at a simple example of association rule mining. So suppose we have a set of items A, B, C, D, and E and a set of transactions T1, T2, T3, T4, and T5. And as you can see here, we have the transactions T1 in which we have A, B, C, T2, A, C, D, T3 BCD, T4 ADE, and T5 BCE. Now what we generally do is create some rules or association rules such as A gives D or C gives A gives C, B and C gives A. What this basically means is that if a person buys A, then he's most likely to buy D. And if a person buys C, then he's most likely to buy A. And if you have a look at the last one, if a person buys B and C, he's most likely to buy the item A as well. Now, if we calculate the support, confidence, and lift using these rules, as you can see here in the table, we have the rule and the support, confidence, and the lift values. Now, let's discuss about Apriori. So, Apriori algorithm uses the frequent item sets to generate the association rule. And it is based on the concept that a subset of a frequent item set must also be a frequent item set itself. Now, this raises the question, what exactly is a frequent item set? So a frequent item set is an item set whose support value is greater than the threshold value. Now, just now we discussed that the marketing team, according to the sales, have a minimum threshold value for the confidence as well as the support. So frequent item set is that item set whose support value is greater than the threshold value already specified. Now, example, if A and B is a frequent item set, then A and B should also be frequent item sets individually. Now let's consider the following transaction to make the things a little easier. Suppose we have transactions 1, 2, 3, 4, 5 and these items are there. So T1 has 1, 3 and 4, T2 has 2, 3 and 5, T3 has 1, 2, 3, 5, T4, 2, 5 and T5 1, 3 and 5. Now the first step is to build a list of item sets of size 1 by using this transactional data. And one thing to note here is that the minimum support count which is given here is 2. Let's suppose it's 2. So the first step is to create item sets of size 1 and calculate their support values. So as you can see here, we have the table C1 in which we have the item sets 1, 2, 3, 4, 5 and the support values. If you remember the formula of support, it was frequency divided by the total number of occurrence. So as you can see here, for the item set 1, the support is 3. As you can see here, that item set 1 appears in T1, T3, and T5. So as you can see, its frequency is 1, 2, and 3. Now, as you can see here, the item set 4 has a support of 1 as it occurs only once in transaction 1. But the minimum support value is 2. That's why it's going to be eliminated. So we have the final table, which is the table F1, in which we have the item sets 1, 2, 3, and 5, and we have the support values 3, 3, 4, and 4. Now the next step is to create item sets of size 2 and calculate their support values. Now all the combination of the item sets in the F1, which is the final table in which we discarded the 4, are going to be used for this iteration. So we get the table C2. So as you can see here, we have 1, 2, 1, 3, 1, 5, 2, 3, 2, 5, and 3, 5. Now if you calculate this support here again, we can see that the item set 1, 2 has a support of 1, which is again less than the specified threshold. So we're going to discard that. So if we have a look at the table F2, we have 1, 3, 1, 5, 2, 3, 2, 5, and 3, 5. Again, we're going to move forward and create the item set of size 3 and calculate their support values. Now all the combinations are going to be used from the item set F2 for this particular iterations. Now before calculating support values, let's perform pruning on the dataset. Now what is pruning? Now after the combinations are being made, we divide C3 item sets to check if there is another subset whose support is less than the minimum support value. That is what frequent item set means. So if you have a look here, the item sets we have is 1, 2, 3, 1, 2, 1, 3, 2, 3 for the first one. Because as you can see here, if we have a look at the subsets of 1, 2, 3, we have 1, 2 as well. So we are going to discard this whole item set. Same goes for the second one. We have 1, 2, 5. We have 1, 2 in that, which was discarded in the previous set or the previous step. That's why we're going to discard that also, which leaves us with only two factors, which is 1, 3, 5 item set and the 2, 3, 5. And the support for this is 2 and 2 as well. Now, if we create the table C4 using 4 elements, we're going to have only one item set, which is 1, 2, 3, and 5. And if we have a look at the table here, the transaction table, 1, 2, 3, and 5 appears only 1. So the support is 1. And since C4, the support of the whole table C4 is less than 2, so we're going to stop here and return to the previous item set, that is C3. So the frequent item sets are 1, 3, 5, and 2, 3, 5. Now let's assume our minimum confidence value is 60%. For that, we're going to generate all the non-empty subsets for each frequent item sets. Now for I equals 1, 3, 5, which is the item set, we get the subset 1, 3, 1, 5, 3, 5, 1, 3, and 5. Similarly for 2, 3, 5, we get 2, 3, 2, 5, 3, 5, 2, 3, and 5. Now this rule states that for every subset S of I, the output of the rule gives something like S gives I to S. That implies S recommends I of S. And this is only possible if the support of I divided by the support of S is greater than equal to the minimum confidence value. Now applying these rules to the item set of F3, we get rule 1, which is 1, 3 gives 1, 3, 5 and 1, 3. It means 1 and 3 gives 5. So the confidence is equal to the support of 1, 3, 5 divided by the support of 1, 3. That equals 2 by 3, which is 66% and which is greater than the 60%. So the rule 1 is selected. Now if we come to rule 2, which is 1, 5, it gives 1, 3, 5 and 1, 5. It means if we have 1 and 5, it implies we're also going to have 3. Now if we calculate the confidence of this one, we're going to have support 1, 3, 5 divided by support 1, 5, which gives us 100%, which means rule 2 is selected as well. But again, if we have a look at rule 5 and rule 6 over here, similarly, if we select 3 gives 1, 3, 5 and 3, it means if we have 3, we also get 1 and 5. So the confidence for this comes at 50%, which is less than the given 60% target. So we're going to reject this rule. And same goes for the rule number 6. Now, one thing to keep in mind here is that although the rule 1 and rule 5 look a lot similar, they are not. So it really depends what's on the left hand side of the arrow and what's on the right hand side of the arrow. It's the if then possibility. I'm sure you guys can understand what exactly these rules are and how to proceed with these rules. So let's see how we can implement the same in Python, right? So for that, what I'm going to do is create a new Python file, and I'm going to use the Jupyter Notebook. You're free to use any sort of IDE. I'm going to name it as Apriori. So the first thing what we're going to do is we'll be using the online transactional data of a retail store for generating association rules. So firstly, what we need to do is get the pandas and MLXtend libraries imported and read the file. So as you can see here, we are using the online retail.xlss format file. And from MLXtend, we're going to import a priori and association rules. It all comes under MLXtend. So as you can see here, we have the invoice, the stock code, the description, the quantity, the invoice data, unit price, customer ID, and the country. Now next in this step, what we're going to do is do data cleanup, which includes removing the spaces from some of the descriptions and drop the rows that do not have invoice numbers and remove the credit card transactions, because that is of no use to us. So as you can see here, the output in which we have like 532,000 rows with 8 columns. So after the cleanup, we need to consolidate the items into one transaction per row with each product. For the sake of keeping the dataset small, we are only looking at the sales for France. So as you can see here, we have excluded all the other sales. We are just looking at the sales for France. Now there are a lot of zeros in the data, but we also need to make sure any positive values are converted to 1 and anything less than 0 is set to 0. So as you can see here, we have still 392 rows. We're going to encode it and see. Check again. Now that you have structured the data properly, in this step what we're going to do is generate frequent item sets that have support at least 7%. Now this number is chosen so that you can get close enough and generate the rules with the corresponding support, confidence, and lift. So guys, as you can see here, the minimum support is 0.7. Now what if we add another constraint on the rules, such as the lift is greater than 6 and the confidence is greater than 0.8. So as you can see here, we have the left hand side and the right hand side of the association rule, which is the antecedent and the consequence. We have the support, we have the confidence, the lift, the leverage, and the conviction. So guys, that's it for this session. That is how you create association rules using the Apriori algorithm, which helps a lot in the marketing business. It runs on the principle of market basket analysis, which is exactly what big companies like Walmart, you have Reliance and Target do. Even IKEA does it.
Why mathematics in machine learning? Aspiring machine learning engineers often tend to ask me, what is the use of mathematics in machine learning when we have computers to do it all? Well, that is true. Our computers have become capable enough to do the math in split seconds where we would take minutes or even hours to perform the calculations. But in reality, it is not the ability to solve the math. Rather, it is the eye of how the math needs to be applied. You need to analyze the data and infer information from it so that you can create a model that learns from the data. Math can help you in so many ways that it becomes mind-boggling that someone could hate this subject. Of course, doing math by hand is something I hate too, but knowing how I use math is enough to explain my love for math. So allow me to extend this love to you guys too, because I won't be teaching you just the mathematics for machine learning, but the various applications you can use it for in real life. So what math do we need to learn for machine learning? Here is a pie chart which comprises of all the needed math. Linear algebra covers a major part, followed by the multivariate calculus. Statistics and probability also play a big role, and you need to know the knowledge of algorithms and much more. This is the requirement that is needed to master machine learning. So now that we have developed this understanding, Let's do some math. We shall kick off with linear algebra. Linear algebra is used most widely when it comes to machine learning. It covers so many aspects, making it unavoidable if you want to learn mathematics for machine learning. Linear algebra helps you in optimizing data, operations that can be performed on pixels such as sharing, rotation, and much more. You can understand why linear algebra is such an important aspect when it comes to mathematics for machine learning. So let's move over to the first topic in linear algebra, scalars. So what is a scalar? A scalar is basically a value. It represents something, right? So scalars are just values that represent something. Suppose we had a laptop on sale and it is priced at 50,000 rupees, right? So this 50,000 rupees is the scalar value of that laptop. What are the operations that can be performed on scalars? It is just basic arithmetic. So for example, we have addition, subtraction, multiplication, division. All of those operations can be applied on scalars. Okay. For example, over here, we are buying a laptop and the accessories. What is the total price? It will be the addition of both the prices. So 50,000 for the laptop and 5,000 for the accessories brings it up to 55,000 rupees. What happens if you're buying a laptop at a 50% discount? So it is half the price, right? It is 50,000 divided by 2. That becomes 25,000 rupees for the laptop. So this is just a brief introduction and all that is required from scalars. So once we are clear with this, let's move over to vectors. So vectors can get a bit complicated as they are different for different backgrounds. Let me tell you how. Computer science people can interpret vectors as a list of numbers that represent something. Physicists consider vectors to be a scalar with a direction and it is independent of the plane. Mathematicians take vectors to be a combination of both and try to generalize it for everybody. All of these standpoints are absolutely correct, and that's what makes it so confusing for anyone learning about linear algebra for mathematics for machine learning. In machine learning, we usually consider vectors in the standpoint of a computer scientist, where the data is in the tabular form consisting of rows and columns, right? And when our data is in the form of pixels or pictures, we consider them as vectors that are bound to the origin and transform them to matrices and perform operations that we shall discuss later. So now that you have a brief idea about vectors, let's jump over to the operations that you need to know when working with vectors. Operations on vectors can be applied only when you know what kind of data you're working with. Suppose you have pixel data and you want to apply rotations but end up doing something wholly different. Your model will not work because it is doing all the wrong operations here. It's important that you make sure that you know what you're working with. Only then you will be able to apply the required operations. So the first operation that we have here is vector addition. So let's understand what vector addition does. So for example, vector addition is also called as dot product. Vector addition is something that is completely different from operations that we've been learning now for scalars. Okay, it's not simple arithmetic. It is actually the total work that is done by both the vectors in a quantified form. So for example, let me say that I want to walk forward by 50 meters and that is one vector. Okay. So me walking forward for 50 meters is one vector. And from there, I go right for 25 meters, right? So that is the second vector. So what is the work that is completely done by both these vectors is me moving forward and then moving right. So let me say, for example, V1 is what I walked forward, okay? And then V2 is something that I moved right. So what is the addition of this? The addition is basically putting both the vectors point to point and then finding the displacement or the work that has been done. If you look at it over here, it is V1 plus V2's work that is in the quantified form of V1 plus V2. It is the displacement. So for example, V1 is a distance and V2 is a distance. V1 plus V2 is the displacement. So that is basically what is a dot product. I hope you've understood this. So let's move over to the next operation, that is scalar multiplication. So what is scalar multiplication? So whenever a vector is multiplied with a scalar value, it either grows or shrinks. What this means is that you have a particular value, a scalar value, which is either positive or it is negative, and it may be greater than 1 or lesser than 1. Whichever is lesser than 1 and it is negative, it will always make it shrink, or else it will do the opposite, it will make it grow. So let me just show you an example over here. So let's say I have a vector called v1. Now if I'm trying to multiply this with a positive scalar value, say k, positive scalar value into v1 will make the vector grow. Whereas if I am trying to multiply this particular vector with a negative scalar value, say minus k, it will be shrinking down. So it is minus k into v1 gives me a shrink vector. So as you can see, this was my normal vector, and if I multiplied it with a constant k, which was positive, it grew, and if it was negative, it shrank down. So that is basically what is scalar multiplication. So the next vector operation is a projection. So what does projection help us with? So for example, let's say I have two vectors, okay, v1 and v2. Now I do not know much about v1 and I just know more about v2. So if I can try to find a way in which I can project the vector v1 onto v2, I'll be able to obtain information about v1. So let me just show you. So for example, I have a vector v1 and I had another vector v2. So I know all about v2, but I do not know about v1 vector. So what happens over here is if I'm able to project the projection of vector v1 onto v2, I will be able to analyze and know the unknown features that vector v1 has. Okay. Actually, if you go with this into deep learning, right, you can be able to find unknown features of the vector, which can help you modify your one image into so many images that you can basically simplify and modify that image into something that it is not. Okay, that comes under deep learning, but we're not going to cover that. But this is a very important concept that you need to understand. It is basically like it's said over here. Projection is the shadow of a vector that it places on the other vector. So whatever information that v1 vector has, I'll be able to somehow extract it from the vector v2 because the projection falls onto v2. That basically brings us to the end of all the vector operations that you need to remember for machine learning. Let's move over to matrices. So what is a matrix? A matrix is the composition, or it is the mixture of numbers, symbols, expressions which are in a rectangular array. It can be rectangular, it can be square, it depends on the order. So what do we use matrices for? We use matrices to convert our equations into the form of arrays. For example, if you've got an equation, you cannot simply put that into your computer saying that, okay, solve this and give it to me. You need to convert it into a list or an array so that you will be able to perform your operations on it, right? That is the reason matrices are so much important to us. And that is the reason it is much more easier for us so that we can convert our equations into lists and arrays and then perform our operations on them. So suppose, for example, you have two equations over here. So how do you convert these two equations into matrices? So what does an equation tell you? If you have 2x plus 2y is equal to 10, what this basically is trying to convey the information to you is that you have two constants x and y. In these constants, if you keep giving different numbers, you will be able to find a different value for it. Let's say, for example, the scalar value is 10 and you have 2x plus 2y, which is basically a vector. I need to find the points of x and y. Find the points of x and y meaning that I'm trying to find the direction of the vector. And then if I'm able to substitute values and then find out how 2x plus 2y is equal to 10, I'm finding all the information I need from that vector so that I can basically find out what all the other information I need from it. That is how functions are very important. You need to understand what a function is trying to convey to you. Let's say, for example, you have the equation of a straight line. So what does a straight line be? It is y is equal to mx plus c. What does this mean? It means that the y coordinate is equal to some value m into x plus a constant. So I'm able to plot this. I'll be getting the y coordinate, the x coordinate, and I'll be able to get a straight line. So whatever numbers I put into these, I will always be getting a straight line. So that is the reason it is called the equation of a straight line. It is always going to be constant. So you have to understand what a function is trying to convey to you. Once we are done with that, let me just tell you how you convert equations into matrices. It's really simple. Take out all the numbers. So you have 2x plus 2y equal to 10, right? So 2x and 2y has two numbers, 2. So those two become one row. 4 and 1 in the second equation become one row. X and y becomes one column, and 10 and 18. So let me just show it to you. So as you can see, we have a matrix 2, 2, 4, 1. Then we have x and y is equal to 10 and 18. If you multiply it accordingly, you will be getting back the same equation that we had earlier. This is how matrices are used in linear algebra. So once you know how the equations are converted into matrices, let's move over to the matrix operations. So what is the first operation? Simple addition. What does addition help you with? It is just basically adding all the directions of two vectors. Why is it two vectors? Because I am converting vectors into matrices, right? You are simply just going to add the corresponding elements of both the matrices. Simply add the corresponding elements of both the matrices. And you have to remember that if you are adding two matrices, it has to be of the same order. What do I mean by order? It is basically the number of rows into the number of columns. So for example, if I have the first matrix, that is 2, 2, 4 and 1, I have two rows and I have two columns. So that becomes a 2 cross 2 matrix. That is the order of the matrix. The next one also, 2, 3, 1, 4, it has two rows and two columns. That makes it an order of 2 cross 2. So if I had 3 rows and I had 2 columns, it would be 3 into 2. So I hope you've understood what order is. Let's say I had these two matrices and I want to add them. So what I do, it is 2 plus 2. So let's say I have 2 over here and I have 2 over here. So what is 2 plus 2? It becomes 4. What is 2 plus 3? It becomes 5. What is 4 plus 1? It becomes 5. What is 1 plus 4? It becomes 5. So it is adding the corresponding elements of the matrix. So I hope you've understood that. So let's move over to the next operation, matrix subtraction. It's the same thing as how you did it for addition. You just subtract the corresponding elements. If you had 2 minus 2, it becomes 0. 2 minus 3 becomes minus 1. 4 minus 1 becomes 3. 1 minus 4 becomes minus 3. Simple. You can understand this very easily. Moving ahead from matrix subtraction is matrix multiplication. What do you do with matrix multiplication? You are basically multiplying the rows with the columns. The matrix of row 1 with the columns of matrix 2. What happens? You have to remember that the number of rows in matrix 1 has to be equal to the number of columns in matrix 2. Only then will you be able to perform the matrix multiplication. So for example, if I had a 2 cross 2 matrix, it would be A11 into B11, A12 into B21, A11 into B12 plus the A12 into B22 accordingly. So let me show you an example for matrix multiplication so that you can understand how it works. Suppose I have a 2 cross 2 matrix that I've already been using for matrix addition and subtraction. Now, how am I going to perform the matrix multiplication is basically I'm going to, multiply the first row into both the columns of the matrix 2. So I have 2 into 2 plus 2 into 1. Then I have 2 into 3 plus 2 into 4. The same thing goes for the second row also. So what do I get? Understand? So if you have any doubts, leave them in the comment section. We'll get back to you as soon as possible. So once we are done with matrix multiplication, let's move over to the transpose. So the transpose is a really simple operation. All you do is you convert the rows into columns. That's it. But why is it so important? Transpose is really important when you want to change the dimensionality of your data. Suppose all your data is in a row. You can reiterate through there, or all your data is in a column. You can do it accordingly. So it is really important when you work with transpose because it helps you to change the dimensionality. It helps you flip the dimensions. So for example, if you're working with pixels, right, pictures, if you change the rows or the columns of your pictures data, you are basically changing the picture, and then you can, analyze it more, get more information from it. So transpose plays a very important role. You need to understand that. So for example, I have 2, 2, 4, and 1. What happens is the first column becomes the first row, and the second row becomes the second column. So as you can see here, it is 2, 2, 4, and 1. And that is all transpose is. So let's move over to the next operation. We have determinant of a matrix. By now, all we have been doing is having matrices being added, subtracted. So what is all of this? It is basically all the vectors being added, subtracted, multiplied, then flipped with their dimensions. You will understand this when you do all of this practically, because all of this is something that we do not do it in our daily lives. But when you're learning with machine learning, when you're performing machine learning, all of these operations come into picture. So all that you've learned by now is basically adding values of vectors, subtracting vectors, multiplying two vectors, then transpose, that is the flipping of vectors. And now you're going to learn about determinant. What is a determinant? All the matrices that we had till now, they are basically directions. They are basically directions and values of all the vectors. Now, all these vectors are definitely going to have a scalar value in them, so that you can understand the weight, you can understand the depth of that particular matrix. What is the determinant helping you with? The determinant helps you with understanding the weight or the sensitivity that it can provide on the data set. That is the reason determinant is really important. It is the scalar value of the matrix, and it can help you give the eigenvalues of the matrix. What do I mean by eigenvalues? I'll teach that to you in the next part, because we are going to understand in depth what are eigenvalues and eigenvectors. That is the reason determinants are so important. So let's say, for example, I had this particular matrix A, B, C, D, E, F, G, H, I. It would be A into E, F, H, I, and then it would be minus B into D, F, G, I plus C into D, E, G, H. So what happens now is I'm going to get this particular equation. So it's AEI plus BFG plus CDH minus AFH minus BDI minus CEG. This is basically what is going to give me the scalar value of the matrix. So I hope you've understood the importance and how determinants are important in machine learning. So next we will learn about the inverse of a matrix. So how do I explain inverse to you? It's a very simple example if you understand that. Suppose I am walking on a road and I walked straight for 50 meters. But then I remember that I had to get back something from the place I started. So I walked back 50 meters. What is the distance that I traveled? The distance that I traveled was 100 meters. Why? Because I went 50 meters forward and 50 meters backward. But what is the work that I have done? It is 0. Why is that? It is because I am at the same place that I started from. That is not the work done. If I move from one place to another place, that is the work done. That is some displacement that my body has achieved. But I have not achieved that over here. Why? It's because I have gone straight and come back straight for 50 meters, making my work done 0. So just the same way, inverse of a matrix works. Suppose you have a vector that moves in the forward direction. You will have the inverse of that particular vector that comes in the negative direction, and it makes all the work done 0. Sometimes there is no inverse of a matrix that exists. That's because the vector does not have all the information that is required to obtain its inverse. So I hope you have understood what is an inverse. Let's see, how do you find an inverse of it? Okay. For a 2 cross 2 matrix, this is how you're going to find it. It is finding the determinant into the transpose, or finding the inverse of the matrix. So it is A and D that is going to be switched over, and minus B and minus C. This gives you the inverse of the matrix. So for orders 3 and above, what do? You find the determinant of A, and then you accordingly find all the different determinants inside of it. So that is basically how you find the inverse of a matrix. Let's move over to how a vector can be used as a matrix. Okay. So by now that I've been telling that vectors can be easily translated into matrices, and I've already shown it to you. And why is it so important? It's because they help you apply operations on the data very easily. And then you have certain well-known operations such as scaling, rotation, sharing, and much more. All of this come under computer graphics, okay? Making these operations on your image or your vectors becomes really easy when you're working with matrices. So that's the reason matrices are so important. So for example, right now I've shown you that if there was an equation v1 as 3x plus 4, it would be 3 and 4. And then you had x and y, then you would have x plus 2y, which would become 1 and 2, and then x and y. That is how vector as a matrix works. What are some of the well-known operations, right? I'm assuming that there is going to be a 2 cross 2 matrix. Whenever you're scaling, it is basically increasing the size. So how do you increase the size? It is Sx and Sy, which are the scaling factors which you perform on your x and y coordinates. Then you have sharing, which is basically moving or reshaping your particular object that you're working with. So it can be M, which is the sharing factor. And then you have the rotation. So how do you rotate your particular object in which direction? So all of that can be done using these particular matrices. So let's move over and understand how matrices can help you solve equations and obtain solutions much more easily. So that is basically vector as a matrix. We have two methods over here. They are the echelon method and the inverse method. For our tutorial, I've been taking the row echelon method because it's much more comfortable for me. If you are much more comfortable with column echelon method, you can go ahead with that. But because I am comfortable with row echelon methods, I've used row echelon method. And next we have the inverse method. So we are basically going to solve the equations. We are going to find the coordinates at which our points give us that particular value. So let's move over with the first method, which is the row echelon method. And I have some equations over here which go ahead like 2x plus y minus z equal to 2, x plus 3y plus 2z equal to 1, x plus y plus z equal to 2. So I'm going to convert all of this into a particular matrix. So let me show you how the matrix looks. It is 2, 1, minus 2 and 2, 1, 3, 2, 1, and 1, 1, 1, 1. So all the information about the equations have been put into the matrix form. And the answers that we are going to get are x is equal to 2, y is equal to minus 1, and z is equal to 1. So this is the reason I'm going to get all these particular values, that is 2, 1, and 2, which I'm getting from the equations. Whenever I put the x, y, and z values into them, I'm going to, get those particular coordinates. Now let me just tell you why we are solving equations, okay? So if I am telling that there is this particular vector that goes like this or comes in this direction or something like that, I want to find the x, y, and z coordinates so that I can obtain the information, visualize it, and then learn more about that particular vector. Now say for example, this is just 2x plus y minus z equal to 2. Let's say for example, what if it was a 2 boxes plus 1 candle minus 1 chocolate is equal to giving me a profit of 2 rupees, okay? So as you can see, these are just simple equations, and these are the coordinates that we get. X is equal to 2, y is equal to minus 1, and z is equal to 1. But what is the importance of this? Okay, let me just give you a simple example so that you can understand what we are actually trying to find out over here. Okay, suppose I have a factory and I want to get a profit of 2 rupees. And I have boxes, I have candles, and I have chocolates. So if I take the first equation, I'm saying that if I have 2 boxes, 1 candle minus the chocolate, it is going to give me 2 rupees profit. So what is X, Y, and Z exactly? X, Y, and Z are the investment costs. How much do I need to invest into them so that I can get back what I really required? So for boxes, I need to invest 2 rupees. For chocolates, I need to invest nothing. For candles, I need to invest minus 1 or something like that. Okay. If I invest so much, I'm going to get 2 rupees profit. So this is like a real life example which is being converted into some equation, and then we just need to solve it. That is the reason vectors are so important and how they can be converted into matrices and then, solved very easily. How does the row echelon method work? I'm going to be taking the step 1, which is R1 divided by 2. R1, when we divide it by 2, we get 1, half, minus half, and 1. So what's the step 2? We will do R2 minus R1. So we have R2, which is the minus of R1. I'm going to get the particular equation, which is 1, half, minus half, and 1, 0, 5 by 2, 5 by 2, and 0, 1, 1, 1, 2. Simple enough, right? So what is the next step? It'll be R3 minus R1. So it is 1, half, minus half, 1, 0, 5 by 2, 5 by 2, 0, and 0, half, 3 by 2, and 1. The next step is 2 by 5 by R2. So you get 1 half minus half, 1, 0, 1, 1, 0, and 0, 1 by 2, 3 by 2, and 1. So what's the step 5? Step 5 is basically R1 minus half of R2. So I get 1, 0, minus 1, and 1, 0, 1, 1, 0, and 0, 1 by 2, 3 by 2, and 1. Step 6 is R3 is equal to R3 minus half of R2. So I have 1, 0, minus 1, and 1, 0, 1, 1, 0, and 0, 0, 1, 1. Step 7 is R1 plus R3. So I have 1, 0, 0, 2, 0, 1, 1, 0, and 0, 0, 1, 1. Step 8 is R2 is equal to R2 minus R3. So I have 1, 0, 0, 2, 0, 1, 0, minus 1, and 0, 0, 1, 1. If you put all of this back into the equation, you will find out that for the first row, 1, 0, 0, 2 is equal to x plus 0 is equal to 2. The value of x is equal to 2. The value of y is equal to minus 1, and the value of z is equal to 1. So this is how the row echelon method works. And what do you have to actually perform in row echelon? It is basically the first row has to start with the value 1. The second row has to have a 0, and then somewhere in the middle it has to have a value of 1. And then the third row should be starting with zeros and then getting some value where it starts with 1 only. So row echelon or column echelon, whatever method you use, you have to make sure that whichever element is the first starting element of the row, it has to have a 1, or it has to be preceding with zeros. So as you can see here, the first row has 1, 0, 0, 2, and then you have 0, 1, 0, minus 1, and then you have 0, 0, 1, 1. So that is how you are performing the row echelon method to solve your matrix. So if you remember, we had x is equal to 2, y is equal to minus 1, and z is equal to 1. Those were the answers that we wanted. Once we are done with row echelon method, let's move over to the inverse method. So suppose we have some equations, 4x plus 3y is equal to minus 13, and minus 10x minus 2y is equal to 5. What does the inverse method tell us? Let me show it to you. So this is the matrix that you come up with. So it is 4, 3, minus 10, and minus 2. Then you have x and y, and which is equal to minus 13 and 5. So what does the inverse method actually tell us? For example, we know that A into A inverse is equal to 0 work done, right? It is the identity matrix, I matrix. So if I have A into the A inverse, so it is like I'm doing the work and I don't do the work, is equal to no work done. So A into A inverse gives me the identity matrix. If A into B is equal to C, so A is my, all the numbers, then B is my x and y, and C is the output value. If I do A into A inverse into B is equal to C into A inverse, I am going to get B is equal to C into A inverse. Because A into A inverse gets cancelled, so B is equal to C into the A inverse of it. So that's what I'm going to do. So what is the inverse of the 2 cross 2 matrix? The inverse is found by this formula, and the inverse is actually 1 by 22, minus 2, minus 3, 10, and 4. So that's the inverse of the matrix. So let me show you how it works. What happens is I'm having A into A inverse into B is equal to C into the A inverse. So A into A inverse is obviously going to get cancelled out because it's an identity matrix. So I'm just going to be left with x and y is equal to 1 by 22 into minus 13 and 5, minus 2, minus 3, 10, and 4. So what I do later, I'm going to just multiply, and this is what I get. So it's basically 1 by 22 and 11 by minus 110. So if I do 1 by 22 into the particular matrix that I found, it is going to be x is equal to half and y is equal to minus 5. So that is how I'm going to be using the inverse method to find or solve the equations. I hope that was simple to understand. So once we've done all of that, we are now capable enough to understand what an eigenvector is. Eigenvectors are really important when you're working with data. All of that, what vectors, matrices, what all we've been doing by now, think of it as the data you're working with in your machine learning algorithm, right? What is an eigenvector? Eigenvector does not change the direction even if a transformation is applied to it. What does a eigenvector really give us? So for example, I have a data. If I am trying to do any transformation on it, it should not change from what it was really. It should not change from what it was initially. It should not become something that is totally irrelevant to me. If I have such data that even if I apply transformations to it, it does not change what it was supposed to be, that is an eigenvector. What does an eigenvector give me? They are the most sensitive parts of my data set, and I can use them and I can trust them for my analysis purposes. So that is why eigenvectors are so important. Eigenvectors help you transform and make your data much more careful. So for example, let me show you what an eigenvector looks like. Okay. So I have a particular rectangle and I have a lot of vectors, but for my example, I'm just going to be using two vectors. Okay. I have a v1 and v2. These vectors are basically trying to explain all the data that is there in the particular rectangle. What happens if I perform the sharing operation? When I perform the sharing operation, my v1 vector has changed its direction completely. It was at some other direction, and after sharing or after performing some operation, it has completely changed its dimensionality, its direction. All the information that it held initially has now completely been changed. Whereas my v2, it has not changed its direction. Yes, it has moved forward. It has multiplied, but it gives me the same information that it was giving me earlier also. So that becomes an eigenvector. Think of this now in the form of a matrix. If my matrix is changing so drastically, how will I be able to perform operations on it? It becomes really difficult. Okay, so for example, think of the vector v2 as a list, which is then just multiplied by 2. It does not make a difference. Why? It's because even if I multiply by 2, it's just going to double the value. But the operation that I want to do on it, the information that it is giving it to me, that's the same. So that's the reason eigenvectors are so important. And what are eigenvalues? The values that we perform on these eigenvectors are all that are eigenvalues. It's that simple to understand. So that is all you need to know about eigenvectors. All the data which is not transforming anything is basically the data that you should be learning with. What are the applications that linear algebra helps us with? You have the first and foremost, which is the principal component analysis, PCA. It is used for dimensionality reduction and it helps increase the quality of data. Then you are working with applying transformations. It helps in encoding. It helps in the single value decomposition, where it is again reducing the dimensionality of a single value data. And then it is used for natural language processing, for latent semantic analysis, optimization of your deep learning models. All of this can be achieved through linear algebra. So it is a very important aspect of machine learning. Once we are done with all of this, let's start our coding for PCA. We will now be coding for principal component analysis. Let me show you how it really works. So I am having all the programs already prepared for you guys, so we do not extend this big tutorial even more further. Let me go to the presentation mode. So what happens over here is I am having these important libraries, which are import numpy as np. Then I have the pyplot as plt. And then from sklearn.decomposition, import the PCA. So principal component analysis is already present. I'm just going to import it from sklearn. So I'm going to get a range of around 200, 300, how much ever it is. After I'm getting that particular range, I'm going to get data. I'm going to get all of that data and then I'm going to put it into my particular list. So what happens over here? I have np.dot and in the range of 2,2 and it is in the range of 2,200. So in the range of 2,200, whatever numbers that you can randomly generate, please give it to me. And then dot t. Why is it dot t? It's because all of this which I'm going to get is basically in the form of a column. I do not want it in the form of a column. I want it in the form of a row. So that is the reason I'm using .t. .t is used to transform it. So I'm just going to scatter that on the plot and then show it to you guys. That is what this particular function does. And then I am doing PCA is equal to PCA of n components is equal to 2. And then I'm going to fit the data into it. And then I have a function which is to draw the vector. So I'm going to do arrow props, dictionary style, all of that I've just given the styling over here. And then I'm going to annotate and draw it accordingly. So this is my draw vector function. And then I'm just going to scatter plot everything that I had. So I have the vector. How am I going to get a vector? It's using this particular formula, which is the vector and 3 and np dot sqrt. So what is PCA explain variance and components? Okay. So if you remember, I had fit PCA with the data that I have generated, right? So explain variance is basically going to tell me how much is the variance between my data points and what are the components that are really required that I look at and perform my analysis on them. So these are what the required components are for me. And after I do all of that, I'm going to get another vector. I'll show that to you guys. And then what I'm going to do is I'm going to find one component only over here and I'm going to fit the data. Okay. And I'm going to transform and perform the inverse transform so that I am going to get a particular linear line which I can just look at and find all the important aspects of the data that I wanted to from it. Let me run the program and let me show you all the outputs. So as you can see here, this is all the data that I had generated using the dot function of the random generating thing. So this is all the random data that I have generated. Then what I did, I had to find out two components, right? Then what I had to do, I had to find out two components. What can I understand from this particular information? This one is a small vector. So this small vector means that this is the only amount of information that it can give. Whereas this vector is so long. What this means is that the longer the length of the vector is, the more information that it can pass to me. Simple enough, right? Longer the length of the vector, the more information that it can pass to me. So what all information I have through this particular vector, all of this is going to give me the best for my analysis. So that's what I'm going to do. I'm going to get all the data points that are according to this vector. So as you can see here, all of these data points are very, very important for my analysis. So this is how I converted such a big, huge data set into one particular line. And if I follow all these points, I'm going to get almost the same amount of information the whole data set is going to give it to me. As you can see, this was such a huge data set, but it's just come up to just one line. It's so easy. Think if you're working with tons and tons of data, it becomes really, really difficult when you're working with it. That's the reason use PCA. And it's just not use PCA. Make sure that you're able to reduce the data as much as you can so that you can get at least all the amount of information that you can from that particular data. You do not need all the data, but you need the information from that data. That is basically how PCA works. I hope it was clear to you guys. So basically, that was all we needed to learn from linear algebra, and I hope it was clear to you guys. So now that we know all about vectors, let's move over to multivariate calculus. Multivariate calculus is one of the most important parts of the mathematics in machine learning. It helps us solve the second most important problem that we are facing in developing machine learning models. The first problem is obviously the pre-processing of the data. The next is the optimization of the model. Multivariate calculus helps us to optimize and increase the performance of a model and give us the most reliable results. So how does something that almost half the class hated help us solve such a problem? So let's break all the ice that's surrounding this, but before that we need to understand the basics. So let's calculus. So the first topic in calculus is a differentiation. Differentiation is basically breaking down the function into several parts so that you can understand every element and analyze it in depth. They are very helpful in finding the sensitivity of a function to the varying inputs. A good function gives you a good output, which can be described using a rather easy equation. The same cannot be said for a bad function. So for example, right here, I have y is equal to e power x. It is really easy to tell that, okay, if it is e power x, this is going to be the graph for it. But look at y is equal to 1 by x. It is such a horrendous graph that I cannot explain it using a particular equation. Those are the types of equations. Those are the good functions and the bad functions. We know all of this, but what are we really after? So let's do all of that right now. Okay, so most of us already know all of this, but what are we really after? So let's understand that with a really simple example. So let's assume that we have a car moving in a single direction only and is already in motion. So if we plot a graph of its speed versus time, it communicates to us how the speed varies as the time keeps increasing and it halts after a certain point. Now, if we want to know the rate at which the speed varies with respect to the time, it turns out to be that we are actually finding the acceleration. The acceleration of the car can be plotted as follows. So what this means is that acceleration is actually a derivative of speed because the speed we have here is just the magnitude and does not hold any more factors, just for simplifying everything. So if there was no speed, there would be no acceleration. It's as simple as that. Now that we have the acceleration, we can justify whether the car had a varying or a constant change in its speed, whether it was moving or not, and much more. But in this case, that is all we need. Now think that you want to find the change in acceleration between a certain range in a time span. Okay. We mark 2 points, x and some variable which is a small portion more than x. We can denote this using x plus delta x. So let's denote this on the graph. So you can see it as it's shown over here. Now, we know that this range has many values in between. But what if we want to know the rate of change only between one point and the next? We know that this is really kind of impossible because between a range, there are countless numbers as the function is continuous. Thus, we approximate that the limit or the step between two input variables is 0. Remember that this 0 that we are assuming is only the smallest possible value that we can make up, and it is not the absolute 0. If we ever work with absolute 0, we would never have had any functions at all. So if you are still confused, this number is basically some value of 0.00000. It just keeps going and then some numbers ahead. But it is never really 0. That is the only way that we can put this as. Okay. So now that we have understood what we are really trying to find, let's make it a general equation. So let's derive the derivation formula. So the derivation formula is f dash of x is equal to limit delta x tends to 0, which is not exactly 0, but we are assuming it to be 0 point something. So we are just going to write 0. And then we have f of x plus delta x minus f of x divided by delta x. That is how the formula comes into existence. This helps us find the rate of change between one point to the other. It is such an important concept as it plays a huge role in the optimization of machine learning models. You need to understand that this is the first order of derivation only. If we differentiate the output of the first differentiation, it becomes the second order differentiation and so on. But that is all the introduction we need from differentiation. So now that we have the basic idea and formula of derivation, let's move over and understand some of the important rules that we need in differentiation. So the first rule that we will be talking about is the power rule. So whenever you have a function which has a variable with some power, you can basically use this formula and solve the equation much more faster. So for example, let's say that I had an equation called as f is equal to 3x square. So let me put this into the formula. So I have f dash of x is equal to limit x tends to 0, 3 of x plus delta x the whole square minus 3x whole square divided by delta x. So x plus delta x the whole square becomes a formula. Let me expand it. And then this is what I actually get. Plus x square and minus x square get cancelled. And then I have delta x which is being removed out of there. So delta x and delta x also get cancelled. Then I have 3 into delta x plus 2x. So I'm going to put the value of delta x is equal to 0 into the equation, which is not exactly 0, but it is so small that I can ignore it. So I have 3 into 2x, which becomes 6x. So that's how I had to solve the whole entire equation, right? So what about the power rule? Power rule is just 3 and whatever number I had, right? So if it is 3x square, let me take out 3 because 3 I am going to treat it as a constant. So x square. So x to the power of 2. So then what I do, I bring 2 down, which is n, and then I have x of n minus 1. So it is 2 minus 1. So it becomes 3 into 2x, which is equal to 6x. So I get the entire same answer, but I just had to do it in 3 steps. I can actually do it either in 1 step, but just for simplification, I've done it like this. The next rule that we are going to be studying is the rule of sum. So if you have a particular function which is the sum of two variables, their differentiation's sum also is the differentiation of the whole function. So if you have f of x1 plus x2, it will be x1 dash plus x2 dash. A simple example will be 3x square plus 5x. Okay, so I'm going to solve the equation right now. 3x square, I hope you remember, I just showed it to you before. And the same thing goes for 5x also. So 5x plus 5 delta x minus 5. And then I'm going to just, cancel out 5x's. And then I have delta x being cancelled out. And then I have x square minus x square being cancelled out. So the whole same process goes on. Then delta x gets cancelled. Then I have 6x plus 5. So I'm going to use the same rule that we learned earlier. That was the power rule. And then I have 3 into 2x plus 5. So I get 6x plus 5. This is basically how the sum rule works. Next, I have something called as the product rule. So if I have a function which is in the form of x into 2x or something like that, the differentiation is very simple. This is how the differentiation looks. If it is f dash of x1 into x2, that is equal to x1 dash into x2 plus x2 dash into x1. That is how you're going to find out the differentiation. And the next rule that we are going to look at is the chain rule. So basically, if I have f dash of g dash of x, it will be f dash of g into x dot g dash of x. This is a very simple example and it's really easy to understand. So if you want to learn more about the common functions, I have my blog which is also put up in the description. And you can go ahead, click over there and learn more about the common functions. Okay. So now that we have understood all the basics that we really needed from differentiation, we'll now be moving over to partial differentiation. Partial differentiation is an important concept that most of us have ignored throughout our academy. What has partial differentiation helped us achieve might be the question that most of you may be having right now. So let me give you an example so that you can understand its importance. Okay. Suppose you are a car designer who deals with the exterior of the car only. You have been given the task to maximize the performance of the car. So how do you do that? You do not go into the car, you do not take out the engine, you do not tune the engine. You are not supposed to do any of that. You just are going to change the particular exterior of the car. So what's happening over here? You know that even the engine and all the other tires and all that, all those are variables also that come to making the car better in its performance. But you are not going to do that. You're not supposed to do that because you are only going to deal with the exterior of the car. Those variables of the engine and all of that, those are kept constant. If those are kept constant, that means that those variables will be performed by somebody else. You are just going to look at your particular variable that you have to change. That is the exterior of the car. So this is how partial differentiation comes into play. You are just going to change one particular variable. All the other variables become a constant. Okay, it's that simple. So what do? You would change the windshields, change the body if necessary, air vents, and many, many more. I've just given whatever I could find. You are just changing what is necessary. That is basically what is partial differentiation. So what are the equations that partial differentiation goes according with? Now, if you can see, it is the f dash of x, y, and z. If you remember the previous slides, we were just working on one variable that is x, which is x1, x2, which may be x squared, 3x, 5x. It was all on x. Partial differentiation is not like that. It is x, y, z, whatever variables it can find. So that is what makes partial differentiation much more realistic, much more easier to understand. Because you are just going to change your factors, your variables. You're going to keep everything else constant. So let's say, for example, you have to find it with respect to y. So y and z become a constant, f dash of x. If you want to find it with respect to y, x and z become a constant, f dash of y. With respect to z, x and y become a constant f dash of z. So what is the complete differentiation? It is the addition of all the three differentiations that we've just found out. So this is how partial differentiation works. Let's show you an example. So if I have a function which is x square plus 3y plus 4xz square, how am I going to find the differentiation of this? So with respect to x, y becomes a constant, so it is 0. And then you have a 2x plus a 4z square. So with respect to y, x square plus 4xz square become a constant, so I'll just have 3. So with respect to z, it will become x square becomes a constant, 3y becomes a constant, and then 4xz square is what I am going to differentiate. So I will have 8xz. So what is the total differentiation? It is a 2x plus 4z square plus 8xz plus 3. So I hope you've understood this really simple example of it. So this is how partial differentiation works. So what are the applications that multivariate calculus comes into play? We have something called as the Jacobian vector. Now what is the Jacobian vector? It is basically differentiating the vector once. Jacobian is basically differentiating the vector once and then putting it into the form of a matrix. That becomes the Jacobian vector. It helps in finding the global maximum of the data set. It is pointing to the maximum data that is there in the data set. And it also helps in linearizing a non-linear function to a linear at a particular point. So that's how the Jacobian helps. So differentiating the Jacobian or differentiating the actual vector twice gives us the Hessian. And it is used in minimizing the errors. It is used in deep learning models, gradient descent for optimizing all the weights and all of that. So that is how multivariate calculus helps us in real life. Let me show you how the gradient descent works. I already have code ready for you guys. Let me go back to the presentation mode. I have a particular import, which is the numpy. And then I have the sigmoid function, which is basically 1 divided by 1 minus e to the power of minus SOP. So this is what I'm going to return back to it. And then I have the error, that is a predicted minus target whole square, or x to the power of 2. This is what the error is basically. And then I have the errors derivation, which I'm going to use over here. So that is basically 2x or 2 into predicted minus the target part. And then I have the actual function over here, which is sigmoid into 1 minus sigmoid, which is the activation function, which is basically trying to find if my particular model is working or not. And then I have the derivation of it, which is just basically x. And then I have the updating function of the weight. So I'm just going to get the weight, I'm going to get the gradient, and I'm going to get learning rate. And I'm going to basically keep trying to, find out the best way that I can find my weight. So here's my function. I have x is equal to 0.1, which is my input. And then I have the target, which is 0.3. And I'm going to have a learning rate of 0.01. And then I'm going to get a random number, which is the weight of it. And then this is the initial weight. What I'm going to do then is I'm going to find the value of y and x, and I'm going to find the errors also. And then I'm going to find all the gradients, and then I'm going to pass the gradient into it and then update the weight. Let me show you an example now how increasing the number of steps is going to make me reach my target much more better. So as you can see, my initial weight was 0.50 thing and all that, and I have just run this for 10 times, right? Let me change this to 1000. My input is 0.1 and this is 0.3. I have to make 0.1 as 0.3, right? So let me run this again. It is still at 0.50. Let me add another 0, which is 10,000 times. Let me run this. So as you can see, it has now become 0.47, which is much more better than what we were actually doing. Let me add another 0 over here. So this is going to take a lot of time because the amount of, steps to be performed are more. But as you can see over there, which was 0.5 previously has now come up to 0.36, which is much, much better than what we were actually getting. Let me add another 0. Let me run it again. 4.6, 4.4, 4.0. As you can see, it is reducing. It's just reducing. The input and our output is almost close enough. what we really needed, the target was 0.3. And as you can see here, we've already reached 0.30 and all the numbers that are succeeding it, right? If you remember, we had 10 steps, which would just give us 0.50 or 51 something. Now, for the amount of times it has learned, it has become much, much, much better than what we were previously getting. So now it is 0.300002 something. It's still reducing. It is still reducing. So this is how the gradient descent works. It keeps repeating, learning. This is the final output that we've achieved. 0.30000577, and it is much, much, much better than what we were already getting from the output. So this is how the gradient descent works. It uses differentiation. Where is the derivation over here? This is my derivation function. This is my derivation function. So these derivation functions are what are helping me to get my new error. And then put that into the gradient descent function, and then basically find and make my weight much more better so that I can get the output, which is from my input 0.1, I have to get the target of 0.3. So I hope you've understood how the gradient descent works. It keeps going in, and it uses differentiation a lot. So I hope that was very easy for you guys to understand. So with that, we have come to the end of all that was required from multivariate calculus. Let's move over to the next topic, which is probability. So what is probability? Probability is measuring how likely an event will occur. What this means is that how much are you sure, or how much quantity that you can give to your sureness that this particular event is going to happen. So that is what is probability. It is the ratio of the desired outcomes by the total outcomes, right? So with that particular formula, you will be able to understand what is the probability. It is the desired outcomes by the total outcomes. So always remember that probabilities always come up to 1. So if you have 0.6, that means you have a 60% probability that this particular thing will happen. If you have 0.6 of something happening and 0.4 of something not happening, they always sum up to 1. Remember, probabilities always sum up to 1. So some examples that I've given over here are rolling a dice. There are 6 possibilities, right? So every possibility has 1 outcome out of the 6 outcomes. So for example, the probability of getting a number 2 is 1 by 6. So that is the probability of getting a number 2. This is basically what is probability. So what are the terminologies that you need to understand when it comes to probability? There are 3 things, okay? You need to understand what is a random experiment, what is a sample space, and what are the events. Let's understand all of these terminologies one by one now. So what is a random experiment? It is an experiment or a process for which the outcome cannot be predicted with certainty. So for example, if I give you a dice, okay, and I tell you to roll it and tell me the number that you're going to get it. You are not sure because that's a random experiment. You have this uncertainty whether this particular event will happen or not, okay? So that process where you roll a dice and all of that, that is a random experiment. So what is the sample space? The entire possible set of outcomes of a random experiment is the sample space of that experiment. It's really simple, right? I tell you to roll a dice, there are 6 outcomes. So it can be either 1, 2, 3, 4, 5, 6. That particular range of 1, 2, 3, 4, 5, 6 is the sample space. It is all the possible outcomes for the random experiment that you've been doing. Simple enough. So what is an event? An event is one or more outcomes of the experiment. So if I told you, roll the dice, you get a number 1, that is an event. You roll the dice again, you get a number 6, that is an event. So what outcome you get from your random experiment is called the event. There are 2 types of events. There are joint events and disjoint events. Let's understand both of these. So joint events have common outcomes, right? Joint events can be together. That is what is a joint event. For example, you have a student who can get 100 marks in statistics and 100 marks in probability. The outcome of a ball that can be delivered can be a no ball also, and it can be a 6 also. And it can be possible are called joint events. Disjoint events do not have common outcomes. So the outcome of a ball that is to be delivered cannot be a 6 and a hit wicket or something like that, okay? So a single card cannot be a king and a queen together. and a man cannot be alive and dead at the same time. So those are disjoint events. Those are not at all possible to happen. Now that we've understood all the types of events, we need to understand the distributions. So now we have three distributions that come under probability. We have the probability density function, we have the normal distribution, and central limit theorem. So let's understand all of these distributions one by one. So the first one is PDF, probability distribution function. So the probability now can be described using an equation. The equation that describes a continuous probability distribution is called the probability density function. I hope it's very clear to you. If it is not, let me just simplify it even more. You have a function which is going to describe the probability of something happening in the form of a graph. It's that simple enough to understand. You have a function which will give you the probability which you can plot a graph on. So that is the reason it is a continuous probability distribution. Okay. As you can see here, you have A and B. Between the range of A and B is the most likely that something is going to happen. So now that you've understood what a PDF is, let's understand the properties of the PDF. The graph of the PDF will always be continuous. It's simple enough to understand that. Then the area bounded by the curve of the density function and the x-axis is always going to be 1. And the probability that a random variable assumes a value between A and B is equal to the area under the PDF bounded by A and B. What this means is basically if you have any particular value or any particular probability that is between A and B, it is going to be equal to the area that is bounded by A and B, the probability value. So that is basically what a probability density function is. So next we have the normal distribution. So what is a normal distribution? It is a probability distribution that associates the normal random variable x with a cumulative probability. So how do you find this particular cumulative probability? It is using this formula, which is y is equal to 1 by sigma into the square root of 2 pi into e to the power of minus x minus mu into 2 divided by 2 sigma 2, where x is the normal random variable that we have just taken up, then mu is the mean and sigma is the standard deviation. And this is how the normal distribution looks like. The graph of the normal distribution depends on basically two factors, which is the mean and the standard deviation. So the mean determines the location of the center of the graph and the standard deviation determines the height of the graph. So if you have a very big deviation between, your variables, it becomes a very short graph and very wide graph. Whereas if you have a good deviation, which is, very less, you will have a tall graph. That is basically what's going to happen over here. That is all we have from normal distribution. Then the central limit theorem. So this is basically a theorem which is stating that the probability is always going to be in the center of the graph. Let me tell you the statement of this. The central limit theorem states that the sampling distribution of the mean of any independent random variable will be normal or nearly normal if the sample size is large enough. So what this basically means is that the distribution of your mean or your samples are always going to be near the center or always going to be near the mean of your graph if your sample size is much large enough. So what this means is that if your sample size is very big, it is going to be a normal distribution. It is as simple as that. So as you can see, if I have n is equal to 1 component, you can see the graph as it increases to 3, as it increases to 10, as it increases to 50. So as you can see, it almost becomes nearly identical to a normal distribution. So that is what the central limit theorem is. So once we are done with that, we will look at the types of probability. We have marginal probability, joint probability, and conditional probability. Let's understand each of this. So what is marginal probability? Marginal probability is the probability of occurrence of a single event. If I flip a coin, it is going to be either a head or a tail. That occurrence of that single event is called as a marginal probability. So for example, I have a deck of cards here and I randomly take out a card from there and I want it to be a hard card, right? So that will be the probability, which is 13 by 2, and it can be expressed by this particular formula. So once we are done with marginal probability, let's go to joint probability. What is joint probability? It is the measure of two events happening at the same time. So the same example over here, I have a deck of cards out of which I want to take out the ace, which is a hearts. So it has to be a ace card and it has to be a heart card, which will be the probability giving me 1 by 52. So now that we've understood what is joint probability, let's understand what is conditional probability. So the probability that depends on something already happened is called as the conditional probability. It is basically the outcome of the event is based on the occurrence of a previous event or an outcome. Conditional probability of an event B is the probability that an event will occur given that A event has already occurred. What are the two types of formula that we have in conditional probability? If A and B are dependent events, then the expression for the conditional probability is given by P of B by A is equal to P of A and B divided by P of A. If A and B are independent events, that means the expression will be P of B only. So it is just the probability of B occurring. Whereas if they are dependent events, means that if you want to find the probability of B, A already has to be occurred. So it is a probability of A and B divided by the probability of A. So that is basically all the introduction that was required from probability. We now have Bayes' theorem. So what is Bayes' theorem? It shows the relationship of one conditional probability and its inverse. What is Bayes' theorem? It shows the relation between one conditional probability and its inverse. So this is the formula, that is P of A by B is equal to P of B by A into P of A divided by the P of B. So what does this particular thing mean? So what we are trying to find out is the probability of the occurrence of A given that B has already occurred is equal to the probability of B occurring when A is already there and the P of A, which is the prior probability, which is something that we already think of, and then the probability of B occurring. So this is basically what the Bayes' theorem is. Let me give you an example for it, okay? Suppose you're a doctor and you're running a clinic where you test if a patient has a liver problem or not. All the previous patients that had come to you, out of them, 10% of your patients had liver problems, okay? So all the patients that had come before, they had around 15% probability that they were drinking. So now we have found out the probability of A and probability of B, the prior probability and the probability of B. So what was the probability that out of all of those patients, even though they had a liver problem, they were drinking? It is 5%, which is P of A by B. Hence, the Bayes' theorem says that the probability that a new patient, whoever is entering, will have a particular liver disease is calculated by 0.05 into 0.10 divided by 0.15 is equal to 3.33%. What this means is that if a new patient is going into the clinic, there is a chance of 3.33% that that particular person is also having a liver problem. This is basically how the Bayes' theorem works. So what are the applications of probability? Probability helps you to optimize your model. Classification of our algorithms also requires probability. The loss can also be calculated using a probability. Then models are built on probability. So let me show you how the naive Bayes classifier works over here. So let me go to naive Bayes. This is the naive Bayes classifier. So let me tell you what I have done over here. I have imported the data sets, the metrics, and all the required naive Bayes classifier, and I've imported the Gaussian naive Bayes classifier. The Gaussian is also another name for the normal distribution. Okay, so normal distributions are also called as the Gaussian naive Bayes classifiers. And why I have done this is because I had visualized it and I came to know that it was a normal distribution. Okay, so I load the iris, that is the load iris dataset, and I load a model. And then I'm just going to fit the model. Okay, then I'm going to get the predicted model of it, and then I'm just going to basically find all the metrics of it. So basically, let me show it to you. What is the precision, recall of all of that? So this is all the accuracy. Then my model has an accuracy of 96%, and this is the confusion matrix, which means that out of 50 it was able to classify all the 50 correctly. Then out of 50 it classified 47 correctly and 3 were wrong. And then out of 50 again over here, 3 were classified wrong and 47 were classified correct. So this is the naive Bayes classifier. So as you can see, probability is actually being used in all of this. The Gaussian naive Bayes classifier already does all of that. So we do not need to worry about it much more. So now that we have finished up everything that we needed to do from probability, let's move over to the last topic for today, statistics. What is statistics? Statistics is an area of applied mathematics concerned with data collection, analysis, interpretation, and presentation. What this means is that you are going to analyze, understand all the data that you've collected and how you're going to present it. So for example, your company has created a new drug that may cure cancer. How would you conduct a test to confirm the drug's effectiveness? What are you going to do? You are basically going to collect a large amount of people around. You're going to take all of those people. You're going to, give them basically the new drug that you have created, and then you're going to interpret all the results that you get from it, and then you're going to present that out of, let's say, 1,000 people, around 900 of them were cured or 950 were cured. So all of those parts come under statistics. Okay. So I hope you've understood that. What are the terminologies that you need to understand when you work with statistics? There is population and there is sample. So what is population? It is the collection or a set of individuals or objects whose properties are to be analyzed. All the data that you have collected is called as the population. So out of all the data that you've collected, you take out a set of data for your analysis. That set of data is called a sample. So what is a sample? A subset of the population is called as a sample. So a well-chosen sample will contain most of the information about the population parameter. So how do you choose the sample? The sample needs to be chosen such that all the data that the population is trying to convey can be conveyed through the sample itself. So that is what is population and sample. Now that we've understood the basic terminologies, let's look at some of the sampling techniques that we have in statistics. So sampling can be classified as probabilistic and non-probabilistic type of approaches. So in probabilistic sampling, we have random sampling, systematic sampling, and stratified sampling. In non-probabilistic one, we have snowball, quota, judgment, convenience, and all of that. Okay. So, but for machine learning, we do not need to take a look at the non-probabilistic approach. We just need the probabilistic approach. So we will be now covering about random sampling, systematic sampling, and stratified sampling. So let's go ahead with that. So what is random sampling? You take out a sample randomly out of the population. That is basically what is random sampling. Each member of the population has an equal chance of being selected in the sample. So that is what is random sampling. So what is systematic sampling? Systematic sampling is basically you follow a particular order out of which how the sample has to be taken. As you can see here, I have 6 particular groups. Now from this 6 particular groups, I'm going to take all the even ones, right? So that will be 2, 4, and 6. That is basically how the systematic sampling works. I follow a system. I follow an order of how I'm going to take the sample. So once we are done with that, what is stratified sampling? What is a stratum, first of all? A stratum is basically a subset of the population that shares at least one common characteristic, which is the gender, which I have taken over here. So as you can see here, I have the whole population, out of which I have found out one property that is common between all of them. That is gender. They are either male or female. So I'm going to break the whole population based on that. I'm going to break my population into the male subset and the female subset. So after that, I'm going to apply the random sampling and I am going to take out all the samples that I am going to be needing. Okay. So once I have now broken down my particular subsets, now I'm just going to be using random sampling and take out all the samples that are required by me. So this is what is stratified sampling. So what are the types of statistics that we need to infer from? We have descriptive statistics and inferential statistics. So let's understand each of these right now. Okay. So what is descriptive statistics? Descriptive statistics is mainly used to focus upon the main characteristics of the data. It provides the graphical summary of the data. So as you can see over there, descriptive statistics uses the data to provide descriptions of the population, either through numbers or calculations or graphs or tables. Okay. So as you can see here, I have my shirt and there can be either 3 particular sizes. There can be the most minimum one, the most average one, and the most maximum one. And all of that is based on the weight of the person. Suppose, for example, if a person weighs 60, he's going to get the maximum one. If the person weighs 40, he's going to get the average one. The person weighs 20, he's going to get the minimum one. So that is how I am describing my data and I'm going to infer data from it. So that is descriptive statistics. So what is inferential statistics? Inferential statistics makes inferences and predictions about a population based on the sample that is being taken from it. So what this means is basically I'm going to generalize a large data set and apply probability and draw a conclusion to it. So it allows me to, infer data parameters based on the statistical models which is using the sample data. I have a whole bunch of population out of which they can tell me they have either the large size or the medium size or the small size. So according to their sizes, I'm going to supply them the t-shirts. So this is basically what are the two types of statistics. There are descriptive statistics and inferential statistics. Descriptive statistics, what does it do? It describes the data. Whereas inferential statistics takes information from that data and then analyzes accordingly to however we want it to. So these are the two types of statistics. Let's go in depth with descriptive statistics. What is descriptive statistics? It is used to describe and understand the features of a specific set of data. So what is descriptive statistics? It is a method used to describe and understand the features of a specific data set by giving short summaries about the samples and measures of the data. In descriptive statistics, it is broken down into the measures of center and the measures of variability. So what does measures of center have? Measures of center has the mean, median, and the mode, whereas the measures of center have the range, interquartile range, variance, and standard deviation. So let's understand all of this right now. So for example, here you can see that I have a data set of a car which contains the variables, the car, the mileage, the cylinder type, the displacement, the horsepower, and the real axle ratio. So I'm going to find out the mean. So what is a mean? Mean is the average of all the samples. So for example, if I want to find the mean of the horsepower, I'm going to just add the values and divide it by the number of values. So I get 103.625. This is the mean of the horsepower. So what is the median? It is the measure of the central value of the sample set. That is what is a median. So let me show you how to find it for the miles per gallon. To find the order of the center value, you have to basically arrange it in the ascending order. Okay. So you have 21, 21, 21.3, 22.8, 23, and accordingly. Now I have to take the two middle values. Okay. So that will be 22.8 plus 23 divided by 2. That becomes 22.9. So that is the median of my sample. Next, let's move over to mode. The value which is most recurrent in the sample set is called as the mode. So let me find the mode for the cylinder type. What is most recurring? The 6-stroke or the 4-stroke? I can see here that there are 1, 2, 3, 4, 5. So there are 5 times that the cylinders type of 6-stroke has been repeated and 3 times cylinder type 4-stroke has been repeated. So 6 becomes the mode of the data. Okay. So now that we have understood all that is required from measures of center, let's move over to the measures of spread. So a measure of spread is also called as a measure of dispersion, is used to describe the variability in the sample or the population. Okay. So the first one is a range. Range is the given measure of how spread apart the values are in a data set. So it is the maximum value minus the minimum value, which gives us the range. So what is an interquartile range? Quartiles tell us about the spread of the data by breaking the data into many quarters, just like the median breaks itself. So for example, if I have 8 datas over here, I can break it down into 3 quarters where I have a 1, 2, then I have 3, 4, 5, 6, and 7, 8, which become different samples accordingly. Okay. How do I find what is the interquartile range? So how will I find the interquartile range of this? Okay. So the first quartile Q1 comes between the 25th and the 26th. So it'll be 45 plus 45 divided by 2. That becomes 45. The second one comes under 50 and 51st. And that will be 58 plus 59 by 2. That will be 58.5. And the next one comes at 75 and 76. That is 71 plus 71 divided by 2, which is always 71. So that is basically what is an interquartile range. It is the measure of variability based on the dividing set into the quartiles. So that is basically how you break down the interquartile range, and it is the measure of variability based on dividing the set into quartiles. So quartiles divide a rank ordered data set into 4 equal parts, which would be Q1, Q2, and Q3 respectively. And the interquartile range is measured by Q3 minus Q1. So if you can see this, you have the whole data, which is 100%, and you have broken down the data into 25% each. So the quartiles come in between the first Q1, Q2, and Q3. So those are the interquartile ranges. So now that we've understood that, let's move over to variance. So variance describes how much a random variable differs from its expected value. It entails the computing squares of the deviations. So that is how you find the variance, which is s square is equal to the summation of 1 to n is equal to 1, xi minus x bar, the whole square divided by n. So xi is the value and x bar is the mean. I hope that's simple for you to understand. What does a variance mean? It means the difference between the data which it should have actually been. So what does the variance actually try to tell you? Okay, it basically means that the data which should have been something and what it really is, what is the difference between them, how much it differs from each other. So that is what is the variance. So what is a standard deviation? Deviation is the difference between each element from the mean. So I have xi and I have the mean. What is the difference between each of them is the deviation. So what is the population variance? The population variance is given by this particular formula, that is sigma square is equal to 1 by n. The whole summation of I is equal to 1 to n is equal to xi minus mu the whole square. Once we have found out the population variance, what is the sample variance? So it is s square is equal to 1 divided by n minus 1, the summation of I equal to 1 to n, and xi minus x bar the whole square. That is the sample variance. So what is the standard deviation? Standard deviation is the measure of the dispersion of a set of data from its mean. What the standard deviation is trying to tell you is basically that how much this data is trying to disperse from its actual data. So how is that given by? It is given by 1 divided by n, summation of I equal to 1 to n xi minus mu the whole square, which is basically the variance's square root. So that is standard deviation. So how do you find the standard deviation? I'm just going to give you an example over here. So say for example, Daenerys has 20 dragons and they have the numbers accordingly. So how do you work out the standard deviation? So the mean is given by adding all the numbers, dividing it by 20. So mu is equal to 7. And then what is the standard deviation? So it'll be xi minus mu the whole square. So it'll be 9 minus 7 the whole square is equal to 2 square is equal to 4. Then you have 2 minus 7, all accordingly. You keep on going and you get the following results, which is 4, 25, 4, 9, 25, 0 accordingly. Once you have done that, put that into the formula. So you have this formula accordingly. So we get the variance square is equal to 8.99 and the standard deviation will just be the square root of 8.9, which will be 2.983. What this means is that with a value of 2.983, the values are differing from the mean. So if you are trying to add 2.983 to all the other values, you will be getting something which is much more similar and much more realistic and much more, closer to the mean of the. So that is how standard deviation works. Now that we've understood all of that, we have a very classic example of information gain. So what does information gain help us with? This is an ideology that comes into picture for decision trees. So let's understand the basic concepts of what we require in information gain. So the first topic that we need to understand is entropy. So what is entropy? Entropy measures the impurity or uncertainty that is present in a data, and it is given by the formula h of s is equal to minus summation of minus 1 to the power of n p of I log base 2 p of I, where s is all the instances in the dataset, n is the number of the distinct class values, and p of I is the event probability. Because entropy is the impurity that a data has. So what is information gain? Information gain is how much information a particular feature will give to the final outcome. So that is given by gain of a of s is equal to h of s, which is the entropy, minus summation of j is equal to 1 to v, s of j divided by j into h of s of j is equal to h of s minus h of a by s. H of s is the entropy of the whole data set. S of j is the number of instances with j and a value of attribute a. S is the total number of data sets. V is the distinct value of attribute a. H is the entropy of the data set with value a and entropy of attribute a. So these are all the requirements. So let me give you an example of information gain. you can see the data set over here, which is for 14 days and the particular, attributes that are given to it. So the forecast is to find out whether the match will be played or not according to the weather conditions. So this is what we are trying to find. Here we have 5 no's and 9 yeses. So we have the outlook, and then we have sunny, overcast, and rainy. So in sunny, we have 3 no's and 2 yeses. In overcast, we have 4 yeses and 0 no's. And in rainy, we have 3 yes and 2 no's. So how are we going to find out which particular node is going to, attribute the most to it? So let's find out the entropy first for the whole data, which is 9 instances say yes and 5 instances say no. So we have a minus 9 by 14 log base 2 of 9 by 14 minus 5 by 14 log 2 of 5 by 14 is equal to 0.940. So what this means is that the data that we have has 0.940 times bad data. Means it cannot give us much information. There is much more impurity in the data. So let's move over. The first step in information gain is to find the root variable. So how are we going to find the root variable? We are going to take all of the attributes and find the information gain from them. We have outlook, we have windy, humidity, and temperature. So let's find out the information gain. So for information gain of windy, we have 6 instances true and 8 instances false, right? So h of s is equal to 0.940 minus 8 into 14, and as you can see, all the other variables. So the gain that we have achieved from windy is 0.048, which is really, really less. So for outlook, the same thing happens over here. We have the information gain that is being passed by it is 0.247. Then we have the information gain from humidity, that is 0.15, which is also really good. And then we have temperature, which is 0.029. You can pause and look at the steps if you want to. Out of all the gains that we have, the variable with the highest information gain is used to split the data. So outlook has 0.247, windy has 0.048, gain has 0.151, and gain of temperature is equal to 0.029. So what are we going to choose? We are going to choose outlook. Why is that? It's because it has the highest information gain. So that becomes our root node. That is a simple example of how statistics is used in the information gain. Next, let's move over to the confusion matrix. So what is a confusion matrix? Confusion matrix is a table that is often used to describe the performance of a classification model. So it is a table that is used to describe the performance of a classification model on the set of test data. So how are you going to calculate the accuracy of this? It will be true positives plus true negatives divided by true positive, true negative, false positive, false negatives. So if you are confused with what is true positive, true negative, false positives, false negatives, let me explain that to you right now. Let's say, for example, there are 2 possible predictor classes which are yes or no. The classifier made a total of 165 predictions. That means 165 predictions were total. So out of the 165 cases, the classifier predicted yes 110 times and no 55 times. So in reality, 105 patients only had the disease and 60 patients did not. So how are we going to put this into the table? So as you can see here in the table, we have n is equal to 165. Then we have predicted no and predicted yes, actual no and actual yes. So if our classifier predicted it no and it was actually no, that is the correct output. If it predicted yes and it was actually yes, that is also the correct output. But it predicted it as yes and it was actually no, that means it has made a mistake. And it predicted no but it was actually yes, it has still made a mistake. What are the correct values over here? Which is 50 and 100. So 50 and 100 are the correct values and 10 and 5 are the wrong values. What is a true positive? True positive are which it was predicted as yes and they actually have the disease. True negatives are predicted no and they did not have the disease. False positives are classifier predicted it as yes but they did not have the disease, and false negatives we predicted no but they also had the disease. So this is basically what a confusion matrix is, and it is helpful in finding out the performance of the classifier that you are working with. So that is what is a confusion matrix. Next comes inferential statistics. It is a method where we infer and understand what the data is trying to communicate with us. So it is broken down into 2 points. It is point estimation and interval estimation. So let's understand about point estimation. Point estimation is concerned with the use of a sample data to measure a single value which serves as an approximate value or the best estimate of an unknown population parameter. So you have such a huge population of India, right? Out of that, you're just going to randomly take out some sample of it. You're going to find out the sample mean, and this sample should be so good enough that it is going to estimate the whole mean of the population. So this is how you use point estimation and try to approximate it for the whole, population. So what are the different methods? We have methods of movement, methods of likelihood, Bayes estimator, and best unbiased estimators. So estimates are found out by equating the first k sample movements to the corresponding k population movements, which is the method of movements. And then we have the maximum of likelihood, which uses a model to maximize a likelihood function. Bayes estimator minimizes the average risk, and it is an expectation of all the random variables. And then we have the best unbiased estimators, which is used to find out the best depending parameter. So that is all that we require from point estimation. Let's move over to interval estimates. So an interval or a range of values is used to estimate the population parameters. So we have a point estimate and we have an interval which gives us the low confidence and the high confidence limit. How is this going to happen? There are 3 things that you need to remember. There is something called as the confidence interval, and it is the measure of your confidence that the interval estimate contains the population mean mu. So statisticians use a confidence interval to describe the amount of uncertainty associated with a sample. Technically, a range of values are so constructed that it is specified probability of including the true value of a parameter within it. So for example, let's take a sample where we have 10,000. So let's say that we have something called as a supermarket. So out in that supermarket, we have collected a lot of data. And in that data, I'm saying that this particular items, okay? So item 1 and item 2, if they both are kept together, they are going to be sold together. And I say that with 90% confidence. So that 90% confidence, okay, is what is my confidence interval. It can be in between this range. It can be between 90 to 95%. And between 90 to 95%, it is highly likely that that particular thing is going to happen. So that is my confidence interval. So what is the sampling error? It is the difference between the point estimate and the actual population parameter, which is the sampling error. Okay. So when mu is estimated, the sampling error is mu minus x bar. It is mean minus the point. What is the margin of error? So for a given level of confidence, it is the greatest possible distance between the point estimate and the value of the parameter it is estimating. What this basically means is that it is the greatest possible distance between what you have predicted and what it actually is, and what level of confidence you are giving to it. Okay, so that is the margin of error. How much error you can allow for the predicted model is what is the margin of error. So I hope you have understood that. So the level of confidence is the probability that the interval estimate contains the population parameter. So as you can see here, all the parameters that come under C, right, are what we are allowing. Okay, that is the margin of error that is allowed. But whatever comes in minus ZC and plus ZC, we are not going to take that. Those are the interval estimates. So finding these intervals is what is our probability. So finding these interval estimates is what is our work over here. Okay. So for example, if the level of confidence is 90%, this means that you are 90% confident that the interval contains the population mean. 0.05 and 0.05 of minus ZC and plus ZC is equal to plus 1.645 and minus 1.645. Those are the Z scores. Anything minus or plus of 1.645 is not allowed. So those are the values that we are concerned with when we are working with interval estimates. So now that we have understood everything we needed to from inferential statistics and descriptive statistics, let's move over to hypothesis testing. So what is a hypothesis first of all? It is some event that you have made up which may have the probability of happening or not happening. Testing that hypothesis is what is hypothesis testing. Is, formally checking whether this hypothesis is accepted or rejected. So how is the hypothesis testing conducted? You first state the hypothesis, and then you formulate an analysis plan of how you are going to, test this particular hypothesis. Then you get all the output. You analyze the data that you've got from all of it. So then you understand whether this particular hypothesis has failed or it is a good hypothesis. Okay. Suppose I have 4 boys over here, which are Nick, John, Bob, and Harry. So they were caught doing mischief in the class, and they have to now serve detention for almost 2 months. Okay. The detention is basically they have to clean the classrooms. So John over here comes up with an idea saying that I'm going to write all the names of ours into chits and then put them into a bowl. Whoever name comes out has to clean the classroom. So what happens here, that we are going to assume that the event is free of bias. So our hypothesis is, what is the probability of John not cheating? Let's find out what happens actually. The probability of John not being picked up for a day is 3/4. Now the probability just keeps increasing on and on if he is not picked up for 3 days. Okay, so it is 3/4 into 3/4 into 3/4 is equal to 0.42 approximately. And what is the probability of John not being picked up for 12 days? It is 3/4 into 12 is equal to 0.032, which is equal to 3.2%, which is less than 0.05, which is 5%. So what this means is that our hypothesis was that John is not cheating. But actually John is cheating over here because it has come down and it has come below the threshold value of 5%, which is 3.2%. So now all of us have come to know that John is cheating because he has not even written his name in the chits. So this is how the hypothesis works. So what is the null hypothesis? The hypothesis that we have created in the beginning, okay? That John was not cheating. That was a null hypothesis. It has no result which is different from the assumption. And we have an alternate hypothesis, which means that our results disapprove the assumption. We had a hypothesis that John is not cheating, but actually through our results, we found out that John is cheating. So this is what is the hypothesis testing. And we have a threshold value. If the probability that we are testing goes below this threshold value, it means that the particular hypothesis has failed. So this is what is the hypothesis testing. So now we need to know something about the P and T values. Okay. What is the P and T values? The P value and the T value help us in our hypothesis testing. Okay. We want to find the height of students who are greater than 5 feet and 7 inches. Okay. So we take a sample of 100 students and find that the mean height was 5 feet and 9 inches. Okay. We make a hypothesis that out of all the 100 students, there is going to be at least 6 students who are greater than 5 feet and 9 inches. So this is our P value. It is the probability value that we are saying that this particular hypothesis is going to be correct. We say that at least out of 100 times, 6 students will at least have a height which is greater than 5 feet and 9 inches. Okay. So this is the P value. This is the probability value that we have given to a hypothesis. The T value is testing this particular hypothesis and finding the difference that we have found out from our assumption and what we have actually calculated from our results. So this is how the P value and the T value help in making the null and alternate hypothesis. You find the result of the null hypothesis and the alternate hypothesis. So this is how the P and the T values help in making and observing the results from the null and alternate hypothesis. Okay. Let me show you a code where we are going to find the mean median mode accordingly and how that becomes helpful to us. Okay. So let me go back to the presentation mode. I have my data over here, which is this particular data. So I'm going to import statistics as S, and I'm going to just find the mean median mode of it. So let me just run this program for now. So as you can see here, the mean is 33.43 and the median is 3 and the mode is 2. 2 has been repeated the most number of times, so that is the reason it is the mode. And the variance is 5124 and the standard deviation is 73. That is how the mean median mode is calculated. Let me run the program now so that you can understand what we are trying to do. So let me close this out. What's happening over here is I have the iris data, which is the load iris, and then I am creating it into a data frame. Okay, simple enough. After that, I am saying that the species is the target and the data of species is equal to, I'm going to just apply all the lambda parts of it, okay? And then I am going to get the description of the data. And after that, what I'm going to do is I'm going to take this data and I'm going to pair plot it. And then I'm going to show the plot to you. So let me run the program. Let me show you the figure first. So I had 4 features over here, right? So that was the petal length, petal width, sepal length, and sepal width. So if you can take a look at this data, you can see that there is a normal distribution here. There's a normal distribution here. Also, there's a normal distribution over here with some exclusions over here. And there is a normal distribution here too, but with some exclusions here. So looking at this, I will be able to understand if I want to, apply the Gaussian naive-Bayes classifier or accordingly to however I wanted to. So this is how statistics has helped me to understand what is my data looking like. Now let me go back over here. So as you can see, this is the count of a 150, right? Simple enough. Then what is the mean? What is the standard deviation? What is the maximum length and maximum width that you can find over here? All of this is done using the describe part of it, okay? And describe is a function that is already available in pandas. So that was a very simple example of how I was able to understand how I have to use the Gaussian naive-Bayes classifier for my iris data, which I showed in the probability part, right? Now we are done with this.
So what exactly is predictive analysis? Predictive analysis is the branch of data analysis which is mainly used to predict future events or outcomes. It is solely based on data-driven approaches and techniques to reach to conclusions or solutions. The analysis mainly makes use of analytical techniques and predictive modeling in order to find relevant patterns in large datasets. In turn, these patterns can be used to make various opportunities in the businesses by identifying risk and benefit points, etc. Predictive analysis is an anticipatory technique for forward-looking solutions and insights to assess any situation. Most of the processes in the predictive analysis incorporates the machine learning terminologies and algorithms for model building, especially to train the models. So it is significantly important to understand how to choose these predictive techniques for model building. And as a beginner, it can help you a lot along the way. So let us quickly take a look at why we do predictive analysis, and I'm sure most of us are aware of the significant increase in the generation of data all around us. It has seemingly become quite clear since we are seeing a lot of data-driven approaches. But humankind has been storing data since a very long time. Documenting every detail has been a prevalent practice. With the digital age, it has become to process the data a lot more easier as well. But it has also opened a lot of opportunities for the years and years of long and unprocessed data to understand the relationship between various aspects of the data and make use of it in real life as well. We can use this data for various purposes. We have like risk and fraud detection, then there is market analysis, operational movements, operational improvements, campaigning, etc. And one simple example is to use the weather data to study the patterns and use predictive analysis based on the insights to predict the future events. So let's take a look at a few predictive analysis techniques as well. First of all, we have regression, guys. So the main goal of regression is the construction of an efficient model to predict the dependent attributes from a bunch of attribute variables. A regression problem is when the output variable is either real or a continuous variable. That can be weight or area or salary, etc. We can also define regression as a statistical means that is used in applications like housing, investing, etc. It is basically used to predict the relationship between a dependent variable and a bunch of independent variables. And simple linear regression is a regression technique in which the independent variable has a linear relationship with the dependent variable. It is basically a technique to analyze data set which has a dependent variable and one or more independent variables to predict the outcome in a binary variable, meaning it will have only two outcomes. And the dependent variable is categorical in nature. Dependent variable is also referred as target variable, and the independent variables are called as the predictors. Logistic regression is basically a special case of linear regression where we only predict the outcome in a categorical variable. It predicts the probability of the event using the log function. Next up, we have classification, guys. So classification is the process of categorizing a given set of data into classes, and it can be performed on both structured or unstructured data. The process starts with predicting the class of given data points, and the classes are often referred to as target, label, or categories. The classification predictive modeling is the task of approximating the mapping function from input variables to discrete output variables. And the main goal is to identify which class or the category the new data will fit into. Now let us try to understand this with a simple example, guys. So a heart disease detection can be identified as a classification problem, and it's a binary classification since there can only be two classes, which is basically has a heart disease or does not have a heart disease. So the classifier in this case needs training data to understand how the given input variables are related to the class. And once the classifier is trained accurately, it can be used to detect whether heart disease is there or not for a particular patient. Since classification is also a type of supervised learning, even the targets are also provided with the input data. And then we have clustering, guys. So clustering is basically, dividing data points into homogeneous classes or clusters. So the points in the same group are as similar as possible, and then the points in different groups are as dissimilar as possible. So when a collection of objects is given, we put the objects into group based on similarity. So that is what clustering is all about. And then we have another technique which is time series, guys. So the time series model comprises a sequence of data points captured using time as the input parameter. It uses the last year of data or the previous data to develop a numerical metric and predicts the data using that metric. It is basically a means of understanding a singular metric is developing over time with a level of accuracy beyond simple averages. So it also takes account seasons of the year or events that could impact the metric as well. And next up we have forecasting. So forecasting is nothing but using the historical data to make predictions or numeric predictions on a new data based on the learning from the previous data. Now that we know what these various techniques are, let us understand how to choose which one would be the best one for us while working on any data. So there are a few factors that you should consider while choosing a model. But before that, before talking about the deciding factors, let us go through the processes before predictive analysis before you start building the model. First up, we have the problem statement, guys. So problem statement tells a lot of things about the project or how you should approach it. If you're looking at the problem statement, you'll be able to know what kind of target you're looking at. So in a heart disease condition, guys, let's say for an example, we have a problem statement to decide or to analyze or predict if a patient has a heart condition or not. So with that said, we have already figured out the target variable, which is going to be categorical in nature, which means it basically will have only two values. That is, one has a heart disease or does not have a heart disease. So it becomes quite clear to us in the problem statement only. We're going to use the classification technique in this particular example. But then there are a few problems where you will not be able to figure out which kind of target variable you will be choosing or what are all the independent factors will be involved in your analysis. So you move on to the next one, which is extraction and loading. And you basically analyze all your data, and transform it and try to make use of all the information that you get from visualization and all these processes to understand what kind of variables you're looking at. And then comes the factors to consider before going for the model, which is what is the target variable. So if the target variable is continuous, you should go for the regression analysis. And if the target variable is categorical, you can go for the classification analysis. And if you're not able to find a target variable, don't worry guys, you can probably go for a clustering analysis. So you'll know which points are similar, which points are not similar, making it a classification or, making clusters. And then you can perform classification on those clusters as well. The next question you should be asking is your data linearly separable? And there is no direct way to actually determine it. So we can go ahead by choosing different models. I mean, you can compare different models to see if your data is actually linearly separable or not. Then the next factor would be the size of the data. You have to look for factors like the size of data to determine the possibility of overfitting and underfitting the model. Also, some models may not work efficiently with small data. So these are some deciding factors for choosing a model before you train the model with the training data. And let us take a look at a few machine learning models so that we can use for predictive analysis. The first one is linear regression. So linear regression is to be used when the target variable is continuous and the dependent variable or variables is continuous or a mixture of continuous and categorical. And the relationship between the independent variable and the dependent variable has to be linear. So that is when you know when you can use a linear regression. After that, we have logistic regression. So logistic regression does not require a linear relationship between the target variable and the dependent variables. The target variable is binary, assuming a value of either 1 or 0 or maybe true or false or something, or dichotomous as well. Then we have the k-means clustering model, guys. So k-means involves placing unlabeled data points in separate groups based on similarities, and this algorithm is used for the clustering model as well. After that, we have neural networks. So neural networks help to understand or help to cluster and classify the data, guys. So these algorithms are modeled loosely after the human brain and are designed to recognize patterns. Then we have decision tree. So a decision tree is a map of the possible outcomes of a series of related choices. It allows an individual or organization to weigh possible actions against one another based on their costs, probabilities, and benefits. As the name goes, it uses a tree-like model of decisions, and they can be used either to drive informal discussion or to map out an algorithm that predicts the best choice mathematically. After that, we have time series, guys. So the time series regression analysis is a method for predicting future responses based on response history. And the data for a time series should be a set of observations on the values that a variable takes at different points in time. So these are a few models that we have for predictive analysis, and these are only a few models, and there are other models also that we can use for predictive analysis. And with that said, let's also see a few applications of predictive analysis. So we can use it for finance, guys. So predictive analysis in finance can help in identifying the risk detection or the risk detection model to identify any fraudulent transactions or loans that you can detect using the predictive analysis. Then there is stock prediction as well. You can gather a lot of data in time and forecast a prediction that can be taken into account for different stocks. And there goes a lot of process behind this, but for as far as the application goes, stock prediction is a pretty good application of predictive analysis in finance. Then we have governments, guys. So governments are using predictive analysis for campaigning. They're using it for weather detection, weather prediction. There is disaster management. They're using predictive analysis for predicting the impact of policies, different policies that they're making, and they're making surveys, etc. We can use the predictive analysis in healthcare for early detection of diseases such as cancer, any heart ailments that may or may not be a part of your life several years later. So it helps in predicting all those diseases or conditions at an early stage. And we can also use predictive analysis in manufacturing. We can actually identify production failures and work on it using the prediction analysis. Then there is sport franchisees using predictive analysis to predict the outcome of certain events in the leagues or something like that. They're trying to make sense of what kind of match they have the best probability or the best prediction of winning, the chances of winning they have, or if they don't have any winning chances, what are the the basic points or basic insights that they're getting from the data that they should work on to win that particular game or a match or a league. And then we have telecom industries using predictive analysis for customer support. They're trying to segregate or segment the customers into groups that they are able to work on them based on their prediction.
So what is meant by deploying a model? Well, you see, deployment is a method by which you integrate a machine learning model into an existing production environment to make a practical business decision based on the data. It is one of the last stages in machine learning lifecycle and sometimes can be a tedious job to do. Now you might be wondering, how do I deploy this machine learning model? Well, the answer for this is quite simple. We have not one or two platforms, but a handful of them. Some of the popular platforms can be Google Cloud Platform, Heroku, AWS Lambda, Microsoft Azure, and many more. Well, speaking about the pipeline to deploy a model, well, it's quite simple. We first work on our machine learning or a deep learning model, and once we are confident with its prediction, we then integrate it with a web application framework like Flask, Django, or React, to name a few.
While developing a framework, you will have to work on marriage between front-end part as well as the back-end. You see, front-end part deals with end-user experience and back-end is where the logic works. Finally, you will deploy it on a server. And here the server that we are going to use is Heroku. So moving ahead, let us now talk about Flask. So what is Flask framework? Well, Flask is a web framework. And what this means is Flask provides with tools, libraries, and technologies that allows you to build web applications. This web application can be some web page, a blog, a wiki, or can be as big as calendar application or commercial website. Well, Flask is a part of categories of micro framework. Micro framework are normally framework with little to no dependencies to external libraries. This has pros and cons as well. The pros of this can be framework is light as there are little dependencies to update and watch for security bugs. The major cons for this is that sometimes you will have to work with more yourself or increase yourself with list of dependencies by adding plugins. So let me now quickly show you how we can install Flask on a system and let's see how we can work around it. So what I'm going to do here is first off go down to my Anaconda and create a virtual environment. And from there I'm going to install my Flask. So let me quickly go to my Anaconda here. And in order for us to activate our virtual environment, you'll do conda environment. You'll be using conda activate. If you haven't created your virtual environment, all you need to do is conda create -n followed by the name of your environment. So now that I've already created it, all I'm going to do is conda activate the name of my virtual environment. And now what we're going to do is we will be getting into folder. So the folder that I've created here is demo. So now within this folder is completely empty. It has nothing else here. So what I'm going to do is first off, in order to install Flask, all you'll do is just write a simple command that is pip install Flask. So here it says the requirement already satisfied. That's because I've already installed Flask in my system. But if you're installing Flask for the first time, it would take some time to download the dependencies and install Flask on your system. So now that we have installed Flask, what we're going to do is we'll go down to our code editor and see how we can work around Flask. So let me quickly jump to my VS Code. So I'm in the same folder that is demo. So here what we are going to do is we'll create one file and we'll save this as app.py. So there is nothing great that we are doing here. It's a simple Python file whose name is app.py. So now what we are going to do is we are going to import Flask. So from Flask, import Flask. And let's see whether we have connected to our correct Python environment. That's Flask demo. So now what's going to happen is let's quickly run our code over here. So we are not getting any error. That means we have successfully installed Flask. And now what we're going to do is let's create a small web page. Let's just see what happens. First off, what we'll do is we'll have app and then we'll create an object of a Flask. And here we'll pass the name. And then we'll have our app.run. But before that, what we're going to do is we're going to use route. So at app.route, I'll show you what is this argument that we're going to pass here. And then we'll define a function, define hello. This function can be anything. And this function will return hello world. And now we'll call this function that is app.run. But before that, we'll have if name equals method main. If this is the case, then what we'll do is we'll run the app. And now coming down to this part over here. Now you might be wondering what is this argument that I'm passing. Well, this argument is nothing but the pattern of a URL. So if I put this something like slash, it means that every time you get into this and this is the pattern of a URL, then it has to run this method. And if instead of this, if it says hi, then the URL pattern should be so and so followed by hi as extension. We'll see how that works. What we'll do now is let us quickly run this application. To do that, all I'm going to do is run this. And now as you can see here, I'm getting this URL. So let me copy this over here and paste it on my browser over here. Now if I hit enter, you'll see that we have a hello world. Now let me do one thing. Let me quickly change this part over here into hello, or let it be hi. And let me save this. And now let's see what happens over here. The reason what's happening now is our server has stopped. So like if you don't want to rerun the server again and again, what we can do is we can turn on the debug mode. So it'll be debug is equal to true. So let me quickly rerun this now. And let me go to this web page and let me re-roll it. So as you can see, a page not found. But now if I do this, if I do hi, right, you will see hello world again. So I hope now you understand this is the pattern or the domain name of our web application. And this is the extension. Whatever extension we give, that gets executed. So let me change this back to slash. And now let's try to rerun this. Before that, let me save this. Although it's auto save, you'll see that, this thing is restarting here. And let me go to my browser. Now it says page not found. But similarly, if I do it just the slash, you'll see hello world. Now what you saw now is that we have hard coded this hello world over here. Although there's nothing wrong with it, but it's a very bad practice to have this written down. So now what we're going to do is we want to incorporate an HTML file. Obviously, as is a web development, HTML and CSS is something which is used. So we want an HTML file to have over here. So what we'll do is all we need to do is we are going to import something called as template, that is render template. And this rendered template will be present over here. So return rendered template. And within this, we are going to pass the name of our HTML file. And as this is a common practice among the developers, what we're going to do is we'll not directly create an HTML file over here. Instead, we'll create a folder which says templates. And then we'll hit enter. And within this folder, we'll create a file by the name as index.html. And now what we're going to do is, as we come back to this, I'll just write the name of a file, that is index.html. And let me rerun our program now. Let's see if there is any errors. So let us now go to our web browser and try loading this. Perfect. So now this is directing us to an HTML page. Let's now quickly fill our HTML page here. Let's go to our index.html. So what we're going to do here is we'll use HTML. We'll call this. We'll give title for this as model deployment. And within the body, let's give a heading tag. So model deployment and some paragraph. Let's say we have linked our HTML page. Let me quickly save this. And let's now see what happens in our web browser. So as you can see, the name has changed here, model deployment, and we have linked our HTML page. So with this, as you can see, we have successfully linked our HTML page. Before we move on to creating our model or anything ahead, there are a couple of basics that is expected of you to know. Imagine a scenario wherein you want to provide an input from the end user, that is from HTML page, or you want to take an input from the end user. So in that case, we'll use something called as Jinja tags. Jinja is something which is used to write Python-like code in our HTML. So to do this, it's pretty simple. First off, we have a couple of things to keep in mind. So here we'll be making use of something called as forms. So we have forms, and these forms have two things, that is a get method and a post method. We'll be making use of post method over here. So now what we'll do is, let's take an application. This action over here represents where our page should land. So we'll just give the page that we want our land to be something like a new HTML page. Let me create a new file here. We'll give the name here as submit.html. And now what we'll do is we'll just type here submit. And now what we'll do is we'll create some input layouts. So we have input. The text of this would be something like text. Let's see where it is. We have to give the name for this. So it will be user name. We can ignore the ID for now. And we can also give a placeholder, username. And to submit this button, we can have input, submit button. So let's see where is our submit. We can ignore the values for now. So now what we'll do is, this is how we take the information from our Python file. This is just the HTML. Now we have to capture this in our app.py or in our main Python file. So for this, what I'm going to do is, first off, we'll go to this hello world, and now we'll create a new function over here at app.route, and then we'll give the pattern. So what is this pattern that we have given here? Submit. So let's say sub, and now we'll define a method def submit. And now what we'll do is, first off, we have to import a module over here. There's a request. And now in order to see whether we have included this or not, so we have if request dot method, if this is equal to post. I hope you know why we are getting this post. That's because the method, that form that we have used here is post, right? So we'll give post over here as well. And just correction here is going to be uppercase. And now what we're going to do is, if the method is post, then we want name is equal to request dot form, and now the name of our form, like it's going to be username. So this is the name, right? So we're going to pass username, and this is going to be a dictionary, so we'll pass this over here. And finally, what we're going to do is we also have to mention this over here, methods is equal to post. So if this is the situation, we have this, and now what we're going to do is return, then we have render template. We want this sub.html to be executed, so we'll write sub.html. And now if you see closely, we want to see which image. Like now we are sending the data from Python file to HTML file. Here we have taken the data from HTML file to Python file. Let me just put down as a comment here, .py. And now what we're trying to do is we are trying to render whatever information that we have got from .python file to HTML file. So now what we're going to do is when we return this, we'll have name, and this would be equal to the name that we have here. This name is totally independent. You can give name, or let me change it to n to avoid confusion, and let me give name over here. And now we'll come down to our submit page over here. And first off, we'll write HTML, and now we'll give some name of our document here, submit page. Let's see what we have given here. So now what we're going to pass here is we are going to pass h6 or something, some random stuff. And now we're going to use ginger tags over here. And here we'll just give the name of our parameter. So the name of our parameter over here is n. So as you can see, it's n. So we'll pass n over here. And let me quickly just give a cross check over here now. Submit.html, and this would route to sub. So let us now quickly execute our code and see whether it's working or not. Just to give you a good look, what we'll do is enter your name. So let us now execute our code. And now let us go to our web page and reload this. Maybe we haven't saved this, so let me quickly save this here. So let me just see if I've made any mistake here. So let me save this and this once again. And let me run this now. Let me copy our URL. So now you can see we are getting this form, enter your name. So I'll enter my name as Junaid, and let me hit. And now once I hit submit, it should redirect me to a new page and displaying my name. So now we are getting this username. This is because we have given the wrong name here. So let me quickly fix that up. It might be a small typo. So we have username. So what I'm going to do is copy this part here. So as you can see, I've missed out an R here. And let me save this. And let me save this over here and save it. Let's rerun our server. And now what I'm going to do is I'm going to reload this and pass a name and then hit submit. So as you can see here, our name has come out. And yeah, so our website is working. As you can see, we are shifting from one page to the other page. So now that you know how to work with Flask, let's build a simple machine learning model where we'll be predicting the marks of a student given the number of hours they have spent. And then what we're going to do is we're going to combine this model of ours with our Flask. Let me quickly move to my code editor for that. So here what I'm going to do is I'm going to use Jupyter Notebook. So I'm going to just go for Colab. Although you don't need this because this is a pretty simple model. So what I'm going to do is let's have file, new notebook. And let me connect this to a server here once. So now what we're going to do is first off, we'll import our data set here. So to get our data set, we'll just upload it from here. So this is our demo file. And now here we have two of our data set. So let me copy them and upload it. So pretty small file. So now what we're going to do is we are going to import a couple of libraries. Import pandas as PD. And then we need numpy as numpy. And then finally we have matplotlib as plt. And we also need a couple more libraries to train our model. but we'll look into that later. So now what we're going to do is we'll execute this code over here, and now we have to read our data set. So we'll give x, let me give it as uppercase, x is equal to pd dot read csv, and now we are going to pass our x value. So let me copy the path and provide this over here. Similarly, we'll do it for y, and now we'll copy the path for y. And let me now execute this. Let's have a quick peek into what is present in our data. So x dot head, and let me execute this as well. So now we are getting certain values, and similarly, let's see what is y representing here, y dot head. So pretty cool. These are nothing but the numbers. So now what we're going to do is we're going to capture the values of our x. So x is going to be, that is a data frame x dot values. This will give us a numpy array. Similarly, we're going to do it for y dot values. So now we'll visualize our plot. Let's see how it looks like. So in order to visualize this, we'll have plt dot scatter. Although this is not required for you when you are creating this, we are just trying to simulate that we are creating a model in a real time. So plt dot scatter, and now we are going to pass our values x and y. And now what we'll do is plt dot x label. This is nothing but number of hours a student studied, and then y label. This would be nothing but marks. So fine, and plt dot show, and let me execute this. So as you can see here, this is our data set. This shows number of hours a student has studied, and this is the marks over here. And the reason why we have negative values is because we have normalized our data. So now what we're going to do is we're going to create a model. So to create a model, this is something that we have to install. Not install. If it's not present, then you can just do pip install sklearn, or else all you need to do is from sklearn dot linear model import linear regression. And let me execute this once again. And now to create our model, what we'll do is we'll create an instance of a linear regression model is equal to linear regression. And yeah, and now to train our model, all we do is model dot fit, and now we are going to pass our values, that is x and y. And now what we're going to do is we will predict the value model dot predict, and let's give any random values over here. Let's say our student has studied like 1 hour, and so we are getting this error. That's because we have to pass this in a shape. The reason why we are getting the error is because we are passing a scalar value. So what we'll do is we will create a block here, and we'll say x test, and now we'll have np.array, and now here we'll give the input of value. So I'll give here marks, and now what we'll do is x test is equal to x test dot reshape, and here we are going to pass 1, 1, and the marks, let's give the marks here. Let's say a person has studied like 2 hours, and let me execute this, and let's pass x test over here, and let's execute this. So as you can see, now it's totally working fine. And yeah, so now what we're going to do is we are going to incorporate this Python file in our application. So to do that, first off, let me come back to my Visual Studio Code. Let's create a new Python file, and make sure this Python file is present within this directory. It's present in the same directory as this. So now let's say marks.py. Now make sure you have everything installed in your virtual environment or in your Python. So first thing, let's see what we're going to do. I'll be going to and fro here. So first off, we are going to have this, and let me get down here to my VS Code and paste it. Similarly, we're going to copy this. Although we can download this as a PDF, that will still open as a Jupyter notebook. So what I'm going to do is, just for the simplicity's sake, let me read it here. We don't need all these values. Oh yeah, we need x dot values and even y dot values. And similarly, y is equal to y dot values. We won't be plotting this. We obviously do need the model. We paste it over here. Similarly, we have to perform the fit because it's going to train the model. Most of the times, if your model is pretty huge and complicated, what you do is you save the model and you just load the model, that is the .h5 file. As we are using a pretty small and very basic example, so we'll just train it here. And then we are going to provide this marks and also finally the predict. So now what we are going to do is we are going to pass all of this in a function. So over here we'll say def marks prediction, and then this will take up an argument over here that is nothing but x test, right? So we'll say marks. And now let's give a proper indentation for this. We won't be needing this part over here. And now what we're going to do is we'll just pass the marks. So we'll call the function. This is what the function would return, the prediction of marks. And now we'll just call the function def. It will be just marks prediction. And the argument that it would take is the marks. So, but before we get this marks, we obviously have to perform this part here because we want it to be in a proper shape. And that is done by this part here. Okay, looks good. So now all we have to do is we are going to pass marks here. And now every time we call this function, it will return marks over here. So now what we are going to do is we will integrate this. So this is all there is over here about creating a model. Now in order to use this model in this file, we have to import this. For that, what I'm going to do is import marks. I hope it looks good. And now let me quickly clear a couple of things here. First off, we obviously need some input from the end user. We have to take how many hours did this user study. So what we'll do for that is enter your marks. Let's give some sassy name here. We'll say predict your score. So predict your exam score. And now let's give a caption here. Enter the number of hours you studied. And now what's going to happen is we have a form here. It says type. So we can keep it as text, or we can also change it to a number. So here will be hour studied, and then we'll give a placeholder name as hour studied. And then you hit submit, and we don't want this to go to a new page. We want it to be over here, and we'll see what we can do about it. And now let's go back here. Let me close this part. So now what's going to happen is, as we're going to stay in the same page, we need to get this part. So first off, if request dot method is equal to post. If this is the case, then I need hours. So number of hours is going to be request dot form, and we are going to pass the name. So let's see what name we have passed over here. So it's hours. So let me copy this and paste it over here. And now what I'm going to do is, before we print the number of hours in our HTML page, let's print it over here. So first off, let's import our model. So it's going to be marks dot name of our function, marks prediction. I hope that's the one. So yeah, it's marks prediction. And marks prediction takes the argument that is number of hours. And now we'll store this as one variable. Let's say marks. Fair enough. And now what we'll do is, so now we'll print our marks here. So we don't need this as of the moment. I would just comment this off all the way from here to here. And let me save this here as well. And let's run our program. Before we execute our program, there's this thing that I have missed. We have to put app.route and as well the methods. So it'll be methods, and then we'll pass a list saying post, and we'll save this here. So here it says no module found called sklearn. The reason why we're getting this is because we haven't downloaded this. It's pretty simple. All we'll do is we'll go to our virtual environment here, and we'll do pip install sklearn and hit enter. So let us now see what happens. Let me quickly execute this. Here it says marks is not defined. So let's get back to our Python file here. So we have marks. All right, let's see where we are going wrong here. It must be a small error due to we're not defining our arguments. So we have marks here. So we are loading our X data, marks. So the reason why we are getting this marks not defined error is because we are calling this function in this marks part here itself. But we don't want this. We want this function to be called only when we are providing the marks, and that is through HTML. So here I have done some changes. So we have marks.predictions, and I have changed the name over here. So now what we're going to do is, let's see whether our model works or not. So let me quickly run our code here. So here it says marks is not defined. That's because we might not have deleted this. So let me save this once again. And let me save this over here as well. And let's execute our code now. It's pretty important that you save your file or change this to autosave. So now what we're going to do is, let's see how our application would look like. So we have to enter a number of hours you studied. So if I put number of hours like 5 and then I hit submit. So now what it will say is we expect a print to be printed out over here. So we're getting some value which is generated over here. So similarly, if I put any other random number here, something like 0 hours, it would be something like 3 or something like that. So as you can see, we are getting a value over here. So now what we want is, we don't want this value to be present here. Instead, we want to pass this value to a HTML file, and then we want to print it. So what we'll do is, we'll put here, we'll say mk is equal to marks predicted, and then we'll also pass this as an argument here, my marks, and then this would be nothing but mk. And now what we're going to do is, we're going to go for HTML over here. And right after the forms, what we'll do here is, we will take a Jinja code, and then we'll just pass the name. That is nothing but my marks. Let's see if you have done any typo. Okay, it should look good. And now what we'll do is, we'll also put here some random statement, something like a paragraph. Your predicted marks are, and then we have my mark. So let me quickly execute this once again. Let me save this, and let's see how this would look like. So let's go back to our browser here, and let's reload this. So we are getting this old value. Like I don't want this. I just want to see this only when I have entered the mark. So what I'm going to do is, I'll write a if condition here. So we'll go over here, we'll write a if condition. So for that, all we'll do is, we'll use a Jinja tag over here. If marks, that is my marks, if this is the case, then show this part over here. And then we'll close the if statement here. This should be as simple as end if. And let's save this, and also save this as well. And let's stop our server and rerun this from the start. So before that, let's close this part over here. So here, as you can see, it says this site can't be reached. So now what we'll do is, we'll run our application now. So what we'll do is, let's get back here. Let's reload this. Okay. I think there's a small error here. Let's quickly fix that up. So what I'm going to do here is, if my marks. So let me copy this up, paste it here. Okay, so let's save this. Maybe the file wasn't saved. Let's save this once again, and let me save this over here. It will restart. And let's now go to our browser here. Let's put 4. So what we can do is, apart from this, is we can try to restart this once again. Let's take a new tab and paste it over here. So here it says local variable mk reference before assignment, my marks, the local variable before assignment. Maybe we are getting an error here. Let me quickly do some changes. Okay. So now let's try running this up. The reason why we are getting this is because it's expecting an input over here. So what I'll do is, as of now, I'll remove this. Let me save this part here and save this as well. And let me run this once again. Okay, so let's try saving this up. There might be a small error. So now what we'll do is, we'll go to our website, reload this, and we'll give number of hours I studied. So, if I put 1, you can see here that we are getting number of the marks that I may end up getting is 84%. So this is all there is about creating a model and integrating a model with a Flask. So moving ahead, let us now talk about Heroku. So what is Heroku? Well, Heroku is a cloud platform as a service that supports several programming languages. Being one of the first cloud platforms, Heroku has been developed since 2007. when it supported only Ruby programming language. But now it supports languages like Java, Node.js, Scala, Python, PHP, and Go. You see, Heroku is a cloud service provider whose popularity has grown in recent years. Heroku is so easy to use that it has become a top choice for many development projects. With a special focus on supporting customer-focused apps, it enables simple application development and deployment. Since Heroku manages hardware and services, businesses that use Heroku are able to focus on perfecting their apps and not on infrastructure that supports them. And also a point that I would like to mention, Heroku gives us a free domain name and a cloud storage so that we can deploy our application. Alright, so let us now move to my browser and show you how we can create our account in a Heroku. So first off, what we're going to do is we are going to type Heroku, and now we'll just click on this over here, and then we'll sign it up. So I'll quickly quit this and sign up. So it says we're going to add some couple of information here. So let me quickly get that done. All right, so once you're done with this, so once you have put all your credentials, all you're going to do is you got to go back to your email, and then you'll be prompted to set your password. And once you're done with that, it's pretty simple. You just have to put set password and log in. So this is how you would create your Heroku account. So now let's see what happens. This is the basics. This is how it would look like. Now, as we don't have any projects at our disposal, what we're going to do is we are going to create a new project, and we'll say marks. So we'll say something like marks prediction. So we have this marks predictions. Then what we'll do is we'll just create an app. Now over here, Heroku allows us to deploy our model in one of three ways. Either we can use Heroku Git, we can connect it to GitHub, and we can also have a container. Using Heroku Git, it's pretty simple. You just need to follow these steps. Paste these commands in your command prompt, CLI. And another popular way to do this, or the easier way to do this, is by uploading your code to the GitHub. So in order to do this, you have to connect to your GitHub, whatever is your GitHub repository, which we will be doing it in a while. And before you can upload your code to the GitHub, we have a couple of things to do with our code. So first off, what we're going to do is, so we'll get down to our command prompt. So let me quickly clean this up, CLS. And we are in the same repository now. And over here, we're supposed to install two important files. One of the file is responsible for installing all the required documents or the libraries that would be going in. And other one is the important file that would represent where our application would start off. So let's get that done now. So what we're going to do is we'll start off by installing this package called as Unicorn. For that, all you need to do is pip install gunicorn. And what this does is this gunicorn is responsible for creating a server within our code. This gunicorn is the one which is responsible for connecting our code with this Heroku. So let me hit enter. I've already installed this. Now, apart from this, what you're going to do is you need something called as proc file. In order to create your proc file, so let me first show you what exactly is a proc file. First off, you'll have a proc file. The way you create proc file is go to any of your code editor and click here, file, and then just type proc file. So P has to be in the uppercase. Then you'll be typing PROCFILE. Okay, and then hit enter. And as you can see, I've already created that file. And within this proc file, what you're going to type is web unicorn app:app. This app over here represents the file that it should start executing from. That is nothing but app.py. And within the app.py, it will tell you which method. So this one, it's capturing this part. And if this part was app2, then we would have written app2. And we won't be changing that. It's totally up to you to write the way you want. And apart from that, you also need a requirements.txt. Okay, so the requirement.txt is kind of important. The reason is because on the Heroku server, we'll be installing, or the Heroku backend team will be installing all of these things. So now way you're going to install this requirements, this thing is by using pip freeze, and then you'll give this symbol over here. Then you'll put requirements.txt. And then when you hit enter, the file gets created. So this is all that you have to do on your system. Now in the next stage, what you're going to do is you're going to create a repository on a GitHub and then upload your entire code onto the GitHub. So let's quickly see how we can achieve that. So as you can see here, I am getting down to my GitHub repository here. So let me get down to my GitHub and let me hit enter here. This will take me to my repository. The first thing that I'm going to do is I'm going to create a new repository. So let's say something like my model deployment. And once you're done with this, all you're going to do is just create this repository here. And now what we'll do is either you can use this command this way, or else what you can do is you can just push this thing here. So import code. So as you can see here, upload an existing file. So choose files and click on all the files present over here. And I'll copy this and open. So now that all our files have been uploaded, all we'll do is commit changes. And yeah, okay, let us add now readme file. So now what we'll do is, it's pretty simple. Now we have to go back to our Heroku server over here. Now as we have connected to our repository, okay, and now what we'll do is we'll just look for our model, that is my model, and then hit search and then connect to this part. Although you have two options here, you have enable automatic deploys. This means what happens is every time you perform any changes to your repository, it will deploy it, or you can also manually do it. I'll just put here deploy batch. This will take some time. Over here, as you can see, it will install multiple libraries, and here you can see here it has detected app file. Here it says push failed. There might be a small error, so let me quickly fix that up. So let us do one thing. Let's try deploying this once again. So deploy batch. So now it has detected this branch over here. Let's see what happens. So yeah, app file has been detected and it's installing all the required libraries here. So as you can see here, it says done and we are ready to deploy our Heroku app. So this is how it works. So as you can see, we have successfully deployed our model.
Now I would like to brief you through the process of how machine learning works actually. And this is pretty much common for most of the algorithms that you're going to implement. First and foremost, you would be needing data. Now I've already talked about the point that data is centric to machine learning. If you do not have data, you cannot make any predictions. And more the data, the better it is for you. So the first part is having data. And once you have the data, the next point you need to confirm or make sure is the data is appropriate for machine learning. And this is where pre-processing steps in. What pre-processing does is it helps you process the data that you have and prepare it for machine learning. I mean, your data might not always be clean. There might be some missing values, some repetitive values, which you do not want in your data when it is getting processed, right? So in this case, we filter out this data, we clean it, we fill in certain values, we predict certain values, and we put in those values there. And once this data is up and ready for working, then we pass it on further, and then we provide a particular machine learning algorithm to it. Now, this again is a trial and error kind of method where it seems simple at times because we've discussed all those machine learning algorithms, right? So to naked eye or to naked mind, basically, we might think in this direction where we would think that, okay, this is the kind of problem I'm dealing with, so this is the algorithm I might use. But that is not the case. At times, the data is misleading. We are not sure what kind of algorithm I want to use, what kind of data I want to pass, and how much data I want to pass. In that case, what we do is we first allot a particular algorithm, use it, implement it, then we test the values, then we try out some other algorithms as well, and then we come to a conclusion as in, okay, this is the best algorithm, and using which I've generated a model which is best to meet my needs. And while doing that, there are quite a few processes that happen, processes like training, testing, validating, where you pass in certain amount of data, you build the model, you train the model, and then again you pass or keep some data behind, which you later pass to test these models, as in are they working properly or not. So this is an iterative process, and this might take in more than one iterations to actually go ahead and jot down or settle down onto a particular point. So once your algorithm is selected, once your machine learning model is built, you can actually go ahead and deploy this model into your environment or real-time working where it would be able to predict the real-time data or the data you provide your so-called algorithm, right? So this is how the whole process of machine learning works. Now, the processes which I talked about, pre-processing, then implementing various algorithms, training, testing your data. Now, this, again, they look simple, or when you listen to them, they seem pretty easy as in training the data and all those things. But once you start implementing these things, it is fairly difficult. Ask any data scientist and that person would tell you that pre-processing is something that is very difficult to deal with. And mostly 60 to 70% of the work is done in these phases only. So what if we had something that could actually help us here? Wouldn't that be easy? I mean, if we could just speed up this process of pre-processing, algorithm selection, training and testing data, instead of doing these manually, can we do all these things automatically? The answer is yes. Now, this is where your Azure machine learning steps in. What Azure Machine Learning does is it helps you carry out the whole process. But as you can see, we have something called as ML Studio, and it focuses on your pre-processing, application of algorithms, and deployment processes. So bulk of the task which can be repetitive or which can require you to put in more efforts to implement manually, it actually helps you automate or speed up that process. So that is what ML Studio is basically. It is a studio or a service in a very popular cloud service provider, that is Microsoft Azure, which lets you implement various machine learning algorithms, and it carries out the bulk of tasks or the bulk processes which you would otherwise not want to do. Now, this is not something that actually is used to replace data scientists. You cannot do that. So no offense to any data scientist who is listening to this video or going through this video. It is more or less complementary to data scientists. You would be needing statistical knowledge, and hence we talked about machine learning a little, because even if you build models using Azure or any platform, you would be required to have proper statistical acumen or knowledge about data science, something that would help you understand the output of the models that you've built. So yes, some statistical knowledge would always help and you cannot replace that. But definitely if you are working on machine learning and you need to speed up this process or make it more efficient, then Microsoft Azure and ML Studio in particular is a very important resource for you to have. So what I'm going to do now is I'm going to switch into the demo part, and we would be building a model so that we can discuss some of the stuff that I've already talked about. And we also get to see how Microsoft Azure works in real time, right? So let me just switch to the Azure portal or console that we have at our disposal. So guys, what I've done is I've gone ahead and I've switched into my Microsoft Azure portal. For people who are completely new to Microsoft Azure, you can actually avail certain services that Microsoft Azure offers you for free for 1 month. Now, during this period, you can avail certain credit for US citizens or people who have an account in US region. They can actually avail up to $200 of usage where you can use certain services. Now, these services are chargeable. That is why the free credit that is made available to you. So, which I believe is more than enough for 1 month's practice. So if you're somebody who's new to these platforms, I would suggest that you go through or sign up for Microsoft Azure and you can avail those services. Now, since I am from India, we have Indian rupees as our currency. And for our usage, we are given somewhere around 13,300 INR or Indian rupees, which is a very big amount if you talk about using a service for a month's time. So it actually serves my purpose. I have been using it for a long time. That is this particular account. I've had a couple of accounts, but this one is something I created some 15 days back. And as you can see, I still have like 12,400 something, which I can use. And we would be not needing this much today. Somewhere maybe 10-20 rupees to the max. So yes, you can go ahead and create this account. Once you do have this account, then you'd be having access to all the services that Microsoft Azure has to offer to you. You can go ahead and create all the resources you can have or utilize its compute services, storage services, database services, and all the services that it has to provide to you. But since we are talking about machine learning, we would be sticking to those applications as well. So in order to use your Azure machine learning, you need to create a workspace where you can actually go ahead and put in all your data. And once you create your workspace, you actually need to go ahead and sign into the Microsoft Azure ML Studio, which is an interface or IDE where you can actually go ahead and create all those models. So in order to go ahead and create a workspace, you just need to come here and type machine learning. And you might be having that thing in the suggestion. It was already typed, I believe, machine learning. And you have this place where it says machine learning studio workspace or service workspace. You can click on these. The studio workspace is something I've clicked on. And you need to put in some details, as in what is the name of your workspace, what subscription are you using, resource group. You can use the one if you already have one. If not, you can create one. Just give in some name. Now, resource group is something that holds in details about your resources that you're using, and then what kind of storage account you are using. You can create a storage account as well. It's not a big deal. It is nothing but think of it as a storage place where you can store in your data. That's it. So you do go ahead and put in these details and then you say create. Before that, you have to put in what pricing tier are you using, and you'd be entering the region where you want your workspace to reside. Now, what cloud does is it stores your data in particular locations on the globe, right? So you can choose the location that is closer to you or closer to your business, depending upon your needs. For now, I'm gonna stick to the basic one that is here because we are just creating a simple demo. In fact, I'm not gonna go ahead and create a workspace because I already have my own workspace. but I would suggest that you put in these details and create one. Once this workspace is created, you can actually just open it, and at the bottom you would be seeing an option called as Machine Learning Studio. Else what you can do is you can type in this URL and you would be redirected to this page where you have to sign in with your Microsoft Azure portal account. And once you do that, you would be redirected to the ML Studio that I'm talking about. So the workspace would be created. Once the workspace is there, you log into your Azure ML Studio, and once you do that, this is what you'd be having at your disposal. Now, these are some of the experiments that I might have worked out or worked on in last week or so. Some of them are finished, some are still in drafts. So you can actually go ahead and create these workflows or these kind of workflows. Now you have so many options here. What are the projects that you create? Experiments, which we just saw, different web services that are made available to you. You can actually go ahead and create web services as well. You have your notebooks. Now you might not always go ahead and start from the scratch, right? You might have your code written in maybe R or some other language like Python. So you want to import that code, you can do that as well, or you can use the existing notebooks which Microsoft Azure has offered to you, where you have ready to use codes or ready to use models as well. And then we have data sets. Now again, you can import your data sets that you have. There was one financial sample data set which I imported recently. You can actually go ahead and use sample data sets as well. Now you can see there are quite a few data sets that are made available here, which you can use and implement your own algorithms or implement the algorithms that Microsoft Azure has to offer to you, right? So you can do that as well. So it pretty much depends upon what do you want to do and what kind of processing do you want to do. As you can see, if you come here, you have some, this is somewhere you can see your trained models as well as in the work you've done or some models that you've implemented. So you can have that here. In this case, we are going to go ahead and implement one of the algorithms or algorithms that are implemented by Microsoft Azure. So if I come here to experiments and I go to samples, you can see that we have so many implementations. So we would be taking a look at one of these and then we would be implementing that on our own. Do not worry, we won't be copying it right away. So we have quite a few options here, as you can see. Okay, let's just go ahead and do one thing. Let's build our own model here. So for that, we need to go to experiments, or rather we can come down here and say new, and I say add a blank experiment. Let's just go ahead and try to build a recommender system or something like that. So to do that, let's call it, say, my recommender. There you go, and save it. Okay, there are no modules, so you cannot save it. So first, let's get started. Now, in order to create a recommender, for people who do not know what a recommender is, it is nothing but you pass in certain data and it might suggest, or the model might suggest to you as in what you might like or what you might want to do. Say, for example, when you shop on Amazon or any other website that is there, you normally have some suggestions, right? I mean, you may like this, you may like that. Same as with YouTube, you go through certain videos and it gives you suggestions as in you preferably might like these videos as well. So that is a recommender system. So let's go ahead and create one recommender system. Let's create one for movies. So let's just go ahead and practice or play with the data that we have. For that, we would be needing a data set first, right? Now, if you talk about ML Studio, it is very simple. You just drag and drop stuff, just like creating workflows. It is as simple as that. Now, in order to use a particular data set, we have these saved data sets here. Samples. Let's make a recommender systems for movies maybe. Yep. So movies. Do I have something in movie? Yeah, there you go. Movie ratings. So we would be using this data set. Now, once you put in this data set, it is available. You can just go ahead and take a look at it. So let's just visualize this data. And as you can see, the information is here. It has certain values like user ID, movie ID, ratings, and timestamp. Timestamp is something that people do not use frequently, but yeah, these are things that are important to us. We have factors like your ID, that is your movie ID, user ID, and rating. It's somewhere around up to 10. So I believe it has started from 0 or 1 maybe. So we have ratings from 1 to 10, which we would be using. So this is the data that we've just visualized, but at times this data is not as simple and as managed. It might have some missing values and you might be required to play with it or make some changes to it. You can actually go ahead and put in some factors here as well. Now here you have so many options that are made available to you, right? So you can actually go ahead and process your data a little, manipulate your data a little, like you can take a look at statistical analysis and all those things. But this being a clean data, we do not need to do that. So we're just going to stick to the recommender system part here. So we have the data set now. I need to select the columns that I want to use. So I'm going to project certain columns out of it. So for that, we have a module here called as project columns. Okay, I don't see it here. I believe they've changed the name. Select columns to, okay, so this is the one. They've changed the name. It's called as select columns in dataset. So we drag it and place it here, and we hold on to the circle that is there on the previous module or the tab we had, and we pull it down so we can connect these two. Now they are connected, and but since I've connected them, there's an error here. It says value required. Now I need to pass in some values, as in what are the columns I need to focus on, right? So I would be clicking on this icon here or tab which says launch column selector, and it gives me options. So I'm going to put in certain rules. Now, what are the columns that I want? First, I would say that get in all columns and just exclude the ones that I don't want. So what are the columns that I do not want? Timestamp was something that won't be very handy, so I'm going to remove that. So I would be excluding that, and I would be saying okay. Once you do that, the error is gone. So we have the data set, we've selected the columns. Now next phase is I need to go ahead and pre-process the data, but data is already pre-processed. So I don't need to do that either. So in this case, I would be going ahead and splitting my data into two parts, my training data and my testing data. Training data is something that we would be passing on to the model, and we would be training a model based on the data. And test data is something that we would be holding back, and then we would be using that testing data to test our models or to predict the outcome or to see whether the model is working fine or not. So to do that, we need to split our data. So come here. This process is easy. Just go ahead and type in the words that you need to do, and it gives you modules to do that. So split data, I just pass in the data. So I've gone ahead and I've created or I've pulled this split data module or tab into my workflow. So yes, the data would be split, and it would be split in this fraction 0.5. That is, we would be using 0.5% data to test. That is half of the data to test and half of the data to train our models. So there you go. I won't be tinkering with these factors. Those are good enough for me. So let's just move further. Now there's an option here where you can zoom in or zoom out your model to fit in the screen. So the data is split now. Next job is to train your data. So train your recommender system. Do we have option to, yeah, train matchbox recommender. So we select this and pull it here. Now what we do is we pass in one of these branches here, first one, and the split data is passed on to this training module or tab. Now I'm not too good with the nomenclature, that is why this confusion. Let's call it tab. So yes, so I've pulled in this data into the tab. So this is something that would get trained here, and I need to score it as well. So once I come here, I select this first, and it shows me the details, as in, okay, how many traits of the data that I have that I want to use to build this recommender system. Let's just say 10. Okay, 10 is fine. I don't see too many problems with it. Maybe let's do it 20. Number of recommendations I want. Okay, no, this can also stay to 5. No problem. Training batches 4 is fine. So we just move further, and next what we do is we just go ahead and score the data that we have. So I say score, and I pick in this thing. So again, to this I would be passing in my training data here, and I would also be passing in my split data, that is the testing data. There you go. So the data that has been trained, that would come here, and also the testing data would be here. So I have this score where I need to give in the details, as in what are the predictions that I'm looking for. Now I basically want prediction where I would be wanting related items, right? If I watch this movie, what kind of movie I need to watch, right? So this is what I would be entering here. So once I enter related items, it says what are the maximum number of related items to find from an item that you have. Let's say I want just one item. There you go. And so it would give me one related item to the movie. So if I pass in a particular movie to this recommender, it should suggest one movie that I might like watching. So that is what I'm talking about here. So one related movie, you can have more than one as well. So that is up to you. So we've done this. Now next is I build a model, or I've actually gone ahead and put in a tab for training and scoring. Next, I need to evaluate this data, right? So I say evaluate or test rather. So it says evaluate your recommender. You get in here, and this time you take in this value, that is your score, and you put it here in this column. We passed in one of these threads here. Next is we take in the split data and we enter it here. There you go. This is fine. I would be saving it here just to be safe. Once you save this data. Okay guys, so the connections that we pass in, these are important. In which port are you passing in what value? So this might hold. And this is more or less an experimental kind of a stuff where you might actually go ahead and put in some wrong connections and you might get in some errors. So you actually need to go ahead and troubleshoot some of those at times, not always. So we've actually gone ahead and we've almost built a model. Now we need one more table here. or one more data set, that is movie IMDb titles. Let's place it here. Okay, it has gone somewhere. Yeah, so I place it here. There you go. And whenever we have a new data set, we always visualize it to understand what it has. Okay, this should not take this long, but for some reason it is. So I have this data set where I have movie ID and movie name. So I would be using this data set for my recommender, where it has some IMDb titles, which is not the actual IMDb, that website which we have. It is a sample data set that is created. So we have this data set here. Now that we've seen the data, I'm gonna go ahead and use a command called as edit metadata, and I'm gonna place it here. And as usual, I'm gonna go ahead and put this thing in here. Now, if I come here, as you can see, there's this column here which says select certain columns which you want to use. So what are the columns that I want to pass to my metadata basically, or what is the metadata that I want to use? So I'm gonna go ahead and click on launch column selector. And in this case, with rules, I would start with no columns and I would say include. So what are the columns I need? First is I need item. So you have to hit the enter button. You won't be given a suggestion here. Okay, for some reason it is not taking in this value. Let me see what is wrong. Okay, we need to pass in first values to this so-called metadata. Before that, we won't be able to deal with items because we just took a look at this data set and it does not have item value. That is why we are not able to pass in that value. So let's pass in other values to it, the values that are more relevant to this data set. So we'd be coming here and we'd be selecting some other values. Now you can see that we have these values that are available. So let's just go ahead and select those. There you go. And I say okay. So the error is gone now. Now we have a metadata which is made available to us, and I have a model which is up and running here. Now I need to put in joins here. Now if you all know what joins do is, they basically help you select data from one table to the other. So we have two tables here or two data sets. So I want to combine the data that these two tables have. Now I won't be getting into the details of joins and all those things, but we would be using them here for the general reference sake. So I have these two data sets here and I want to predict or compare the table with the table that is here. So what I'm going to do is I'm gonna build a model or create a join that lets me compare the movie names from one data set with the other, or give me recommendations from one of the two data sets, right? So for that I would be needing a join here. So let's just come here and say join. Okay, before we get into this thing, there is one more important point. My edit metadata data type, it has to be string. There you go. Now I need to pass in values to this tab as well. So for that, I would be needing a score from here. So I would be taking this and I would be placing it here. There you go. And one from the metadata to this joint. Now, what are the values that I want to pass in here? Now it should be item, I believe. So as I've said, hit the enter button. There you go. And you say okay. And columns from R or the other table, what do you want from here? I would be saying maybe movie ID. There you go. I say okay. What kind of join do I want? I want left outer join. Now again, I won't be getting into the details of these joins. Don't keep the right key columns because that is the reason I'm using this join. There you go. I would be needing one more join here and I would be pulling it here because the first join would just give me the movie ID, but I just don't want the ID. I want the movie name as well, right? So I'd come here, I'd pull in this thing and I would pass it to this data set and edit metadata. There you go. Again, if I come here, it would ask me for values. I would say, give me related items if you have any. And here, I want the movie name. We would say save. If we missed out on one thing, we need to come here first and remove this left outer join and now save. We are bound to have some errors, guys, so stay tuned. Now this thing runs, it would run it tab by tab or module by module, and then everything would be executed. So this might take a couple of minutes. Once the module or the tab is executed, it shows a green tick on it. As you can see here, we have ticks here and here. This might take a longer because we have increased the number of iterations to 20 in the slide or in the tab when we were working on it. So the whole processing might take a little longer than normal. Okay, it says related item not found. Let's see why is that happening. Launch recommender selector. Yeah, this is the one that is there, related item 1. Probably there is no related item variable in the dataset that we generated. Now, as I've told you in the first model, I'll show you where. First, let me select this for now, and let me say, okay. Here in the score match box, I had passed in number of related items, right? It was 1. So by default, it was given a name called as related items 1. So that is something which we are passing in here, or something that we would be displaying. So there you go. So what we've done is we've actually gone ahead and put in all the stuff that we wanted to. Let's just see whether it runs. And once it runs, I would be explaining this again to you people, so do not worry. First, let's run it. Now this time around it should happen quicker because most of the stuff is done. We just have the error in the last tab or the last module. So the other parts should be done quicker, as you can see. And now the last one would be implemented and it is done already. So guys, our model is up and running. Let's just go ahead and check. So when I click on this icon and I say visualize, it should give me some values. See how relevant values these are. Let's just verify it. Now this being a model, it might not be that accurate, but let's hope it gives some values. It is not giving me the movie name and movie ID for the other section or the related item. Let's see why is that the case. But it says if you have seen this movie, you might like this movie, but we do not have that movie. So let us see where we have gone wrong first. So there is some error here or here. We have a movie ID here. So let's just come here and see. Okay, so we can just match ID to ID or map ID to ID. So let's remove this for now and say movie ID, and then see whether we get the output. So I say save, not save as. I would say save, and I would run this. So again, it should run quicker than the last time. There you go. Now let's just see what is the output that we get. So I say visualize. And there you go, guys. It's as simple as this. I mean, we put in or pulled in some values and we've edited certain values and we have the result here. Now this is an Indian movie called as Talash, and it says that if you like this, you might like this. Oblivion, probably Jack Reacher. I haven't seen either of this. Iron Man, you might like Stand By Me. So I don't think this recommender is that accurate, but probably I'm sure that there would be some movies in it which are more relatable. So, and for people who are big movie fans, they probably would be able to relate a lot more to the movies that I hear. So again, you can actually go ahead and select the number of related items that you want to select, and you might actually go ahead and tinker and tailor your algorithm a little more. For that, you have to play with the values that are there you have in this algorithm. You can just come here and switch in these details, and probably the answer might vary depending upon the inputs that you pass to this algorithm. So this was my basic aim. I wanted you to get some hands-on on Azure Machine Learning Studio and nothing more than that. But as far as this model goes, or this particular session goes, we've actually gone ahead and taken in 2 data sets. We've actually gone ahead and built a model, trained it, tested it, and then we've used a join to actually go ahead and see what would be the possible movie that you might want to watch if you liked one of those movies. So again, as I've already mentioned, it might not be that accurate. You are free to go ahead and play a little more with it. You can pass in your own data sets as well.
Now, what exactly a chatbot is? A chatbot, as you know, is a complete conversational, we can say, toolkit, right? Which is basically written in natural language. Like we have the concept of NLP, natural language processing. Now, the main purpose of this one is, again, where it simply understand the intent of the user. That means the context, right? Because again, if we talk about NLP, natural language processing, it simply revolves around the idea of different context, because the same thing can be said in different manner. The same thing can be said in different manner when we are talking about the context here, right? So different users, they can simply say things in different contexts, and that is exactly what we have to focus on here, correct? Because then because again, just like we have Alexa, we have Google Assistant, we have Siri. Now, for performing the same task, we can order these assistants in different manner, right? And again, it doesn't matter in which context we say them. We give them the order, they will perform the activities, right? Because again, they are able to judge on the context, right? They are able to evaluate in which context that particular thing has been said and how they have to process it. And that is what a complete concept for natural language processing is, right? And basically, it is simply used for understanding the intent of the user and sending a response back based on the business rules of organization. That's the main concept of chatbots running on NLP, natural language processing here. All right. And further, now the first chatbot called as Eliza was built in 1966 to mimic the human conversation altogether. That was when the first chatbot Eliza was built, right? And in terms of chatbot applications, here they are extensively used in online shopping, in booking tickets, in news reports, in ordering foods, right? So there are multiple use cases available for chatbot application that we can think of, right? And again, basically in terms of types of chatbots, we have command bots and then we have learning bots. So command bots works on the concept of predefined text that has been defined inside these chatbots again, and based on those predefined responders, they can respond accordingly. Or here we have learning bots. So based on the users, how they are interacting, they can learn their pattern, they can learn their language, and then only they can get started, right? Depending upon the context in which they have been set here, you can simply start understanding the users' languages in which context they are saying things, and then only they can get started. All right. And Amazon Lex here is basically a service for building conversational interfaces into applications using voice and text-based support, right? So basically, now here it simply uses NLP, natural language processing, along with the ASR called as automatic speech recognition. So these are all two different components that we have. We have these Amazon Lex based on NLP as a natural language processing, and then we have ASR called as automatic speech recognition as a part of ASR itself, right? So basically, this is used for building the conversational interfaces into any application using voice and text-based results altogether. That exactly we have Lex for, right? We have Amazon Lex altogether as a part of the entire discussion here. Now, the main purpose of Lex, as we have discussed, is it is basically used for building the chatbots for handling the customer support, or we can say customer contacts the bank. Now, for example, if we are implementing this on top of any banks, right? So in here, customers can contact the banks for the account balance, right? They can simply send the message, or they can simply use the chat-based system that the bank has been, or that bank has opted in for. Bank customers, they have opted in for, right? And then now we can use Lex, we can use AWS Lex as a part of Amazon Web Services, right? And then we can allow Lex to understand the context of the user based on the request, what they have generated, right? And after this request here, we have Amazon Poly, right? So again, here what they can do is they can simply respond to user in speech, right? Poly is again a service offered by Amazon where we can deliver the results as a part of speech itself. We can deliver the results as a part of speech as well, right? So again, they can simply revert back, okay, savings account or checking account balance. Again, they can simply revert using the Amazon Poly service as well, right? And for sending the notification, we can simply use Lambda service. Now, Lambda is a serverless computing services offered by AWS. So basically, we do have the costs for launching the full-fledged server. We have EC2, right? The concept for which we had discussed so far. And AWS Lambda is basically a serverless computing platform offered by AWS, right? That we can use to get started, right? So using Lambda here, we can simply connect our application with DynamoDB. Now, DynamoDB is also something that we will be discussing in detail as we move further. So it's basically DynamoDB is a NoSQL database. DynamoDB is a NoSQL database. Then we have Amazon SNS. SNS is simple notification service used for delivering the notifications that has been generated by any service. And then we have Amazon SES. SES is simple email service. That means if we want the emails to be sent, right? We want the emails to be sent here, then we can simply use SES for that, right? And at last we have all the other services that we can use. Suppose if we have data also stored as a part of RDS, we have data also stored as a part of RDS with any engine, right? Then we can connect it Lambda using these two, or you can say these multiple engines as well as a part of AWS Lambda services integration. And once they have got the data, then again they can send the data back to Lex, right? And again, these now whatever is happening here, the logs for these will be stored and events are also kept a track of. Now this is also done using a service called as CloudTrail. Now CloudTrail is also a service offered by AWS through which it simply maintains the logs for different kind of activities happening in the entire system altogether, right? So that any kind of activity happening here, this can be reported. This can be reported back, and we can say well here as a part of AWS, right? And once the entire processing has been done here, now the customer is provided with the accurate, or we can say account balance, either through voice or either through text-based system. And as a part of our hands-on here, we'll be focusing on how we can create one chatbot as well using AWS Lex. And in here we can use it to build powerful interfaces to be used with both mobile applications, right? Like we have the customer, like we have OYO Health, right? So basically it is also used for building high interactive and conversational user experiences for IoT itself, because again it is highly useful for IoT platform as well. IoT as in Internet of Things, where different devices are connected to a single network altogether as a part of IoT platforms. And this is being used by NASA, right? Again, these are basically used for building the enterprise the chatbots to check sales data, marketing performances, and much more, right? So again, there are multiple use cases that we can have, that we can observe on top of these automated chatbots, right? And this will be really useful when we are deploying the applications for our own company as well, right? When we are building applications for our own company, and then we can simply deploy these as a part of our entire integration as well. Now again, if we are not the actual developer, still we can have the entire team delivered for us, right? As a part of use case for Lex, here. And basically the main benefits of using Amazon Lex is it offers an easy to use console, and we have predefined bots. So here, even though when we don't have that much of technical expertise here, we can simply define the logic, and then we can get the entire chatbot up and running by using the predefined services offered by AWS here, right? And again, it simply employs advanced deep learning functionalities that we can offer here, correct? And again, it provides us complete seamless deployment and scaling. And again, there are multiple integration built in with AWS platform and offering a cost-effective platforms here. So basically, in order to understand the Lex here, first of all, chatbot receives the user input, and then it can simply reply with the answers and perform the actions, or we can also ask for other inputs as well, right? If the entire input has been received here, right? If the entire input has been received by chatbots, then you can simply process it first, right? And using the Lambda services here, it can simply connect. Now chatbot will simply trigger AWS Lambda service, and Lambda function, whatever we have defined here, it will simply be integrated by some other services that we have, DynamoDB, SNS, SES, and for any of the services as per the requirement or as per the structure that we have defined for chatbots, right? And then here we can, and then in order to get it started, first of all, here we can create a chatbot. Then we can test the bot on a Windows side. Then we can simply publish a version and create an alias, and then we can deploy it on top of a suitable platform here, right? And before we get started on seeing the hands-on on top of Amazon Lex here, first of all we have certain terminologies that we have to be acquainted with. First of all, we have Amazon bot. So it's simply an artificial program that is useful for simulating an interactive conversation, right? Then we have intent. Now intent simply represents an action that users want to perform. For example, we want the user to send an image. We want the chatbot to send an image, right? Or we want the chatbot to send the users to a link altogether. So these are the intent, right? That means the action that the user wants to perform, correct? And then we have the attributes as name, other cases, and then we have intent fulfill, right? We'll be discussing these parts step by step as we continue further. And then we have slots. So slots are simple parameters that an intent might require, right? Suppose again we have intent, right? we want the user to suppose open up a specific web page, right? Again, and there are multiple parameters. That means which page it has to at which page, which time slot here. What are different other parameters that needs to be specified here as a part of intent, right? Then we have slot types. So again, each and every slot has a type, and again here we can use built-in, or we can also define our own custom slot types altogether, right? Once the intent has been completed, again it will simply build a function to fulfill the intent, and it will simply be deployed on top of client application as well. So yeah, there are two ways through which we can fulfill our intent. We can use our inbuilt lambda function, or in case it has been some other functions defined by the companies itself or the client for which we are building it, they can use those. And then we can define the lambda function as a part of a code hook, here, right? Where the users can customize the entire, we can customize the entire user interaction, or we can simply initiate and validate the user input. Suppose if they have entered a wrong input, then that cannot trigger the entire AI system as well, correct? And that's why we have to make sure we are validating the entire input of the users as well. And then at last, we have to simply execute the entire input altogether, right? All right, so now let's get right back to our console so that we can log into our console, and then we can have the quick access on top of Lex services. Okay, here we have to enter the MFA code. Let's fetch our MFA code as well. Just a moment. So here we can enter the MFA code 879104. Okay, it hasn't changed. 169996. So once we log in into our console here, we would be able to see the same portal for which we have signed up. Now, once we are not, as always, guys, so again, here we simply have to look for the service that we are focusing on, right? Like we have been looking for S3, for EC2, for IAM services. So same way here, first of all, here we have to search for a service called as Lex, right? So here we can simply use a search bar. We can simply go ahead and use the search bar here. And here we can simply search for a service called as Lex. Now here we'll be finding Lex here. Here we have Lake Business. So here we have to open up Lex. Let's open this up. Currently by default we are into Mumbai. So now remember guys, Lex is not available for every region here. So currently we are in Mumbai. So now let's do one thing. Let's simply switch to North Virginia. As we had discussed, not every service is available in every region here, right? So here we can switch to our service for North Virginia. Now, once we are into Amazon Lex here, we can simply click on Get Started. First of all, we have to look for the service called as Lex, and then here we can simply click on Get Started here, right? Now in here we can choose. We can create our own custom bot, or we can choose any of these predefined samples here. Just like we have now, we will be looking at samples for almost every service that we will be discussing here. For example, we have other services like we have Beanstalk, we have CloudFormation, right? Where we get multiple predefined samples. Suppose we are just simply a beginner, right? And we want to see how exactly the chatbots work, and we want to see a simple, or we can say simple base here, right? Then we can simply choose these samples as well. For example, here we want to try a hands-on for booking trip, right? For order flowers, for schedule appointment, right? For example, here we're looking for book trip, so we can choose book trip. We want to look for order flowers, right? We can see a sample for order flowers. We can look for schedule appointment as well, right? So based on our now, as you can see, as soon as we are making changes here, the responses and the questions are also being changed here, as we can observe. So if we go to order flowers, Again, if you go for booking trip here, if you go for booking trip, you can see, first of all, here we have, I would like to book a hotel. Sure, which city? New York City. Then what date do you want to check in? And then we are simply checking for it, right? So basically, first of all, it simply starts with the intent. That means that the user main intent is to book a trip, to book a hotel altogether, right? That's the main intent of the users, correct? Then they have started with the other cases. Now, then we have started with the other cases. That means spoken or type phrases, right? That invokes our event. Now, currently our main intent is to book hotel, right? And for booking the hotel, as a user, we have received, okay, I would like to book a hotel, right? And then we have slots. Now that means again based on the parameters here, then we have asked which city, and then they are giving us slots as in the required data pointers to fulfill the intent, correct? That is a part of city altogether, right? And then we have prompts, here. So prompts will simply ask question how the user okay, say any additional data that needs to be defined, and then once we have defined this, then we are simply fulfilling it as well, right? And then it will simply process it. Okay, are you sure you want to book a seat or book the hotel in your city? Once the user confirms, then the entire confirmation will be done here, right? Same way for ordering flowers as well, same way for schedule appointment, right? So in here we can simply create our own chatbots using these systems, right? And in here we can simply click on custom bot. To get started, we can simply click on custom bot, and in here we can define the bot name. In here we can define the bot name here, what exactly we are trying to create here. We can define the entire bot name. Now under bot name, we can simply, let's say here we are trying to create any bot, right? In here we are trying to create any bot here. Okay, so for what purpose shall we create this bot here? So we can go for movie booking as well, because movie booking sounds good. So let's book a movie, because again, we don't want to make anyone hungry by ordering food, right? So let's go for movie booking here. Now in here, we can define the bot name. Suppose say we want to call this as book movie. Here we can call this bot as book movie altogether. So let's say we make it as book movie. And then we can define the language. Then here we have to choose the output voice itself, right? Now these are the output voice, as in, now in case you have been using the, we can say the different voice based system, like we have Alexa, we have Siri, right? So in here we can define the voice as well, right?
Hello, my name is Sally.
As you can see, suppose if we go for Sally here, right? So basically, it will simply showcase you a sample of the voice in which we want the chatbots to respond here. For example, let's say we want to hear some other voice here. For example, suppose for Matthew.
Hello, my name is Matthew.
Right? So depending upon our context here, we have different use cases.
Hello, my name is Kendra.
Sounds interesting. So that's it. So just like we have our own voices here, we can simply go for the current voices here. Now, for example, let's hear for Ivy as well.
Hello, my name is Ivy.
Okay, this sounds like a schoolgirl. So now here, let's say we stick with salad.
Hello, my name is Sally.
And here we can simply define the text that we want to hear, right? For example, suppose we have, or suppose which movie do you want to book? Or suppose which movie, as simple as which movie, right? Let's suppose we simply type which movie itself. So this will simply talk this aloud.
Which movie? Which movie?
As you can see, now we have the entire sentence being repeated in our own voice, in that particular voice altogether. Yes, Ajay, we can have our own. Now we can't have our own voice, but again we can choose a voice that we want to use as an output voice here. We can choose the output voice here, right? Now, once we define that part here, then we have session timeout, right? So here we can define this as a session timeout. For example, that means after a given time period, it should be how much time it should be opted out for. Because again, now as you can see, now Siri has an Indian version, right? Siri do have an Indian version. So currently it is being developed as a part of the entire development for every possible assistant, because they have already known that this is going to be a big market, and that's why they are customizing this. All right. Now, once we define this part here, now next is we can simply define the IAM role. We can keep it to by default. We can choose the default IAM role for this entire service. Now here, depending upon a rule here, we can simply make it yes, or we can simply define the no as well, right? Suppose here we don't want to, now here we are not following the entire COPAPA rule, mostly applicable for Europe. Or if we are, again, we can simply keep it to yes, and then we can simply have to define the role altogether, right? So in here we define the timeout as opposed 2 minutes. We define the session timeout to be 2 minutes as a part of standing timeout, and then we have create. Once we define it here, we can click on create, and this may take a second. Okay, let's refresh. Now, once we define the intent here, now once we have the bot created, then we have to start by defining the user, we can say user intent altogether, right? So here we have to click on this option which says create intent. Now, once you click on create intent here we have to simply define, okay, if you already have the intent created from the past, then we can simply work on importing the intent, or we can simply click on create intent here. We can click on create intent, and then we can define the intent. For example, let's say here our main intent is to book movie ticket. Here our main intent is to book movie ticket. We can define book movie ticket, right? That is our main intent, book movie ticket. And once we add this here, now here we have to define the utterances. That means, now for example, suppose the first attempt here, that means the first component that the user will be typing here as a part of utterance here, right? The first thing that user will be typing in. So here we can simply define, suppose say here we get ask the user, suppose as I would like to book a movie ticket. We can define I would like to book a movie ticket, right? Now in here we have to define multiple slots as well. In here we can define multiple slots as well, right? Now slots are basically, we can say the variables. Now these are the variables for the legs itself, right? Suppose let's say when we are now in case, suppose let's say when we are ordering pizza, right? The slot will be like, for example, size, or again, or for example, in here we have to define, that means the options, right? So slots are simply like option itself. Slots are simply like options, right? So here what we can do is we can simply add the slot itself, right? So here we can define the name as well. For example, here we can define the name. Suppose what can be the slots, or we can say for movies itself, what can be the option for movies. So for example, suppose if we are talking about hotel booking, right? Then slots can be location. That means in which location we are trying to book a hotel, right? Same way for movies, what kind of slots can be there? So first of all, it can be location, right? Then we have to choose a slot type as well, right? That means this is what, now this is just like we have data type, just like we have data type itself, right? For example, here we have multiple things defined here, right? For example, here we have region, book, we have book series, we have civil, colors, country, codes, right? So there are multiple slot type that we can define here. There are multiple slot type that we can define here, right? So for example, here as we define location, suppose we are asking the users as location itself, right? Then we can choose some different slot type here, right? For example, here we are defined simply, now here we want to go for location itself, right? Or suppose let's say here we simply want the user to type in their city name. Now, since this is basically focused only on for US itself, so here we can search for city. Suppose let's say here we are going for US city itself, right? And then we have to define the message. Suppose here we choose the US city here, then we have to define the message as well. That means in which city, or suppose what city or which city we are looking for, right? So here we can define what city as a location, right? And then suppose if we want to keep on adding more prompts here, as a part of more slots here, we can simply click on add, and then we can ask for more options here. For example, next is we can also ask for timing as well, right? Timing, or we can say we can ask for show time, right? And then we can define again we can choose between the slot itself. We can choose from the slot itself, right? Suppose here we want the user to enter time itself, right? So what we have done, we have chosen show time, and now we are asking the users to the slot type is basically focused on time altogether, right? We can choose time, and then here we can ask the user as show time as a part of preference here, right? So here we can simply define as show time, and then we can simply define these step by step. Now, in here, once we have defined the slots here, then we have the confirmation prompt as well, right? So here and here, we can simply configure the confirmation prompt as well. Suppose once the user have entered anything, they'll be prompted with the confirmation as well. Next is again, we can define now in terms of fulfillment here, we can simply return the parameters to the client itself. Now, next is in terms of any kind of responses here, right? Again, if we want to add a specific and customized message here as a part of response, we can simply define these, right? Now let's keep this by default. We don't want to change this, right? So here we can keep this by default here. No, Sitarama, we haven't defined anything under confirmation prompt, right? But again, if we want, we can define a confirmation prompt as well. For example, suppose if we want to define a confirmation prompt, right? So okay, suppose are you sure you want to order a drink? For example, let's say if the user has selected, suppose are you sure you want to book a ticket, right? Here we can define the name itself, right? Suppose here we have are you sure you want to book. Now in here we have to define the parameters. Now in here we have to define the parameters itself. For example, if we type in as are you sure you want to book. Now currently we have to define, now this should be replaced with the movie name, right? Suppose let's say here we have here they are asking for show time for location. Now okay, we haven't asked for movie, right? Or suppose any kind of movie name itself. So again, if we want, we can add another slot as well. If we want to ask the users for movies as well, right? For which movie they're trying to book here. Suppose if this is what movie itself. So here we can name this as movie, and in here now whether we want this to be treated like a name itself, or suppose we already have a option available for movie in this slot type. Like we have movie, we can search for movie. Right here we can choose a movie here as a part of slot. Just a moment. Right, and again here we can choose okay which movie, or suppose which movie or what city, show time. Okay, we can go for what movie itself, right? Or we can say for which movie. Here we can define the prompt as well, right? Here we can choose okay how exactly we want it to be added here. For example, we want to keep on adding multiple prompts here. We can simply go on and on one by one. We can define that, and in here we can define the order as well, right? We define the movie, then we have chosen the movie name. Here we can go for which movie, like we have defined as a question, right? And in here we can define the orders as well. Suppose we want first of all we want the bot to ask for location, and then we want the bot to ask for movie, and then we want the bot to ask for show time, because that should be the order, correct? Because we want to ask for the location, the movie, and the show time. Suppose we no longer want this show time to be mandatory here, right? We can simply market these two for being the most important components here, location and movie altogether, right? We can define those, and then we have the confirmation prompt. Here we can choose, okay, are you sure you want to book Now suppose we had defined the name as movie, right? Then in here in parameters, now remember this has to be made as a part of double quote, as a part of parenthesis itself, right? So here we had to define movie, right? And suppose if the user does not define as confirm, suppose if the user does not define as confirm, then again, if the user simply says no, then again here we can simply make sure, okay, your movie tickets are not your movie tickets are not booked, we can simply showcase them complete message like this one, right? Okay, your movie tickets are not booked, right? So in here we can have a complete control of how exactly we want to create the bots here, right? This is how we can customize the entire bot as well. Here we can customize the entire bots exactly as per our requirement, right? Now, next is we can define the response as well. Now, by default, we can simply return the parameters to a client itself, or we can simply send it to a Lambda function, right? Now, currently, as we have not discussed on Lambda function yet here, we can simply keep it to return to parameters to client for now. Then we'll be coming back to the Lambda function in a while. All right. Now, in terms of response, we can keep it to blank as of now, because again, here we can keep this option blank altogether. We don't want this one, right? Now, in here, we can simply click on save intent. Once we are done, we can simply click on save intent. Now, once we are done here, now what we can do is now to see this in live action here, we can simply click on build. Okay, I think we missed on the hook URL here. I think this will generate a simple error as we have missed the hook URL. Now, depending upon the parameters here, guys. So again, here we can simply it may take some time for this one to be executed here. All right, so now once we have the bot created here, now once the bot has been successfully created here, now here in the right section of the screen here, we can see a sample test bot, right? Absolutely. So now here we can simply go ahead and test it as well, right? So for example, here we simply test, okay, I want to, suppose here we can simply define as I would like to book movie ticket. As you can see now, even though we suppose, let's say, we simply type book movie ticket. Now we have defined I would like to book movie ticket. As you can see, can you all see this? We have the what city here, right? So now in here we can simply define, suppose we want to define this, say suppose we want to book this up in New York. We want to book a ticket in New York altogether, right? Then it will automatically ask which movie. Suppose if we name the movie as any name here, for example, like Shawshank Redemption. Again, then it is asking us for show time, for example, let's say for 8 p.m. right? And again, since we have defined for the confirmation as well, this will ask, okay, are you sure you want to book for Shawshank? As you can see, can you all see this? All 3 slots have been filled here, correct? So we had defined location, we had defined show time, and then we had defined movie name itself, right? So all these slot details has been completely booked. And as you can see, all of these 3 details has been booked here, right? So suppose if we simply revert this with yes, as you can see now, intent movie ticket is ready for fulfillment. That means now we can simply define the fulfillment, right? So currently we have defined, okay, we want this to be returned to the user itself, right? And suppose we want to run a Lambda function, that means we want the actual booking to be done, right? Then we do have to integrate this as a part of Lambda function as well. So I hope you all are enjoying this. You all did enjoy this entire discussion on machine learning using like how we can create this using the chatbot, guys. And now as a continuation here, suppose let's say we want to create a Lambda function. We want to create a simple Lambda function here, right? So Lambda, as you know, is simply a serverless computing platform. Lambda is what? A serverless computing platform, right? And now if we want to indicate Lambda here, what we can do is, first of all, we do have to go ahead and create a Lambda service, right? We do have to go ahead and create a Lambda service. Now for doing that, we can simply search for a service called as Lambda. Now we haven't discussed this part yet, and we will be discussing this part going forward, step by step. For example, in here, if we want to process it by Lambda function, we can process it. In case we want to store the data into Amazon Aurora database, or suppose DynamoDB, right? Depending upon where we want the data of suppose if we already have a list of store times with us, right? How we can refer to those store timings, how we can store data. That means suppose whatever is being entered by the user, how we can store it as well. Like we can all do this exactly as per our requirement, right? We can do this all exactly as per a requirement here. So now in here, what we can do is, first of all, in order to add a Lambda function, we have to create a Lambda function as well. We have to create one Lambda function as well, right? And for doing that, what we have to do is we simply can search for service called as Lambda in services. We can simply open up Lambda service. Here we can open up Lambda. Now, when we open up Lambda here, we simply have to create one service. We have to create one function here, right? Now, in here, what we can do is, now in here, if you don't want, now if for the first time, for the first time user here, now Lambda, as you know, is a serverless computing platform, right? So basically, the main purpose of Lambda. Now we will discuss Lambda going forward as well, but again, to have a quick understanding of what exactly Lambda is, first of all, let's go back to a Picasso board to have a quick understanding here, right? Now to understand Lambda in a much better way here, so basically when we are launching any application, like we discussed on the concept of EC2 as well, right? When we are launching any particular application altogether, we have to deploy, we have to create one server. We have to create one server on top of EC2, right? As an Elastic Cloud Compute server itself, right? Now, if we can use this server for, we can use this EC2 server, right? As we have been discussing so far. If we want to deploy any application on our or for our website, suppose we are deploying a website, right? Then we can deploy the website on top of EC2, right? And again, suppose we want to test the application altogether. For example, if we only want to test the application, we don't want to deploy a full-scale application. We don't want to deploy a full-scale server. Then what we can do? We can simply use a service called as Lambda, right? So that suppose if we want to simply execute and test our code here, right? That means we are only looking for testing the code. Then we can use this Lambda function to simply now using this Lambda service, we can upload a code to Lambda. And suppose the code took 3.2 seconds, suppose 3.6 seconds in order to be executed complete, right? That means here we have to pay only for these 3.6 seconds, nothing less, nothing more, because as we have discussed in EC2, there's a pricing for an hourly basis. That means we have to pay for every hour, correct? But here in Lambda service, the pricing is for every 100 milliseconds. The pricing here is for every 100 milliseconds here, right? That means here we have to pay only for the exact duration of time for which the code has been executed, right? And let's say suppose if we have any kind of event trigger system, for example, we have any kind of notification systems where we need to use the processing power only when there is a change or only when there is a trigger in the event, correct? Then we can use the services for Lambda.
So let's have a look at the top 10 skills which are required to become a successful machine learning engineer. So starting with programming languages, Python is the lingua franca of machine learning. You may have had exposure to Python even if you weren't previously in programming or in a computer science related field. However, it is important to have a solid understanding of classes and data structures. Sometimes Python won't be enough. Often, you'll encounter projects that need to leverage hardware for speed improvements. Now make sure you're familiar with the basic algorithms as well as the classes, memory management, and linking. Now if you want a job in machine learning, you will probably have to learn all of these languages at some point. C++ can help in speeding code up, whereas R works great in statistics and plots. And Hadoop is Java based, so you probably need to implement mappers and reducers in Java. Now next we have linear algebra. You'll need to be intimately familiar with matrices, vectors, and matrix multiplication. If you have an understanding of derivatives and integrals, you should be in the clear. Otherwise, even simple concepts like gradient descents will elude you. Statistics is going to come up a lot. At least make sure you are familiar with the Gaussian distributions, means, standard deviation, and much more. Every bit of statistical understanding beyond this helps. Now, theories help in learning about algorithms. Great samples are naive Bayes, Gaussian mixture models, and hidden Markov models. You need to have a firm understanding of probability and stats to understand these models. Just go nuts and study measure theory. And next we have advanced signal processing techniques. Now, feature abstraction is one of the most important parts of machine learning. Different types of problems need various solutions. You may be able to utilize really cool advanced signal processing algorithms such as wavelets, shearlets, curvelets, and bandlets. You need to learn about the time frequency analysis and try to apply it in your problems. Now this skill will give you an edge over all the other skills. Now this skill will give you an edge while you're applying for a machine learning engineer job over others. Now next we have applied maths. A lot of machine learning techniques out there are just fancy types of functional approximation. Now these often get developed by theoretical mathematicians and then get applied by people who do not understand the theory at all. Now the result is that many developers might have a hard time finding the best techniques for the problem. So even a basic understanding of numerical analysis will give you a huge edge. Having a firm understanding of algorithm theory and knowing how the algorithm works, you can also discriminate models such as SVMs. Now you will need to understand subjects such as gradient descent, convex optimization, Lagrange, quadratic programming, partial differentiation equations, and much more. Now, all this math might seem intimidating at first if you've been away from it for a while. Yes, machine learning is much more math intensive than something like front-end development. Just like any other skill, getting better at math is a matter of focused practice. The next skill in our list is the neural network architectures. We need machine learning for tasks that are too complex for human to code directly. That is, tasks that are so complex that it is impractical. Now, neural networks are a class of models within the general machine learning literature. Now, neural networks are a specific set of algorithms that have revolutionized machine learning. They are inspired by biological neural networks, and the current so-called deep neural networks have proven to work quite well. The neural networks are themselves general function approximations, which is why they can be applied to almost any machine learning problem about learning a complex mapping from the input to the output space. Of course, there are still good reasons for the surge in the popularity of neural networks, but neural networks have been by far the most accurate way of approaching many problems like translation, speech recognition, and image classification. Now coming to our next point, which is the natural language processing. Now, since it combines computer science and linguistics, there are a bunch of libraries like the NLTK, Gensism, and the techniques such as sentimental analysis and summarization that are unique to NLP. Now, audio and video processing has a frequent overlap with the natural language processing. However, natural language processing can be applied to non-audio data like text. Voice and audio analysis involves extracting useful information from the audio signals themselves. Being well versed in math will get you far in this one. And you should also be familiar with the concepts such as the fast Fourier transforms. Now, these were the technical skills that are required to become a successful machine learning engineer. So next, I'm going to discuss some of the non-technical skills or the soft skills which are required to become a machine learning engineer. So first of all, we have the industry knowledge. Now, the most successful machine learning projects out there are going to be those that address real pain points. Whichever industry you are working for, you should know how that industry works and what will be beneficial for the business. If a machine learning engineer does not have business acumen and the know-how of the elements that make up a successful business model or any particular algorithm, then all those technical skills cannot be channeled productively. You won't be able to discern the problems and potential challenges that need solving for the business to sustain and grow. You won't really be able to help your organization explore new business opportunities. So this is a must-have skill. Now next we have effective communication. Now you'll need to explain the machine learning concepts to the people with little to no expertise in the field. Chances are you'll need to work with a team of engineers as well as many other teams. So communication is going to make all of this much more easier. Companies searching for a strong machine learning engineer are looking for someone who can clearly and fluently translate their technical findings to a non-technical team, such as marketing or sales department. Now, next on our list, we have rapid prototyping. So iterating on ideas as quickly as possible is mandatory for finding one that works. In machine learning, this applies to everything from picking up the right model to working on projects such as A/B testing. You need to do a group of techniques used to quickly fabricate a scale model of a physical part or assembly using the three-dimensional computer-aided design, which is the CAD. So last but not the least, we have the final skill, and that is to keep updated. You must stay up to date with any upcoming changes. Every month, new neural network models come out that outperform the previous architecture. It also means being aware of the news regarding the development of the tools, the changelog, the conferences, and much more. You need to know about the theories and algorithms. Now, this you can achieve by reading the research papers, blogs, the conferences, videos, and also you need to focus on the online community, which changes very quickly. So expect and cultivate this change. Now, this is not the end. Here we have certain skills, the bonus skills, which will give you an edge over other competitors or the other persons who are applying for a machine learning engineer position. On the bonus point, we have physics. Now, you might be in a situation where you would like to apply machine learning techniques to a system that will interact with the real world. Having some knowledge of physics will take you far. Now, next we have reinforcement learning. So, this reinforcement learning has been a driver behind many of the most exciting developments in the deep learning and the AI community. From the AlphaGo Zero to the OpenAI's Dota 2 bot. This will be critical to understand if you want to go into robotics, self-driving cars, or other AI-related areas. And finally, we have computer vision. Out of all the disciplines out there, there are by far the most resources available for learning computer vision. This field appears to have the lowest barriers to entry, but of course this likely means you'll face slightly more competition. So having a good knowledge of computer vision, how it works, will give you an edge over other competitors. So as you know, we are living in the worlds of humans and machines. In today's world, these machines or the robots have to be programmed before they start following your instructions. But what if the machine started learning on its own from their experience, work like us, and feel like us, and do things more accurately than us? Now, well, here's where a machine learning engineer comes into picture to make sure everything is working according to the procedures and the guidelines. Now, in my opinion, machine learning is one of the most recent and exciting technologies there is. You probably use it a dozen of times every day without even knowing it. So before we indulge into the different roles, the salary trends, and what should be there on the resume of a machine learning engineer while applying for a job, let's understand who exactly a machine learning engineer is. So machine learning engineers are sophisticated programmers who develop machines and systems that can learn and apply knowledge without specific direction. Artificial intelligence is the goal of a machine learning engineer. They are computer programmers, but their focus goes beyond specifically programming machines to perform specific tasks. They create programs that will enable machines to take actions without being specifically directed to perform those tasks. Now, if we have a look at the job trends of a machine learning engineer, so as you can see, in Seattle itself, we have 2,000 jobs. In New York, we have 1,100. In San Francisco, we have 1,100. In Bengaluru, India, we have 1,100. And then we have Sunnyvale, California, where we have 500 number of jobs. So as you can see, the number of jobs in the market is too much. And probably with the emergence of machine learning and artificial intelligence, this number is just going to get higher. Now, if we have a look at the job opening salary-wise percentage, so we can see for the $90,000 per annum bracket, we have 32.7%. And that's the maximum. So be assured that if you get a job as a machine learning engineer, you'll probably get around $90,000 a year. That's safe to say. Now for the $110,000 per year, we have 25%, $120,000, we have 20% almost. Then we have $130,000, which are the senior machine learning engineers. That's a 13.67%. And finally, we have the most senior machine learning engineer, or we have the data scientists here, which have the salary of $140,000 per annum, and the percentage for that one is really low. So as you can see, there is a great opportunity for people who are trying to go into machine learning field and get started with it. So let's have a look at the machine learning engineer's salary. So the average salary in the US is around $111,490, and the average salary in India is around 7,19,646 rupees. That's a very good average salary for any particular profession. So moving forward, if we have a look at the salary of an entry-level machine learning engineer, so the salary ranges from $76,000 or $77,000 to $151,000 per annum. That's a huge salary. And if we talk about the bonus here, we have like $3,000 to $25,000 depending on the work you do and the project you are working on. Let's talk about the profit sharing now. So it's around $2,000 to $50,000. Now this again depends upon the project you are working, the company you are working for, and the percentage that they give to the engineer or the developer for that particular project. Now the total pay comes around $76,000 or $75,000 to $162,000. And this is just for the entry level machine learning engineer. Just imagine if you become an experienced machine learning engineer, your salary is going to go through the roof. So now that we have understood who exactly is a machine learning engineer, the various salary trends, the job trends in the market, and how it's rising, let's understand what skills it takes to become a machine learning engineer. So first of all, we have programming languages. Now, programming languages are a big deal when it comes to machine learning because you don't just need to have proficiency in one language. You might require proficiency in Python, Java, R, or C++. Because you might be working in a Hadoop environment where you require Java programming to do the MapReduce codings, and sometimes R is very great for visualization purposes, and Python, as you know, is one of the favorite languages when it comes to machine learning. Now, next skill that a particular individual needs is calculus and statistics. So a lot of machine learning algorithms are mostly maths and statistics. And a lot of statistics is required, majorly the matrix multiplication and all. So a good understanding of calculus as well as statistics is required. Now next we have signal processing. Now advanced signal processing is something that will give you an upper edge over other machine learning engineers if you are applying for a job anywhere. Now the next skill we have is applied maths. As I mentioned earlier, many of the machine learning algorithms here are purely mathematical formulas. So a good understanding of maths and how the algorithm works will take you far ahead. Now next on our list we have neural networks. Now neural networks are something that has been emerging quite popularly in the recent years, and due to its efficiency and the extent to which it can work and get the results as soon as possible, neural networks are a must for a machine learning engineer. Now moving forward, we have language processing. So a lot of times machine learning engineers have to deal with text data, the voice data, as well as video data. Now processing any kind of language, audio, or the video is something that a machine learning engineer has to do on a daily basis. So one needs to be proficient in this area also. Now these were only some of the few skills which are absolutely necessary, I would say, for any machine learning engineer. So let's now discuss the job description or the roles and responsibilities of a particular machine learning engineer. Now, depending on their level of expertise, machine learning engineers may have to study and transform data science prototypes. They need to design machine learning systems. They also need to research and implement appropriate machine learning algorithms and tools, as it's a very important part of the job. They need to develop new machine learning application according to the industry requirements. They need to select the appropriate data sets and the data representation methods, because if there is a slight deviation in the data set and the data representation, that's going to affect the model a lot. They need to run machine learning tests and experiments. They need to perform statistical analysis and fine tuning using the test results. So sometimes people ask what exactly is the difference between a data analyst and a machine learning engineer. So statistical analysis is just a small part of a machine learning engineer's job, whereas it is a major part, or it probably covers a large part of a data analyst's job rather than a machine learning engineer's job. So machine learning engineers might need to train and retrain the systems whenever necessary. And they also need to extend the existing machine learning libraries and frameworks to their full potential so that they could make the model work superbly. And finally, they need to keep abreast of the developments in the field. Needless to say that any machine learning engineer or any particular individual has to stay updated to the technologies that are coming in the market, and every now and then a new technology arises which will overthrow the older one. So you need to be up to date. Now, coming to the resume part of a machine learning engineer. So any resume of a particular machine learning engineer should consist like clear career objective, the skills which a particular individual possesses, the educational qualification, certain certification, the past experience if you are an experienced machine learning engineer, the projects which you have worked on, and that's it. So let's have a look at the various elements that are required in a machine learning engineer's resume. So first of all, you need to have a clear career objective. So here you need not stretch it too much and keep it as precise as possible. So next we have the skills required, and these skills can be technical as well as non-technical. So let's have a look at the various technicals and the non-technical skills out here. So starting with the technical skills, first of all, we have programming languages as in R, Java, Python, and C++. Now, the first and the foremost requirement is to have a good grip on any programming languages, preferably Python, as it is easy to learn and its applications are wider than any other language. Now, it is important to have a good understanding of topics like data structures, memory management, and classes. Although Python is a very good language, it alone cannot help you. So you will probably have to learn all these languages like C++, R, Python, Java, and also work on MapReduce at some point of time. Now, next on our list, we have calculus and linear algebra and statistics. So you'll need to be intimately familiar with matrices, the vectors, and the matrix multiplication. So statistics is going to come up a lot, and at least make sure you're familiar with Gaussian distribution, mean, standard deviations, and much more. So you also need to have a firm understanding of probability and stats to understand the machine learning models. Now next, as I mentioned earlier, it's signal processing techniques. So feature extraction is one of the most important parts of machine learning. Different types of problems need various solutions. So you may be able to utilize the really cool advanced signal processing algorithms such as wavelets, shearlets, curvelets, and the bandlets. So try to learn about the time frequency analysis and try to apply it to your problems, as it gives you an upper edge over other machine learning engineers. So just go for it. Next, we have mathematics, and a lot of machine learning techniques out there are just fancy types of function approximation. Having a firm understanding of algorithm theory and knowing how the algorithm works is really necessary, and understanding subjects like gradient descent, convex optimization, quadratic programming, and partial differentiation will help a lot. The neural networks, as I was talking earlier, so we need machine learning for tasks that are too complex for humans to code directly. So that is the tasks that are so complex that it is impractical. The neural networks are a class of models within the general machine learning literature. They are a specific set of algorithms that have revolutionized machine learning. Deep neural networks have proven to work quite well, and neural networks are themselves general function approximations, which is why they can be applied to almost any machine learning problem out there, and they help a lot about learning a complex mapping from the input to the output space. Now next we have language processing. Since natural language processing combines two of the major areas of work that are linguistic and computer science, and chances are at some point you are going to work with either text or audio or the video. So it's necessary to have a control over libraries like GenSim, NLTK, and techniques like word-to-vec, sentimental analysis, and text summarization. Now, voice and audio analysis involves extracting useful information from the audio signals themselves. Being well versed in maths and concepts like Fourier transformation will get you far in this one. Now, these were the technical skills that are required, but be assured that there are a lot of non-technical skills also that are required to land a good job in a machine learning industry. So, first of all, you need to have an industry knowledge. So the most successful machine learning projects out there are going to be those that address real pain points. Don't you agree? So whichever industry you are working for, you should know how that industry works and what will be beneficial for the industry. Now, if a machine learning engineer does not have business acumen and the know-how of the elements that make up a successful business model, all those technical skills cannot be channeled productively. You won't be able to discern the problems and the potential challenges that need solving for the business to sustain and grow. Now, next on our list, we have effective communication, and now this is one of the most important parts in any job requirement. So you'll need to explain machine learning concepts to people with little to no expertise in the field. The chances are you will need to work with a team of engineers as well as many other teams like marketing and the sales team. So communication is going to make all of this much easier. Companies searching for a strong machine learning engineer are looking for someone who can clearly and fluently translate their technical findings to a non-technical team. Now, rapid prototyping is another skill which is very much required for any machine learning engineer. So, iterating on ideas as quickly as possible is mandatory for finding the one that works. In machine learning, this applies to everything from picking the right model to working on projects such as A/B testing and much more. Now, you need to do a group of techniques used to quickly fabricate a scale model of a physical part or assembly using the three-dimensional computer-aided design, which is the CAD data. Now coming to the final skills which will be required for any machine learning engineer is to keep updated. Now you must stay up to date with any upcoming changes. Every month new neural network models come out that outperform the previous architecture. It also means being aware of the news regarding the development of the tools, theory, and algorithms through research papers, blogs, conference videos, and much more. Now another part of any machine learning engineer's resume is the educational qualification. So a bachelor's or a master's degree in computer science or IT, economics, statistics, or even mathematics can help you land a job in machine learning. Plus, if you are an experienced machine learning engineer, so probably some standard company certifications will help you a lot while landing a good job in machine learning. And finally, coming to the professional experience, you need to have experience in computer science, statistics, data analysis. If you are switching from any other profession to a machine learning engineer, or if you have a previous experience in machine learning, that is very well. Now, finally, if we talk about the projects, so you need to have not just any project that you have worked on, you need to have working on machine learning related projects that involve a certain level of AI and working on neural networks to a certain degree to land a good job as a machine learning engineer. Now, if we have a look at the companies hiring machine learning engineers, so every other company is looking for machine learning engineers who can modify their existing model to something that need not need much more of maintenance and can self-sustain. So basically working on artificial intelligence and new algorithms that can work on their own is what every company desires. So Amazon, Facebook, we have tech giants like Microsoft, IBM. Again, in the gaming industry, we have, or the GPU industry, graphics industry, we have NVIDIA. In banking industry, we have JP Morgan Chase. Again, we have LinkedIn, and also we have Walmart. So all of these companies require machine learning engineer at some point of the time. So be assured that if you are looking for a machine learning engineer post, every other companies, be it a big shot company or even the new startups, are looking for machine learning engineers. So be assured you will get a job. The first tool which I'm going to talk about is scikit-learn. It's not exactly a tool, it's a library, but it's the initial steps which one should follow. So scikit-learn is a free software machine learning library for the Python programming language. It is a simple and efficient tool for data mining and data analysis. It is built on NumPy, SciPy, and Matplotlib. It provides a range of supervised, unsupervised machine learning algorithms in Python like classification, regression, clustering, dimensionality reduction, and much more. So this is one of the basic steps or the basic building block of any machine learning project or application out there. So you need to know scikit-learn. This is one of the most important tools. Next I'm going to talk about is KNN, which is Constants Information Miner. It is a free and open source data analytics, reporting, and integration platform which is built for powerful analytics on a GUI-based workflow. This means you do not have to know how to code to be able to work using the KNN and derive the insights. What you can do is you can work all the way from gathering the data and creating models to deployment as well as production. It consolidates all the functions of the entire process into a single workflow. You can gather and wrangle the data, you can model and visualize, you can deploy and manage, and you can consume and optimize as well. So it's an all-in-one package, and the most important aspect is you do not need to know how to code. So the next library which I'm going to talk about is one of the best library out there for machine learning. which is TensorFlow. It is created by Google Brain team, and TensorFlow, it's an open source library for numerical computation and large-scale machine learning. When it comes to artificial intelligence framework showdown, you will find TensorFlow emerging as a clear winner most of the time. Now, what makes it so special? So TensorFlow provides an accessible and readable syntax, which is essential for making these programming resources easier to use, and being a low-level library provides more flexibility. And with the new version of 2.0, it is just going to be on the top of any machine learning or deep learning purposes. It is one of the best machine learning tools available, and it also uses Keras and other high-level APIs to make things a little smoother. And the most important thing is it can run on both CPU as well as GPU, and it really helps in graphical purposes, like if you're dealing with images, videos, TensorFlow is the way to go. Now, Weka, which is the Waikato environment for knowledge analysis, it is an open source Java software that has a collection of machine learning algorithms for data mining and data exploration tasks. It is one of the most powerful machine learning tools for understanding and visualizing machine learning algorithms on your local machine. It has both a graphical interface and a command line interface. Now, the only downside to this is that there is not much documentation or online support available. But all in all, it's a very good software, and it's based on Java. It also provides predictive modeling and visualization, and it's an environment for comparing learning algorithms. And the graphical user interface includes data visualization as well. Now next, we have a library which is one of the biggest rival of TensorFlow, which is PyTorch or Torch. So PyTorch is a Python-based library built to provide flexibility as a deep learning deployment platform. The workflow of PyTorch is as close as you can get to the Python scientific computing library, NumPy. It is actively used by Facebook for all of its machine learning or deep learning work, and the dynamic computational graphs are a major highlight of PyTorch. The support for CUDA ensures that the code can run on the GPU, thereby decreasing the time needed to run the code and increasing the overall performance of the system. Now, this framework is embedded with ports to iOS and Android backends. Now, RapidMiner, the next tool which I'm going to talk about, is a data science platform for teams that unite data preparation, machine learning, and predictive model deployment. It has a powerful and robust graphical user interface that enables users to create, deliver, and maintain predictive analytics. With RapidMiner, uncluttered, disorganized, and seemingly useless data becomes very valuable, as it simplifies data access and lets you structure them in a way that is easy for you and your team to comprehend. Now, few of the features are that it results in visualization a lot. Through GUI, it helps in designing and implementing analytical workflows. One of the downsides is that the tool is very costly. Now, Google is not very far behind. Apart from TensorFlow, we have the Google Cloud AutoML. Now, Google Cloud AutoML makes the power of machine learning available to you even if you have limited knowledge of machine learning. The Google's human labeling service can put a team of people to work annotating or cleaning your labels to make sure your models are being trained on high quality data. Now, how cool is that? They have various products for different purposes, which makes it a very good machine learning tools. For example, we have AutoML Vision, which is used for images. We have the AutoML Video Intelligence, which is specifically designed for video. We have the AutoML Natural Language, which is used to structure and get the meaning of text. We have the AutoML Translation, which dynamically detects and translates between different languages. And we have the AutoML Tables, which builds the models on your structured data. Now, we have the Azure Machine Learning Studio as well. Now, Microsoft Azure Machine Learning Studio is a collaborative drag and drop machine learning tool you can use to build, test, and deploy predictive analytics solution on your data. You drag and drop datasets and analysis modules into an interactive canvas and connecting them together to form an experiment, which you run in the Machine Learning Studio, and there is no programming required, just visually connecting datasets and modules to construct your predictive analytic model. And finally, you just have to publish it as a web service. Now, Accord.NET is a .NET machine learning framework combined with audio and image processing libraries, which is completely written in C#. Now, the tagline being machine learning made in a minute. That's an amazing tagline, guys. And it is a complete framework for building production-grade computer vision, computer audition, signal processing, and statistics application. Libraries are made available from the source code and through executable installer and the NuGet package manager. The only drawback is that it supports .NET, that it only supports the .NET supported languages. It provides algorithm for numeric linear algebra, numeric optimization, statistics, artificial neural network. It also provides supports for graph, plotting, and visual libraries as well. And it has more than 38 kernel functions. It contains more than 35 hypotheses tests, including one-way and the two-way ANOVA test, non-parametric tests like Kolmogorov's Smirnov test, and many more. Now, this is rather an interesting product by Google, which is the Core Laboratory. It is a free Jupyter Notebook environment that requires no setup and runs entirely on the cloud. It is a Google research project created to help decimate machine learning education and research. That's a good step forward by Google. It is by far one of the top machine learning tools, especially for data scientists, because you don't have to manually install any of the package and libraries. Just import them directly by calling them. You can directly save your project on the Google Drive, GitHub, or any location in various formats as well. And it also supports libraries of PyTorch, Keras, TensorFlow, as well as OpenCV. These are pre-installed. Now, this is a major step forward in the machine learning education department by Google, so hats off to them. Now, NLTK is another tool which I'm going to talk about, which is the Natural Language Toolkit, and it's an extensive library for natural language tasks. It is a go-to package for all your text processing needs, from word tokenization to lemmatization, stemming, dependency parsing, chunking, chinking, removing the stop words, and many more. Text processing is an extremely important part for any NLP task like language modeling, neural machine translation, or name entity recognition. And it also provides a synonym bank called the WordNet. Now, these are a few of the tools, basically the libraries and the frameworks, which are really necessary if you are going for machine learning or if you're going for deep learning, as a matter of fact. And these list of tools are enough for anyone to get started in the machine learning world.
What skills are required if you want to build machines that can learn on their own? We'll first go through a couple of job descriptions to filter out the skills needed. Then I will list the skills for you. Alright, so the first one we have is from Apple, and it's for ML engineer. You can pause your screen if you wish to read it, but I'll quickly give you the bullet points. They want somebody who knows Python and libraries like scikit-learn, pandas. The candidate should be really good with big data and database technologies. The candidate is also required to be familiar with the Linux operating system, and they should have familiarity with TensorFlow. So let's move on to the next one. This one is from EY, and it's for an AI ML engineer. Again, pause your screen if you want to, but here's the gist. They want somebody who knows machine learning development and infrastructure, and the person should know big data and cloud-based architecture. They should also possess programming and algorithmic skills. Some programming languages they mentioned are Java and Python, and the candidate should also be well versed in big data tools like Spark. So from the two job descriptions, we can extract the list required, and they are as follows. First, one should know a programming language. You can learn languages like Python, Java, C++, and so on. Although do note that Python is the go-to choice for most of the organizations around the world for making machine learning models because of its powerful libraries. So for the purpose of this video, we will emphasize on Python. Second, you should really strengthen your math fundamentals. Don't worry, it's not all math that you need to be good at. but particular areas of math, which we'll see later on in the video in the roadmap section. But for now, just remember that you need to be well versed in math that has any utility in machine learning. Third, you must know various types of machine learning models and algorithms. Along with this, you should also be able to implement these abstract concepts using machine learning libraries like NumPy, scikit-learn, TensorFlow, Panda. These are some of the famous ones. Fourth, it's a good idea to learn how to build machine learning systems that can process natural language, which can be in the form of text, audio, or video. The reason why this is a good idea to learn right off the bat is because first, natural language is all around us, and second, this will help you get ready for more complex machine learning and artificial intelligence projects in the future. 5. Because data is produced in obscenely high volumes every day, and so it's essential for someone thinking about a career in machine learning to know how to work with big data. And so they should know technologies like PySpark, Hadoop, etc. So those were the top 5 skills that you should acquire if you want to start a career in machine learning. So now you might ask, well, how do we get them, Kev? Well, it's finally time to lift up the curtain on roadmap. Okay, so why don't we get started? Here's the roadmap. First, programming languages and libraries. Well, there are many programming languages to choose from, but we highly recommend Python because it's very useful when it comes to machine learning, and the whole world is using Python. But regardless of the programming languages that you choose, you should be able to understand how to do file operations like read and write, and how to load files into memory. You should know how to work with functions and object-oriented programming. You should know how to use modules for reusability of the code so you don't end up writing the same code again and again. You should know how to handle exceptions. And if you're using Python, you should know Python libraries like NumPy, Pandas, Matplotlib, scikit-learn, TensorFlow, and so on. So there are so many useful resources. If you want to get started with the first step, we actually have a certification in Python just specifically for this so that you can learn it for machine learning. Or you can even check out our YouTube videos that will give you some of the tutorials. If you need more help, then again, go down in the description and find the link to that certification. It's going to be Python certification for machine learning. Moving on. Second, mathematics for machine learning. Let's get into what kind of math do you actually need for machine learning. So these are the areas that you need to work on: linear algebra, calculus, probability, and statistics. So diving a little deeper in each of the areas, starting with linear algebra, you should know what a scalar is, a vector is, a matrix is, and you should know how to perform different operations on each one of them. And of course, you need to know what the application of linear algebra is in machine learning. Then moving on, calculus, you should know what differentiation rules are, what partial differentiation is and how does it work. And of course, you should know the application of calculus in machine learning. Probability. So you should know all the terminologies in probability. You should know what distribution in probability is and how it works, the types of probability, Bayes' theorem, and application of probability in machine learning. Lastly, for statistics, you should know all the terminologies, of course. You should know what different sampling techniques are, types of statistics, and hypothesis testing. So that was all about what to learn. But what about where to go to find all of this? We have excellent blogs on our Edureka website that you can access for free. It covers end to end of what we just discussed and more. We have a collection of full-length YouTube videos to help you learn this math. But if you do need more help with this stuff, as it happens, people could be coming from various educational backgrounds where math was not taught to them, then we do have statistics courses on our websites, and we will be happy to leave the links to them in the description. Okay, moving on. Step number 3, data science and machine learning fundamentals. In data science, you should know stuff like what is data science, data analysis pipeline, data extraction, types of data, techniques like data wrangling, exploratory data analysis, data visualization, and so on. And when it comes to machine learning, you should know what are the types of machine learning models, For example, supervised learning, unsupervised learning, reinforcement learning, and what are the different types of algorithms that are used within these different types of models. And you should know concepts like dimensionality reduction, time series analysis, and finally, after you learn all of these, you should know how to do model selection and boosting. So this is where most of the people start to have trouble because they don't have a set path. And so I recommend to go for a certification. And we have an amazing certification. It's called Python Machine Learning Certification, which dwells into the basics of data science and machine learning and talks all about the various techniques and algorithms that we just discussed. And it prepares learners with the help of a dozen or more case studies. And with many hands-on projects, you'll be building machine learning models yourself in no time. So I'll be happy to leave the link to that certification in the description. Do check it out. You can thank me later. Moving on. Step number 4, natural text processing. So after you're done with data science and machine learning fundamentals, algorithm techniques, and you build a couple of hands-on projects, so you get a good grasp on the basics of machine learning and you can actually build practical models out of it. Next step is to start learning about natural language processing. Here you should learn about text mining and what natural language processing is. You should learn how to extract, clean, and pre-process text. You should also learn how to analyze sentence structures using various tools and models. And then also learn text classification using different models. We have amazing certification for this one as well, which is called NLP with Python certification, where you learn all these concepts and you actually get to do practical labs and you can build projects. And this is a lot of fun because you're going to be able to do that with other learners. So I'm going to leave the link to that certification in the description. You can also check out our YouTube videos on this. And you can also check out our blogs that can help you out in this regard as well. Moving on. So fifth and final step for this roadmap is big data and tools like PySpark, Hadoop, etc. So let's take a look at them. So in terms of big data technology, you should understand the concepts of big data, Hadoop, and Spark. And you should be very good with Apache Spark framework. You should be able to have enough knowledge to play with Spark RDDS. You should properly know the data frames and Spark SQL. And you should be able to use Spark MLlib to do machine learning. And you can understand the basics of Apache Kafka and Apache Flume. And you should absolutely know Apache Spark Streaming, processing multiple batches of data and data sources. And you should know a little bit of Spark GraphX as well. Now, I know all of this is going to sound very complex, but I'm going to give you a link to certification. And then there's so many useful resources that we have on YouTube channel in terms of tutorial for each of these topics that you can explore and you can learn for yourself. But if you do need a little bit of help, don't be afraid. Like we have great certifications, we have great blogs, and we will leave the links to them down below. And if you have any questions ever, don't be threatened by all of this. You can always come to us and ask us. And so before we actually move on to the last section of the video, let's quickly recap. So the first step is to just learn some of the programming languages. We recommend Pythons and they're great libraries for machine learning. And then learn the math needed for machine learning. We went over that as well. The third step is to learn the data science and machine learning fundamentals, algorithms, techniques, and do some hands-on projects. We have amazing certifications for that as well. After that, it is very essential to learn natural text processing and how to do that using different models. And then finally, you should understand big data and tools like PySpark and Hadoop because they're very necessary in today's world because of the amount of data that we're producing every day. And so if you follow all of these steps properly and if you need any help, just let us know. But we want you to become a machine learning wizard. And so we hope through this video that you are able to follow all of these steps and you can get to where you want to go. So the last session is useful resources to help you get started. Obviously, throughout the video, I kind of gave you a glimpse of what are the kind of resources that you can refer back to if you need help during the whole process, during the whole roadmap. But one of the most useful resources that you can find is our YouTube channel. You can find all sorts of tutorials, and especially the stuff that we took a look at. All of the skills that we discussed are going to be on our YouTube Edureka channel. So please go check that out as well if you want to get started. If you have any questions, you can obviously let us know. Another rich source for educational content is our blogs. If you haven't checked out our blogs, I do recommend that you do it right after this video because they're amazing. And for the people who need a little bit of help, don't worry, we got you. We have so many certifications. We're going to leave the links to each of these in the description below. But everything that we went through, there's certification for each one of them. And our master programs covers all of the 5 skills that we spoke about, and it can take you from zero to hero in machine learning. And I just want to point out before I share parting words with you in this video that our master's programs alumni work for amazing companies like Amazon, Google, Microsoft, Cisco, Dell, KPMG, and many more.
Let's start with the core interview questions. First thing, how will you explain machine learning to a school going kid? So in this case, the interviewer is interested to see how you can explain the concepts in machine learning in a very simple manner so that even a school going kid can understand. You can give an example to a kid saying that, okay, your friend has invited you to a party and you meet completely strangers there. So you have not seen them previously, they are just completely strangers to, and you're going to meet them. Since you have no idea about them previously, so you will try to classify them based on the available things that you can visualize. That is like what is the gender, what is the age group, so how are they dressed, how do they behave with you, like what is their attitude. So he will try to classify them based on those features. So this is a pure example of unsupervised learning. So in this case, we don't have any prior knowledge. So in this case, they are completely totally strangers. How is it different from the supervised learning? So in supervised learning, the benefit will be you will have some prior knowledge, and based on that you will try to go. So you can explain to the kid that as you already got identified to those kids, in future you know their names, so you will try to classify them whenever you see them. So that will be the example of supervised learning. So let's move on to the next thing. What are various types of machine learning? So first of all, you have to say that the machine learning is categorized into majorly 3 components. First is the supervised learning, second is the unsupervised learning, and third is the reinforcement learning. So in the supervised learning, it is like learning with a teacher. So training data set is like a teacher is giving you like training the machine. So teacher is trying to train based on the whatever teacher knows. So model is like trained on this predefined data which you have, and it start to make decisions based on the, again based on this rule that it has identified from the existing data. It will try to make some predictions and decisions on the new data. You can give some examples as we have here. In this case, when we have apples and bananas, we feed machine apples and bananas with the label saying that, okay, this is the apple, this is how it looks, this is the set of bananas, and this is how they look. So when you feed it to the machine learning supervised algorithm, so what it does is it tries to identify the patterns which are there with each category. So it will set the rule that, okay, apple looks like this, banana looks like this. So this is the training data that we have provided based on which our supervised learning learns it. And we use this model on the new data set. So for example, in this case, we are using this green apple, and based on the structure which is already there, the green apple is still going to be predicted as an apple based on the shape it has. Okay, so that is the example of supervised learning. Let's move to the next thing, which is unsupervised learning. So in this case, it is like learning without a teacher. So model learns through the observations which are there, and it tries to identify some patterns and structure which will be hidden within the data. So in this case, we are not labeling the data. So model is given a data, and model is left on itself to learn the patterns and relationships out of the data by creating clusters. So clustering is one of the major techniques which are used in the unsupervised learning. There are many, but it is the most popularly used within the unsupervised. So for example, when we feed the apples, bananas, and the mangoes here again, but in this case, we are not labeling them. We are not telling the machine that, okay, these are the apples, these are the bananas. We're just giving it the data, saying, okay, this is what it is. We don't know anything about it. So when we feed it to the algorithm tries to learn the patterns out of it and tries to classify them. It won't say this is apple, this is banana, but it will say, okay, these are similar. So apples are similar, and it'll try to cluster them together. Bananas are similar. It will try to separate them in a different cluster. And mangoes are similar. It will try to cluster them in a separate cluster. So it will try to understand the patterns which are there within the data and give you the clusters out of it. So that is the unsupervised learning. Third part is reinforcement learning. So in this case, model learns with hit and trial method. So assume that we are playing the Mario game, and in the Mario game, the player is called as the agent in the reinforcement learning. We have an environment which is nothing but a game. There will be some predefined actions which agent can take. For example, in the game of Mario, it will be he can move forward, he can jump, he can go into the tunnels, he can fire the bombs. So those are the steps. And based on the steps, your environment will try to reward you. Either it will reward you or it will penalize you. Based on that, your model will get created, which will say, okay, these are the best actions, where when you do these actions, you will get your score more, which is like a reward. And when you don't, you do this kind of action, your score will get penalized. So based on this environment, your reinforcement learning will try to learn those things. So that is one example, and you can also give some examples related to the AlphaGo, which is a Go playing game which recently was developed by a Google-based company. And you can also say that chess-based games can be automated with the reinforcement learning. So there is one more category within machine learning which is not much talked about, which is the semi-supervised algorithm. So which are basically combination of supervised plus unsupervised. So in this case, what happens is you have a data set which is half of it is labeled and half of it is not labeled. So in this case, both supervised plus semi-supervised are used to create your models. So you can also give this so that there will be more confident on you. Okay, so let's move on to the next thing. What's your favorite algorithm and can you explain it in a minute? In this case, interview is trying to understand as how you can explain some complicated techniques and technologies in a very simple and simplistic manner to some higher up people or the clients or those kind of things. So make sure you have some choice and you can explain different algorithms in a simple manner. You keep for every example, try to keep some simple examples so that you can effectively and you can easily explain it so that even a small kid can understand as how you're explaining those things. So how deep learning is different from machine learning? In this case, first thing is you have to know that deep learning is not completely different from machine learning. You have to say that, okay, deep learning is a small part of machine learning. And in the core machine learning, based on the input, first you have to do the feature extractions. You have to classify the features which are the good, which are trying to explain your model better based on some exploratory data analysis, and based on that you will feed it to the algorithms, and those algorithms will try to identify the patterns within those and give you the output. In deep learning, it is a bit simplified. What happens is based on the input, the model will try to extract the features on itself and will try to create a model based on those. So it is trying to combine both the things of feature extraction and classification into a single thing, and it will give you the output. So that's why it is recently being very popular. So that is one thing. And deep learning is basically, if you know, the deep learning is constructed most of the neural networks. So and neural networks are basically borrowed from the idea of the human brain. So how the human brain works and how the neurons within the brain really works in a very complicated and effective manner. So those are the things which have been taken and being implemented in the deep learning. And machine learning is about the algorithms that basically parses and learns the data and tries to identify the patterns within the data, apply whatever pattern learned from the data to the new data whichever is coming. So that is the most of the thing which was related with the machine learning, but deep learning has come a bit more advanced to it. Okay, so explain classification and regression. So classification and regression is part of supervised learning. So you have to say this first, that this is part of the supervised learning. supervised learning is broadly categorized into these two parts, and regression is mostly dealing with the continuous variable. So in continuous variable, it's like you're trying to predict the sales, you're trying to predict the stock market values. So wherever there are continuous predictions, you're trying to do the regression of your data. So classification is like you're trying to predict the different classes which are there within the data. So for example, the classes could be like, is the student going to pass or not? Is my customer going to buy my product or not? And is my salary is within like high, medium, low? So those are the different classes. And when we're dealing with the classes, we say it is classification. And we're dealing with the continuous values, we say it is regression. So in this case, if you see, the regression is like size of your house, area, and the location which are there. And classification is like when you're trying to give it a classes. So very cheap, affordable. So you're creating a 5 classes here, and that becomes the classification. What do you understand by selection bias? In the statistical term, sampling is basically trying to sample some data from your population. So you are trying to take some portion of the data from the population, and when you have some bias to some specific set of data. So let's assume we want to take a population of all the data scientists within India. When you're talking about India, you have to take data from all parts of India. But let's assume you just take the sample from the Gurgaon. So when you just take the sample from the Gurgaon, you're getting a selection bias. You're getting bias to the Gurgaon, and you're just selecting the data from there. So in this case, you're getting bias to those conclusions of your inaccurate conclusions of yours, and you're not making the accurate decisions based for the population. Okay, so that is the selection bias. So what do you understand by precision and recall? So in this case, let's go on with the example. So let's imagine that your girlfriend keep on giving you surprises from last 10 years of your birthdays, and one sudden day she comes to you and asks you, do you remember all birthday surprises from me? And you just get shocked. And in this case, to extend your life, what you do is you try to recall all the 10 surprising events that you had in your previous birthdays, and this recall that you're doing is nothing but the number of events you actually correctly trying to recall it, and the actual events which have happened. So this is the ratio that you're trying to capture of all the recalls that you're doing correctly and the number of the correct events which happened. So for example, if you are trying to recall out of 10 all the 10 correctly, then your recall ratio is nothing but 1. So which is again 100%. But if you're trying to recall only 7 events correctly, so as per the ratio, what will happen is the number of events you can correctly recall is 7, and the total number of events which are there is 10. So in this case, your ratio will be 0.7, which will be 70%. But let's assume you might be wrong in some answers. So for example, you answered you remember 15 times, but out of this only 10 were correct and 5 events were actually wrong. So you remembered from some another events. So in this case, so you recall all the events which are there, but it's not completely precise. So in this case, the precision is the ratio that the number of events you are recalling correctly to the number of events you recall. So which is like out of 15, you are trying to recall the 10 as a correctly. So that is the precision which we have. So 10 real events and 15 answers. So the ratio is the 66% in this case, which is 10 divided by 15. Okay. In the formulas, you can represent all those things in a simple formula. So number of events you can correctly recall are called as the true positive. So which you said as true, you said as a positive, you are able to recall them correctly, and they're actually there. So number of all correct events. So this is also again the true positive which you recall correctly plus the false negative which you didn't recall. Okay, and the next thing is the number of events you recall. So which is true positives plus the false positives. In this case, what's happening is the correct recall that you did, all the events that you correctly remembered, and some which are not correct. So you said, okay, I recall them. So for example, when we had it 15, so in that case, there were some like 10 were correct and 5 were the false positive, which was you didn't recall them correctly. So based on all this above, recall is true positive divided by true positive plus false negative. So true positive plus false negative is nothing but the number of correct events, as we already saw that. So number of events you can correctly recall divided by number of correct events. And precision is true positive divided by true positive plus false positive, which is the number of events you can correctly recall divided by number of all events you recall. Okay. So the next question is explain false negative, false positive, true negative, and true positive with a simple example. So previously we just saw the example where we had an example of the birthday surprises. So you can also go with the example where it will be more realistic, as it will give some impact to it. So for example, the true positive. So in this case, we can take some real example where what the model that we are trying to build, what it does is based on the fire is there or not, it will try to raise an alarm. So in the first case, it's true positive. So in true positive, what will happen is you said you have to do the alarm and there is actually a fire. So there is actual fire and you try to do it. It is the right condition. So that is the true positive. Second is the false positive. In this case, you raise an alarm, but there is no fire. So in this case, what will happen when you raise the alarm? There is no fire, but still people are running. So that is not a good thing, and that is called the false positive. Third example is false negative. So false negative, if you're not raising an alarm even when there is a fire. This is the worst condition that we have in all the situations. So your aim is to raise an alarm when there is actual fire. But this condition says when there is still a fire, you're not raising any alarm. So this is the most harmful thing which can be there and where your model is not working. So you have to be very careful with this thing one. And true negative is something where there is no fire and you have not raised any alarm, which is still good. Okay. What is confusion matrix? So to explain this confusion matrix to your interview, you can take some simple examples such as you want to create a model where what you are trying to look is you have a bank and that bank wants to identify who are the customers I should be giving loan to so that they won't default me. So I have a training data where I know that okay, these are the customers who were good, who didn't default, and these are the customers to whom I gave loan but they defaulted. So that data is used in making these predictions, and you have a model which has done this also. So assume that we have 165 people in the training set, and after doing the prediction, so in the training set, what we have got is in actual 105 people can be given loan who didn't defaulted, and 60 people who bank gave loan they defaulted. So what your model is predicting in this case is it says 110 people can be given loan who will not default and 55 people can be rejected so as they are going to default. But this is on a higher level. But when you look as a confusion matrix, what will happen is you will try to see, okay, how my model is performing and where are the true positives, true negatives, and how should I take care, not take care, but how is it performing at the part of the false positive and the false negative. So assume we have a true positive. So in actual, there are 105 people who the bank's training data says can be given loan who didn't default, but out of that model has identified 100 people, so which is a good thing. And for the no case, for the rejection case, out of 60 people the model says 50, which is again a good thing. But your model says for 10 people who are actually defaulters, but model says you should give them loan. So those are the things which can be looked into the future, but confusion matrix will help you to understand how your model is performing based on the predicted, the model output and the actual data which you have. So what is the difference between inductive and deductive learning? So to help this concept, you can give some good examples such as a father want to explain his son how the fire can burn him. So there are two ways that he can teach his kid as how he can get impacted from the fire. So first thing is he will show him some examples, like he will show him some videos or he will show some demo as how the fire will get him burned. So based on the observations, the kid will learn and make some conclusions out of it. So that is the example for inductive learning, where he will do the observation and see how the things are going to be and make some conclusions out of it. And for the deductive learning, it is like father is letting the kid play with the fire. So the father will wait till kid will get burned and try to make some conclusions out of it and have the observations after it. Like he will get himself burned and then he will say that okay, fire makes us burn. So that is the deductive learning where what happens is first you will make some conclusions and then you draw the observations. Similarly, in the field of machine learning, it is like out of the data you will try to do some observations and these observations are stored as a model, which is like you have observed all the things and kept it as a model. And the deductive learning is like you are giving it a data and based on the previous inductive learning that it has already done, it will try to deduce the output of it. So how is KNN different from k-means clustering? One important thing happens is people are really confused with what is KNN. Sometimes like is KNN clustering or is k-means a clustering? In this question, the clustering is given to you as k-means clustering, but sometimes the interview will just ask you how is KNN different from k-means. First thing you have to do is you have to understand the difference as k-means is a unsupervised technique algorithm and KNN is a supervised technique. In KNN is used as a supervised algorithm. KNN is used for classification and regression, and K-means is used for clustering. As it's a clustering algorithm, it is used to create the clusters of your data. K within KNN basically means it tries to observe the K neighbors. So in the case of regression, it will try to identify the surrounding K neighbors and take the average and give you the output. And in the case of classification, what it will do is it will try to see the surrounding neighbors, K neighbors, and whatever the majority of the class is there, it will assign the class to that. So in this case, K is your neighbors based on which your regression and classification will be done. In the case of K means, it is the K clusters that you're going to create out of your data. So K in the both cases is different and you have to give this differences to the interviewer. So one thing is once you know that okay, K means is an unsupervised and KNN is a supervised, you can further go on top of that. Okay. Can you explain me what is ROC curve and what does it represent? So in this case, interviewer is interested to know how good you understand the ROC curve and how you can use it to understand your model's output. So interviewer is very much interested as how you are trying to use this in your model performance. So as ROC is also one of the performance parameters for your model and this is used in the cases of binary classification. The full form for the ROC is Receiver Operating Characteristics Curve, and its fundamental use started with the diagnostic test evaluations. So in the medical field, its application started and it is used in the machine learning field to do the classification related algorithms performance evaluation. So in simplistic term, it is the plot of true positive rates, which is also called as the sensitivity, against the false positive rate. So what happens is once you get the output in the probabilities, you can use the different cutoffs and you can use the cutoffs to distinguish as what is going to be the true cases and what is going to go for a false cases. And you can plot the ROC curve and ROC curve says when your curve is having 1, your model is good. And the plot with the 50% like 0.5, which is nothing but this blue line, which is the worst case. It's like your model is saying you have a 50% chance in the prediction. It's just saying it's just a normal guessing work. So you're either guessing 1 or 2 with a 50% probability. The more closer to this and more area this curve is trying to cover, the better is the algorithm. So better you're trying to predict the true positive rates than the false negative rates. Your true positive rates should increase faster than the false positive rates in this case. So first we saw like what actually ROC curve does and we will see like how you can interpret it now. So you can give the interviewer some idea about what is really ROC curve, give some details about it, and you can give the technical details like how you can interpret it. So first of all, it is like trade-off. There is always a trade-off between sensitivity and specificity. And one will increase in one will create a decrease in another. So it is really important with the ROC curve, you will see these differences as how they are getting impacted. The closer the curve follows to the true positive rate line and the more area it covers, such as the yellow one, as it is covering the highest area, that is more better than the pink one, and pink one is more better than the blue one. The blue one is, as we already said, is like just a random guessing with a 50% of probability. And the slope of the tangent line at the cut points gives you the likelihood ratio as how likelihood your model is. What's the difference between type 1 and type 2 error? So this is one of the very important concepts which you interviewers trying to understand as how you try to distinguish between the type of errors, or do you understand as how this type 1 and type 2 errors are impacting the performance of your model. So interviewers trying to understand those things, so you can give some good examples to say how these are going to impact. So first thing is, type 1 error is false positives. So when something is not true, which in actuality is not true, but your model is saying it is true. So as we have the example, if a doctor says to a male person that he's pregnant, so it is like something is not true, but you are saying it is true. So which is the false positive and is an example for the type 1 error. And the type 2 is a false negative. So when something you are saying is not there, but in actuality is there. So when you're saying negative, so you are saying it is not there, but in actuality it is false. So that is the false positive. Similar example comes to where female is pregnant and the doctor says she is not pregnant. So this is like your model says something is not true, which is in the negative case, but in reality it is there. Is it better to have too many false positives or too many false negatives? This case really depends on the domain and the type of problem that you're solving. So based on the different problems and the different business requirements, you have to decide on what to have. So there is always a trade-off. You have to maintain the trade-off between these false positives and false negatives, and you have to decide which one we can keep as a more. As we already saw in the previous case, where you can imagine that where a doctor says a male person that he is a pregnant person. So these kind of model is always going to be a problem, and you have to decide like how many of these cases you can manage. So is it like out of 100, can you say that you can manage 10 false positives, or how many you can consider for those, and you can move on with the model. So similarly, there is example wherein the spam filtering. So can you say a good mail as a spam or not? So that trade-off you have to manage, and based on that it will go. So this you have to define beforehand which one you can go on with, and you have to create a model as per that. So these kind of questions are mostly related with the domain specific questions. So you cannot just select any one of it and just give example. So beforehand, just try to understand what domain you're trying to explain, and before that try to first be clear with what is false positives and what is false negatives. After that, select some specific domains and give the examples. So for example, in the medical testing, negatives may provide a false reassuring messages to the patients and physicians that some disease is absent, but you're actually saying it is present. So what will happen in this case is you are trying to give inadequate treatments to both the patients and the disease, which is not required. And these things will cost patients to the medical and the medical agencies, and these kind of things has to be managed. So it is desirable to have many false positives in this case. The other example could be the spam filtering. So in this case, a false positive occurs when spam filtering is blocking or wrongly classifying the legitimate emails. So you can't have that as many times. So users will get irritated when your actual mails are getting into the spam. So in this case, we prefer to many false negatives over the many false positives. So based on the domain, it differs, and you have to give the example specific to those domains. Okay. So which is more important to you, the model accuracy or the model performance? This question, the interviewer is trying to understand how better you know these terms. So do you really know the differences between these terms? So first thing, try to understand what these terms are. In actually, the model accuracy is part of model performance. It is subset of the model performance. There are different model performance measures, and model accuracy is one of them. So for example, let's consider the case of fraud detection. So in this case, what will happen is you will have millions of rows, and within those only very less percentage of rows will have actual frauds. So in those cases, if you look for the model accuracy, your model accuracy will mostly be higher and it won't give you a complete picture of your model performance. So model accuracy is just a subset of the model performance, and there are more metrics that you have to look to understand the model performance. Next question is, what is the difference between Gini impurity and entropy in decision tree? So both, first thing, both the things are used as a impurity measure in decision tree. What do we mean by impurity measure? So first you have to tell the interviewer what is really impurity in the decision tree. So impurity is something as how disclassified your classes are within the tree. As when you make a splits, how your classes are getting split. So Gini is one thing where what it does is it tries to see as when you pick a random sample out of the different labels, what is the chance of it getting picked? It tries to add those probabilities and create an impurity. So it is basically 1 minus those probabilities. The lesser it is, you're more confident that your labels are getting clustered in a different groups and different nodes. Entropy is a measurement of lack of information. So when you're making a split within your data, it tries to identify as how disorganized this data is. Basically, both are trying to do a similar thing, but they are just doing it in a different manner with different mathematics. What happens is, performance-wise, they both are same, but mostly people would go with Gini as it is less computationally overheading, as entropy uses a log function within the calculations, and that is bit computationally expensive. So using Gini, it can be reduced. So mostly people would go with the Gini. So what is difference between entropy and information gain? So when we're trying to make a split within the data, entropy is an indicator like how messy is your data within the nodes which you have. So as you keep on splitting the data based on the different features, you have the nodes and within those you have the labels. And entropy is giving you the measure as how disclassified those are within your nodes. Information gain is something which says how better you are achieving the goal of separating your labels into different nodes. So as your entropy keeps on decreasing, your information gain keeps on increasing. So both are related with each other, and as your entropy is decreasing, your information gain will keep on increasing. Your information gain will keep on increasing as your nodes are getting pure and pure. So node purity basically says as you're getting specific classes within the nodes, those nodes are getting purer. So when we are trying to take specific classes, like our classes are getting segregated based on the tree and the nodes are getting purer and purer. So information gain will keep on increasing as we are moving toward the leaf nodes and the nodes are getting purer, and our entropy will keep on decreasing as we are reaching closer to the leaf nodes. What is overfitting and how do you ensure you are not overfitting with a model? So overfitting is really important concept within the modeling performance, and your interviewer is really interested to understand as how you are confident with those terms and how you can explain those, so that once you explain those things, interviewer is interested to see as you know the machine learning models in the right terms or not. So once you do the fitting of your model, there could be three different ways that your model is getting fitted. So first is the case of underfitting. In underfitting, what is happening is your model is not learning completely what is there within the data. It is biased to a specific set of data and it is not learning the patterns which are there within the data. So when new data comes in, it won't be able to classify it properly or regress it properly. Balanced is a balanced condition where what's happening is your model is learning the patterns within the data in a very generalized manner. What do you mean by generalized is your model is learning it on the training data, plus when you give it a new testing data, it is still able to generalize it what was there in the training data. Overfitting is something which is like very much closely getting fitted with the data which is there within the training set. So it is getting very much closer. It's creating a curve as you see in the diagram, very much closer to the data which is there within the training. So when you give it a new testing data, it won't generalize it very well. So you have to be sure in overfitting, it's trying to create a model which is very much learning all the parameters in an exact manner from the training data, which shouldn't be the case. The next part is how do we ensure our model is not overfitting. So for this, there are multiple ways that we can control the overfitting. First is we collect more data. So as we have lesser data, our model will try to get very much exact to what is there within the training data. Getting more data may help it to generalize well. Second is using ensemble methods that average the models. So when we split our data into multiple components, or we use multiple models which will try to understand data in a different manner, each model within ensemble will try to understand the data in a different manner. They'll try to capture the different patterns, and when you try to average those, your overfitting will reduce a bit. Choosing simpler models. So simpler models are like logistic regressions, where you understand what is happening. In logistic regression, you will get a parameters as how the coefficients are there with each of your features. So you can try to understand what is really happening and try to make some tweaking to the model with the simpler models. Few more thing is you can try to add regularization. So there are regularizations called L1 and L2, which basically penalizes your model when it tries to overfit or underfit. It tries to balance your data and it doesn't let it overfit or underfit. You can set the boundaries as how stricter you want to be with the regularization. So that is the fourth step. Explain ensemble learning technique in machine learning. So first of all, you have to explain. So interviewer is interested to see how you can explain the theoretical part of it plus the practical part of it. First, as a theory, ensemble is nothing but different models combined together, and each model is trying to understand the data in a different manner. So each model will try to capture different patterns within the data. All are weak learners. So in this case, they are called all are weak learners, and when we combine them together, they become a better model. A single model is created out of it, which is a better predictor model. So if you see the example which is there below, it is like we are feeding a different set of data and we are creating different models. So these are the different models which are creating out of the different samples of our data. And this all models are combined into a single model. And based on the new data, output of all these models are combined together and your single output is created by merging all the outputs of different models. So in the case of regression, it is mostly like you try to average those values and create a new value. In the case of classification, you try to take the majority of all those. So ensemble learning is basically learning from committee or crowd. So you basically train a large number of models and then try to combine their predictions and create a single conclusion out of it. So for example, when we split our data set into different samples, and those each sample is fed into a similar kind of algorithm. For example, the decision tree. So we create 100 decision trees on 100 samples of our data, and each model is trying to capture different patterns of your data. In the end, we try to average all the outputs of these 100 models and we take a single output. So the ensemble model's power is very different and they are very popularly used to control the overfitting of your models. So there are two components, there are two types which are there in the ensemble model. One is the bagging and the other is the boosting. So you can just give the theory about like how both of them works. So boosting is something where what we are doing is we are trying to sample the data. Different samples are trained on similar kind of algorithms such as the decision trees, the logistic regression, or the SVM. On all samples, a single algorithm is used. And at the end, you combine all the outputs of these models, and that is the output of the bagging. And boosting is the algorithm where what happens is your each model is trying to understand the misclassifications which are there within the previous model and try to learn those. So each model, the next model will try to learn the misclassifications which are there within the previous model and become better and better. And again, the combined output of all this is taken to create an ensemble of it and use it. Yeah. So this example is similar to a bagging algorithm where what is happening is we have a different samples of data and we are using a model. So let's assume we are using a decision tree in this case. So we are training decision trees on each of these models, and in the end, output of these models are being fed to a whole ensemble, and ensemble model, it will try to aggregate all the responses from these models and give a single output. So as a single learner can't do this whole together, would do. So that is the power of ensembles, as each one is trying to learn different parts of it and give you a single output which is more powerful than the single algorithm. So what is bagging and boosting in machine learning? Both bagging and boosting are nothing but the types within the ensemble models. And as we know, ensemble models are nothing but collection of different models. They are also called as the weak learners. And we combine all these weak learners output to create a single learner, which is a better predictor of your than the all weak learners. So both generate data from the sample. So you take a random samples out of your data. It is mostly with the replacement, as you take a data and you again replace it and you again take a different sample of it. So it's called the random sampling of your data. So in both the cases, all the weak learners are aggregated to create the final output. So in the case of classification, you try to take the class which is coming as the highest. If you're training 100 models and you have a binary classification, assume that out of 100 models, if 80 models are predicting that your class 1 should be there and 20 models are predicting your class 2 should be there, then in ensemble, class 1 would be selected as the output. In the case of regression, it is like you're trying to average all the outputs. As it's a continuous data, you try to aggregate all the output from the different models. So both are good at reducing the variance. So as both are good at reducing the variance, as they are trying to learn different models, they reduce the overfitting of your data, and in effect, they also reduce the variance which is available within the model. So as part of the differences, boosting what it does is it tries to learn different weak learners. Is different samples are created and each sample is trained on a similar model. So for example, if we are using decision tree, on all sample we use decision tree and each one predicts their performance. Whereas in boosting, what it does is it tries to learn from the mistakes that the previous model has performed. Each model is a better version of the previous model. So boosting tries to weight the misclassified classes which were there in the previous model. And so as it keeps on moving, it tries to change their weight and create a new model so that the new model will give more weightage to the ones which were misclassified in the previous model. So with this, it keeps on improving itself. Bagging gives equal weightage to each model's output while creating ensemble output of your model, whereas boosting gives a different weightage to each model. As each model is an improved version of the previous one, they have a different weightage and the data weights are also changed as within the each bagging model. So your weightage is also changed while you are aggregating the output of your boosting data. So as an ensemble model, both bagging and boosting helps you to solve the problem of overfitting and in effect helping to reduce the variance. Boosting tries to also reduce your bias, which is nothing but underfitting. As you keep on learning from the previous mistakes, you're getting better and better with the instances which are not much good, which is the bias. How do you screen for outliers and what should you do if you find one? In this case, your interviewer is interested to know as how you give importance to the outliers, how you understand them, and when you find them, how you are trying to improve your models with the outliers, how you take your decisions once you know you get the outliers. So first thing, you screen the outliers using different ways. So some of the ways are, one is the box plot. So box plot really helps you to understand when you plot the data, you see that box plot uses an formula of IQR, which is interquartile range, multiplied by 1.5 plus your third quartile minus your first quartile. This 1.5 multiplied by IQR is added to the third quartile to create the outliers on the top, and from the first quartile it is subtracted to create the outliers in the bottom line. So that is one way to screen the outliers using box plots. Second is the probabilistic and statistical model. So using the properties of different distribution models, such as the normal distribution, the exponential distribution, the way your data follows it, you can see if your model is following those distributions or not. And the cases where it is following very outside boundaries of your distribution, you can treat them as outliers. Third is the linear models. So with the linear models, you can try to see as, for example, in the time series linear model. So when in the time series linear model, when you're learning the data, whenever a new outlier comes in, you will try to screen those. For the linear models, such as the logistic regression, you can try to flag them pre-hand as, okay, these are the outliers, flag them as 1. These are the non-outliers, flag them as 0. And your model will try to learn which are the outliers and which are not. And in future, you can use those models to screen your outliers within the data. And the last is the proximity-based models. So proximity-based models is like k-means clustering. So you use the k-means clustering to create a clusters within your data, and the ones who fall outside of your clusters or outliers will form themselves their own cluster, and you will see that you will have your classified versions of your outliers. So that is with the proximity based models. How do you handle these outliers? You have to take a decision very carefully in this case as how important are these outliers to your data. And when you have a very high data and you can risk dropping those outliers, then you can go on with that, or you can cap your data using the percentile. So mostly what people do is they use the 99 percentile or 95 percentile. So whatever the values are above those percentiles, your outliers are capped to those. So your outliers will get reduced. The last option is impute based on some rules. So based on some business rules or the data exploration that you do, using those, you can impute your outliers so that you can go on with the model creation. What is collinearity and multicollinearity? So this is one really interesting thing as what happens in this cases. So collinearity occurs when you're trying to do a regression on a multi-features and you see that your two of the predictors are correlated with each other. For example, let's assume you have a date of birth and the age. So when you have both of this, your date of birth and age is always going to be correlated with each other. So in those cases, these two features are part of collinearity within the regression. Multicollinearity is something which occurs when you have more than two variables which are correlated with each other. So we can extend the previous example, which is we have the age, we have the year on which he was born on, and the class that he is on currently. So for example, if he is on 5th class, he is on 7th class. So those are also going to be correlated with each other. So in this case, we have three predictors which are correlated with each other. So what do you understand by eigenvectors and eigenvalues? So let's just see a bit of example to understand what is really happening in this. So in the left case, if you see, we have a square matrix which is being multiplied by a non-zero column matrix equal to again some a non-zero vector. And on the right side, if you see, we are getting an equation where our original square matrix is being replaced with 3 and we are still having the column vector. So we are able to represent the whole thing which is there on the left side to the right side by replacing the scalar. So the scalar in this case is called as the eigenvalue in the original vector, and the multiplication that we are doing, the second vector is called as the eigenvector. So let's see the mathematical definition for this. If you see this equation, ax is equal to lambda x. So in this case, eigenvector of your square matrix A is a non-zero vector x such that for some number lambda we have this equation. So in this case, we have this square matrix A multiplied by our eigenvector gives us a lambda multiplied by eigenvector. So we are getting a scaled down version of the scalar square matrix as a scalar, and which have its own applications. So for example, how is this thing used? So a few of these use cases are eigenvectors are used to understand the linear transformations which is there within your original square matrix. So in data analysis, we visually calculate the eigenvectors for the correlation and covariance matrix of the original data. So whenever we have any data, we can calculate the correlation matrices, covariance matrices, and we can calculate their eigenvectors from those matrices. What this basically gives you is how much of your transformations are there and within the data, and these eigenvectors calculated from these correlation matrices can be used in the further algorithms called the PCA and the factor analysis, and these algorithms really helps you to reduce the dimensions which is there within your data. So that is from the point of data analysis. The other applications are eigenvectors are the directions along which a particular linear transformation acts. So when you apply some linear transformation, this eigenvectors are actually giving you like in which direction those transformations are being applied. So this is like when you apply this transformation, what is the direction which is being there. It can also be used to do the compressions within the data. So eigenvalues and eigenvectors are also used in the image field where images can be compressed using those values. What is A/B testing? So A/B testing is a statistical hypothesis testing which tries to compare different cases. So in our cases, we want to measure how different model performs as compared to each other. So assume that in production you have a model which is already running and tries to see how your users are clicking through your products and they're buying those products. So your model basically predicts some recommendations of the products and captures like how what is the ratio that once you recommend them and they buy it, you introduce another model into the system which is just limited to few users, and which also does is it recommends few products and captures how many of them are actually buying those products. And using some hypothesis testing such as the t-test, ANOVA test and different tests, A/B testing tries to identify which model is better, which is trying to give you a better output in a comparison. So you can give the examples to the interviewer as in the cases where we want to identify when a user clicks on the pages to increase the outcome of the interest. So some websites, what they do, they try to introduce different functionalities to different users and see how different functionalities are creating a better outcome and better revenues. And they use those things in the future. So what is cluster sampling? So when you have a population and within a population, you have different clusters available. So for example, the previous example that we saw when we want to find out salaries of all the data scientists within India. So we have different clusters like we have a cluster of Gurgaon, we have a cluster of Bangalore, we have a cluster of Mumbai, Pune, Hyderabad. So these are the different clusters which we have within which there are different data scientists. When we try to randomly select those clusters for our analysis, that is called as the cluster sampling. So in this case, the sample is nothing but different clusters and we are trying to select those samples. So for example, if managers are your samples, then companies are basically clusters and we do the clustering of these different companies. When we select random clusters of these companies, that is called as the cluster sampling. So running a binary classification tree algorithm is quite easy. But do you know how does the tree decide on which variable to split at the root node and its succeeding child node? So you can explain the things we have discussed already about the Gini and the entropy parameters. So what Gini does is it calculates for subnodes what is the probability and success for each classes, and that is done by it squares the probabilities of success like p square with the q square, which is the probability of success for each class and the probability of failure for other class. Once these probabilities are calculated, your weighted Gini score is calculated for each node. So whenever you have a lesser Gini score, you go with that feature for the splitting of your nodes. So entropy is a measure of impurity or randomness within your data. It's like how misclassified your classes are within the nodes. So it's for the binary classification. When you have the binary classification, we have the probability of success, we have the probability of failure. So for the positive class, we have the probability of success, and the other one, we have the probability of failure. So we use the entropy formula to calculate which one to split. So for whichever variable we have the lesser entropy, we go with the split of that node. So entropy is basically zero when a node is homogeneous. So when everything is within a single node and your node is completely pure, your entropy becomes zero, where a node completely contains a single class. When a node contains a 50-50% of your class 1 is like if it is 100 rows and 50 of them are class 1, 50 of them are class 2. At that point, your entropy value is highest. So the maximum value it will take when you have both the classes in an equal number within the nodes. The final agenda is to lower the Gini or the entropy. For whichever feature we have the lower value, go with the split of those for the current parent node. So now we are done with the core machine learning, so which were mostly related to the theoretical aspects of the machine learning. Now we will start with the Python related questions with the machine learning. As machine learning can be done with different languages like R, Python, SAS, but currently we are more focusing on the Python, and we will start with our practical questions which are there with the machine learning. So first question is, name a few libraries in Python used for data analysis and scientific computations. In this case, interview is trying to understand. So in the initial level, he will try to ask you these questions to gauge you if you really know about the core libraries which are used for the data analysis in the Python or not. So the core libraries which are there within Python are NumPy, SciPy, Pandas, and Scikit. So first of all, NumPy. NumPy is a numerical library to deal with the data. So as the name suggests, it's a numerical pie. So it tries to deal with the numbers. So all the core libraries such as the SciPy, Pandas, Scikit uses NumPy to store the data. So those are the core storage format for all the data in data analysis. So SciPy, its full form is basically scientific Python. So it basically gives you a library to deal with all the different kind of mathematical functions. So you can do Fourier transforms for the audio related data. You can go with the optimizations. You can go with the interpolation. So these are just a few examples, but all the mathematical related tasks you can go with the SciPy, and SciPy uses, as we already discussed, in a core NumPy to store the data. So Pandas is a data analysis library again where you can store the data in a tabular manner, which is called as a data frames, and data frames are very powerful function within Pandas. So data frames gives you a data manipulation access. You can access the CSVs, you can load the databases, you can load the Excel files, and you can do your operations on top of it. You can do the aggregations, merging, and all those kind of analysis related to the data you can do with the Pandas. Scikit is purely a machine learning library. What it gives you is access to the different machine learning models you can use. So it contains a different components. It contains a pre-processing component where you can do the pre-processing of your data. It provides a library for that, and it also provides you a different modeling library where you can access all the core machine learning models. So on top of that, we have Matplotlib, which is a purely a data visualization tool. So with the Matplotlib, you can visualize your data in a very efficient manner and in a faster manner. And Seaborn is something which is built on top of Matplotlib and gives you a more better visualization of the data and gives you different new kinds of visualizations which are not there within the Matplotlib. So you just can give this detail to the interviewer, just list them all and give a bit of the description about each of them. So that would be enough in this case. Which library would you prefer for plotting in Python language? Seaborn or Matplotlib or Bouquet? So all these three have their own applications. So preference is something would come based on the thing that you are currently performing with the data analysis stage. So for example, when you're doing a quick analysis within your data, so you want to have a quick access to the charts, then you can use the Matplotlib. For example, Matplotlib provides you a quick access to the bar charts, pie charts, histogram, line charts, scatter plot. So for the quick analysis and the data exploration, you can go with the Matplotlib. Seaborn is something which is built on top of the Matplotlib. And you can use this when you want to do a bit in-depth analysis of your data. For example, when you want to have a statistical analysis within the data, and Seaborn gives you a bit more types of graphs which are not there within the Matplotlib. So for example, when you want to have a distribution charts with a more detail, so Seaborn provides you charts such as the violin plots, it gives you a KD plots. So for the detailed explanation of your data, you can go with the Seaborn. Bouquet is something which is an interactive visualization. Bouquet you go when you want to present your data to something of the outside world, when you want to publish it on a web and you want your user to interact with the data, then you use Bouquet. So when you go to the outside and you want to publish your visualization to the outside public, you use Bouquet for that purpose. So how are NumPy and SciPy related to each other? So this thing you can give a bit of detail as what is really NumPy first and what is really SciPy. And the thing is SciPy is a bigger library and NumPy is part of it. So NumPy is a smaller part of SciPy. NumPy helps you to define arrays and you can perform some operations on top of those arrays using the NumPy libraries. So different types of operations are like indexing, sorting. You can change the shape of it. You can change the matrices. You can create a splits within your data. You can merge different arrays together. So NumPy will help you with all those. SciPy, you can go to a next level when you using on top of those NumPy arrays when you want to create some mathematical formulation. You can go with the SciPy. So when you want to do the optimization, you want to do the Fourier transform, if you have audio data, for those kind of applications, you can go with the SciPy. So what is the main difference between a Panda series and a single column data frame in Python? So interviewer, he would like to really understand if you know the core concepts within the Python or not. And pandas is something which is the core of the data analysis, as all your data is stored within pandas and you're dealing with pandas most of the time. So in this case, interviewer will try to gauge you as you know the basic terms which are there within the pandas or not. So first thing, data frame is something which can store multiple columns, but a series cannot store multiple columns. So series is just a single column, but with the data frame, even if it's a single column, you can go with the multiple columns, you can add the columns to it. And there are some limited functions which are there with the series, and data frame has additional functions on top of series. So for example, LOC is a function which is there on top of this. So data frame is the upper level layer on top of series and gives you more control to the data. But the basic difference is with the series, you just have a single column, but with the data frame, you still can add more columns to the data. How can you handle duplicate values in data set for a variable in Python? So in this case, you may have to write a code and show to the interviewer that how you can really achieve this thing. So you can just import the pandas library, show that you are just reading a random file using the pd.read_csv, and you use the build data frame.duplicated to get the list of all the duplicate values which are there within the data, and just show that you can also drop those columns if sometimes we want to drop those, thereby some mistake created by the collector. So the duplicate values can be removed using the drop_duplicate columns. So these two functions you can try to show and explain them what they do. That would help you in that. Write a basic machine learning program to check the accuracy of the data set, importing any data set using any classifier. So in this case, you're not limited with what data set you are loading, what data classifier. The important thing which you have to show is how you are loading your performance parameters, and things that the interviewer will gauge is how you are trying to use the performance metrics. Are you trying to use it on the test set or the training set? Or you're trying to use it on the train data or just a test data? So you have to be very sure, as you don't have the computer to do the output, you just want to write it. So you have to be sure that you are using a test set to show the accuracy parameter, and you have to use both training y and test y in this case. So you have to start with the complete program. You have to show all the steps which are involved within the accuracy part. So you have to start importing your data. Just take some random data. You can just show that you are reading some data and try to separate your data into the X and Y, the target data and the predictor data, and try to create a split within the data of train and test validations. You can use whatever ratio you want to use. You can use 80%, 70%, 50% as you like, but you need to give some justification to that also if your interviewer asks for it. Once we have split our data into train and test set, the next task is to use the classifiers to train the data and create a model out of it. So you can use any classifiers here, but choose something which you already know better, because interviewer will ask you whatever model you're going to use in the next step. So you have to be sure whatever you're using, you know it better. So once you have created an instance, you can use it to fit it on the training data. So use the X train data and the Y train data, create a model. Once you have done that, you use it to make predictions on top of the test data. So you use the X test and create a predictions out of it. And accuracy tries to compare your data, like your original data and whatever predictions you have done, and give you a score out of it. So you will load the metric accuracy score from the sklearn metrics. Once you have done that, you use the print to use the accuracy score, and accuracy score will take two parameters. One is the original matrix, which is the y-test, comma, the predictions which you have currently made. So once you get that, it will create an accuracy measure for that. So accuracy will be nothing but the true positive plus true negative upon the all data. So it will calculate that and give you. The interviewer in next step may ask you like, how can you improve the accuracy score? So once you put the accuracy score, the next thing the interviewer may ask you is, how can you improve the accuracy score? So you can go for three simple steps where you can try to increase the accuracy of your model. First simple step would be try to see if you can make some tweaking into your probability cutoff. So the default probability cutoff is 50%.
So the ones which are above the 50% is tagged as 1, and the ones below the 50% probabilities are tagged as 0. So if you are changing it to something like 0.8 and then checking the accuracy, if it makes changes to your model, it is still good. If it doesn't, the next step would be try to see if you can find out some better features using some feature importance algorithms such as random forest, and different tree models are available which will give you the better features as per the target. So you can use those features and train a model so that you will have your accuracy increased. And next step would be create some new features and see if your model makes any improvement in your accuracy. You can make some new features or you can add some more data so that it will help your model to generalize better. For this part, we have completed with the Python related interview questions of the machine learning. So this was more of a technical part of it where we saw how we can code, how we can show the interviewer that interview is more interested to see how you can code the things and how confident you are with those things. Okay, so now we are done with that. We will now move on to the scenario based questions where we will see some puzzle kind of things, and the other are real problems where the interview is related to understand as how you try to solve those problems. Let's start with those. So you are given a data set consisting of variables having more than 30% of missing values. Let's say out of 50 variables, 8 variables have missing values higher than 30%. How will you deal with them? So missing values could be of any reasons. So something like it's your data got corrupted while storing and you got a missing data. The person who collected the data may have done some mistakes and that data is treated as a missing data. Or it could be like there is nothing for those kind of values. So it's like it is supposed to be blank and it's supposed to be missing. So there are different conditions for those. So let's see how we can try to handle those things. First, we can create a new feature which will say, okay, this much of the part is non-missing and this much of the part is missing. So we can assign it 1 and 0. We can create a new binary variable. It's possible that this thing is trying to give you some idea about the data and there will be some hidden pattern within your data because of this some missing values. So it's possible that creating this new feature will help your model to give the better accuracy and give the better performance. Second thing, we can remove that completely. If you have a high count of data, so for example, if you have a very good amount of data and you can say that, okay, I can leave with removing this 30% of the data, then you can blindly remove this. If it is not giving any value to you and you can't spend much time on trying to improve it or trying to impute it, then you can blindly remove it. Or you can check the distribution. So for example, there are different ways to check how your missing values are to the similar cluster. So some examples are, you can see your missing values are clustered on some other values. So can we give those cluster values to those missing values? So it's like identifying clusters and based on those clusters, we give values to the missing data. Or the second thing is we use the distribution. So if they are continuous in nature, we can use the distribution to assign some data to them. So write an SQL query that makes recommendations using pages that your friends like. So assume you have two tables. First table is a column table of users and their friends. Second table is a two column table of users and the pages they like. It should not recommend pages you already like. So why would interviewer ask an SQL question in this case? So it is like he's trying to understand how better you know the recommendation engines from the database point of view. So it is like he's trying to understand your knowledge in a different term. So first thing, you have these two tables. So first table is including, you can assume, you have to make some assumptions and draw the picture of this two tables first. So first table will include a user ID and a friend ID. Second table will include a user ID, the page ID they have liked. And then once you have this structure of these two tables ready, the next step is to merge them together based on the friends. So as we are interested to know as which friends are liking which pages, and based on that we want to recommend it to the original user. So first thing is we have to combine these two tables using a unique key which is the friends ID. So we join these two in the SQL using the friends ID. That is one condition. Second condition says it should not recommend pages you already like. So what you do, you have to have a way where you can exclude the pages which were already liked by that user. So this can be done by an inner query. which you can use here to select the pages which that user has already selected. And in the where condition, you can say the page should not include this. So if you look at the whole query again, we are first selecting the first table user ID, the friends table user ID, and the likes table page ID from friends F join like L. So we are trying to join them together on friend ID and the user ID. Second is, as we mentioned, that was the first thing. And the second thing is we try to remove the recommendations, the pages which he has already liked. So which we'll do by page ID, not in the pages which he has already liked. So this is the condition which is trying to do this. And this is how you can explain this thing to the interviewer. So there is a game where you are asked to roll two fair six-sided dice. If the sum of the values on the dice equals 7, then you win $21. However, you must pay $5 to play each time you roll both dice. Do you play this game? And in follow-up, what is the probability of making money from this game if you're playing it for 6 times? So the first condition says if the sum of the values on the dice equals 7, then you win $21. But for all other cases, you have to pay $5. So in this case, if we first assume all the possible cases, as we have fair six-sided dice and we have two of them. So there is 6 multiplied by 6. We have 36 different cases. And out of it, having two dices equal to 7 is like we have 1 and 6, we have 2 and 5, we have 3 and 4, we have 4 and 3, we have 5 and 2, and we have 1 and 6 again. So those are nothing but 6 possible chances are there out of 36. If we take a ratio, 6 by 36 will give us 1 by 6 ratio. So this says we have a chance of winning $21 1 in 6 games. So assume that we are playing 6 games and out of it we win 1 game of $21 and 5 games we lose. So in this case for 5 games we have to pay $5 and this will be $25 and we are winning one time which is $21. In this case if you see there is a loss. So we are paying $25 and we are winning $21 in this case. So for the first question, do you play this game? This is no, as we are getting a loss as per the probability. The second question says, what is the probability of making money from this game when you are playing it for 6 times? If you assume in this case, we are making 6 games and out of that, the winning probability, if we just have a win in one case, it be a loss. If we win 2 games out of 6, we are going to win. If we win 3 games, it will be profitable again. So 2, 3, 4, 5, 6 are the cases where we will see a profit. So this case can be simulated with the binomial distribution. So binomial distribution takes 3 parameters. First is your probability of winning and losing. So that is in our case nothing but 1 by 6. The second is the number of plays, which is 6. And the third is the number of cases that we want to identify. So for example, in our case, we want to have a condition where the number of wins is greater than 2. So we want to identify. The first case is a failure where in the first case we are always losing. But in the second, if we win 2, 3, 4, 5, 6 times, we will always be winning. We will have a extra money. We have to find a probability where we will have more than 2 wins. So that can be simulated with the probability to get the answer for the second question. So the next question, we have 2 options for serving ads with newsfeed. So first is out of every 25 stories, one will be an ad. Second is every story has a 4% chance of being an ad. The question says for each option, what is the expected number of ads shown in 100 news stories? If we go with the option 2, what is the chance a user will be shown only a single ad in 100 stories? What about no ads at all? So in this question, if we look at the first part, which says for each option, what is the expected number of ads shown in 100 news stories? So let's check it for the first one. So for the first one, out of every 25 stories, one will be an ad. So this is like 1 out of 25. In the second case, every story has 4% chance of being an ad. So this is like 4 out of 100. And which is again nothing but when we divide 4 by 100, we will have 1 by 25. So for the first question, the answer is both are similar. So both the cases have expected number of adds in 100 similar, which is 1 by 25 or 4%. Both are equivalent to each other. For the second question, you have to see is the question asks what is the chance a user will be shown only a single ad in 100 stories. If you see this question, it is an example of binomial distribution. So as we just saw in the question 3, binomial distribution takes 3 parameters. First is the probability of success and failure, which is in our case is 4%. Second is the number of total cases, which as the question says 100 stories. Last is the case that we want to identify, means probability that we want to find out. So the question says what is the chance a user will be shown only a single ad in 100 stories. So we want to have the 3 parameters as 4%, 100 stories as our n, and single ad as our probability chance. So if you see, the probability can be calculated as 0.96 is basically not getting selected, which is 1 minus 0.96 raised to 99. So 99 cases are not going to selected. Multiply the chance of selecting, which is 0.04 raised to 1. So we are calculating a probability of not getting selected of 99 samples and getting selected of one sample. So this is the binomial distribution for selecting one ad out of 100 stories. The second question just says what is the probability of no ad at all. So in that case 0 and 99 would become 100. So 100 multiplied by probability of one case. So it will become 7.03%. The only thing is you have to identify like which distribution is highlighted from your question. So sometimes you will see that normal distribution kind of questions will be there where you have mean, standard deviation, and based on that you have to identify different things. In this case it was binomial, so based on the parameters which are there in your question, you have to identify which distribution you can use for that and try to solve it. How would you predict who will renew their subscription next month? What data would you need to solve this? What analysis would you do? Would you build predictive models? If so, which algorithms? This question is very generic, and interviewer is really trying to understand how you try to approach your problem. So when you are given a problem, how you try to identify different components which are there within your problem, how you try to solve each of those confidently, as how much of your knowledge is there within each of it. So what you have to do is let's assume something as first thing, how would you predict who will renew the subscription next month? Let's assume we are trying to predict the subscription for Dish TV subscription. So who is going to renew the subscription next month for the Dish TV? So that is the problem statement first. We define it. What data would you need to solve this? So in the case of Dish TV subscription, we would like to identify how many number of hours for that household the channels are active, how many number of kids are there in the home, how many number of adults are there in the home, which are the different channels they use, for how much time, and from previous month, how much increase or decrease has happened in this month. So this all variables would help you to understand if in the next month again that customer is going to buy or not. So if there are kids in the home, there are chances that because of kids, whenever there are kids, they will look for the TV, and kids will always help you in understanding if there will be subscription or not. And if the subscription has either increased or decreased from the previous month, will also help you to understand if that user usage has increased or decreased. So that will help you to understand the trend and make your prediction better. So what analysis would you do? So we would like to do the classification analysis in this case. We want to identify, okay, this customer is going to subscribe next month, this customer is not going to subscribe. So this is a pure classification related problem. Would you build predictive models? Yes. So for the classification related problem, we would like to build a predictive model. So we would already have a historical data. We will gather the data which is already existing and use that to train our model. So we can use any algorithm. So we can use any classification related algorithms in this case. So we can use random forest, we can use logistic regression, we can use neural networks, whichever we can try different models and see which one performs better and based on that we can continue with the model which performs better and tune it further. So you have to start with the step by step and show that okay, this is the next step, this is the next step till the end of your model. So even in this case, if so, which algorithm would not end the problem? Algorithm you have selected, after that you have to validate your algorithm. It will even go that in production, and within production you will also validate again and see in real life how it's working, make again changes to the model. So those things may change again as the interviewer may keep on asking you the further things, and you have to be ready for those things. Interviewer may start with few questions, but as you keep on solving the problem, interviewer would keep on digging further as what would you do next. So you have to be ready for all those things. So be prepared for those things. How do you map nicknames Pete, Andy, Nick, Rob, etc. to real names? So this is like understanding how you try to solve a problem where there is not much of data is there. So this example is just you have just a nicknames and you want to identify the real names to them. So this can have different answers. It is not related to a single answer and there is no generic fixed answer. But interview would be interested to know as how you are trying to approach the problem and solve it. So few things could be like, as you don't have any data, first you try to gather as to which components these things are related. So for example, if you are trying to understand these nicknames from a Twitter tweets, try to see who is trying to refer to who, and based on these nicknames, see the relation as which person is trying to talk with which person, and you can try to identify based on the NLP algorithms as what is the real names for those people. So similarly, you can try to identify in the Facebook, or if you have some customer feedbacks and within those customer feedbacks, you want to understand this, you can do it that way. But this would be more like you have to understand in the context. So in which context people are talking to whom, and based on that, you can try to identify the real names. So this is just a one example, but it is not related to just single one. You can create your own, as I said, there is no single answer to this problem, but it mostly depends on how you are trying to approach that problem and solve it. A jar has 1,000 coins, of which 999 are fair and one is double-headed. Pick a coin at random and toss it 10 times. Given that you see 10 heads, what is the probability that the next toss of that coin is also a head? So let's first try to split the problem statement that we have. So the different components are, we have 1,000 coins, of which 999 are fair. So for the fair case, we can say that okay, there is 0.5% probability that it could be head or it could be tail, and one is double-headed. So it is not having probability and it is just 100% probability that it's a head. We pick a coin at random out of this 1,000 and toss it 10 times. So each time we select a coin, we toss it. We select a coin, we toss it. So we try to do it 10 times. Given that you see 10 heads, what is the probability that the next toss of that coin is also a head? So let's see what we can do in this case. So basically we have two types of coin which can be chosen in a two different ways basically, and there are probabilities associated with each and they are different. So for the first type of coin, which is fair, we have 999 out of 1,000, so which is 0.999. And the chances of selecting the second coin, which is unfair in nature, is 1 out of 1,000. So these are the probabilities that we have got first. Now, as the question says, we have already chosen 10 heads. We have already done some experiment and we have got 10 heads. So what is the probability of selecting those? So selecting 10 heads in a row is equal to the chances of selecting fair coin multiplied by getting 10 heads plus selecting an unfair coin. So if we see that, first thing is selecting 10 coins from the 999 fair coins is, we have the probability 0.999 multiplied by the fairness is basically probability 0.5 raised to 10, which will give us 0.999 multiplied by 1 by 1024. So when we multiply this, we will get a chance of selecting coin A, which is nothing but selecting the 10 coins from the fair coins. The second part is the probability of selecting the second coin, unfair coin, multiply by 1, which is basically everything is head there, as we don't have anything, everything is head, so it is 1. So probability of here is 0.001. Probability of A says selecting the 10 coins from the fair coins. Probability of B says selecting the 10 coins from the double-headed ones. Now the second question says given probability of fair coins, what is the chance of selecting the coin from that? It is like a conditional probability, and in this conditional probability, what we are doing is we are dividing the probability of A given probability of A and B. So given both of them, what is the probability of selecting the coins from the fair coins? This is the probability. And the second part basically says given double-headed sided coins, what is the probability of selecting from that? So these are the two individual cases. Once we have got that, we have to create a combined probability which will include the chances of selecting the coin from the fair coins multiply by 0.5 plus the chances of selecting the coin given it is the double-headed multiply by 1, and this would create a combined probability and give you the output as 0.7531. So for this case, we have to go step by step, divide the problem into smaller parts and get to the answer of it. Suppose you are given a data set which has missing values spread along one standard deviation from the median. What percentage of data would remain unaffected and why? In this case, there is not much details about how is the distribution of data. It is just said that there is a one standard deviation from the mean which is missing data. So we have to make some assumptions. So as most of the data follows a normal distribution, we would assume that this data is also following a normal distribution. And we would say that, okay, a normal distribution has within one standard deviation a 68% of the values. So as per the normal distribution, within one standard deviation, around the mean, median and mode. As for the normal distribution, all are equal. All mean, median, mode are at the same location. And from the mean, around one standard deviation, we would have 68% of the values. And as the question says, missing values are spread along one standard deviation. So 68% of the values are basically missing, and question asks what percentage of data would remain unaffected and why. So everything left after the 68% would remain unaffected. So we would say 100 minus 68, that would be 32. So 32% of the values would remain unaffected by missing values. You are given a cancer detection data set. Let's suppose when you build a classification model, you achieved an accuracy of 96%. Why shouldn't you be happy with your model performance? What can you do about it? So first thing is, as this thing is mostly related to the domain of cancer detection, interview is trying to gauge you as how better you know as so how the accuracy of the models works in a different data distributions. So if we look at the cancer detection domain, in the cancer detection domain, very few of your data points would have actual cancer. So for example, if you have a 1 million patients data, out of that you would have like around 1,000 of them would be having cancer. So it's like a very small set of data is having actual cancer. So let's assume we are creating a confusion matrix. So when we create a confusion matrix, we see that in the true positive, which is just 1,000 values. So even if our model tries to identify like 500 of them, so we'll get in the true positive 500. And let's assume in the true negative, we are getting all the negative values, which is 1 million minus 500, which went into the positives, and everything remaining will go into negative. So if you create the accuracy, it is like 500 divided by whatever is there in the remaining parts. So 500 is what you got a true positive values, and something you will get in the true negative. And when you divide it, you will have a bigger accuracy. So your model will give like 98%, 96%. As your true positive is actually very small, your true negative would be very large, and small components will be there in the false positive and false negative. So when you try to divide them, you will have a bigger accuracy always. So accuracy is not used in those cases where your distribution of positive cases is very less. So in this case, accuracy won't be helpful for us to evaluate the performance of our model. So we have to go with other performance metrics which are available. So for example, We have recall, we have precision. Recall is again called as the sensitivity. Again, we have another as the specificity and F1 score. So this different performance metrics will try to identify the model performance based on different components. So accuracy is mostly useful when you have the classes which have some similar count. When you have some similar count but not very smaller classes, then your accuracy will be helpful. But when you have very small positive class, such as the cancer detection or the anomaly detection, so again, anomaly detection is a similar case where fraud detection basically. So fraud detection is again a case of this case where we have very small number of values. So we can't use accuracy in that case and we have to use the different performance metrics. You are working on a time series dataset. Your manager has asked you to build a high accuracy model. You start with the decision tree algorithm since you know it works fairly well on all kinds of data. Later, you tried a time series regression model and got higher accuracies on the decision tree model. Can this happen? Why? So first thing, as it is a time series data are mostly linear in nature. So as the next value would be related with the previous value. So let's assume we want to look at the stock prices. So stock prices which are today are related with the yesterday. So whatever value was there yesterday, it is the either higher or lower as compared to what was there in the yesterday. So as compared to this, what decision models would do, decision models would just try to identify some rules within your data. So they would just do some rules which is very non-linear in nature. If there is actually some proper patterns within rule, the decision tree would really helpful. But what the time series related regression should do it, they would try to regress it based on the historic value. As they are linearly correlated with the previous values, the time series regressions would work by regressing it on the historic values. So that's why time series regressions would be more accurate than the decision trees because we have a linearity available within the time series data. Suppose you found that your model is suffering from low bias and high variance. Which algorithm you think could tackle this situation and why? So first thing, so low bias and high variance. So bias and variance are the term mostly used when, so bias basically means you're getting bias to a specific set. So when you have a higher bias, your model is getting underfit. It's not preferring anything and it's just underfitting your data. And high variance is something where your model is very much overfitting to your data. So in our case, it says there is low bias and there is a high variance. So our model is doing a overfit. So first thing is we can use some kind of bagging algorithms. So what these bagging algorithms do is they try to divide your data into multiple samples. So those are samples with the replacement and each sample is trained with a decision tree. So now what happens? We are creating multiple trees which are trying to understand different patterns within the data set. Whatever data you are feeding, whichever sample you are feeding, whatever the patterns available within that sample, each model is learning those things. So now you have a weak learners and when you combine those weak learners, you create a strong learner which will also try to reduce your overfitting. And how it reduces the overfitting is as you're creating more and more models, if some of them is trying to overfit, the others will try to help to get balanced variance in this case. The other technique that we have is we can use the regularization technique. So regularization, there are two types of regularization. There is L1 regularization and there is L2 regularization. Those techniques we can use to penalize the model. So what happens? Those try to penalize whenever your model goes for a higher variance, it tries to penalize it by some parameters that we provided. So based on those parameters, it tries to restrict your model for going beyond the limited threshold of the overfitting. So the regularization is the second technique. And third is we can use the feature importance. So we can use the different tree based techniques like we can use the random forest like feature importance techniques to select top features and we can use those to create a model so that our model will try to fit with those important features. So when we try to add all the features, some features may make our model very much overfitted and when we have a new